In this course, we will build a real-world, enterprise-level patient management system using production-ready microservices. You will gain hands-on experience with Java, Spring Boot and Docker for our backend microservices, Postgres for data storage, and Kafka for event-driven communication. We will also learn how to build API gateways and load balancers using Spring Cloud Gateway, and we will implement both REST and gRPC for microservice interaction, ensuring a scalable and efficient architecture. We will also learn how to authenticate users and secure our APIs using authorization and bearer tokens, which we will build into a dedicated authentication service. This ensures our system follows industry security best practices. Beyond development, you will learn how to deploy these services to AWS using local stack, write automated tests for reliability, and follow best practices that are used in real-world enterprise application. Each module is going to build upon the last, adding a new feature to our patient management system and giving you a complete end-to-end understanding of how these technologies work together in a production-grade system. This course is beginner-friendly and we will build everything from scratch, but it's not for first-time coders. So to get the most out of this course, you should have some basic knowledge around Java, such as variables, loops, classes, methods, and OOP, some basic experience with Spring Boot, and a simple understanding of how REST APIs work, some basic database knowledge, and some knowledge of microservices and Docker would also be helpful. So if you have built a simple Spring Boot application before, you are ready to take the next step into enterprise-level microservices. In the first part of the course, we will set up and build everything for local development. We will be running our microservices in Docker, using Postgres SQL Docker images for our database, and we will be setting up communication between our microservices using a combination of REST, gRPC, and Kafka. So this is what our development environment will look like, where we will build and test each piece before moving on to deployment. Once development is complete, things will get a bit more advanced and we will learn how to deploy everything to AWS using local stack and infrastructure as code. This will allow us to simulate cloud infrastructure such as ECS, RDS, and API gateways, as well as some of the AWS managed services like MSK for Kafka, all while keeping everything on our local development machine, allowing us to avoid the costs associated with a real AWS account. By the end of this course, you will know how to take an enterprise system from local development to full cloud deployment. So before we dive in, here are some important resources to help you throughout the course. The complete code for this course is available on GitHub, as well as architecture diagrams and some of the code snippets. You can find a link to these in the video description, where you will also find timestamps for this video course as well. This course is supported by JetBrains, and we will be using IntelliJ Ultimate, and viewers of this course will get a free license for IntelliJ Ultimate, and the link for this is also in the description as well. Lastly, we have a private Discord server, which is a serious learning community for asking questions, getting course support, and networking with others who are on the same career path as you. To get access to this Discord, you can visit codejackal.com for instructions on how to get the sign up link. My name is Chris, and I have been a software engineer for 10 years, working extensively with the technologies you are about to learn. This course is designed to help you build real-world enterprise-level skills, whether you're aiming for a new job or leveling up your career. I'm excited to have you on this journey, and there's plenty to do, so let's get started. Okay, so the first thing that we're going to do is that we're going to install the things we need to set up our dev environment on our own laptops or computer. So since this is a Java Spring course, the first thing that we need to make sure that we have is the Java Development Kit. So as the name suggests, the Java Development Kit helps us build Java apps and it is provided by a company called Oracle. So if you go to oracle.com in a web browser, in the top navbar, there will be an option called Products. So if we click this, and if we scroll down to the bottom, we will see Hardware and Software. And in here, we will see a link for Java. So go ahead and click this. And on this page that appears, we're going to click the link that says Download Java. And if we scroll down, you can see all the Java versions that are currently available. So there's two Java versions that the web page mentions here. So the first one is JDK 23, which is the most recent release of Java. And then we have JDK 21, which is the version of Java that is under long-term support. So what that means is that this version is going to be supported and receive updates in terms of security patches and things like that for a very long time. So due to this reason of long-term support, this is the version that we're going to use in this course, JDK 21. So we'll scroll down again, and under the JDK 21 tab, we're going to choose your operating system here. So I'm on Windows, so I'll choose Windows. And down in here, I'm going to choose the MSI installer and download this version just by using this link on the right-hand side. So this will start to download. And if you're on Mac, you can choose the Mac OS option, and it's probably best to use the DMG installer, and the setup steps should be the same. So after the download completes, just open up the installer and just follow the steps until the very end, and Java should be installed on your system. So the best way to check that Java has been successfully installed on your system is to open up a terminal or a command prompt. And in here, if we type Java -- version as a command, and then if we hit enter, you can see that it says Java 21.0.5 and using the LTS version, which is the long-term support version. So if you're not seeing this, or if you're seeing any errors, try and run the installer again. And if that fails, try and update your environment variables to make sure that it's pointing to the correct version of Java and so on. Okay, so now that we have Java installed, the next step is to install Docker. So Docker is used to run containers, which are essential in a microservices app setup. So in order to create and develop with Docker containers, we need to ensure that Docker is installed on our system. And the best way to do that is to install Docker Desktop. So in a browser, if you go to docker.com, you can see that it will bring us to the Docker web page. And if we scroll down a bit, we can see what Docker Desktop looks like. So it's a nice UI that lets us see containers and images and things like that. But the most important thing is that it installs the Docker context onto our development laptop. So that means that all we have to do is start Docker Desktop. That will start the Docker context, and then we can start working with containers and images and so on. So let's install this then. If we scroll up to the top and just choose the download Docker Desktop option here. And if you hover over the link, you can see that there's a few options. So again, just choose the one that makes sense for your operating system, and it should download an installer in your browser. Once this is downloaded, go ahead and run the installer, and it should install Docker Desktop on your own system. So to check that Docker has been installed is to open Docker Desktop. So just go ahead and open the Docker Desktop application. So there should be a shortcut icon either in your start menu or on your taskbar or whatever. Just open this up, and as you can see here, we have the new UI for Docker Desktop, and it's running our own system. So on the left, you can see the different things that are Docker related, like containers and images and so on. So don't worry if these things don't make sense right now. We're going to see how each thing ties together to create a microservices setup. But for now, we're just getting things set up. So this looks to be working, so that's good. If you want to double check that Docker is installed on your machine, again, you can open up a command prompt, and then in here, just do Docker -- version. And then it'll say Docker version 26 or whatever. Okay, so far so good. We have Java SDK and Docker installed, and we also have a nice Docker UI to help us when we need it. Okay, so now that we have Docker set up, the next thing that we need to do is install an IDE onto our system. So an IDE is an application that lets us write some code. So if we go back to the browser, and in the URL, we're going to go to jetbrains.com. So JetBrains is a company that makes enterprise level tools and software for developers. And one of those tools is an IDE that's called IntelliJ IDEA Ultimate. So this is the leading industry standard for creating enterprise Java applications. And it's something that I have used personally for years throughout my career. And it makes it extremely easy to work with things like Java, Spring Boot, Docker containers, and databases, all from within the IDE itself. We can also build front ends, run and debug code, and work with Git. So it's a great productivity tool that will speed up the time that it takes to create our applications. So to get IntelliJ IDEA Ultimate, what we're going to do is go to the Developer Tools tab at the top, and in the dropdown, we're going to choose IntelliJ IDEA. So this will bring us to the IntelliJ IDEA web page, where you can see some more stuff about the IDE and the features and all that good stuff. But if we go to the top, there will be a download button here just below the title. And if you click download on this page, you will see a download link for the different operating systems. So again, just go ahead and download the package for your operating system and choose download, and it will download the installer that we need to run to install the IDE on your system. So you'll probably notice here some text that says free 30-day trial. So IntelliJ IDE Ultimate is a paid product, but don't worry, you don't have to enter any card details or things like that to start this free trial. And I also have a coupon code that you can use to extend this trial to 90 days, which will give you extra time to complete this course and experiment with the IDE yourself without having to pay any money. So before we get to the promo code, you have to download and install the IDE. So go ahead and run the installer when it completes. And after the install completes, you can go ahead and open up the IDE on your system. So when you open up the IDE, you should see a welcome window that looks something like this. And on the bottom left, this tiny little gear icon here, this is what we want to click. And under here, if we choose the Manage Licenses option, you can see it'll bring up the license that you currently have for your free trial. So it should say something like free trial 30 days or something along those lines. But what you want to do is click this Activate New License button, and then you'll see an options for activation code. So this is where you want to put any promotional codes or coupons that you have that will give you some extended access to IntelliJ IDEA Ultimate. Because this course is supported by JetBrains, they have kindly provided an extended free trial for all my students. So you will get up to 90 days of free trial so that you can experiment with the IDE and complete this course without having to pay for a full license. So to get this promo code, what you have to do is jump back to the browser, and in the URL, we're going to go to jetbrains.com/store/redeem and hit enter. And then in here, you'll see a little form that lets us redeem a coupon code. So if you scroll down, and the code that you want to put in here is Chris Blakely, just like this, and go ahead and fill out the rest of this form with your details. And down in the tools and IDE section, what you want to do is choose a product from the dropdown, and in the dropdown, scroll down until you see IntelliJ IDEA and just choose this one. And after you've chosen this and filled out this form, just scroll to the bottom and choose redeem. So this will send a code to your email address that you entered up here. So it's important that this email is an actual email that you use. And then once you have this code, just jump back to your IDE and paste the activation code into this little box and choose the activate button. And that will give you 90 days to use IntelliJ IDEA Ultimate for free. You can also find the code and the link in the description of the video. And if you have any problems with the free trial, drop a comment below and I'll try and help you out. Okay, so now that we have a Java JDK installed, as well as Docker and our IDE, we are ready to start to create our first microservice, which is going to be the patient service. So before we get into building our patient service, I want to take a bit of time to explain the architecture of a Spring Boot app. So Spring Boot is a framework that lets us build Java applications fast and efficiently, and comes with a lot of nice things out of the box, such as dependency management, being able to build a RESTful API server, interacting with a database, and it also has a built-in server that helps us with the local development. And because Spring Boot is modular through its dependencies that we can add as we need them, it's perfect for building lightweight microservices that we can then containerize. So in any Spring Boot architecture, there are three main components or three main layers. And the first one is the controller. So one of the main ways that microservices can communicate with each other and also with its clients is through HTTP requests. So any HTTP requests that are received to our microservice, for example, a GET or a POST request that might come from a front-end client, is going to be received and handled by the controller. So the controller will then do some validation. For example, it will check if the required properties exist in the body of the request, and then it will decide what to do with that request and pass the data to the appropriate service. So over here, we have the service layer, and the service layer does is that it handles any business logic that the request might need, and it will also perform any external calls that it needs to do to fulfill that business logic. So for example, if we are handling the business logic for creating a patient, this might be that the email address for a patient has to be a unique email address that doesn't exist in the system already. Or another example would be that that patient has to live in a certain location to be able to be registered with the system. So those are examples of when we say business logic, and this all gets handled in the service. So once the service layer has handled the business logic, it will then call the repository layer for any database interactions if needed. So down here, we have the repository layer, and the repository layer is solely responsible for interacting with the database. So if we go back to our example of creating a patient, when the service layer calls the repository layer. The repository layer will create a new patient record in the database. One of the added benefits of the repository layer is that it hides away the raw SQL queries that we would typically write when interacting with a database and allows us to interact with the database instead using what we call a model. So a model in this architecture would be, for example, a patient. So when we create a new patient, we create a new patient object based on the model, and then this is what gets passed to the repository, and then this is what gets saved in our database. So we will explain more about how this works in the code when we see some examples as we build out our first patient service. But this is essentially the architecture of the microservices that we are going to build. So the last thing I want to talk about before we get into the code is what's called a data transfer object, or a DTO. So over here between the controller and the service layer, you can see we are passing and returning a DTO, or a data transfer object. Sounds pretty complicated or has a complicated name, but this is essentially just a simple JavaScript object which has the sole responsibility of passing data from one layer to another. So in this example, where we are creating a patient, after we receive a post request, that request will be converted to what's called a DTO, and this DTO Java object is going to have all the properties that are received in the request in it. This DTO then gets passed to the service, and the service layer will convert the DTO into its corresponding model entity object. So for example, when we're creating a patient, we would have a patient request DTO, and in the service, this will get converted to a patient entity or a patient model object before it gets saved to the database. So why do we use DTOs? There's a few reasons, and the first one is that it keeps the internal domain models, or in other words, our database entities, hidden away from the client. So this protects our app's internal structure from being returned to any of the clients. It also allows us to send or receive only the fields that are relevant to the client, rather than exposing all the fields in our domain model. So a quick example of this would be if we have a patient domain model or a patient entity in our database. This might have some private medical information in it that we do not want to expose to the front-end client. So in our DTO, we would simply ignore this field as opposed to returning it in the response. So again, we'll see how this looks as we build out some examples. It also means we can validate the client inputs, such as if the fields are valid in the request, and it means we can return the errors back to the client a lot earlier, as this validation is done in the controller as opposed to waiting until the request flow reaches the database before finding any errors. So hopefully this gives you an idea of the structure of a Spring Boot app in terms of what we're going to build when it comes to our patient service. And we will refer back to this diagram as we build out the different layers of our code to help clear things up. So now that we have an understanding of this, what we'll do is jump back into IntelliJ and we will create our first microservice. Okay, so now that we have our dev environment set up and we have an idea on how a Spring Boot application is going to look, what we can do now is start to create our first microservice, and this is going to be the patient service. So go ahead and open up IntelliJ IDEA Ultimate, and what you should see is the Welcome to IntelliJ page. So from here, we can add new projects, open existing projects, and even do some stuff with remote development. So what we want to do is we want to choose the new project button here, and it's the one with a little cross on it. So go ahead and choose this. And on this screen, you can see that we have a bunch of options that allow us to create a bunch of different types of projects. So on the left, you can see we have an option for Spring Boot, and this is what we will use to create our microservices, and it's one of the benefits of using the Ultimate Edition of IntelliJ IDEA, as it lets us create a Spring Boot application really quickly using this UI. But before we get into that, what we want to do is create an empty project up here that we will use to hold all of the microservices and things that we need for our application to run. So you can think of an empty project as just a folder that's going to keep everything nice and organized in our IDE, just so we can manage things much easier. So go ahead and choose empty project, and we're going to give this a name, and we'll call this patient management, just like this. And on the bottom right, go ahead and choose create, and hopefully you're seeing a window that looks like this. So this is the main editor that we will be working with to build out our different microservices applications. So on the left-hand side, we have the project window. As you can see, it's got a folder called patient management, and this is the empty project folder that we just created. And if we open this up, you can see that there's not very much in here. There is a .idea folder. And if we open this up, this just holds some information about the modules that we're going to add to our project. And it has some workspace settings and things like that as well. So it's quite bare minimum at the minute. So what we're going to do now is add the patient service to this folder. So go ahead and right click on patient management, and then we're going to choose new. And in the dropdown, we're going to choose a module. So go ahead and click module, and you will see the new module window appear. So this is similar to the window that we've seen before, in that it lets us create essentially a new project. So the way to think about a module is that it's going to be a standalone microservice. So even though it's part of the wider patient management folder, this module or this microservice is going to be completely standalone, and it will run by itself as its own project. So the only reason we're putting everything in the patient management folder is that it makes it easier to follow along with the course, and also just helps us keep all of our microservices organized so that we can jump between them whenever the need arises during development. So with that in mind, on the left hand side, we're going to choose Spring Boot, and on the right, we're going to give the Spring Boot microservice a name, and we'll call it patient service. And under the location here, just make sure that it's inside the patient management folder. Just below this, you'll see a string that says the module will be created in patient management. After we've done that, we are going to keep the language as Java, and the type down here is going to be set as a Maven project. So what Maven is that it's a package manager that helps us manage our dependencies, and it will also help when it comes time to building the Docker image in order to deploy our Spring Boot microservice to its container. Okay, so next we will decide a group, and just going to say com.pm for patient management. So this can be whatever you want really, but the convention is usually the reversed company domain. So for example, this might be a website that is hosted at .com, and the artifact, it should be pre-populated for you, but just keep it as patient service if not, and then the package name should be .pm.patient service. And the last option we need to choose is the JDK down here. So what you want to do is choose the dropdown, and we're going to choose OpenJDK version 21. So this should hopefully appear in the dropdown since we installed the Java JDK in a previous step. So if not, go ahead and choose add JDK from disk, and just choose the location where you installed the JDK to. And after we have chosen all our options, we're going to choose the next button down here, and it's going to bring us to a screen that lets us choose our dependencies. So as we said previously, Spring Boot is quite modular, which makes it perfect for microservices. And it means that we can choose the things that we want to add to our project to keep our project as small as possible, which is always good when working with microservices and containers. So there's a few things that we're going to add here. And the first one is going to be Spring Boot Starter Web. So if we type web in this little search bar up here, and you should see just below an option says Spring Web. And on the right, you can see that Spring Web gives us the option to build RESTful applications using Spring MVC, and includes the Apache Tomcat as the embedded container. So Apache Tomcat is a development server that lets us start a server locally, which will run the actual Spring Boot server and expose some of these RESTful APIs when we create them. So go ahead and tick this, and it should get added down in here into the added dependencies box. And the next one we want to add is we want to add Spring Data JPA. So go ahead and type JPA in the search bar again, and just below Spring Data JPA will appear. So Spring Data JPA is the Java persistence layer that will persist our entities in the database. So for example, when we create a new patient entity, Spring Data JPA will see that this patient entity or patient object will have to be persisted to the database, and it will create the queries behind the scenes in order to do that. So we'll see how this works as we go throughout the course. But for now, we'll add our next dependency, and it's going to be Spring Boot DevTools. So if we type DevTools, this will appear in here, and go ahead and select it. And what this does is it allows us to perform fast application restarts, which is good because we will be continuously stopping and starting our containers as we make code changes. So we want the containers to start as quickly as they can. And this package will help with that. So the next package that we're going to add is going to add Postgres, and we're going to choose the Postgres SQL driver. So what this does is that it adds a driver that allows our repository layer to communicate with the Postgres databases, which is what we are going to use to store our data. And the last one we need is validation. So if we search for validation here in the search box, and then we'll choose validation. And over here, there's a small description that says Bean Validation and Hibernate Validator. So this is going to allow us to validate the requests that we receive from the client in our DTOs, but it also allows us to validate the entities before they get saved to the database, just to make sure that the data is valid there as well. So down in our added dependencies box, we should have 5 dependencies, which will get us started in building out our patient service. So we will add more dependencies as we need them, but for now, these are the main ones. So after you have added these 5, go ahead and choose the create button. And hopefully now you are brought back to the main ID window. And on the left here, you should see the new patient service has been added as a module. So you can tell it's a module by highlighting the folder, and there should be a little square in front of the folder that says module. So if we open this up, you can see we have a lot more stuff in here than we did in the previous folder we created. So if we look in the source folder, you can see we have a main folder. And if we keep opening this up, you can see we have a bunch of different folders for different things that our application is going to need to run. So in the resources folder, we have application properties, and this is where we specify the properties and environment variables that our application is going to need. So we'll explain more about how this works as we go through the course when it comes to Docker containers and so on. And if we jump into the Java folder, which is the one just above the resources here, and it should be a different color. And then if we open this up, you can see we've got our package, which is com.pm.patient service. And then in here, we have patient service application, and this is a Java file. And if you look to the left of it, you can see it's got a funky icon that has a green arrow on it. And this means that this is the entry point for our app. So if we jump into the patient service application, you can see in here, we have our public static void main class, which is the entry point for a Java application. And inside this, all we have is a Spring Boot application.run class. And this essentially says, start up our Spring Boot app anytime we try to run the project. And as you can see, we've got an @Spring Boot application annotation up here that was added for us. And this again is used to tell Spring Boot that this is the entry point for our app. The last thing to show is if we go back into the patient service folder on the left here, and then go down to pom.xml, you can see that it's got a bunch of XML, which is a list of all our dependencies. So there's some other stuff in here too, which is the metadata for our microservice, which is used by Maven to help build things. And then if we scroll down, you can see we've got our dependency section here. And then we have all the dependencies that we added whenever we created the module. So we've got a Spring Data JPA up here. We have the validation one, and then we've got Spring Boot Web and things like that. So whenever we come to add new dependencies, this is where we will come to add them. And then we will use the Maven stuff to help us import the dependencies to our project and so on. So that was a brief overview of the file structure and some of the different files that we get whenever we create a Spring Boot application. So the first thing we're going to do is we're going to create the patient model. So since this is the patient service and the core responsibility of the patient service is to handle the patients, it makes sense that we have an entity to represent a patient object in our database. So on the left-hand side in our patient service, we're going to go into the Java folder, and inside the com.pm.patient service, we're going to right click and we're going to add a new package. So we'll choose package from the drop-down option over here, and we're going to call this new package model. So this package will hold all the domain entities that this microservice is responsible for. So go ahead and hit enter, and on the left here, you should see that the model folder has been created. So we're going to right click on the model folder, and then we'll go to new, and then we're going to choose Java class, and we're going to call this patient, just like this, and it's going to be a class. We just make sure the class is selected here, and then hit enter. And as you can see here in the main editor, that we now have a patient class. So in here is where we will specify all the fields that we want to store for a given patient. So the first thing to do is we want to add the entity tag to this class to tell Spring that this class is an entity class and that it should be used to persist data in the database, which we will see working in a second. So just above the public class definition, we'll say at, and then we'll say entity, just like this. And this is going to add the import from the Jakarta persistence package. And now we have an error on our patient class. If we hover over it, you can see that it says persistent entity patient should have a primary key. So what this error is telling us is that since we're going to store the patient entity in the database, each of the properties of a patient, which we will add in a second, is going to correspond to a column in the patient table. So essentially, at the end of this, we're going to have a patient table in our database that corresponds to this patient object. So Spring is telling us that the ID is needed as it's going to be needed in the table in the database. So this is the first thing we'll add. So just inside the patient class, we'll say at, and then we'll say ID. And this is going to come from the Jakarta persistence package again. And just below this, we're going to say generated value. So the nice thing about IntelliJ is that it tries to help us in terms of code completion. So sometimes you'll see this little hint and things, and it'll say tab to complete. So go ahead and hit tab, and it'll add in the code for you. So at the end, we need to add some braces, and then we'll say strategy is going to be equal to, and then we'll say generation type auto, and then we'll take a new line, and then we'll say private, and then we'll add a space, and then we're going to say UUID, and then we'll say ID in here, and we're going to import the UUID object from the java.util class here. So hopefully it's given a suggestion. So just go ahead and click this, and as you can see, it gets updated at the top of the file here. So all we're doing with this is we're saying that this property, which is a UUID or a UID, is going to be the ID of this patient entity, and it's going to be auto-generated by the database. So that means every time we create a new patient in our database, we do not have to specify an ID, and the ID will get handled automatically for us by Spring JPA and also our database without us having to do anything. So the next thing we want to store is the patient's name. So we'll take a few lines here, and then we'll say at, and then we'll say not null, just like this. And then we'll take a new line, and then we're going to say private string, and then we'll say name, just like this. So now this will add a name column to our database for each of the patient records that we have added to our patient table. And what this not null tag means is that whenever we try to persist, or in other words, whenever we try to save or update a patient record to the database, it's going to fail and give us an error if the name property for the given patient does not have a value in it. So this is some nice validation that we're doing at our persistence level, just to make sure that things are being saved to the database correctly. So we'll see how this works whenever it comes time to run the app. But for now, we'll just continue and add some more properties for this patient entity. So we'll take a new line again, and in here we'll say at, and then we'll say not null, and we'll take a new line again, and then we'll say at, and then we'll say email, and we'll import this from the Jakarta validation package. So what you can do here is do Alt on your keyboard and enter, and this will bring up the import window here. So go ahead and choose the top one, and it will get imported automatically for you at the top here. And then just after at email, we'll take a new line, and then we're going to say at column, and then we'll say unique equals true, just like this. So what this means is this is just some additional validation to make sure that anytime we try to save a patient with an email address to the database, that the email address for that patient is unique. So this just means we can't have duplicate emails in the database for any of our patients. And then we'll take a new line here, and we'll say private string email, and the autocomplete has guessed right this time. So we'll just hit tab, and this will add it for us. And the next thing we will add in here is we will add in the address. So again, we'll say at not null, take a new line, and I will say private string, and then we'll say address, just like this. And we'll add a few more for the date of birth and the registered date. We'll say at not null, and then on a new line, we'll say private, and this time we'll say local date, and we'll say date of birth, just like this. So by specifying the type of this property as being the local date, it will save a timestamp to the database as opposed to a string. And because we're using a built-in type from the java.time package, it will all be handled for us by the JPA persistence layer and the database. So this is nice because it means we don't have to work too much with dates. Still have to do bits and pieces here and there, but the majority of the work will be done for us. So The last one we'll add is we'll add one for the register date. This will be similar. We'll say at not null, and then on a new line we'll say private local date, and then we'll say registered date. Okay, so now we have a Java class which we've called patient that we've labeled as being an entity, and we've added some properties to each of our entity with some different types. So this entity is going to get represented as a table in our database, and each of the properties are going to be represented as a column. And this will all be handled by the JPA persistence layer and the repository, which we will create later. So now what we need to do is we need to add getters and setters for our patient entity in order for us to set and get individual properties depending on what we're trying to do and the information that we want to get from the patient. So in object-oriented programming, it's good to have the properties themselves marked as private so that we cannot directly access them. And the only way to access these properties is through these getters and setters that we are about to create. So this encourages good encapsulation, and it's a common approach whenever working with objects in Java. So to do this, what we will do is highlight all of our properties. So just start from the bottom down by the registered date, and then we'll scroll to the top and we will select everything. And then we're going to right click and going to choose the generate option here. So what the generate option does is it generates some code for us. And as you can see, we have an option here for getter and setter. So if we click this, and you can see that IntelliJ has detected all of the properties that do not have any getters or setters added yet. So go ahead and choose the top one, and then we'll choose shift, and then we'll choose the bottom one just to select all of these, and then we'll choose OK. And as you can see here, we now have some public methods. So methods are accessible to other classes outside of the patient class, and we have a getter and a setter for each thing. So if we look at these two, for example, this is how we get an ID, and this is how we set the ID. And then we have a few more down here for all of the other properties that we added as well. And then you'll notice that the types are all the same. So what we will do is scroll to the bottom, and we will just make sure that the properties that we added previously are at the top. So just copy this code, and then we'll do Control X to cut, and I'll just scroll to the top, and then we will put our cursor just inside the opening brace of our class, and then hit space, and then we'll paste this in here just like this. So this isn't necessary, but it is nice to have the private properties at the top of the class so that other developers who are coming in after us can easily jump into the patient entity and see what properties are available. And if we scroll down, you can see all our getters and setters are here as boilerplate code. Okay, so this is good. We have our first entity, which is the patient entity, and we've added a bunch of properties, added some validation, and added our getters and setters. So now what we can do is that we can add a database, and then we can configure Spring to automatically synchronize all of our entities in our code with our database. What I mean by that is that it's going, anytime we start our application, it will connect to a database that we configure. It will then check all of the entities in the code and compare the entities against the database. So if there's no patient table, or if the patient table exists but it doesn't have a property that exists in the patient class, then the JPA persistence layer is going to create the tables or the properties or whatever's missing. So this is really powerful, as it means that anytime we create an entity, it's automatically going to get added to the database without us having to go and manually create the tables with all the columns and ensure that all the column types are the same as the entity, and so on. So to see this working, we are going to use what's called an in-memory database. So this is a nice thing that Spring provides, in that it allows us to start an in-memory database without having to set up all the infrastructure and things to get an actual database running. And it's a good thing to use during development so that we can quickly test if our patient's microservice is able to interact with the database successfully and that the persistence layer performs all the actions that we expect. So as we progress throughout the course, we're going to be using Docker and a real Postgres database for a more production ready setup. But for now, we are just focusing on the actual patient service microservice itself. So an in-memory database is a good approach for this. Okay, so with that in mind, what we'll do is we will go into our project and patient service folder. We're going to scroll down until we see the pom.xml file. So the pom.xml file contains all the dependencies that are added to the project and that are handled by the Maven package manager. So you can see some of the dependencies we added whenever we created the patient's microservice. So what we want to do is add a new dependency for our in-memory database. So scroll down until you see the closing dependency tag here, it will look like this. And then we'll just take a new line above this one. And then we'll add an angle brace, and then we'll add a dependency just like this. So IntelliJ should auto complete it for you. And what we're going to do is inside of the group ID, we're going to say com.h2 database, and the artifact down below, we are going to set as h2. So if you see an error here, what you can do is after you've added it into pom.xml is go back to the project, and in the pom.xml file over here, just right click, and in the options, scroll down until you see the option for Maven, and then highlight this, and then just choose the option to reload the project. So what this will do is it will go and download any new dependencies from the Maven repository, which is hosted in the cloud, and it will add it to your project. And over here, if all goes well, you should see that there are no errors and all is good to go. So this adds the H2 database to our project. Now what we need to do is we need to configure our patient service Spring application to use this database when it starts up, and to sync any changes in the entities to the database itself. So to do this, we go into the project again on the left, and in the patient service over here, we're going to go into source, into main, and then into the resources folder. And we should have an application.properties over here. So just double click this and it will open on the right hand side. And all we have in here so far is the name of the application. And this was created by Spring whenever we bootstrapped the project. So what application properties is that it lets us define values that we can change through configuration depending on how we want our app to behave. So for example, we are about to add some configuration for our H2 in-memory database that we want to use during development. But whenever we Dockerize our app and deploy it to production, we are going to want to change the database to point or to use a production database that is hosted on AWS, for example. So by specifying our database connection in the application properties, it means that it's easy to change the database and other configuration points depending on the environment that the code is deployed in without having to physically go in and change the actual code itself. So we will see more about how this works whenever we come to using Docker containers and whenever we deploy to AWS. But for now, we're just going to specify the properties that we need for the in-memory database. So we'll say Spring dot, and then we'll say H2, and you can see in here that we have a few options that IntelliJ is suggesting for us. So the first one we need is the H2 console path, and then this is going to be equal to H2 console, just like this. So anytime we start the application that has a H2 in-memory database, it provides us with a endpoint that we can view in the browser to see the data in the database, which is good for being able to see the actual contents that we have in our tables. So the next thing that we want to do is say spring.datasource.url, and this is going to be jdbc h2 m, and then we'll add a colon, and I will say test db. So what this means is that we are just specifying where the database is in URL form. So this basically just means that we are going to be using JDBC, which is a way that Spring connects to a database, and it's going to be using the H2 in-memory database, and the database is going to be called testdb. So the next thing we need to do is we need to specify a driver, and then we'll say spring.datasource.driver class name. This is going to be equal to org.h2.driver. So this basically says that we are going to use the H2 driver in coordination with JDBC to connect to our database from our Spring Boot app. And if you're having any problems with this line, what you can do is go to the main menu, which will be up here, and scroll down until you see invalidate caches, and then just click this and it will invalidate the cache in IntelliJ and hopefully fix the issue. Sometimes whenever we add dependencies to pom.xml, IntelliJ sometimes doesn't pick up the latest changes, and we just need to clear the cache to get it to detect the new packages. So next we need to specify a username and a password that we will use to connect to our database. So we'll add a new line, and then we'll say spring.datasource.username, and then we'll just set this to whatever we want. So we'll say admin_viewer, and on the next line we'll say spring.datasource.password, and then we'll just set this to password so that it's easy to remember. Now, when our in-memory database starts up, it's going to create an admin viewer user and assign them the password of password, and this is what we use to connect to the database. So this is just a security thing. And on the next line we'll say spring.jpa.database platform, and then this is going to be equal to org.hibernate.dialect.h2dialect, just like this. So all we're doing here is we're just specifying the dialect of the database that we are connecting to. And this is all we need to connect to the database itself. So now the next thing we want to do is we want to tell Spring JPA to sync the entities with the database. So to do this, we just specify a few more config points in here. So we'll just say spring.jpa.hibernate.dll.auto, and then we're going to set this to update. So this config point is one of the main ones that tells Spring to update the database if it detects any changes in our entities. And the next one we need is we want to say spring.sql.init mode, and we will set this to always. So what this will do is that it will perform the checks against the database and our entities every time we start the app. So this is good because if we are developing our app and then we make changes to the patient entity, for example, and then we start the app again, it's going to cause the JPA persistent stuff to kick in, and then our database is always going to be in sync with our patient entity. And the last thing we'll add while we're in here is we want to specify the server port. So we'll say server.port, and then we're going to set this to 4000. So this isn't directly related to any of the database stuff, but we're just adding it in here now because as we go throughout the course, we're going to be adding a lot of microservices, and we want to be able to keep track of all the different ports. So we're going to use a convention of any application that we want to run as a microservice is going to be on a port in the 4000 range. So for example, the next microservice we create will be 4001, and the one after that will be 4002, and so on. So this is just a convention to help ourselves remember what ports things are started on. Okay, so you can go ahead and save this, and what we can do now is start our Spring Boot application and see what happens. So at the very top of the ID up here, you can see that we've got some actions that we can perform. So you should see something called Patient Service Application. This is a config that IntelliJ has created based on our Spring Boot app. So what we can do is choose the Run Patient Service Application, the little green arrow to the right hand side. And if we click this, you can see down in here that we have some log messages have appeared. So if we scroll over, you should see something along the lines of started patient service application in 2 seconds or whatever. And you can also see that Tomcat started on port 4000. So if you can't see this little run window here, you should see it on the left in your toolbar. So just click this arrow and it will bring it up. Okay, so now that our application started, what should have happened is that our patient entity that we created earlier should have synced with the in-memory database and created a patient table that has all this stuff in it. So what we can do is go to the browser, and in the URL, we'll say localhost, and then we'll add a colon, and then we'll say 4000, and then add a slash, and then we'll say h2-console. And if you hit enter, you should see something that looks like this appear. So this is the login form that will allow us to log into the web console and view our patient table if all went well. So all we have to do is fill out some of these fields. So in the driver class, what you want to do is say org.h2driver, and then the JDBC URL is going to be the same as what we specified in our application properties. So it's jdbc:h2:mem:/testdb, which is the name of our test database. And then for the username, this is again what we specified in our application properties, and it's just admin_viewer, and the password would be password as well. So after you've filled in this form, go ahead and choose the connect button in here, and you should see something that looks like this, provided that the login was successful. And over here on the left hand side, we have this viewer, and this displays all the stuff that is in our database. So as you can see here, we have a patient table, and if we expand this out, you can see that we have a column for each of the properties in our patient entity. So now anytime we add a patient to our database, they will appear as a row in this table. Okay, so this is good. It shows that our Spring Boot application is able to connect to a database, and it's able to update the entities and create tables and do all that sort of database stuff without us having to write any manual SQL queries or do any manual tasks in the database. So hopefully you can see how powerful this approach is, as anytime we add properties now to our patient entity and start the app again, everything will get automatically synced up to the database. And This is great for development as it really speeds things up. And because we used a application.properties file to specify the connection details to the database, it means whenever we come to using a real Postgres database, all we have to do is change the configuration in here, and we don't have to change any code, and it should all work the same. Okay, so at this point, you can feel free to go and add some things to the patient entity if you want to just explore how things get synced up with the database. So you can change some properties in here, stop and start the application, and then go to the web console to view the tables just to see how the changes are affected. Okay, so now that we are able to persist entities against our database, the next thing that we can do with JPA is populate our patient table with some dummy data. So this is nice for development as it makes it easier to test things without having to do too much manual work to create a bunch of patients. So the easiest way to do this is to provide a data file that JPA will use to populate our patient table. So I'm just in the GitHub repository for the finished repo here. So you can find the link for this in the description, or just go to my GitHub account and search for patient management, and then you'll find it as well. So in here, we have all of the finished microservices that we're going to build. And what you want to do is look for the patient service repository and just click this. And in here, we're going to go to source main. And finally, we're going to go to the resources folder. And in here, you will see a file called data.sql. So go ahead and click this, and it will open up the data.sql file. And as you can see, it's just some raw queries that we can run against our database. So in here, I have provided a bunch of statements that will insert some dummy patients into the database. So I think there's a total of 15 or so, and each one just has the data we need to fill a row in the table. So it has an ID, has a name, email, address, date of birth, and a registered date. So what you want to do is up here, choose this raw button, and then this will give you the code in a nice format that you can copy and paste. So go ahead and do Control A or Command A on Mac, and then just do Control C to copy everything. And then we'll jump back into our ID. And then in here, we're going to go to the resources folder on the left that's inside our patient service microservice. And we're going to right click on the resources folder, go up to new, and then we're going to add a new file. And then we'll just call this data.sql. So this is just named the same as what it is in the finished repository, and then just hit enter. And as you can see down here, it's created a new data.sql file, and it's got a little database symbol beside it. So IntelliJ knows that this is a database related file. So in the main window of the editor here, just paste in all of the code that we added, and that should be it. So just double check that you don't have any errors and stuff. So all looks good here. So now what's going to happen is anytime we run our application, JPA is going to have a look in the resources folder, and it's going to check for a data file. And if one exists, which it does in this case, then it will run this file against the database. So this is all handled by the JPA persistent stuff. So there's nothing else we have to do now. It works the same way as it does with persisting the entities. So it all happens behind the scenes, and we don't need to worry too much about it from this point on. So to see this working, all we have to do now is go to the top and choose the run button up here. So if you click run, and down here, it should open up the run window. And if you keep an eye on the output, you will see that if all goes well, you should see patient service started in 2 seconds or whatever. And now what we can do is jump back to the browser, and in the URL bar, all we're going to do is go back to the H2 console and have a look at the table. So just go to localhost /4000/h2-console and hit enter. And in here, just fill in the details again if they didn't persist from the last session that we did, and then just choose connect down here, and it should bring up the UI for the H2 database. And on the left over here, we're going to expand out the patient table. And if you click on it, on the table name, it should add the select query to the right hand side, and then just click run. And down below in this little table here, you should see all the data. So this looks like it worked because we've got 15 rows. And if you scroll over, you can see that all of the fields are populated, and it's got some nice dummy data for us to work with. So this is a quick approach to get some data into your database during development, which is always good for local testing. This approach can be used as well when we write integration tests to quickly add database data that we can assert in our tests. So we'll see how this works in the later parts of the course. If you're having any problems with this, double check the console and just to see if there's any errors, and also double check the name of the data.sql file just to make sure that's correct and that you put it in the resources folder. So now that we have our in-memory database set up and we're able to connect to it and perform persistence against it, what we will do now is create the repository layer. So if we look back to our little architecture diagram, you can see we have this repository layer here, and this is the layer that is responsible for performing interactions against the database in order to get, create, update, and delete data from the database. So even though JPA uses the model to perform persistence on the actual entities and the tables, the repository layer also uses JPA to interact with the actual data in those tables that were created already. So we'll see how this works as we build out the example. So in the code on the left-hand side, we're going to go into the source folder, into the main folder, into Java, and then into our main package here. And then we're going to right-click, choose new, and we're going to add a new package. And we'll call this package repository, just like this, and go ahead and hit enter. So as we go throughout the course, we will keep our code base organized by adding different Java files into the correct packages, and this just makes it easy to find things as we go. So inside of the repository package, we're going to add a new Java class, and this will be called patient repository, and this is going to be an interface. So choose interface from the drop down list here and go ahead and hit enter, and you will see that we have a new interface that has been created that is called patient repository. So the first thing we need to do here is we need to add the repository annotation to this interface. So we'll take a new line just above the public keyword here, and then we'll say at, and then we'll say repository, just like this. So this tells Spring that this interface is a JPA repository. And the next thing we need to do is after the patient repository keyword in here, we're going to say extends, and this is going to extend JPA repository, and then we'll add some angle braces, and inside the angle braces we're going to say patient, add a comma, and then we're going to say UID, and go ahead and import the patient class from the model folder, and we'll also import the UUID package from Java util so that our code looks like this. So what this does is it creates a patient repository that extends the base JPA repository, and we pass in the entity that we want this repository to control. So in other words, because it's the patient repository, we pass in the patient entity here, and we also pass in the type of its ID. So if we have a look at the patient model by doing control and click on patient, in the previous section we added the ID for the patient entity as being a UUID. So this is why we have to specify it in here, and this is essentially it. So by extending the base JPA repository, we get access to a lot of out-of-the-box CRUD functionalities, such as being able to create, update, get, delete, and so on using this repository interface. So we will see how this works when we implement the service layer that will actually call this repository, but this is it for now. So don't worry if this doesn't make sense, because we haven't added very much code in here, but we are getting a lot of out-of-the-box stuff because we are using JPA. So this is our repository completed for now. So what we can do is we can close these files, and then we'll jump back into our project, and we'll go back into the main package of our patient service, and we're going to add a new package again. So we'll right click, go to new, go to package, and then we're going to call this service, just like this. And if we jump back to our architecture diagram, we have created the repository now. So the next step is to create the service that will handle any business logic for the given request and call the repository layer. We'll jump back to the code, and in the service folder that we just created, we will right click, we'll go to new, and this time we'll choose Java class, and we're going to call this patient service, just like this. Close down the project folder, and then you can see over here we now have a patient service class. So this is going to be where all the business logic and DTO conversion happens for a given request. So the first thing we'll do is we will annotate our class. So we'll say at, and then we'll say service, because this is a service layer. And what we could do in our patient service class is we can add a patient repository variable that will give us access to the patient repository class and its methods. So here we'll say private, and then we'll say patient repository, and then we're going to call it the same name of patient repository. So this is what it should look like. And now what we're going to do is we're going to take a few new lines, and we're going to create a constructor for the patient service class. So if IntelliJ has added a suggestion for you that looks like this, so public patient service and then patient repository as method argument, go ahead and hit tab so that your code looks like this. Then on the next line, we're going to say this.patient repository is equal to the patient repository. What this pattern is it's called dependency injection. What this means is that the patient service class receives its dependency, in other words, the patient repository that it needs via its constructor, instead of instantiating the patient repository itself by using the new keyword. So this essentially makes our code more modular. It's easier to test as we can pass in some mock patient repositories whenever we are constructing the patient service object in our tests. And it also adheres to the principles of inversion control. So this is a big pattern in Spring, and we will see plenty more examples on how this works as we go through the course, as we create more classes, and when it comes to writing some tests at the end. So don't worry if it doesn't make sense right now, but this is a pretty common pattern, so we will see it a lot. Okay, so now that we have created our constructor and we have injected the patient repository, now we can add a method to our patient service called getPatients. So this is the first method that we're going to create in our service, and it allows us to return all the patients in our database. So just after the patient service constructor, we'll add a new line, and then we'll say public, because this is going to be a public method that all our classes can use. And then we'll say list, and then we'll add angle braces. And if the pop-up appears, just go ahead and hit an enter, and we'll import the list class from the java.util package, and it will import at the top view. Inside of the brackets, we'll say patient response DTO. So we haven't created this class yet, but remember, anytime we are in the service layer is going to convert our domain entity models into a response DTO that has specific properties that we want to return to our clients and our front end. So we will come back to this piece in a minute, so don't worry about the error right now. And outside the angle brace, we're going to call this getPatients, and then we'll open some braces, and then we'll add our curly braces in here. And as you can see here, the IntelliJ has picked up what we're trying to do. So it's guessed that we're trying to get the patients from the patient repository. We'll just go ahead and hit tab, and this will autocomplete for us. So as you can see now, we are using the patient repository, and we are using one of the built-in JPA methods to help us create a query that returns all the patients from the database. So find all, as the name suggests, is going to return all the patients in the database. But if we delete this for a second and press dot after repository, you can see we have a bunch of other out-of-the-box options that we can use in order to retrieve data from our patient database. So we can find all by ID. These are all things that JPA has figured out how to do based on the patient entity that we passed to it in the repository whenever we created our patient repository. So for now, we're just going to use the find all method, and then this is going to return a list of patient domain entity models. Okay, so now we have a list of patients that we get back from the repository, and we've stored it in a patients variable. So now what we need to do is we need to convert the patient domain entity object into a patient response DTO object. So before we can do that, we have to create the patient response DTO. We'll jump into our Project Explorer, and in our patient service package, we're going to right click, add new, and then we will add a new package, and then we'll just call this DTO. So all of the data transfer objects that we are going to need are going to go into this new package called DTO. So go ahead and hit enter, and we will right click on this again, go to new, and we're going to add a new Java class, because remember, a DTO is just a simple Java object. And in here, we will name this patient response DTO, just like this, and it's going to be a class. So go ahead and hit enter, and we can close down the project window again. So this is our DTO class. And if we jump back to our architecture diagram, you can see from here, we have partially created our service layer, and the service layer is going to create a DTO that gets returned to the controller, which in turn gets returned to the front end in the response. So this DTO is going to contain all the properties that we want to return to the front end client. So we'll jump back to our code. So inside our patient response DTO class, we will start to add the things that we want to return in the request. So we'll say private string ID, and on the next line we'll say private string, and on the next line we'll say private string email, say private string address, and we'll say private string date of birth, and this will be all our properties. So you will probably notice that the patient response DTO is very similar to the domain entity model. So if we open up the patient domain entity model here, and you can see we've got some similar properties. But we also noticed that some of the types are different. So for example, in the patient domain entity, we've stored the ID as a UID, and we've also stored the date of birth as a local date. However, in our patient response DTO, we have stored everything as a string. This is one of the reasons why we use a DTO, because if we try to convert this patient entity into JSON, which is what typical HTTP requests would use to return data in the response, we could encounter some issues trying to convert these complicated types into a JSON string. Whereas if we use a DTO and use more primitive types, it's easy for us to manage those types of conversions because we are returning things as simple strings. You'll also notice that in the patient entity object, we have stored the registered date in the database, but we do not return it as part of the patient response DTO. So in our system, we only store the registered date in our database for auditing reasons. There's no reason to return this to the front end. Therefore, in our patient response DTO, we do not have to add a property in here for it. So this means that the registered date for all of our patients will never be exposed on the front end. This is another benefit of DTO. So hopefully you're starting to see why we use a separate object for the different layers in our system. Okay, so now that we have the properties in our DTO, we can generate the getters and setters. We just highlight all of the properties again and right click and scroll down until you see generate, and then choose getter and setter in here, and then just highlight all the properties and choose the OK button down here. And this will generate all the getters and setters. So what we want to do is just make sure that all the properties themselves are at the top and that the getters and setters appear after. Okay, so this looks good. And on the right here, you'll see it says one related problem. If we click this, it should bring us back to the patient service class that we created a while ago. And it's brought our attention to the patient response DTO symbol that cannot be resolved. So IntelliJ has picked up that this class now exists and it's asking us if we want to import it. You just hover over this or choose Alt and Enter, and it will import the DTO for us. That we have a DTO class, we can run some logic in our get patients service function that converts each of the patients that we receive back from our repository to a patient response DTO object. So to do this, we are going to create a helper class that accepts the domain entity model and returns a DTO. So we'll go into the project, and in our patient service in here, we're going to right click, go to new, add a package, and then we'll call this the mapper package. So just like this, and then hit enter. And then we'll right click on the mapper package that was just created, and we'll go to new, and then we'll go to Java class. And we'll call this patient mapper. And this is going to be a Java class, just like this. So on the right, you should see this new class was created for us. And what we're going to do inside of this class is say public static. Then we'll say patient response DTO. And this is going to be the return type. And then we'll say to DTO. And then we'll add our braces. And this is going to accept a patient, which is our domain entity object. And we'll just call it patient. And then we'll add our curly braces at the end. And then we'll take a new line in here. And what we're going to do here is we're going to instantiate a new patient response DTO. So IntelliJ has guessed correctly what we're trying to do. So just go ahead and hit tab, and this will create a new object. So at this point, what we have is we have a patient DTO class, which we just created. And then we also have the patient entity class that we want to convert. So all we have to do now is do each of the properties individually. So we'll take a new line down in here, and we'll just say patient DTO.set ID. So as you can see, this is why we use getters and setters now, because we are able to get IntelliSense on all the properties that we are able to change using the setter. So we'll say ID, and we'll say patient.get ID, and then we'll say to string. So all we've done is we have taken the ID from the patient and we have set it as being the ID on our new patient DTO. We can continue doing this, and if you hit enter, and IntelliJ IntelliSense will have guessed what we want to do next, and go ahead and hit tab, and this will set the name. And if we take a new line, we'll say patient DTO dot set address. So sometimes IntelliJ will guess and sometimes it won't. So if it doesn't, just follow along and type it out manually. And the argument for the address, we can get the address from the patient object, which we get from up here. So hopefully now you're starting to see the pattern. And next we'll do email. So we'll do patient DTO.set email, and we will get the email from the patient object. And I think the last one we need to do is the date of birth. So we'll do patient DTO set date of birth, just like this, and then we will get the date of birth from the patient object. So now that we have added all of the properties that we want to return as part of the DTO to the client in the response of the request, we can simply return this DTO. We'll say return patient DTO, just like this. So you'll also note here that we did not use the patient get registered date anywhere in our code up here because we didn't want to return the registered date as part of the DTO. So we've also used a separate mapper class to convert from the entity to a DTO, just to keep things more modular, and it keeps all this logic out of our service layer. So now that we have this, we can jump back to our patient service class up here and new line after the repository call. And this time we'll say list patient response DTO, and then we'll call this patient response DTOs. And this is going to be equal to patients. So this patients variable is this one up here, and we'll say dot stream, and we'll say dot map, and then we'll open our braces and we can pass in our function. So we'll say patient, then we'll say dash, and then we'll do a right angle, and this will create an arrow. And then we can say patient mapper, a capital P, and then we'll say dot to DTO, and then we'll pass in the patient. And just outside the last brace over here, we'll say dot to list and add our brace so that your code looks like this. Let's talk about what we just did a bit more. So we have created a new list of patients response DTOs, and we have set this equal to patients.stream.map. So what the .stream.map function is essentially similar to a for loop in that it will iterate over each item in the given list. So in this case, it's the patients list. It then gives us the patient that it's currently on in loop as a variable that we have called patient here. So for each patient, we are going to call the static toDTO method on the patient mapper that we created previously. And then we're going to pass the patient to that function, to that method, and then the return result of this gets added to the patient response DTOs list up here. So this is what the toList function does. So at the end, if we have, let's say, 15 patients that get returned from the repository, patient response DTO will have 15 items in it as well that get assigned to patient response DTOs variable. Okay, so hopefully that makes sense. And the next thing to show is that we can use a shorthand in here. As you can see, we've got some squiggles under this. So if we highlight this, it says the lambda, so a lambda is like an inline function, can be replaced with a method reference. So go ahead and click replace lambda with the method reference, and you can see that it's shortened the code quite a bit, but it's doing the exact same thing. So what we can't see here now is that the patient variable that gets provided by the map function that used to be over here is getting passed automatically behind the scenes to the toDTO method over here. So if this syntax is too confusing, you don't have to use it, but it is nice to understand what's going on because it makes your code nice and short. So this is also why we moved the patient mapper to a different class. As you can see, our service layer is nice and easy to follow as well, and it doesn't have all the logic directly in here to perform the conversion to a DTO. Okay, so the next thing we need to do is we simply need to return our new list of DTOs back out of this method. So we will take a new line, and IntelliJ has guessed what we're trying to do. So go ahead and hit tab so that we return the patient response DTOs. And now at this point, anytime we call the get patients function from the controller, we're going to get back a list of patient DTOs from the service function. And we have more suggestions from IntelliJ. So if you want to apply them, just hover over and choose inline variable here. So all it's saying is that there's no point instantiating a variable when we can just return the result of the stream directly. So go ahead and choose inline variable if you want, and it's made our code cleaner again. Okay, so now that we have created our service layer, the last piece of the puzzle is to create the controller. So again, the controller is used to handle HTTP requests and handle the HTTP response as well. So let's jump back into our code. And what we're going to do now is we're going to go to our project, and under the main package on the left-hand side, we're going to create a new package, and we're going to call this package controller. So this is where our patient controller is going to go. So go ahead and hit enter. And inside of the new package that we just created, we will right click and go up to new again. And this time we're going to choose a Java class, and we're going to call this patient controller, and this will be a Java class. So go ahead and hit enter again, and this will create our class under the package for us. So now we have our patient controller. can add a few annotations to our class to tell Spring what type of class this is. So just above the public declaration over here, we're going to say at, and then we'll say REST controller, just like this. So this will come from the Spring framework package, and we'll take a new line, and then we'll say at again. And this time we'll say request mapping, and we'll add some braces, and we'll add a string in here, and then we'll say slash, and then we'll say patients. So what these two annotations do is that it tells Spring that this patient controller is a REST controller, and we're also telling Spring that this patient controller is going to handle all requests that start with /patients. So for example, if we have a request to our patient microservice, which will be http://localhost:4000, because that's the port that we set in our application properties. And if we say /patients, all requests that look like this will be handled by this controller. So this is what this annotation's for. And inside our controller, we can start to add our public methods. So the patient controller is dependent on the patient service. So we're going to use our dependency injection technique again here to inject the patient service to the controller. So what we'll do is we'll say private final, and then we'll say patient service, and then we'll just call this patient service as well. And then we'll go ahead and add the import by doing Control Enter, and this will import it from the service package, as you can see up here. Okay, so now what we can do is we can highlight our variable here by double clicking on it. And then we can hover over it. And then under the hints here, you can see it says add construction parameter. So go ahead and click this. And as you can see here, IntelliJ has created a constructor for us and automatically passed in the patient service and assigned the argument to the variable up here. But this is the same technique that we used in the patient service to inject the repository. So hopefully you're starting to see this pattern, and as we go throughout the course we will see how we can use this pattern a lot and how it keeps our code nice and modular. Okay, so we have our patient service. Now the next thing we need to do is we need to create a method that will handle the various CRUD requests that we're going to receive. So the first operation that makes sense to handle is the get all patients endpoint, as we created the service method to do this in the previous section. So down here, we're just going to add a few new lines to give ourselves some space, and we're going to add a get mapping. So again, this is a Spring annotation that will tell Spring that the method that we're about to create is to handle any get requests. So we'll take a new line, and I will say public, and then we'll say response entity, and then we're going to open some angle braces, and then inside the angle braces, we're going to say list, and then we're going to open some angle braces again. And then inside here, we're going to say patient response DTO, and then go ahead and hit Alt Enter to import the list from the Java package. And just outside the last angle brace, we're going to call this get patients, and we'll add some braces at the end as well. So this method is called get patients, which we've named here. And we've said that it's going to return a response entity with a list of patient response DTOs. So what a response entity is that it's a Spring object that creates a HTTP response without us having to do much of the code ourselves, and it lets us set properties on the response quite easily, as we'll see in a minute. So the first thing we need to do inside of our get patients method is we need to call the patient service to get all the patients. We'll take a new line, and then we'll say list, and then IntelliJ will have suggested a line that looks similar to this. So go ahead and hit tab, and as you can see here, it's added a variable called patients, which has a type of list, and each item in the list is a patient response DTO object, and it gets assigned to the result of the patient service .get patients call. So now all we have to do is return this. So we'll take a new line, and then we'll hit tab again, and as you can see here, it's using the response entity along with the method. So this means that we're going to return a status code 200, or in other words, that the response is okay, back to the client to inform the client that all went well. And then we're going to add the patients, which is a list of patient response DTO, to the body. And then this whole thing is going to get returned back to complete the flow. And this will get sent back as a HTTP response to the client. And that's it for get endpoint. So now that we have the controller, the service, and also the repository in place, what we can do is we can test our endpoint and see what the result of a get request to our patient service looks like. So go ahead and run the patient service application. And once it's started, you can use this little hide button here just to hide the terminal. And you can see down here that there's a little green dot on the run button, just to let you know that your app is running. And we're going to go back into the project, and at the top level folder, the patient management folder, we're going to right click, we're going to go to new, and we're going to go to the directory option. So we'll choose directory over here, and we're going to call this API-requests. So this will create a new folder over here called API requests, and we're going to right click on this, choose new again, and we're going to create another directory, and this time we'll call this directory patient service. So this folder, as the name might suggest, is going to have a bunch of API requests for each of our microservices that we're going to use to test the endpoints as we build them out. So we're going to right click on patient service again, go up to new, and this time you want to scroll down until you see this option called HTTP request. So go ahead and choose this, and we're going to give this a name, and we'll call it get-patients, and then go ahead and hit enter. And as you can see on the left, it's created a file that has a .http extension, and it has a little API symbol on the left. So what this is that it's a built-in feature of IntelliJ IDEA that allows us to make HTTP requests to our endpoints. So this is completely separate from our application, and it's similar to how a web browser might work or an API client such as Postman. But the nice thing about it is that it's built into the IDE, so it's good for our productivity, as it means we're not jumping between all the different windows. If you prefer, you can use something like Postman or any other API client that you're comfortable with. It's up to you, and the end result should all be the same. So in here, we need to specify some things. So what we can do is change this comment at the top. So we'll say get request to get all patients. This is just for our own sake so that we can remember what this does as we progress throughout the course. And as you can see here, it's added a get request. So this is what the get keyword is in all capitals. And to the right here, it's given us a example endpoint. So we're going to highlight this, and we're going to delete, and then we'll do HTTP : and then we'll say localhost : 4000, and then we'll say /patients. So as you can see here, IntelliJ is being helpful, and it's picked up that there's a patient's endpoint available from the patient's controller, and that it's a get request. So go ahead and choose this, and this is all we need to make a simple get request to our get patient's endpoint that we just created in the patient controller. So now all we need to do is on the left hand side of our endpoint, there's a little green arrow, and we're just going to click this arrow, and this services window should appear. So if it doesn't, it should be on the left hand side under this little hexagon icon that has a run button in it. So just click this, and then you should see on the left panel here, you should see HTTP request option and the get patients endpoint. So once you see this, just to the right, you can see that we've got a bunch of stuff here. And if we scroll up, you can see that this stuff is actually an array of patients. As you can see, it's an array, which is indicated by the closing square brace here. And each item in the array has a bunch of patients' details in it. And this details corresponds to the data that we added whenever we seeded the database with some dummy data. So if you scroll up, you can see there should be about 15 objects or so here, one for each row in our database. And at the top, you can see some information about the request as well. So it's giving us a status code here. So 200 means everything went well. And it's also specified the content type of the response as well as being JSON. So all this was handled in our controller whenever we created the response entity. So the response entity takes our DTO and converts it to JSON, which is what we see here. So this is good, and it shows that it's working. So congratulations on creating your first Spring Boot endpoint. If you're having any problems or seeing an error here, have a look at the terminal in the run window just to see if there's any errors, and also make sure that the patient service application is started before you try and run the requests. Okay, so now that we are able to get all our patients, the next step that we will do is we will add an endpoint that allows us to create a new patient. So the first thing we're going to do is we're going to create the patient request DTO. So just like we return a patient response DTO, whenever we receive a request that involves working with data from the body of the request, such as creating a patient or updating a patient, we will use a patient request DTO to pass this information between the controller and the service layer. So in our project window, we will go into our main package in our patient service, and we're going to go to the DTO folder that we created in the previous sections, and we're going to right click, choose new, and then we're going to choose Java class. and this will be patient request DTO, just like this. And this will be a Java class. So go ahead and hit enter, and this will create a new class for us. So in here, we're going to add all the properties that we expect to receive in the body of the response whenever we create a new patient. So the first thing we will do is we will add some annotations. We'll say at, and I will say not blank. And this is going to come from the Jakarta validation constraints package. So we'll add this, and then we'll take a new line, and then we'll add the at symbol again. This time we're going to say size, and we'll add some braces, and I will say that the max size is going to be equal to 100, and then we'll add a comma, and then we'll add a message. So we'll say message is equal to, and then we're going to say name cannot exceed 100 characters. And then after this, we'll take a new line, and then we're going to say private string name. So this is going to hold the name of a patient, and we're also adding some validation in here that says that the name cannot be blank and that the size of the person's name cannot be over 100 characters. So you can set this max to whatever you want. What we're just trying to learn here is how validation is going to work. So if the name is blank and the size is over 100 characters, then Spring will automatically return a response with this message in it. So this is another reason why we use DTOs as opposed to using our entities directly, because the validation in the request could be different or slightly different to the validation on the patient entity that gets saved to the database. So it's good to separate these things. And next, we're going to add a property for the email. So we'll say add not blank, and then we'll take a new line, and then we'll say email. And this time we're going to add a message in here that says email should be valid. And we'll take a new line, and we'll just say private string email down in here. And I think actually we should also add some messages for the not blank tags, which we can do. So we'll just jump back up here into the name annotation, and we'll add some braces, and we'll add a message in here as well. And then we'll say name is required, and we'll do the same for the not blank message for the email. We'll say message, and then we'll say string, and then we'll say email is required. So this just means depending on the type of error, the client will see a different error message and be able to handle the issue appropriately. So the next one we'll do is we will do the address. So we'll say that's not blank, add a message, and we'll say address is required. And then we can take a new line, and then we'll say private string address. So we'll just keep the validation a bit simpler for some of these things, just so we don't run into too many problems as we're going through the course. And the next one we'll do is add the date of birth. We'll say not blank, add a message, date of birth is required. And then we'll just say private string date of birth. And the last one we want to do is we want to do the registered date. We'll say at not blank, and then we'll say registered date is required, just like this. And then we can say private string registered. And then on a new line, we'll say private string registered date. So even though we don't send the registered date back in the patient response DTO, we still need a way for the admins of our patient management application to enter in a registered date. So on the front end, when we come to build out the form, the admin will be able to add a patient along with the registered date. But from that point on, the registered date is hidden in our internal systems, and the patient response DTO does not return a registered date for any of the patient requests. But this is the reason why we keep the patient request DTO and patient response DTO different in case we need to change the data that gets input versus the data that gets returned. And this should be it for all the properties. So what we'll do is we will put our cursor just below the list of properties, and then we'll right click, go to generate, and then we're going to choose getter and setter. And then we'll just choose all of the properties, and then down here, click OK. And this will generate the getters and setters for our properties. Okay, so now we have a DTO. What we can do is create the service function that will accept this DTO as an argument, and that will handle the conversion from the patient request DTO to the patient domain entity model before calling the repository to save the patient. So we'll see what this looks like now. And we will, so what you can do at this point is go to the patient service, but instead of going to the project and jumping through the file tree to find the file, what you can do is double tap shift on your keyboard. So do shift twice. And as you can see, it brings up this search thing. And up here, if you choose classes, and what you can do is search for patient service. So if you search for patient service, you can see it appears in the list here in the package. This is a quick way to jump between different files, and it's good productivity tool, as you can also search for different files and text and things like that. So it's a good habit to get into early. So from here on out, we're going to jump between our classes using this little technique. So go ahead and double click on the top result here, the patient service one. And as you can see, it brings us to our patient service file. So down here is where we added the get patients method in the previous section. So what we're going to do is scroll down, and just after this method, we're going to add a new line or two, and we're going to say public, and then we'll say patient response DTO, and then we're going to call this method create patient, and we'll open some braces, and then we'll say patient request DTO, and then we'll call the variable patient request DTO as well. So if we jump back to our little architecture diagram for a second, we are building the service layer for the create patient stuff. And just like the service layer returned a DTO in the previous section, whenever we built the get patients endpoint, it's going to receive a DTO as well, which it will get from the controller. So we haven't created the controller yet, but the service layer will receive the DTO and convert it to a domain model. So we'll jump back into our code, and inside of our function down here, we are going to say patient, new patient is going to be equal to, and then we'll say patient repository dot save, and then we'll open some braces. So in here, if you hover over it, we can see that it's expecting a patient entity. So this dot save method comes from the patient repository that we created previously, and it is a built-in JPA method that allows us to save an entity to the database. So this isn't something that we created, it's provided by JPA. So this save method expects an argument, but we cannot just pass in our patient request DTO in here because it'll give us an error, and it basically says that the types are not compatible. So what we have to do is we need to convert our patient request DTO to a patient entity model object. So let's delete this, and what we're going to do is go back to our patient mapper that we created. So hit double shift and go to classes, and then we'll do patient mapper just like this. So go ahead and double click it, and it will bring us to the patient mapper class. And if we have a look in here, this is where we added a static method that converts a patient object to a patient response DTO. So what we're essentially going to do is do the opposite of this and return a patient object from a patient request DTO. So it's going to be similar to this. So we'll scroll down, and down here, we're going to add a line or two, and then we'll say click static, and then this is going to return a patient entity model. So we'll say patient, and then we'll say to model, and then we'll open some braces, and then this is going to accept a patient request DTO, and then we'll call this patient request DTO as well. So just be careful with the naming and stuff here, because the autocomplete might be suggesting the wrong class. So it's the patient request DTO that we're passing in here, and that is what we're going to convert to a patient entity model. So in here, we can say patient is equal to a new patient object. So all we're doing is creating a new empty patient object, and we can add a new line, and then we can start using our setters to add properties to this new patient object. So we'll say patient dot, and then we'll do the name one first. So we'll say set name, and then in here, we're going to do patient request DTO dot get name. So all we're doing is we're taking the name from the patient request DTO, and we're setting it as the name on the patient object. So now it's just rinse and repeat for the rest of these. So we'll do the address. So we'll do set address, and then we'll get the address from the request. And then we'll take a new line, and then we'll do email, and then we'll take a new line again, and then we'll do patient dot set date of birth. And the date of birth is going to be a bit different, because if we hover over the set date of birth setter, you can see it's expecting a local date object, but on the patient request DTO, the date of birth is a string. So we just need to parse this, and we can do that by using the built-in Java packages. We'll say local date dot parse, and then we'll say patient request DTO dot get date of birth in here, just like this. And then the last thing we can do is say patient dot set registered date, and we could do similar to what we did with the date of birth. So we'll say local date dot parse, and then we'll just pass in the get registered date that comes from the patient request. And that's it. So now we've created a new patient object from the DTO object, and we can just return this. So we'll take a new line and then say return patient, and that should fix all of the errors in here. So now if we go to the patient service, and we'll scroll down to our create patient method, and what we can do now is inside of our braces in here, we can say patient mapper dot to model, and then pass in our patient request DTO. So that your code looks like this. So the patient mapper dot to model is going to return a patient object, which is why we can just pass this in here directly. So then that patient object gets passed to the save function of the repository, and then that gets persisted to the database behind the scenes, and we get a new patient, and the new patient record that was created gets assigned to the new patient variable here. So once that's done, we can convert the new patient variable to a DTO and then return it back to the controller. So IntelliJ has suggested this for us here. So go ahead and hit tab, and that's the end of our create patient method. Okay, so now we have a method that handles the conversions from DTO to entities and saves the entity to the database. We can add our controller function. We can add our controller method to our patient controller. So go ahead and tap double shift and hit tab to go to classes, and then we'll say patient controller, and this will open up our patient controller where we have added in the get patient request handler that we created previously. So just below the get patients method, we'll add a new line and we'll add our annotation, and this is going to be a post mapping. So anytime we are creating stuff, we use a post request. So, and we'll take a new line again, and then in here we'll say public response entity, and then we will add some angle braces here, and then we'll say patient response DTO, and then we'll call this method create patient, and then we'll add some braces, and then I'm going to add some annotations in here. The first one is going to be valid, which comes from the Jakarta validation package, and then we'll add a space, and then we'll add another annotation which says request body, which comes from the Spring framework package, and then over here we're just going to hit tab to autocomplete this so that it adds the patient request DTO type and then the patient request DTO object. So what these annotations do is that it performs the validation on our patient request DTO to make sure that all the properties match the validation annotations that we added to the patient request DTO object. So if we have a quick look at this, we added different validation messages depending on the property and the type and so on. So the valid tag is going to go and check all these things behind the scenes, and if any of the properties are in an error state, Spring is going to return an error to the client for us without us having to do anything. So that's a quite nice feature of Spring Boot. And this request body annotation is going to convert the JSON request to our patient request DTO for us. So we'll see how this works whenever we come to test this using the HTTP client. But for now, we're just going to continue with the rest of our controller. So inside of the body of our controller method, we're going to say patient response DTO, and then we're going to hit tab to autocomplete so that your code looks like this. So all we've done here is we've called the patient service, we've called our create patient method, and we've passed our patient request DTO to it. The create patient method is going to return a patient request DTO, and it gets assigned to this variable up here. So what you can do at this point, if you want to format your code, is do Alt, Control, Shift, and L on Windows, and this will bring up the format file, and then just hit run, and this will hopefully format the code a bit nicely for you. But at this point, all we need to do is return the patient response DTO that we received back from the patient service, which should have the new patient that was just created in it back to the client. So I'll add a few new lines in here, and then we'll just hit tab to autocomplete, and your code should look like this. So we're just returning a response entity, and we're saying that the status was okay, and then we're going to return the patient response DTO as the body. So the reason we return the patient response DTO back in the post request is that it's going to have all the latest and most up-to-date information as it comes back from the database. So this will include its ID, which the clients might need depending on what they want to do next. Okay, so at this point we can test our code using the HTTP client. So just check that you don't have any errors and stuff. If you do, just double check the imports are coming from the right place and so on. So go ahead and start the patient service application. After it starts, we're going to hide this, and we're going to jump into the project tree again, and under API requests, we're going to go into the patient service folder. We're going to right click, add a new HTTP request. Goes down here again, and we're going to call this create patient, just like this, and then hit enter, and then we can close this down. Okay, so in here, we can create a post request, which is similar to the get request that we created previously. So we're going to delete most of this. We'll just highlight the URL and the verb and hit delete. And then we'll change this to post, and then we'll add in our endpoint. So we'll say http:// and then we'll say localhost:4000/ and then we'll say patients. And all being well, you should see that IntelliJ has picked up the endpoint that we're trying to test here. So we'll just click this, and then we need to specify a content type this time. Since we're sending data, we have to tell the server what to expect. So we'll say content-type, add a colon, and then it's going to be application/JSON. So the request that we're sending is going to contain the new patient information in JSON format. So this is what we need to add next. We'll add a new line, and then we'll add some braces to indicate that this is the body of our request. And then we'll add a string, and then we'll say name, and then just add some text in here. It doesn't really matter. So I'll say John Doe, and then we'll add a comma at the end here, take a new line, and then we'll add email. And again, it doesn't matter too much what this is. Just put in a valid email. It doesn't have to be a real one. It just needs to be in the correct string type. And then we'll add a comma again, and then we can add address, and then just add a string, and then we'll add a comma again. And now we just need to add our date of birth, and then we can put in something here. It doesn't have to be real, and we'll add a comma at the end, and then we can add a register date, and we'll do the same again. So it can be whatever date you want, just as long as it's in a valid format. So I should mention here that the date is in the format of year, month, and then day at the end. So this is the standard that we're going to use. And the last thing we'll do is we'll change this comment at the top before we forget. So this just creates a new patient entity. And this is all we need to create a patient. So this is what's called the body of the request. So all the stuff inside the braces. And this is what gets converted to our patient request DTO so that we can work with it easily as Java objects. So with your patient service application started, so just make sure it's running, and go ahead and choose the run button on the left here, and it should bring up the services window again, and under HTTP request over here, you should see that you now have a new post request that was created, and in the window on the right, you should see that we get some JSON back in the response, and our response to the push request is 200. So this is all looking good. If we have a look at the response, you can see that we've got this ID. So the ID has been generated in the database at the point when JPA persisted our patient entity to the database. And at the point where we converted the patient entity to the patient response DTO, we also added the ID, and that gets returned in the response. So this seems to have worked, but what we'll do is we'll actually check our in-memory database just to make sure that this record appeared. So if we jump back to the browser and just go to the H2 console again and choose connect, and then what you can do is choose the patient table up here, and it should add in the select statement here, and then just choose run, and it'll probably be at the bottom. So if you scroll to the bottom of the results table here, I'll just close some windows so that we can see. If we scroll down here, you can see we have our John Doe, and then we've got our test@example.com as the email, and all the other fields have gotten saved as well. So this is good and shows that it's working. So the last thing we want to check is that the validation gets triggered correctly for an invalid request. So this is pretty straightforward to do. We'll just jump back to our ID, and we'll close the services window down slightly just so we can see the request up here. And what we're going to do now is we're going to delete the email and send it as an empty string and see what happens. So just set the email to something that looks like this. And then if we hit the run button to the left of our request and scroll up, we can see we get a response back, but the error code is 400 this time, which indicates a bad request. And if we scroll down, you can see we have a bunch of stuff in the response, and it gives us an array of errors. So if we have a look at this, we can see that the field is email, and if we scroll down a bit more, we can see that we have a default message which says emailed is required. So because we got an error response back, means that the patient was not saved to the database. So this is good. It shows that our patient endpoint is working, and some of our basic validation is working as well. So if you're having any issues at this point, again, have a look at the terminal or the console just to see if there's any error message appeared here, and just double check some of your syntax, the push request, and if you're still having issues there, have a look at the finished code on GitHub to compare your code to mine. So in this section, what we're going to do is we're going to have a look at how we can improve our error responses, and also how we can handle some business logic validation. So in our previous section, we tested what happened whenever we tried to create a patient that didn't have an email address, and we get a response that looks something like this, that has a status code of 400, and then we have a lot of information in the body of the response that describes the error. What we want to do is simplify this a bit so that it's clear to the client and to any calling front ends exactly what the error is. We also want to hide some of these implementation details from any of the clients, such as the name of our DTOs and the codes that are very Spring Boot specific. So to do this, we will go into our project tree on the left here, and we'll go into our patient service, into the source folder, and into the main package. And in here, we're going to right click on the main package and we're going to add a new package, and this is going to be called exception, just like this. And inside of this exception package, we're going to add a new Java class, and then we're going to call this global exception handler. So as the name kind of suggests, this is going to handle all of our exceptions, and it gives us some flexibility into how we actually handle the exceptions, as we'll see in a second. So go ahead and create this class, and we're going to annotate our global exception handler class with the controller advice tag. So we'll say @ and then we'll do controller advice, just like this. So what this class does is it lets us handle cross-cutting concerns, such as error handling, outside of controllers and our services. So this approach just means that we can centralize our exception handler logic, and it keeps our controllers and services clean in terms of code. So in here, we'll say @exception handler, and then we'll add some braces, and then we'll say method argument not valid exception class. So this is the name, and it's quite lengthy, but essentially this is going to handle any of the validation errors that get triggered when JPA validates the request DTOs in the request itself. So just after this exception handler tag, we'll create the method. So we'll say public response entity, and this is going to return a map. We'll say map in here, and then we'll add some more braces, and then we'll say string, comma, string. And we can import the map from the Java package. So just do Alt Enter, and this will import it for us. And we're going to give this method a name. So we'll call it handle validation exceptions. And if we scroll over, you can see that Spring has done some autocomplete here. So just press tab, and this will complete the signature. So what this does here is it's going to catch all of those JPA errors, such as email address is not valid or email address is required. And it's going to put everything into this variable here that we've called EX. So this is going to have a type of method argument not valid exception. So now that we have access to this, we can shape the response and be specific about what we want to return. This is what your code should look like so far. And inside of this method, we're going to create a new hash map. We'll say map, and then we'll tab to complete so that we end up with this statement. So we're essentially going to have a map with key value pairs of errors. And this is what we will return as JSON at the end of this method. So we'll see how that works in a second. But before we get to that, we need to get the actual errors from this method argument not valid exception class. So we'll take a new line after the map, and then we'll say x or ex dot get binding result. Then we'll say dot, and then we'll say get field errors. Then we'll say dot for each, and then we can say error, and then we'll add an arrow in here. For each error that there is in this for each loop, we're going to say errors dot put with some braces. And then inside of this, we need to provide two arguments. So we'll say error dot get field, add a comma, and then we'll say error dot get default message, just like this. And if you want, you can format this line by doing Alt, Control, Shift, and L on Windows, and it should make things a bit easier to read. So what we're doing here is we are taking all the errors from the exception variable that gets passed in up here as an argument, and we are getting all the field errors out of that variable. And then for each of the field errors, we're going to add the field, and we're going to add the message for that error to the errors hash map that we have defined up here. So by the end of this line of code, we should have a hash map up here with some key value pairs of object properties and any associated error messages for those properties. So now all we do is we return the hash map from this method, and then Spring will handle the conversion of our map to JSON, and then return the request and return those errors as the body in the response of the request. So we'll see how this works shortly. We'll just do return, and then we'll say response entity, and then we'll say dot add request, because add request means that there's something wrong in the request, and this will return a 400 status code to the calling client. And then we'll say dot body and pass in the errors like this. And that should be it. Now, when we make a request from our HTTP client with an invalid field, the Spring validation will kick in, and this code will intercept the response and handle the errors in a nicer way, and then return the errors to the calling client or the front end in a nice JSON format. So let's look and see how this works. So go ahead and start up the patient service application. And after it's started, we'll go back to our create patient.http file. And in here, we should have a request that looks like this. This is what we used previously. And what we want to do is leave the email address blank, and we will run this request and see what happens. So on the left, choose the run button. And as you can see in here, we have a much simpler response object telling us what the error is. So on the left is the field, and on the right is the description of the error. And these things are coming from our global exception handler class. So we can try this again if we exclude the email address field altogether here. So just leave it out from the request. And if we run this request again and have a look at the response, you can see that we get a different type of error and it says email is required. So this shows that our annotations are working, and depending on the annotation that gets triggered, the response error is going to be different. Okay, so now we have an idea of how request validation works. We can have a look at how to perform some business logic validation in our service layer. So in our ID, we're going to double tap shift and do tab to take us to classes, and then we'll search for the patient service. So this is where our service layer is for our patient app, and it's a good place to put any business logic that we will have around the creation of a specific patient. So business logic is typically things that are specific to the business goals and to the business needs, as opposed to a technical limitation. So what I mean by that is, if we take, for example, some business logic might be an email address must be unique. In terms of storing this in a database, there's no problem. But from a business point of view, it causes problems, because if we want to contact a patient and there are many patients who have the same email address, this is bad, as it means we don't really know who owns that email address. So this is so another example is that we can only register patients who are of a certain age or who are within a certain distance to a given hospital. And these are all things that we check for in the service layer. So we're just going to use the simplest example here of having a unique email address, just to give us an idea of how to perform some business logic and handle the error. So with that in mind, the first thing we're going to do is we're going to add a new method to our patient repository that checks if an email exists already. So we'll double tap shift and then we'll go to patient repository. It should appear at the top here. So hit enter and it will bring us here. So in here is where we have our patient repository, and it's not doing very much at the minute because it extends the JPA repository, which has given us all the things we needed so far. Whenever we want to add our own specific methods that we want to expose to the service, we must define them in here. So what we will do is we will say Boolean, and then we'll say exists. And as you can see, we've got some autocomplete here. And this autocomplete, or these options in the IntelliSense, are the things that JPA repository can expose if we wanted to, but we need to be specific about it. So we can say exists by, and then again, JPA have given us some options that we can search for. And as you can see, there are a lot of things that we get out of the box because we're extending a JPA repository. So for example, we can search for an address that contains a certain string or ends with a certain string, and there's a whole bunch of them here. So feel free to scroll down and have a look at the things that we can do with the out of the box methods. And when you're happy, what we want to do is say email in here and then hit tab so that the code looks like this. So all we've done is tell JPA that we want to expose a method to our service layer called exists by email, and we're going to pass in an email address, and we want to return a Boolean that tells us if this email exists or not. So if you're quite new to Java and Spring in general, this might seem a bit confusing because there's a lot of magic that happens behind the scenes thanks to how JPA works. But as we go throughout the course, we'll see a lot more examples of how this works and how you can create your own queries to pull data from the database using this sort of syntax. But for now, this is all we need. So we'll jump back to our patientservice.java class up here. And at the very top of the create patient method, we're going to add a new line, and we're just going to add an if statement. So we'll say if, and then we are just going to invoke the repository method that we just created. So we'll say patient repository dot exists by email, and then we'll pass in the email address that we get from the patient request DTO up here. And we're just using the getter to get the email and pass it to the repository. So if this turns out to be true, this expression turns out to be true, that means that there is already an email existing in our database and we can't create the patient. So what we'll do is we'll throw a new error. So we'll say throw new, and we're going to throw a custom exception this time. We'll say email already exists exception. And then we're going to open some braces. What we're going to do is we're going to pass in a string. So we'll add a string, and don't worry about this error just yet because we haven't created this exception class. And inside the string, we'll say a patient with this email already exists. And then we'll add a plus. And then we'll say patient request DTO dot get email, just like this. So anytime we use the throw new keyword, it's going to stop execution. So that means if there is an email address and the code enters into the if block, that's going to throw a new exception, and it will try and return a response at that point. So that means this code will never get called in the case that an email exists already for a given patient. So at this point, we are going to create a custom exception. So what we could do is use one of the built-in exceptions that Spring and Java provide, but they're quite generic and it often makes it difficult to find out what the problem is. So by using our own custom exceptions that are well named, it makes it easy for us as developers to trace in the logs what has happened for a given request. So to create a custom exception, we're going to go into the project and into our patient service main package up here and into the exception package, and we're going to add a new Java class, and then we'll call this email already exists exception, and this is going to be of an exception class. So as you can see down here, we've got this option for exception and the icon's different. So this is the one you want to pick and then hit enter. And as you can see, it's created the exception class for us. So this is all we need to create a custom exception. And you can see it extends the runtime exception. So this is why we tend to use our custom exception, because if we didn't use a custom exception, the error that would be thrown would be of type runtime exception, and that can mean literally anything. And it's sometimes hard to debug what the reason is. So we'll see how this helps us debug in the logs as we test this feature after we're finished coding it up. But for now, all we want to do is double tap shift and we'll tab to classes, and we're going to go into our global exception handler that we created previously. So go ahead and jump into this. So in here is where we have the controller device, which acts as, in this case, a global error handler. This is where we can use our new email already exists exception. So just after the previous exception we added, we're going to take a new line down here and we're going to add a new one. We'll say at, then we'll say exception handler, and then we'll open our braces. And then in here is the class of exception that we want to handle. We'll say email address already exists exception dot class, just like this. We'll take a new line after this annotation, and then we'll say public, and then we'll say response entity. And just like before, we'll return a map, and then we'll return string inside this to say that we want a map of key value pairs of type string and string. And then we'll add some angle braces again just to close this. And then we'll call this handle email already exists exception. And we will get the argument. So we'll say email already exists exception, and then we'll just call this X, just like before. And then outside of this brace, we'll add some curly braces just like this over here, and then we'll hit enter. And then let's format the code so that's easier to read, so that your method should look like this. So we've got a handler, and it's going to handle the email already exists exception. So now what we can do is we can create a map just like we did before. We'll say map, and it's going to be string. It's going to be a new hash map. And all we want to do here is say errors.put. This time we just want to specify a generic message. So we'll just say message, and then we'll add a comma, and then we'll add a string, and then we'll say email address already exists, just like this. And once we're done, all we have to do then is return the response entity along with a bad request status code, and we'll just pass the errors in like this to the body, and they will get returned to the client. So this is an example of how we can add very specific exceptions and error messages for any of the business logic in our code. So as we go through the course, we will make some more of our own custom exceptions and see how they work in terms of the response and in the logs. So just before we test this, what we're going to do is add a logger in here, and we'll add a custom log message that will get displayed in the console when the app is running. And this is purely to help us with debugging and to find any errors in our code. So if you type log, and hopefully IntelliJ will suggest some things, and what we want to do is choose the top one here. So it's org sl f4j.logger. This is the most common logger that's used in Java and Spring enterprise projects, and is what we will be using today. So go ahead and hit enter, and as you can see, it's changed color. And if we scroll up a bit, you can see up here that it's created a static logger, and it's initialized the log variable for us. So this is what we can use to display our own custom error messages in the console. So we'll say log.warn, and then we'll say email address already exists, and we're going to open and close some braces here. So this is a placeholder syntax. So in order to fill the placeholder, we'll add a comma after the string, and then we'll just do x.getMessage. So now anytime we receive a request to create a patient that has an email address that already exists, we should see the log message in the terminal. So we'll just log out the text that says email address already exists, and then we're going to print out the message as well in case it gives us any valuable information that we might be missing in our own custom string here. So after that happens, and then the response gets handled down in here. So there's 2 steps to the exception handler. One is for the client and one is for ourselves to catch any bugs. So that's pretty much it for adding our custom exception handler. Now, anytime the email already exists exception gets thrown in the code, it's going to get handled in this dollar advice. So before we can test this, we need to configure the log levels for our app. So we'll double tap shift, and then if we search for application properties, you can see it appears as the top option up in here. So we'll just choose this, and this is where we have all of the configuration for our app so far. At the very bottom, we'll just add a new one, and we'll say logging.level.root is going to be equal to info. So what this means is that we're telling our Spring app that we want all info, warn, and error messages to be logged to the terminal or the console. So after we've done this, we can go ahead and start our patient service application. Oh, and we have an error in the build output that says cannot find symbol, and it's telling us where it is. So anytime you see these sort of things, it should tell you where the file is and the line. So just go ahead and click this, and all that we have forgot to do here is import our custom email already exists exception into our patient service. So just hover over this, and then you can choose import class or do alt and enter, and the error should go away. And after you've done this, you can open up your build window again, and at the top we'll just choose the run patient service application, and hopefully this time everything starts up okay. So now what we want to do is we want to try and make a request to create a patient with an existing email address. So we'll close down some of these things to tidy our workspace, and we will minimize the terminal for the minute, and then we'll do double shift, and then we'll say create, and do dash, then patient, and we'll open up the createpatient.http file. And what you want to do is put an email address back in, something like this. So ideally what you want to do is add an email address here of one of the patients that exists already. But what you can do is you can add an email address and then run the request the first time to create the patient, and then the second time you try to do it, it should fail because the email address doesn't exist. So let's see what happens. I run this request, and let's have a look at the services. And it said created, so that's okay because I didn't have an email address with that patient stored in the database. But if we run this a second time, so just click run up here, we can see we get a 400 error, and we get a message that says email address already exists. So this is good, as is what we want. So it shows that our custom exception handling is working. And now if we have a look at the console, we can see we have some warning messages here. So if we look at these and scroll over, so we can see we've got a warning from our global exception handler, and it says email address already exists. A patient with this email address already exists. And then we've got the email address that it tried to create. So apart from some formatting issues in here, this seems to be working. And then we have another one, and this one is specific to the email already exists exception. And then you can see that this gets logged out again. So you can see how easily it was to see why a request failed in this case, because we were able to just scroll down the logs, and then we seen our warning, and we had some nice clear error messages that appeared in the logs. So this would look a lot more verbose and harder to see and harder to spot and things if we didn't add our custom error handling, because it would throw a runtime exception and it's hard to know what happened. So this is one of the benefits of using the logs. Okay, so now that we can get and create patients from our patient service, the next thing we're going to learn how to do is how to update a patient in our database. So we'll start by double tapping shift and then tab, and we're going to go into our patient service. We'll say patient service, and it's going to be the top one. And in here, we'll scroll to the bottom, just below the create patient function or method, and we'll take a new line in here. And what we will do is create the method which will handle the business logic for updating a patient. We'll say public, say patient response DTO, and then we'll call this function update patient, and then open some braces. So in here, we're going to accept 2 arguments. The first one being the ID of the patient we're going to update. So we'll say UID, and then we'll say ID. And then the second argument is going to be the patient request DTO, and it's going to be of type patient request DTO. Go ahead and add the import for the UID class from the java.util package, and then we will format our code so that it looks like this. So whenever we update a patient, we're going to receive a patient request DTO object, quite similar to what we did whenever we created a patient in the method just above. The only difference is this time that we are going to update a patient, and that's why we need to know the ID of the patient that we're going to update, and this will come from the request as well. And we'll see how that works whenever we code out the controller. But for now, we're going to add the logic to our update patient method. So in here, we'll add a few lines. And first thing we need to do is get the patient that we're going to update by its ID. So we'll say patient, and then we'll call this patient, and then this will be equal to patient repository. Then we'll say dot, and then we'll say find by ID. So IntelliJ has given us some hints here, and we will pass in the ID up here. So what this method's going to do is it's going to find a record in the database where the ID column matches the ID that we pass in. And it's going to return an object, and it's going to assign it to the patient variable. Now we have an error, and if we hover over it, you can see in here that it says that the provided type is of a type optional, and then inside the braces you can see that it's got the patient type within it. So what this means is that an optional type means that there's a potential that the repository couldn't find a patient with the ID, and it's going to return null. So what we can do is we can handle this case by chaining a conditional on to the end of this statement. So over here, just after the last brace, we're going to say dot, and then we will say or else throw. And inside of the braces, we're going to add some more braces. We'll add a dash and then add a right chevron to create an arrow. And then we'll say new patient not found exception. And then we'll add some more braces, and then we're going to add a string, and then we will say patient not found with ID, and then we'll add a colon, add a space, and then after the last speech mark, add a comma, and then we'll just pass in the ID and go ahead and format the code just to make things a bit easier to see. So we'll scroll over again, and this is what your code should look like. So don't worry about this exception because we haven't created it yet. But essentially what's going to happen here is that the patient repository is going to try and find an entity by its ID. If not, it's going to throw the new patient not found exception, and we will handle that exception in our advice like we did with the other custom exceptions that we made so far. If it does find a patient, then it's going to assign it to the patient variable over here. So let's go and create our custom exception before we continue, just to get rid of this error. So we will go into the project, and in here, we're going to go to the patient service, and we're going to go to exception, and then we're going to add new Java class, and then we'll call this patient not found exception. And this is going to be of type exception. So go ahead and select this and then hit enter. So that's all we need to do in here. And then we'll jump into our global exception handler over here in the exception package. And then we will scroll to the bottom, and we're going to create a new method that will handle the patient not found exception. So we'll add a few new lines in here. We'll say at exception handler, and we'll open some braces, and then we'll say patient not found exception dot class. So after this, we can take a new line, and then we can just hit tab in here to create the method signature. And then for the argument, it's going to be patient not found exception, and then we'll call this EX. And then we'll add some braces to the end, and then we'll just format our code so that it looks something like this. So now in the body of our method, we just need to do similar to what we did up here, and that's create a map and then return an error back to the client so that the client knows what happened. So inside the body of our method, we will hit space, and then we'll say map, and then tab to autocomplete so that it creates a hash map called errors. And then we'll say errors.put, and then we'll just tab to complete this as well. And we're going to add a property to our map called message, and it has a value of patient not found, and this is what will get returned in the response of this request. So on a new line, we'll just say return, and then we'll tab this as well to complete this line. And this is what our exception handler is going to look like. And the last thing we will do is we will add a log message for ourselves just to add some context to the logs if we get an error during the update so that we're able to identify what the problem is. So just after the open brace up here, we're going to add a new line, and then we'll say log, and then just hit tab so that IntelliJ completes the code for us. And all we're doing here is we're going to say patient not found and log out the message just in case there's some additional detail in there that we can use. This completes the exception handler for the patient not found class. So now what we can do is jump back to the patient service.java class, and we can import the patient not found exception to get rid of the error. And now we have an error over here because we have provided two arguments, but our patient not found exception only expects a single string. So all we have to do is change this comma after the closing speech mark to be a plus, and we can use string concatenation instead. Okay, so now at this point, we've handled the patient not found scenario, so we can assume that we have a patient. And the next thing we want to do is check that the email address in the request does not exist in the database. So this is similar to the code that we wrote up here in the create patient. So we added this if block that checks if the email in the request already exists in the database. And if it does, then we throw an email already exists exception. So this is what we want to do. So we'll just copy and paste this. Just copy from the bottom of the tag to the if statement up here, and then do Control C or Command C if you're on a Mac, and then we'll scroll down and then we'll just paste it just below our statement here, and it should all work the same. So this is okay to copy and paste code because we're only using it in 2 places. If we were using it in more places, we would probably extract this out to its own function. So it's up to you if you want to do that. In the end, the code should all work the same. So now that we've checked if the email in the request exists or not, and we've handled that case, we can now update the patient. So the way we update the patient is we update the object that we received back as the patient variable after the call to the repository completed using its getters and setters. So let's see what this looks like. So down here, after this brace, we'll just add a few new lines, and then we'll scroll down, and then we'll say patient, and then we'll do set name, and then we'll do patient request DTO to get name. And that's essentially it. So we just do the same for all of the properties. We'll say patient.setAddress, and then we'll get the address from the DTO, and then we'll do patient.set email, and then we'll get the email from the DTO, and then we'll do patient.set, and I think the next one we can do is date of birth, and then we'll get this from the request DTO as well, .get date of birth, just like this, and then we're going to get an error because we need to convert the string date of birth that we get in the patient request DTO to a local date. So all we have to do is just inside the first brace here, we're going to say local date dot parse, and then add an opening brace, and then at the very end over here, just before the semicolon, we'll add a closing brace. And I think that's all the properties that we can update, because we do not allow the registered date to be altered after it's created, and we never update the ID of a patient after it's been created as well. So this is why we update each property individually, because it gives us control over what property that we want to update during the request to update the patient. So now what we can do is, after we've updated the patient object, is we can save it back to the repository. So we'll take a new line, and then we'll say patient, and then we'll hit tab, and then we'll say updated patient is equal to patient repository save, and then it's going to save the new patient. So JPA will handle the update for us, and then it will return the updated patient record as an object and assign it to the updated patient variable here. So now what we can do is return an updated DTO object with this updated patient back to the controller so that it can complete the request. So we'll say return, and then we'll do tab to complete the code, and then we'll have patient mapper dot to DTO, and then we'll pass in the updated patient in here, just like this. Okay, so now what we can do is we can jump into the controller and create the request handler that will handle the request for updating a patient. So we'll double tab and then say patient controller, and then we'll jump in here and we'll scroll to the bottom, and then down in here we'll take a few new lines, and this time we're going to use a put mapping. We'll say at put mapping, and we're going to open some braces, and we're going to add a string, and then we're going to say slash, open some curly braces, and then we'll say ID. So anytime we are updating an entity, we use a put request, and anytime we want to use a put request, we normally use it in association with an ID so that we know the ID of the entity that we are going to update. So the ID inside these braces tells Spring that we want to convert the UID that we get in the request to an ID variable. So for example, if we get a request to localhost :4000 /patients/ and then a UID, which will look like this, then Spring is going to convert this part of the request into an ID variable and pass that variable to our update patient method, which handles the request. So we'll take a new line in here, and then we'll just do tab to trigger the autocomplete, and we're going to say public response entity, and it's going to be of type patient response DTO, which is going to be the return type, and then we'll just call the method update patient. And then in here we're going to say at path variable, add a space, and then we'll say ID, add a space, then we'll say UID, and then we'll say ID. So this path variable annotation tells Spring that this is the variable, this ID variable, that we want to map to the path variable that we receive in our put request. And the next thing we need to pass in is the request body. So in here, just after ID, we'll say comma, and then do at, and then we'll do request body. And if we scroll over, you can see that Spring has guessed what we're trying to do. So hit tab and it will add the autocomplete. And then we will format our code just to make it easier to see. So this is what your method signature should look like. And this line means that the updated patient data that we receive in the body of the request as JSON is going to get assigned to the patient request DTO. Okay, so now we have these things, we can start to implement our update patient method. So we'll take a new line inside here, and then we'll say patient response DTO, and then we'll hit tab to autocomplete, and we should have patient response DTO. And we also have a variable called patient response DTO, which is going to be assigned the result of the call to the update patient method on the patient service. And we need to pass in the ID. So we'll say ID, and then we'll hit tab, and it will automatically pass in the patient request DTO as well. So at this point, we are going to have a updated patient response DTO object with the new patient details that were just saved to the database. So all we need to do is return this. So we'll take a few new lines in here, and then we'll just hit tab to complete the method and return the patient response DTO as part of the body of the response entity with an OK status code. And that's pretty much it for the put mapping. Okay, so at this point, what we can do is we can test the update patient endpoint using a HTTP request. So to do this, we will jump into the project panel on the left, and we're going to go into the API request folder, which is just inside the patient management folder. And in here, we will go into the patient service, and we're going to right click on patient service and then go to new. And down in here, we're going to select the HTTP request option. So go ahead and choose this, and then we'll call this update-patient.http. So go ahead and hit enter, and then this will create a skeleton HTTP request that we can add our code to. So since the update request is going to be similar to the create patient request, and it uses the same request DTO, what we can do is copy the create patient request into our update patient HTTP file. So over here, we'll choose create patient, and we will just grab all this and do Control-C to copy, and then we'll jump back to the update patient.http file, and then we will replace the contents in here with the stuff we just copied. So go ahead and delete the existing stuff and then do Control-V. So there's a few things we need to change in here before we can test our update endpoint. So the first thing we will do is update the comment at the top, and we'll change this to say updates an existing patient entity, just like this. And then we'll change the verb. So the verb is this orange text here, and we want to change this from a post to be a put, just like this. And because we are updating a specific patient, we need to provide an ID in the URL. So the best way to get an ID of a patient that we know exists is to take an ID from the seed data that we used whenever we initialized our in-memory database. So in the project tree, we're going to go into the patient service on the left, and then we'll scroll down until we see the resources folder, which is down here. And then we'll open this up, and then we will go down to the data.sql file. And if we open this up, you can see that we've got all the SQL data, which is the raw queries, which adds data to our database. And if we scroll down, you can see each of the insert statements has a well-known ID. So what we can do is just take the ID of the first patient here. In this case, it's going to be John Doe, and we'll just copy the ID inside of the string, inside of the quotes, and then we'll jump back to our update patient.http file up here, and we will paste it in the URL over here just after a slash. So we'll say slash, and then we'll paste in the ID just like this. So the content type is going to be the same, and it's going to be JSON. And in the request, the only change we need to make here is we need to take out the register date because the business logic of our app says once a patient has been created, the register date cannot be changed. So at this point, we are ready to test our update endpoint. So before we send this put request, what we will do is we'll update one of these values just to show that it does actually get updated in the database. So what we'll do is change the email address. We'll just change this to something else. So we'll say test2@example.com. And then we will go ahead and hit the run button on the left here. And in the services window, we should see that we get the new patient back in the response, and the email address has been updated. And then we also get a 200 status code. So this is good. It shows that our endpoint is more or less working, but we're going to try another scenario here and we will see what happens. So in the request, what we're going to do is we're going to take out the email address field altogether, and then we're just going to hit send again on this request. So just choose the green arrow on the left again. And this time we get a 500 error back. And then we also see in the response that we get an internal server error, and then we get a could not commit JPA transaction. So this is because we haven't enabled the validation to happen in the controller for the given patient request DTO. So that means that the blank field for email address is making its way all the way to the repository layer, and it's trying to be saved there. And JPA can't save an empty field because it's marked as required on the database, and then it throws this big scary error. So to fix this, what we'll do is we will jump into the patient controller.java class up here, and we'll scroll down to our update patient endpoint method. So as we can see in here, even though we are using the patient request DTO, and if we have a quick look at this, we have specified that these fields have to match a certain criteria. We haven't told the controller to trigger the validation checks, and all we have to do in here is we just need to add a validated tag to the request body variable in the arguments of our method. So just in here, before the request body tag, we'll say @ and then we'll say validated, open some braces, and then we're going to pass an object in here, and then we'll say default.class. What this does is it tells Spring to validate the request using all the defaults that we specified in the DTO. So at this point, we can restart our patient service application by choosing the rerun button at the top. And once this is started, we can hide the run panel, and then we can jump back into update patient.http file at the top. And what we want to do is still leave out the email address this time, and we want to hit run. And this time, let's see what happens. So if we scroll up, you can see we have a better error response this time. So we have a 400 bad status code, which is good, as this tells the client that something went wrong. And down in here, you'll also notice that the error message is better. So it says email is required. And if we try to add the email address back in, so we'll just add our email back in. And this time we're going to pass in a blank email to see what happens. So go ahead and hit the run request button. And if we look at the services window, you can see we get the same error for the email address. So this is good as it shows the validation is working in our patient request DTO. So you'll also notice that we have an additional error here, and it says registered date is required. So this is a bit of a problem because we have said that we don't want to provide a registered date whenever we are updating a patient, but we do provide it whenever we create a patient. And because we are using the same DTO, the validation is being triggered for this field. So there's a few things we can do to solve this problem. We can create another DTO called update patient request DTO that does not have this field anywhere in it, but that would make our code a bit too verbose, as we would have an additional class to maintain. So the second option that we have is to use validation groups. So this is a concept where we can add an additional tag to the controller to tell it to validate specific fields depending on if it's a post request or an update request. So what we're going to do to see how this works is we're going to go into the project, and under the patient service project, we're going to go into the main package in here, and we'll just right click on the DTO folder down in here, and we're going to add a new package this time, and then we're going to call it validators. And inside the validators folder that was just created, we're going to add a new file, and we're going to call this create patient validation group. And this is going to be an interface. So go ahead and choose interface from down here and then hit enter, and this will create a new interface for us. So this is all we need to do in here. So all we're doing really is we're creating an interface for a new validation group, and we don't have to add any properties to it. All this does is create a group that we can add things to in different parts of our code. So we'll see how this works now by double tapping shift, and then we're going to go into patient request DTO.java, and this will bring us to the file where we have our validation in our patient request DTO. So we're going to scroll down until we see this one where it says registered date. So this is where the problem is, because as you can see, we've added the not null annotation that has a message in it. And then we've also, which is fine for the create request, but whenever we are updating a patient, we don't want to send a registered date because we don't want to be able to update it after it's been created. So this works for the create, but it doesn't work for the update. So the way we fix this is we will change this tag to be not blank. And then just inside the first brace here, we're going to say groups, and then this is going to be equal to create patient validation group dot class. And then we'll add a comma so that our code looks like this. So all we've done here is we've said that we want the registered date property to be part of the create patient validation group class that we just created. And we'll scroll down until we see the getters and setters for the registered date, and then we can just delete those as we don't need them anymore. And I don't actually think that these are required on getters and setters because they're added to the actual property up here. So I think IntelliJ was being a bit too helpful for us whenever we generated our getters and setters, but it shouldn't do any harm to leave those in for the rest of the properties. But just to be safe, we'll take it out of this one. And once we have the registered date property added to our validation group, what we will do now is we'll double tap shift and go into the patient controller. So we'll go into patient-controller.java, and we're going to scroll to our getPatient method. So it should be this one in and around line 37, depending on how your IDE set up. And this is where we added the valid tag previously. So all we have to do is change this to use the same validated tag that we used in the update patient method down in here. So we'll just change this to say validated, and we'll add some braces, and then we're going to add an object in here, and then we'll say default.class, add a comma, and then we'll say create patient validation group dot class, just like this. So this validated tag does the exact same thing as the valid tag that we just removed. The only difference is we're being a bit more specific about the things that we want to be validated during this request post method. So whenever we create a patient, it's going to run all the default properties that exist in the patient request DTO, and it's also going to run any additional checks for properties that are tagged with the create patient validation group annotation in our DTO. So if we quickly jump back to the patient request DTO, any classes that do not have the groups annotation in them are assigned to the default class, and the registered date property belongs to the create patient validation group class because we specifically specified it in our DTO. So this is why we have to specify the default class as well as the patient validation group class in our patient controller. So this means that anytime we create a patient, we're going to have additional validation kick in for the registered date field. And anytime we update a patient, the registered date field is going to be ignored in the validation because we haven't specified the group in the validated tag in here. So now what we can do is rerun our application, close some of these tabs just so we don't confuse ourselves. And then we'll jump back into update patient.http file. And in here, we're just going to add an email address back into the request so that we can do an update. So we'll just change some of this about again. So we'll do test_updated, just so it's clear that this is the property that we are going to update. And this time, whenever we trigger the put request, it should not return the error that we've seen previously. So if we look at the services tab, and if we look at the last result we got back from the put request, so a good way to do this is to look under services, and then under HTTP request, you can see the most recent request that you run. So just click on the put update patient one, and in here is a reminder of the error we've seen before we changed our code. So these should both disappear now because we are going to enter a valid email address, and because we're doing a put request, the registered date field should be ignored because we've added our new validation code. So go ahead and hit run. So you can choose this green icon here or the one to the left in the actual request itself. And this time you can see that even though we didn't send a registered date this time, it didn't cause any problems because we got a 200 result back, and also our email address for John Doe got updated. So this is good. It shows that we're able to validate our put request now. So we're just going to double check our create patient request to make sure we haven't broken anything there. So on the left, hopefully you will see the post create patient request. If not, just go and grab it from the API request folder in the project tree and double click it, and then it will open up the request. So the main thing we want to check in here is that we haven't broken the validation for the registered date anytime we create a patient. So we'll change some of these about so that the fields are unique. So just add some new values in here. And what we'll do first actually is we'll delete the registered date just to see if the validation triggers. So go ahead and delete this property for now, and then go ahead and hit the run button on the left. And if we open up the services window, in response, you should see we have a 400. And this time we didn't include the registered date in our request to create a patient, and we get an error back that says registered date is required. So this is a good example of how to use validation groups to specify different properties that we want to include for different types of requests without having to create different DTOs. So just for completeness, what we'll do is we'll open up our create request again, and we'll just add in the registered date again and run this request just to check that the patient does indeed get created. If we look at the services window, you can see we get a 200 back, and we get an ID and some JSON data for a patient, which means the patient is getting created successfully. Okay, so at this point, we're going to fix our first bug that we've encountered in our app. So to see what the bug is, what we're going to do is create a put request to update a patient. And what you want to do is go into the data.sql file in the resources folder, and you just want to grab the ID again for the John Doe user. So this is the user that we're going to try and update. So just grab this and then jump back to update patient.http file up here, and then just paste it in after the slash over here. And then we also want to grab the email for this user as it gets inserted into the database. So when the database gets seeded, John Doe gets populated with johndoe@example.com. So now if you try to update the name, so for example, let's say John Doe, and then we'll just say updated in here, and then we'll keep everything else the same as it is in the database. And then if you hit run on this request, and if we have a look at the service response in here, you can see we're actually getting a 400 error, and it says email address already exists. So this is a bit unexpected because we only changed the name, but it's trying to update the email address again in the database. It's seeing that the email address already exists in the database, and then it's throwing an error. So to fix this, you will double tap shift, and then we're going to go into our patient service.java class, and then we're going to scroll down until we see the update patient method. And this is where the problem is. So if we scroll down, we added this code previously in the course where we check the email address that we receive from the patient request DTO, and then we check if this exists in the database. If it does exist, then we throw an error. So there's a problem with this code. If you want to have a go and try and fix it yourself, you can pause here. And a hint I'll give you is that it's got something to do with this, or to be specific, it's got something to do with this line here. So feel free to pause here and try yourself. Otherwise, code along with me and we'll fix this error. So whenever we try to update the patient, we have a patient request DTO, and this request is going to have an email address in it. So what's happening here is that whenever we have this check to check the database for an email address that already exists, JPA is finding the email address that already exists for the user that we are trying to update, and it's thinking that there's a clash. So all we have to do is write a new repository method that ignores the user, that ignores the email address of the user that we are currently trying to update. So what we'll do is we will double tap shift, and then we'll go into our patient repository.java, and then in here we're going to add a new method to our interface. So we'll say boolean, and then we'll say exists by email, then we'll say and then we'll say ID not, and then open some braces, and then we'll pass in string email, and then we'll pass in a UID as an ID. So now what this method will do is that it will go and search the database for any patients that have an email address for the patient that we're trying to update, but it will ignore the patient that we're trying to update in its search results in it. So hopefully that makes sense. And now that we have this new method, we can jump back to our patient service, and in our update patient method down here, we have the line where we call the repository to check for the email. All we have to do is say patient repository dot, and then say exists by email ID not. And over here, we just have to add a comma before the second last closing brace, and then we can pass in the ID like this. Essentially what this code now does is it checks whether there is another patient in the database with the same email as the one I'm trying to update, but with a different ID. And then if the patient exists, it's going to throw the same error that we've seen before. So what happens now is that this code will check if there is another patient in the database with the same email as the one we are trying to update, but with a different ID. So this just stops JPA from incorrectly flagging the email as duplicate, even if we're trying to update the same record in the database. Okay, so now that we've got this, we can restart our patient service application, and then we will jump back to our update patient.http request. And this time, if we try to update our John Doe patient by changing the name, I'll keep the email address the same as what is in the database. And if we try to run this request and have a look at the service, you can see that this time the name gets updated successfully and all the other fields are kept the same. Okay, so that rounds it off for the update patient endpoint. And we've added some robust validation, both in the controller layer and also in the business logic when we validate our email addresses as well. Okay, so the last endpoint that we will build in our patient service is going to be the delete endpoint. So this will round off our CRUD operations when it comes to interacting with a patient using our REST API. So with our IDE open, we will double tap Shift and we're going to go into the patient service. We just type patient service and it will be the top one here. So patientservice.java. So in here, we're going to scroll to the bottom and just before the closing brace, we're going to add a few new lines and we're going to say at, and it will say delete mapping. And in here is where we will build out the service method that we need in order to delete a patient. So we'll say public, then we'll say void as there's not going to be anything to return here. And then we'll just hit tab to autocomplete and this will give us the delete patient method that accepts a patient ID as a UID. Inside the braces, all we have to do is call the patient repository. So again, we'll just hit tab to autocomplete the code and we just say patient repository.delete by ID. So the delete service method was pretty straightforward in terms of code as we don't have to run any business logic at the minute. So we just directly call the repository. But the reason we still use a method in the service layer is so that it makes our code more extensible. And what I mean by that is if we ever need to add business logic to delete a patient in future, we can simply do it in this method without having to do any refactoring. And it also follows the pattern that we have been using so far. So now that we have this, we can double tap Shift again, and then we'll say patient controller.java, and this will take us to the patient controller. And again, towards the bottom of the file, we'll take a new line just before the closing brace. And in here, we'll say at, and then we'll say delete mapping, and then we'll open some braces, and then we'll add a string. And then we're going to say slash, and then we'll add some braces, and then we'll say ID. So just like the put request method that we did previously up here, we pass in an ID in the URL, and then Spring will parse the ID and provide it to us as a path variable. So after the delete mapping annotation, we'll take a new line, and then we'll say public response entity, and then we'll open and close some angle braces, and then we'll say void, as this isn't going to return anything. And then outside the last brace, we'll say delete patient, and then we'll just hit autocomplete to give us the signature. So what we should have now is that we have a delete patient method that accepts a patient's ID, which we get from the URL of the delete request. And this is going to return a response entity, but it's going to be empty because there's not going to be anything to return in this case. And inside of our method, we will say patient service.delete patient, and then we'll just pass in the ID just like this. And then on the next line, we'll say return response entity dot no content dot build. So what this does is it's going to call the patient service and call the delete patient method, which will then delete the patient from the repository. And then it's just going to return a response entity here with no content, and that will return a status code of 204. So 204 means no content. And then it's just going to complete this request. And that's pretty much it for a delete endpoint. So it's nice and straightforward in terms of the code. So all we need to do now is test this. So we can start our app, and we'll go to the project folder on the left. And what we're going to do is scroll towards the top, and we're going to go into the API requests folder and right click on patient service, and then we'll choose new, and then we're going to choose HTTP request, and then we'll call this one delete patient.http. It's like this, and this will give us an example in our code. So in here, we will update the comment. So we'll just say delete an entity, and can delete the boilerplate code that it gave us as well. And this time we're going to use the delete verb. So anytime we want to delete something, we use the delete request, and then we just have to pass in an endpoint. So we'll say http://localhost:4000, and then we'll do /patients, and then we just need to get an ID. So again, you can just grab an ID from the data.sql file. So we'll jump into the project and scroll down until we see the data.sql file in the resources folder. And from here, we're just going to pick an ID of a patient that we want to delete. So in this case, we'll just delete the John Doe patient. So we will go back to our delete patient.http file after we've grabbed one of the IDs, and then we'll just paste it in here after the trailing slash. So then this is the ID of the patient that we're going to delete. So go ahead and start the app if you haven't already. And then in the delete patient HTTP file, we're just going to hit run on the left hand side here. And then we'll have a look at the response. And as you can see, it says here, its body is empty, which is what we expect because there's nothing to return whenever we delete an entity. And we have just returned a status code of 204, which informs the client that there is no content to display. So on the face of it, this seems to have worked. So what we'll do is have a look at the web console. So in the browser, just go to localhost:4000/h2-console, and it should bring up this login screen, and then enter the details just like we did before. and then hit connect. And this will bring up the actual console. And then if you click on patient, it'll say select star from patient, and then just choose the run button up here. And this will run the query against the database and display all the rows. And if we have a look in here, we can see that John Doe has been removed from the database. So this is good. It shows our delete patient endpoints working. And one thing to note about the way we have set up our app so far is if you stop and start the patient service application, it's going to perform the persistence stuff again, which means the data SQL file is going to run. So if you see John Doe appear in here after you start the app, this is probably why. So each time you start the app, you get a fresh bunch of data, which is nice, but sometimes it can cause a bit of confusion. So just keep that in mind. If you're seeing any problems up until this point, have a look at the terminal and also have a look at the finished code in the example to compare your code to mine. Okay, so now that we have built some endpoints in our patient service, we're going to look at how to use OpenAPI and Swagger to generate our documentation that describes what our API does. So documentation is really important as it allows other developers and even third-party integrations to interact with our API if we allow them to do so. So what OpenAPI and Swagger is that it's a tool and a standard for designing, documenting and interacting with APIs. So it's a very common one that's used by a lot of enterprises throughout the world to document their APIs in such a way that it's usable by others. So if you go to the Swagger website, it gives you an example of what some documentation would look like based on an OpenAPI specification. So if we scroll down, you can see that it gives us a number of endpoints and a short description about what those endpoints are. So for example, if we stored a bunch of pets in our database and we had a bunch of endpoints that allowed us to interact with the service to retrieve and update those pets, we would use these endpoints. So for example, a push request to /pet would add a new pet to the store. And then if we open this up, you can see that it shows us not only the endpoint URL, but also what the request would look like. So here's an example of some of the things that we would be able to add if we were adding a new pet to this database, and this would go in the body of the request, as we can see over here, and it's a required field. And if we scroll down again, you can see that we would get some responses back and things like that. So this is a very common thing that you will be working with in enterprise environments, especially when working with APIs. So it's important to know how to build one and also how it works. So the good thing for us is that there is a package that's available for Spring Boot that helps us generate this documentation based on our controller endpoints. So if you go to springdoc.org, it will bring you to this webpage, and you should see a package called springdoc-openapi. And if we scroll down a bit, you can see there's some information about it here. So this is a Java library that helps us automate the generation of API documentation in Spring Boot projects. And it supports Spring Boot 3 down here, which is good. And it gives us the Swagger UI, which is the thing we just looked at over on the Swagger website over here. So this is what's called the Swagger UI. So we will get this for free as well, which is good. And there's a bunch of other things as well. So feel free to have a look at this website. There's a video here as well that explains how it works. And once you're ready to get started, scroll down until you see the Get Started tag here. And inside of this section, you'll see the dependency that we need to add to our project. We'll go ahead and copy this dependency, and then we're going to go to our project, and in the ID, we're going to double tap shift, and then we're going to go to pom.xml, and this should be in the patient service. So as you can see here, it's the patient service one. And if you click it, it will bring us to our pom.xml file. So in this file, we have a bunch of dependencies that we've added so far to our project that we need to make it work. So all we're going to do here is scroll towards the bottom, and just above the closing dependencies tag, we're going to take a new line, and then we're just going to paste in the dependency that we just copied. So you might be seeing a red error here around the version or around the artifact ID, and that just means that Maven is unable to resolve this dependency. So we fix this, we can open up our project tree, and in the patient service over here, we're going to scroll down until we see the pom.xml file, and it should be towards the bottom here, and just right click this, and in the menu scroll down until you see the option that says Maven, and then just choose the reload project option here from the list. And as you can see, some stuff happens down here, and that should make the error go away. If you're still seeing the error at this point, what you can do is restart your ID, and you can even try and clear the cache from the IntelliJ menu down in here, and hopefully that fixes it for you. And once we have this, we can close our POM XML file and close our project tree. And now what we're going to do is double tap Shift again, hit Tab to go to classes, and then we'll go to patient controller, which is where all of our endpoints are. And in here, we'll just scroll towards the top where we have defined some tags up in here. So it's just above the class definition for this controller. And after the request mapping tag, we're going to add a new line, and we'll say at, and then we'll say tag. And this import is going to come from the io.swagger.v3.oas.annotations.tags package, which is the one we just installed. So go ahead and select this. And in the braces, we're going to add a name. And this name is going to be the name of the entity that this controller is going to control. So because this is the patient controller, we're going to tag this with patient. And we'll add a comma just outside the last string, and then we'll say description. And then this is just going to be equal to a description for our patient controller. We'll just say that this is an API for managing patients. And that's the first bit done. So now we've tagged as controllers so that all of our endpoints, which we're going to add some open API tags for next, are going to appear under the patient section in our Swagger UI. So we'll see how this looks in a second. But for now, we're going to scroll down until we see the get mapping. So it should be down in here. The method's called get patients, and we've annotated it with a get mapping. And then we'll take a new line, and then we'll say at, and then we'll do operation, and then add some braces, and then we'll say summary equals, and then we'll say get patients. So this is all we need to do to get this endpoint to appear on our Swagger UI under the patients tag. So because we've already annotated this with a get mapping, it's going to display the right verb and things on the UI, and it's automatically going to figure out the endpoint to display based on the method signature here and also from the request mapping up here. So all these tags work together, even though they come from different packages, to create our documentation. So there's a bunch of stuff we can add to this. If you type comma after the summary and do control space, you can see that there is a whole host of different things that you can add, such as a description, a request body example, responses, and things like that. But just to keep things simple, we're just going to add the bare minimum that we need in order to get this working. So now that we have a get request, we can do the same for the rest of our operations. So we'll scroll down until we see the post mapping one here, which is the create patients method. And we'll just take a new line under the post mapping, do at, and we'll say operation, and we'll add our braces. And then in here, we'll say summary. This will be equal to a string, and then we'll just give it a summary. So we'll say create a new patient, just like this. And then just for speed, we'll copy this, and then we'll scroll down, and just below the put mapping tag here for the update patient method, we'll take a new line and paste this in, and then we'll just update the summary to say update a patient. And then the last one we need to do is for delete patient. So we'll just scroll down to the very bottom, and just below delete mapping, we'll take a new line and we'll paste again, and then we'll just update the summary to say delete patient, and that should be it. So now what we can do is we can start our application. So go ahead and hit the run button on our patient service application. So go ahead and start the app, and what you want to do when it's started is go to the web browser, and in here go to localhost 4000/v3/API docs, and then hit enter. And what you should see then is a bunch of JSON that is in Open API spec standard. So it probably won't make too much sense right now because it's in JSON format, but what we can see is things like the Open API version that it's using and things like the tags that we added to our code. So the best way to see this in a Swagger UI is to highlight all the code and then do Control C to copy it. And then next what we will do is we will go to the Swagger online UI editor. So just go to swagger.io, and it will bring you to the homepage for Swagger. And what you want to do then is choose tools at the top. And in here, what you want to do is go to Swagger editor. We'll choose this, and on this page, you'll see a few options. So go ahead and choose try Swagger editor. And this will bring up a online editor that looks something like this. So on the left, you can see there's a bunch of stuff, and then on the right, you can see the Swagger UI that's based on the spec on the left hand side. So on the left hand side, go ahead and do Control A to select everything, and then just delete it, and then do Control V to paste in your JSON doc in JSON format. And you might see an option here that says if you want to convert your JSON to YAML. So go ahead and click OK. And all being well, you should see on the right hand side a visual representation of your OpenAPI spec. So if we have a look at the Swagger UI on the right here, you can see we have the tag that we defined for our patient controller. And underneath, you can see we have a little drop-down box for each of the endpoints or operations that our patient controller supports. So if we look at the post patient, for example, you can see down here that we have an example of the request body that needs to be sent along with the request in order to create a patient. And we scroll down some more, we can see we have the response as well as the status code to expect and things like that. And at the very bottom, you can see it's even generated some schemas of our request and response objects. So if we open these up, you can see that they contain all the properties that our request DTO have, and also some of the validation included as well. So this is a really good way to build out documentation, as it means someone coming along after us is able to have a look at the docs to see what endpoint are available for our app. So as we go throughout the course, we're going to build more endpoints and microservices, and we will continue to add our documentation along with that. So one of the extra benefits of having a specification like this is that it means we're able to generate API requests from the front end, as we'll see in the later sections of the course when we build out a UI that is used to manage patients. And we'll see how quick and easy we can build our API requests from the front end by generating the requests based on our OpenAPI specification. Okay, so now that we have a working Spring Boot app that has some CRUD endpoints, what we're going to do is introduce the concept of Docker to our application. So far, we have been running our patient service application on our development machines, so either your Windows laptop or computer or your MacBook, and we have been using an in-memory database for convenience. But this does not replicate the production environment that we are going to create on AWS, and we are going to look at how Docker solves this problem. So what is Docker? Docker is simplifying the building and deployment of apps using lightweight containers. How does this help us with the problem that we have? In enterprise environments, microservices typically involve running a number of different apps, software, and tools. So we might have 2 or 3 microservices to run. We might have a reverse proxy or a load balancer, and we might have a database, as well as a Redis cache, and so on. So when it comes to development, trying to install all these things is pretty time consuming. We have to go and find the installation files for Postgres, for example, and install each thing individually. So the other drawback here is that we can end up with different versions of the software compared to what other developers on our team would have. There could be subtle differences between the versions that could cause side effects whenever it comes time to running our app. So Docker allows us to simplify this process by containerizing each of these individual things with all of the config, the code, and the settings, which each thing needs to individually run, all packaged up in a nice container. This means whenever a container starts and runs, it's going to work the same, whether it's on a specific development machine, such as a Windows or Mac, as well as whenever we deploy to cloud services, such as AWS, Azure, or even Google Cloud. Okay, so now we have an idea of what Docker does. Let's have a look at how it works. So when we develop our apps in our IDE, there are typically a bunch of things and files that are needed for the app to work. So we'll have some config and some dependencies. So for example, in our Java app, we have our application properties, as well as the Maven dependencies that we added throughout the course so far. We'll also have the runtime. So in our course, we're using Java. So this is the JDK version that we need to use. And then we'll obviously have our source code. And this is the manual code that we added, such as our endpoints, our services, and so on. So whenever we run our code locally, IntelliJ does some smart things behind the scenes to compile our code, start the runtime, and deploy the config to the running code, which is fine for Windows. But whenever we deploy our code to AWS, for example, we don't want to have to install the config, install the runtime, and run the source code every time we want to start the app on AWS. So what we do is we create a Docker image. So a Docker image is an artifact that contains all the source code, the runtime that's needed for the app, and any config and dependencies that we need for our app to work. And all these things get packaged up inside this Docker image. So you can think of a Docker image as a blueprint, which is used to create containers. So a Docker image doesn't actually start or run the app. It just contains all the things we need to run the app, packaged up in a single artifact that we can then use later. Once we have an image, what we can do is we can upload the images to a Docker image repository or a registry. This is where Docker images are stored, managed, and distributed. So this is usually stored in the cloud, and there are many providers who can store Docker containers, such as Docker Hub or AWS ECR, which is what we will be using. Another way to think about the Docker image registry is that it's a source control repository for Docker images. So just like we store all our source code on GitHub, we store all our images in the Docker registry. So for better local development, Docker can also store your images in a local registry on your own development machine, so on your laptop or your computer, within the Docker context, which makes it easier and faster to test and work with containers without the overhead of having to upload the Docker image to an external image repository every time you want to test a change. So this is a nice feature that we'll see working as we go through the course. So once we have an image created and stored in either the local Docker image repository or a cloud-hosted image repository, we can pull the image and start a container that is based on this image. So this is an important step, as this is the point where our app actually runs, and it's running inside the container. And this container is going to have all the config, the runtime, and the source code packaged within it. And once we have created a container, it will run anywhere that has Docker installed. So we can start this container on our local machine and using some simple Docker run commands. And when it comes time to deploying the container to AWS, we will use the same commands to run the app. And this will give us confidence that our code is going to run the same regardless of the environment, because all its dependencies are packaged up within the container itself, as opposed to being installed individually on the machine or server that needs to run the code. So hopefully this gives you an idea of how Docker works. Now what we'll do is we'll jump back into our code and we will create our first Docker containers. Okay, so now we have an idea of how Docker works. What we're going to do is create our first Docker container from an existing image. So to do this, we're going to set up a real Postgres database for our patient service application. So far, we have been using an in-memory database for development, but in production enterprise environments, you would typically use a real database such as Postgres. So this is why we want to use a Postgres database in our dev setup as well, as it gives us a production-like environment to work with. So I'm just in IntelliJ here, and the good thing about using IntelliJ IDEA Ultimate is that it has great support for working with Docker right in the IDE. So on the left, what you want to do is go to Services and just click Services, and you should see under Services that we have an option that says Docker. And if we expand out this option, you can see that we have an option for each of the things that Docker can use. So we can see the containers that we currently don't have any running at the minute. We can also see any images that we have, and we can see the networks and also the volumes. So we'll explain a bit more about each of these as we need to. And as we create images and containers and things, you can see that they will appear under here. So this will make it really easy for us to manage things as we're developing the many microservices that we're going to need. So to create and start a new Docker container, what we're going to do now is up here is we're going to choose the three dots, and we're going to go to Edit Configuration down in here. And in the window that opens, you'll see that we have a configuration for our patient service application that appears under Spring Boot. So this is the out-of-the-box config that we get whenever we created Spring Boot project. So what we're going to do is up here, we're going to choose this plus arrow, and we're going to scroll down until we see Docker here, and then we're going to expand this, and then we're going to choose Docker image. So on the right, you can see that the panel has updated and we have to enter some options. So the first thing we'll do is we'll change the name for this configuration. So in the name section at the top, we will change it from Docker image to say patient-service-db, because this is going to be the database for our patient service. And as you can see over here, it's updated the name. So this is just to help us keep track of what our different Docker configurations are controlling. So the next thing we need to do is specify an image or a name. So Postgres provide an official image that we can use out of the box without us having to create our own image. So if you go to dockerhub.com and scroll down, you can see that we have a whole bunch of out of the box images that are provided by the creators of the different tools that we can use in our own applications. So these are open source and they're free to use. And there's a whole bunch of stuff that we can use depending on what we want to do. So If we look at databases and storage on the left here, you can see there's a ton of different databases that we have access to. And the one that we are looking for is the Postgres database here. So if you click this, it'll bring us to the official Docker image for Postgres. And on the right, you can see there's some instructions if you prefer to work with Docker using the CLI. So in order to use this in our code, all we have to do is grab the name. So this is called Postgres, and then we'll jump back to IntelliJ into our configuration, and we will Postgres in here as the image ID that we want to pull. So whenever we talk about pulling an image, we are essentially downloading that image from the image repository where it's currently stored. So this is going to go and download a Postgres image from dockerhub.com and add it to our local Docker context. And it's usually good practice to specify an image tag. So to do that, we say colon and then we say latest. So every time we add an image to the image repository, it's going to have a version. So by saying latest, we are always pulling the latest version of that image. And then we'll specify a container name. So this is the name that we give to the actual container that gets created based on the image. So we will just call this patient-service-db as well, as it matches the name of our configuration. So the next thing we need to do is we need to specify some environment variables that we can pass to the Postgres container when it starts. So to do this, we're going to choose the modify options dropdown on the right, and then going to go to environment variables. And as you can see, a new option has appeared here that will allow us to add environment variables. So on the right hand side, you want to choose this little folder icon, choose this, and it's going to let us add environment variables. So go ahead and choose this plus button here, and we'll add a name, and we'll say Postgres_user, and then going to give this a value of admin_user, and then we'll add another one, and then we'll say Postgres_password, and we'll add a value in here, and then we'll just say password. And the last one we will add is Postgres_db, and then we'll add a value of being db. So these are three things that we pass to the Postgres container when it starts, so that the Postgres application that's running inside the container can create a new database for us and also create a user and a password so that we can access that database. So go ahead and hit OK, and you should see that the environment variables get added here as a string. But the next thing we want to do is we want to expose a port on the container so that we can access it from our ID. So again, go up to the modify options, and then we will choose bind ports. And again, an option will appear in our window here. And then we'll just choose the folder icon over here. And this window should appear called port bindings. So in here, we'll add a new port binding, and we'll say host is going to be 5000 and the container port is going to be 5432. And these last two options you can just leave as default. So what this does is that whenever we start a Docker container, by default, we cannot access the app that's running inside the container outside of a Docker context. So for example, if we wanted to connect to our database from our ID to check the data that's inside the database, then we wouldn't be able to do that because of the way Docker works. So by exposing a port on the host of 5000, that means we can use port 5000 to access our database that's running inside the container. So hopefully that makes sense. We'll see how this works when we connect to the database from IntelliJ IDEA after we get the container started to see what this actually does. So go ahead and hit OK here. And the next thing we want to do is we want to go to the modify options again, and we want to go to bind mounts to this option here. And again, we'll just go to the little folder icon over here. What bind mounts is that it lets us save a copy of some data to our own development machine in the file structure. Because whenever containers are created and destroyed, all the data inside it is also destroyed. So this is good for databases because if we stop and recreate the container from scratch, it will automatically populate itself with the saved data that was saved on our own development machine. In here, go ahead and choose the plus icon again, and the host path can be anywhere you want that is accessible in your file system. In here, what you can do is just specify a directory where you want to save your database volume to. So I'll just choose C, and then I'm just going to add in a path here, and I'm going to put all my volumes in a folder called db volumes, and I'll say /, and I'm just going to say patient-service-db. So if you prefer, there's a little folder icon here too that you can use to choose where to save the database volume to, and then the container path is where this volume is going to get mapped to inside the container. So inside the container, Docker will create its own file system as well for all the things that it needs to start the container as well as our app. And part of that is going to be a Postgres data folder. So we'll say /var and then say /lib/ and then we'll say Postgres equal /data. So now this means whenever the container starts, it's going to pull the database volume from the host path and apply it to the Postgres data folder inside the container. So this means every time the container starts, it's going to be populated with whatever data was saved on the host. And it just means that we don't lose our patience every time we destroy the container. Okay, so go ahead and hit OK here, and you should see in here that the volume gets added to the bind mount section. So the last thing we need to do is add this container to a network. So again, we will go into the modify options drop down and scroll down to run options this time. And you can see here that it's given us a place where we can add additional options that we want to pass to this container. So in here, all we have to say is -- and it will say network. And then we're going to name this network internal. So each of the containers is going to run in its own isolated environment. And that means that we cannot connect to it even from other containers in our Docker context. So by adding our container to a network called internal, that means all the other containers that are on the internal network will be able to communicate with other containers that are also in the internal network. So go ahead and hit apply, and this will be it for our first Docker container. But before we can run this, we actually have to create this network. So go ahead and hit OK, and then we'll come back to this in a second. What we're going to do is go to the Docker service on the left. If you don't see this, by the way, there's a little plus icon up here. It says add service, and then you just choose Docker and then connection. And then it should pick up the Docker context on your system, assuming that you've started it correctly. And also double check that you have Docker desktop running as well. So go ahead and open up the Docker option here, and then we'll scroll down to networks. And in here, you can see we have some of the networks that Docker uses, but we want to create our own network here just so we don't get mixed up. So go ahead and right click on networks, and then we'll choose create network. And over here, you can see it says specify a network name. So go ahead and just type in internal and choose OK. And you should see the internal network appear in the list. If we click on it, it says that there's nothing to show because we don't have any containers yet, but our network is running. And now that we've done this, what we can do is at the top in the drop down, you should see the configuration that we created for our patient service DB a moment ago. So go ahead and choose this one, and then we'll just choose the run button on the right hand side. And as you can see, now it's doing a bunch of stuff in the terminal. So if we have a look at this, you can see that it's pulling the image and it's printing out the logs from inside of the container. So if we scroll down, you can see it's creating a database and all this sort of stuff. And if we scroll to the very bottom, you can see Postgres init process complete, and it's ready for startup. And then an extra message out here that says that the database is ready to accept connections. So you will know that this worked if you see up here that we have a green kind of box with a green circle in it. And over here as well, in the containers tab in the services, you will see we now have a running container, and this is our Postgres container. And if we have a look at the networks tab now, if we click on internal, you can see that we've got our patient service DB has appeared in here. And that means our container is running and also has been connected to the internal network. So IntelliJ IDEA uses the same Docker context as the one that is installed on your system. So if you open up Docker Desktop and go to the containers on the left here, you can see that we have patient service DB and it's running as well. So IntelliJ is not doing anything special here. All it's doing is managing the containers and the images that already exist on your system. So if for some reason you aren't using IntelliJ IDEA Ultimate, you can use the CLI or Docker Desktop to view and manage your containers, and it will all work the same. If you're having any problems at this point, double check the run configuration. So you can go back up here and then just choose the 3 dots to the right of your config and choose edit, and it will open up the configuration again. You can find all these options in the README of the completed code on GitHub, just to double check that you haven't accidentally added any errors in here by mistake. Okay, so now that we have a database working, what we can do is Dockerize our patient service application so that anytime we run the app, it's going to create a new image with the latest code, and it's going to run a container in our Docker context and connect to our patient service DB. So by running our code as a separate container from the database, it means we can deploy our patient service separately from the database, which is good for speed and good for performance. It also means that if we have a Dockerized patient service, it means we will have a setup that closely matches that of our production environment. So the benefits of that is that we will be able to catch any issues early, as opposed to waiting until we deploy our code to production and finding out something doesn't work because the code behaves different after it's been deployed to a container and things like that. So with that in mind, what we're going to do first is create our first Docker file. So on the left in the project tree, we'll open up the patient service and we're going to right click on this and we're going to go up to new and we're going to scroll down until we see the option for Docker file. We go ahead and click this, and what a Docker file is that it is a set of commands and instructions that lets us create a Docker image. So in here, we'll just highlight everything and hit backspace. And the first thing we need to do is specify a base image for us to use. So a base image usually contains things like the runtime and the build tools that you want to use. And this will be taken from an existing image, again, that's provided by the official maintainers. So in here, we'll say from, and I will say Maven, add a colon, and I will say 3.9.9 dash Eclipse dash, and I will say Pemarin, and I will say dash 21. So this is an image that has JDK version 21 in it, and it also has the Maven build stuff in it as well. So since we're using Maven to build our code in IntelliJ, anytime we run it as a pure Spring Boot app, it makes sense to use Maven here as well. And at the end here, we're going to say as, and then we're going to say builder. So I'll explain a bit more about what this means as we go, but this is essentially a step that we can define in our Docker file. So we're going to have a step that builds the code, and then we're going to have a step that runs the code. And we'll see why they're two different steps in a minute. So the next thing we're going to do is we're going to specify a working directory inside the container. So we'll say work dir, and then we'll say /app. So as mentioned previously, a container is going to have a whole bunch of files in it that it needs to start the container and run any of the code inside the container. So by specifying a working directory, it keeps our own custom code in a single location that we know about. So the next thing we have to do is we need to say copy, and then we're just going to copy our pom.xml file. So the XML file has all of our dependencies in it, so it's important that we copy this over, and then we'll add a space, and then we'll add a dot. So what this means is that it's going to copy the pom.xml file to the folder of our working directory, which in this case is /app. So at this point, after we've copied our XML file, we can install all the dependencies that our Spring Boot app needs. So say run, and I will say mvn, and I will say dependency, add a colon, and I will say go offline, and I will say -b, just like this. So the mvn command is what's used to install all the packages. So it comes from the Maven image up here. And dependency go offline just means cache the dependencies unless a change has been detected. So this just means every time we stop and start the container, as our code changes, it'll cache the dependencies, and this will make it faster to start up the container. So on the next line, we'll say copy, and then we'll say src, and then we'll say space, and then we'll do ./src. So all we're doing now is copying all our source code over. So if we look at the project folder, we've got a source folder here, and it's got all of our code in it. So this is what we need before we can compile everything inside of the image. So after we've copied the source code and installed the dependencies, what we can do now is package everything up into a single jar. So we can say run mvn clean package, just like this. It just tells Maven that we want to create a new package from our Spring Boot app, and this will create a single .jar file that has all our stuff in it. Okay, so now we've built our code using the Maven base image. What we can do now is create another step that describes the instructions on how to run the build code. So we'll take a new line in here, and then we'll say from, and then we'll say open JDK-21-JDK, then we'll say as, and then we'll say runner, just like this. So since this is the step that actually runs the code, we don't need Maven because Maven is a build tool. But at this point, we've already built all of our code, so there's no need for Maven. So we just use the open JDK runtime to run our built code. So on the next line, for this step, what we'll do is we'll define the working directory again. We'll say work dir, and then we'll say /app. So just keeping this the same as up here. And on the next line, what we want to do is say copy, and then we'll say --from, and we'll say equals, and then we'll say builder, and then we'll say ./app target, and then we'll say slash, and then we'll say patient-service-0.0.1 say .jar, and we'll add a space, and then we'll say ./app.jar. So what this is going to do is it's going to copy the patient service snapshot jar that was created in the builder step up here, and it's going to copy it into the runner step. It's going to place it at /app.jar. So once the jar has been copied over, we'll take a new line and I will say expose, and then this is where we specify the port that our app runs on. So in our application properties, we've said that the app runs on port 4000. So we'll just say that here as well. And the last thing we need to do is we need to specify a command for the run step to use to actually start our code. We'll say entry point and then add an array, and I will say string, and I will say Java, add a comma after the string, add another string, and I will say -jar, add a string again, and I will say app jar. So all we're doing here is using the Java CLI that comes from the JDK to start our app.jar, and this has all our patient service code in it. And that should be it for our Docker file. So now what we can do is we can use IntelliJ's built-in Docker features to build an image and automatically start our container using a configuration. So what we will do is we will go up to our config section at the top here, and again we'll choose edit, and on the left we're going to add a new configuration, and then we'll scroll down until we see Docker file. Go ahead and choose this, and in the name section at the top we'll call this patient-service. Here we'll add an image tag, and we'll just tag this image with the name of the service. So we'll say patient-service, and then we'll add a colon, and then we'll say latest. And if we scroll down under the run options here, we will give this container a name as well so that we can identify it easily. We'll say patient-service, and we have to specify a few environment variables so that we can connect to our database container that's running in Docker as well. So under the modify tab, we'll choose the environment variables option, and in here we'll just choose the little folder icon again to open up the environment variables. So now we can specify our database connection for our Spring app to use anytime we want to connect to our patient service database that's running in a separate container. So we'll click add in here, and then we'll say Spring_data source URL, and then a value for this is going to be JDBC, add a colon, and then we'll say PostgreSQL, and then we'll add a colon, add a //, and then we're going to say patient-service-db, add a colon, and then we'll say 5432/db. So what this is it tells Spring how to connect to our database. So you might notice that this is very similar to the connection string we specified in our application properties, and that's because environment variables get mapped to application properties. So this is how we override our application properties whenever we start a container. And then in here, we're just specifying the address as being PostgreSQL, and that the URL is going to be patient-service-db. So anytime a container is running inside a Docker context and we want to connect to another container, we can use its container name, and Docker will automatically find that container and resolve the DNS for us behind the scenes. So don't worry too much if you're not 100% sure on the networking side of things, but all you need to know is that anytime you want to connect to a container from a different container, you can use its service name to do so, and that's usually the name of the container. And then we specify the container port that this is running on. So most databases always run on port 5432 by default, and then we just specify the database that we want to connect to, and that's going to be DB. This is the name of the database that we created in our patient service DB container when we started the container through IntelliJ. So go ahead and click add over here again. This time we'll say Spring_data source _username, and the value for this is going to be admin_user, and we'll add the next one, which is going to be Spring_data source _password, and the value for this is going to be password. So these are things that we passed to the database container when we started it, and it's going to be used for authentication so that our patient service container can actually connect to the database using these values. So the next thing we want to do for development containers is we want to make sure that our database gets automatically populated anytime we make changes to our entities. So we'll say Spring_JPA_hibernate_DDL_auto, and the value for this is going to be update. And on the next line, we'll say Spring_SQL_init_mode, and this is equal to always. So these two properties are what we added to our application property file to automatically persist our entities and our data in the in-memory database. So this is the same thing as to what we're doing here. By passing these things in as environment variables, it means we can change them as we deploy this container to production. So even though we're going to be using the same container we deploy to our production environment on AWS. We can change these values. For example, we might not want to perform the automatic persistence, as we might want to use migrations for that. So in that case, we'll just leave these properties out whenever we deploy the container to production. So this is the beauty of environment variables, as we can specify different settings for our development experience, and then whenever we deploy to AWS, we can specify more production ready values in here. So this should be all we need. So go ahead and hit OK. The next thing we need to do is expose a port. We'll go to modify, and then we'll go to bind ports, and in here we'll just click the little folder icon again, and then we'll add a plus, and then the host port we're going to say is port 4000, and our app is running inside the container on port 4000 as well. So we'll just keep these things the same so we don't confuse ourselves. And this just means by exposing a port on the container that we can access it from outside of the Docker context. So this is good for development again. So go ahead and click OK. And the last thing we need to do is we need to specify a network for this container to run on. So in the modify dropdown, choose the run options option, and in the input say -- and I will say network, and I will say internal, just like this. And that means that this patient service container will be running on the same network as the rest of our containers, which is important because we need to connect to our patient service database container from our patient service container. Okay, so that should be it for our patient service Docker configuration. So there's one last thing we need to do before we try and run this. So go ahead and click OK. And on the left in the project tree, we're going to scroll down until we see our application properties file, and in here we have specified all the properties that we needed to connect to our H2 database. So because we are specifying the data source, the username, and so on, and our JPA options as environment variables, we no longer need them in here. So all we'll do is highlight all of these things and then do control and / just to comment it up. So we don't need these, but I'm going to leave them here just in case you want to use them as a reference in future for in-memory database. Or if you decide to run the patient service application outside of Docker, you can uncomment this again and it will use the in-memory database. So we'll just add a comment up here to remind ourselves, and we'll say uncomment to use in-memory database outside of Docker. So just make sure that we keep the server port in here and also the log level, as these are things that are going to get copied over in the application.properties file and added to our container. So regardless of the environment, we're always going to have a consistent port, but we can override it from Docker if we want to. So go ahead and save this, and you can close this down. And now the next thing we want to do is go into the run options up here, choose our patient service configuration, and then go ahead and hit the run button just to the right, and we'll see what happens. So it should open up the services window, and as you can see, it's building our Docker image. And at the point when the image has completed and the container is going to run, you should see an output that's very similar to what we have seen so far anytime we have run our patient service application through the ID. So if we scroll down, you can see that it says patient service application has started, and these are the container logs. So you will know it will have worked if you see the patient service container appear over here. And if we look at the images section here, you can see that it's also created an image and tagged it as latest, and this was created 50 seconds ago. And we can see our Postgres image here as well. And if we have a quick look at the networks under our internal network down here, we can see we now have two containers in the network. So far so good. This looks like we have a running container for our patient service. And the nice thing about this now is that anytime we make code changes in our project, we can just go ahead and press run, and it will go and build a new container and start it up again automatically for us. So this is a great developer experience, as now we're able to develop inside a running patient service container, and this container is going to be the exact same one that runs on AWS when we deploy to production. And the nice thing about IntelliJ IDEA Ultimate is that we have all the tools that we need to do this right inside our IDE. But likewise, if we wanted to manage our containers from the CLI or from Docker Hub, you can see that they also appear in here. We can do what we want with them from here as well. Okay, so at this point, we have our patient service running in a container, and we also have our patient service DB that's running in a container. So there's a few tests and checks that we want to do to make sure that our development environment is still set up the way we had it before. So one of the nice things that we had about our development setup so far was that we automatically seeded the database based on the .SQL file that we had in our resources folder inside of the patient service. And it had a number of patients that would automatically get added to the database anytime we started the app. So we also auto created the tables if the tables didn't exist based on our entities. So these are the things that we want to check in our database. And the nice thing about using a real Postgres database now is that we can do this from within IntelliJ IDEA itself. So again, IntelliJ has excellent built-in tools to help us do this. So what we can do is over on the right-hand side, if you hover over this icon that looks like a cylinder, it should say database. And if you click this, you should see a window that looks like this. So if we expand this out a bit, this lets us connect to running databases using credentials. So what we want to do here is choose the new button on the top left, go to data source, and then we'll scroll down to the option for PostgreSQL, which should be down here. So it has the little blue elephant icon to the left, and go ahead and click this. So in the name at the top, we're going to change the name to say patient-service-db, and down here and down here, we need to specify some connection details. So whenever we created our database container, we exposed a port, and that port was port 5000. So this is what is known as the host port. In other words, it lets us connect to the database inside the container from outside of the Docker network. So obviously our IDE is not running inside Docker. It's not connected itself to the internal network that we created. So this tells Docker to expose a port on localhost that allows us to connect to the database. This is why we leave the port as localhost, as Docker does this mapping for us. So down in here, we have to specify some authentication details. So for the user, it's going to be admin_user. And for the password, it's going to be password. And the database that we want to connect to is just called DB. So these are the same credentials that we used to create the database whenever we started our Postgres database container. And it's also the same connections that our patient service container is going to use as well. And you can see down in here that the URL has been updated for us. And hopefully now if we click test connection, we see a succeeded message. And that means that we're able to connect to our database running inside of our database container. So go ahead and click apply. And then if you click OK, you should see the name of your connection up here. And if we open this up, you can see we have our database. And if we expand this and expand public and expand the tables, you can see we have our patient table here. So if you right click this, edit data, so in here, we should see all the patients that were seeded to our database. And because it says no rows, that means that something's gone wrong somewhere along the line. So even though we're able to connect to our database, that's a good first step. If you're not seeing any rows as well, the first thing to check is the environment variables for our patient service. So go ahead and go up to the three dots at the top, and then we'll click this, and then we'll go to edit, and we're going to have a look at the environment variables, as that's where we defined how the JPA persistent stuff kicks in. So it's likely something to do with this. So if we have a look at the environment variable in the browser here, and what we want to do is just double check this and check the values just to make sure that the URL is right, as well as the port and the DB. So all these things look good, and the username and password look good as well. And it could be something to do with the Hibernate stuff itself. And it looks like I've added a spelling mistake in here. So this variable should be spring_SQL_init, just like this, and _mode. So yeah, just check these and make sure that the spelling's okay and the values are okay. You can find these in the completed repository too, if you prefer to copy them, and then you can just paste them in here and then go ahead and hit OK, and then choose the apply button down here. And then all we have to do now is rerun this configuration to get a new Docker image and a new Docker container. So go ahead and hit run. And in the services window, you can keep an eye on things and just make sure that the patient service has started. So it'll say start a patient service application. And you'll also see the patient service Docker containers gone green up here. And this time, if we go back to our database window on the right, choose database, and then just expand everything out again until we get to the tables. And this time you can just press F4 on your keyboard or choose the right click option again, both the same. And if we have a look at the results will appear here. Things are a bit squashed, but you can see that there are 15 rows this time. And if we try and hover over some of these to get some examples, you can see that John Doe is the top one, and that is the patient that we have been working with so far. So this is good. It shows we're now able to seed our database from our patient service. And the difference is this time is because we're using a real database. Any new patients we change or update are going to persist into the database, and it will always be there. So anytime we stop and start the patient service, we'll have the same data that we had whenever we previously ran it. So if you're having any problems at this point, make sure to double check your run configurations. And if you're still having issues, go ahead and check the completed code on GitHub to compare your Docker files and things to do the code we have written here. Okay, now that we're sure that our database is working and we're able to connect to it from our code and see our database, we can do a quick test to make sure that our patient service API endpoints are still working. So what we can do to test this is go to the project tree, and then we'll go into our API request folder, and we'll just choose the get patients one, and all being well, everything should work the same as it did before. So this one will do a get request to localhost 4000. So this is the host port that we exposed on our container, and then Docker will map this to localhost for us. So go ahead and hit run, and then in the services window, in the results, you should see all of the patients that we currently have in our database. So if you want, you can try the rest of the requests. So you can try a create and update patient, but at this point we'll assume that our new development setup, which uses Docker and a real database, is now working, and from here we can continue to build out our microservices architecture in the same way. So if you're having any problems at this point, double check the logs. So if you go to the services under containers, if you choose one of the containers, you can see that it gives you the logs for that container. And then you'll also see if there's any issues with the actual building of the container itself. And from there, you can hopefully pinpoint the issue. Also have a look at the finished example on GitHub, which has the finished Docker files and the environment variables that you need to run containers and things like that. So when you're happy, we will jump into the next section. So far, we have been using REST to communicate with our patient service to send and receive data. So REST is good because it has strong browser compatibility. It uses JSON and it works seamlessly over HTTP. So in this section, we're going to explore how microservices can communicate using what's called gRPC. So what is gRPC? gRPC is a high-performance open source RPC framework that leverages HTTP2 and protocol buffers for efficient, low-latency communication between its services. So that's the fancy definition. But in other words, while REST provides an excellent way for browsers and other clients to communicate with services using JSON format, gRPC offers a faster and more efficient method for microservices to interact with each other utilizing the protobuf format to send and receive data. While both REST and gRPC both use HTTP beneath the hood, gRPC is significantly faster and more efficient, which is better for internal service-to-service communication where high performance and low latency are required. So to show how this works, we are going to automatically create a billing account for a patient when a patient is created. So when an admin fills out the form on the front end, this form will make a REST request to the patient service, which is similar to what we've seen in our REST HTTP request when we use the IntelliJ clients. And from here, the patient service will then make a gRPC request with the necessary patient details, which will be in protobuf format, to the billing service. The billing service will then perform any business logic, do any database stuff, and anything else that it needs to do to create a billing account for that patient. So to work with gRPC, we need what's called a proto file. So this file is used to describe our gRPC server, such as the available methods, what the request looks like, and what the response looks like. And it's usually named based on the service that we're trying to interact with. So in our case, it's going to be called billingservice.proto because this file describes how we interact with the billing service. So this file is then used to generate a gRPC client and a gRPC server. So this means we can make requests from the patient service using the gRPC client, which are then received in the billing service using the gRPC server. So having a proto file also means that if the server changes, so for example, if there are any changes to the functionality, or if there are any changes in the request or response data, then all of the clients are able to regenerate the code that is needed based on this new proto file. So this approach scales really well, as if we add another microservice. So for example, down here, if we added an appointment service that also needed to interact with the billing service, all the appointment service has to do is grab the proto file, generate the code for the client, and then it is able to interact with the billing service using gRPC requests to send and receive data. So in the next section, what we're going to do is build our billing service, and we're going to build our gRPC server, and we're also going to add a gRPC client to our existing patient service so that the two can interact. And we'll also write our very own proto file as well. So just a quick note on the proto file. There are many ways to store a proto file so that all the different services can easily get access to it. So there's some options here, including using Git submodules or storing it as a separate Maven package, which all the services would add as a dependency, or we could use a cloud-based thing such as Artifactory. These things tend to be quite complicated to set up. So for the purpose of learning, to focus solely on how to use gRPC, we are just going to copy the proto file for the billing service into all of the services that need it. So we're going to have one in the patient service and we'll have one in the billing service, but both these files are going to have the exact same content. So just be aware of that, and be aware that typically in enterprise environments that there are more robust ways to store this file. Okay, so now that we have an idea on how gRPC works, we're going to see it in action by first building out our billing service in our project. So I have the IDE open here, and what we're going to do is we're going to go up to the patient management folder in the project tree, and we're going to right click here, and then we'll choose new, and then we're going to go to module, and then we'll add a new module in here just like this. So remember, anytime we add a new module to our patient management folder, we are essentially creating a new microservice. So on the left, just make sure that you have Java Spring Boot selected as a type. And then on the right, we can start filling out these options. And the first one is the name. So we'll call this billing-service. And in the location, just make sure it's inside the patient management folder. And as a language, we'll just leave it as Java. And then as the type, what we're going to do is choose Maven, as we have been using Maven to build our code so far. And then in the group, we will keep this as com.pm. And the artifact we'll leave as billing service. And then the package name we will leave as com.pm.billing service as well. So for JDK, what you want to do is choose JDK21, and then just make sure that Java 21 is selected down here as well. And then go ahead and hit next. On the next screen, you're going to see the list of dependencies. So go ahead and type web in the search box over here. And what you want to do is choose Spring Web. And this will allow us to create a basic microservice that also has Apache Tomcat in it, which is the server that we use to start our apps. And since the billing service is going to be relatively straightforward for this section of the course, we don't need any other dependencies. So what you can do is jump down here and choose create. And this should bring us back to our project tree. And then over here, you should see you have a new module called billing service. And if we open this up, we will have a bunch of stuff that we're familiar with seeing. So we have our source folder, and inside here, we have our main package with our Java folder. And then we've got our billing service package down here. And then we also have our billing service application, which is a Spring Boot application. Okay, so now that we have the basics of our project set up, what we're going to do is add all the gRPC and proto dependencies that we need in order to integrate a gRPC server with our billing service. So what we're going to do is on the left, we're going to go into billing service and then scroll down until we see pom.xml. And if we open this up, you can see we have some dependencies and things that were generated by the IDE whenever we bootstrapped our billing service in IntelliJ. So if we scroll down, you can see we have the dependency section. So this is where we're going to add a bunch of dependencies for gRPC and protobuf. So there are quite a few dependencies, and it would be a bit tedious and error prone to type them all out ourselves. So what I have done is provided all the dependencies that we need for the section in the finished GitHub repo. So what you want to do is go to the GitHub link in the description down below, and it will bring you to the completed repo page on GitHub. So if you scroll down, you should see in the README here, there are some code snippets that you can copy and paste depending on what part of the course you're on. So if we scroll down until we see billing service in here, and then just below there's a section for gRPC setup. And if we scroll down some more, you can see there's a list of about 4 or 5 dependencies that we need for gRPC to work. So what these do is that there's a few dependencies in here that help us generate some protobuf code based on our proto file. And then there's some code that helps us to start a gRPC server as part of our Spring Boot application. So these are all well-known dependencies that are used in enterprise. So you can go and have a look at the GitHub ID for each of these if you want to learn more about them. So what we're going to do is copy this code snippet. So on the top right, there's a copy button. So go ahead and click this, and then we'll jump back to our ID. And then in the ID, what we're going to do is just above the dependencies tag, the closing one, we're going to add a few spaces. And then in here is where we're going to paste in those new dependencies. So go ahead and hit paste and it will add them in for you. And sometimes not, you'll see this little M with a refresh icon at the top here. And this is a button that helps us reload the project when Maven detects changes. So go ahead and click this and it should reindex all the dependencies to clear any errors that you might have. And if you don't see this, what you can do is go up to the project and on pom.xml, if you right click and scroll to the very bottom, you'll see the Maven option and then just reload the project from there. So both these approaches do the same thing and it just helps resolve any missing packages that your project might have. So after we've got our dependencies in, the next thing we need to do is we need to add some build steps to the build section down here to tell Maven that we want to generate the protobuf code that we need anytime we start our app. So this is to save us doing it manually, and instead anytime we stop and start our app, even inside of the Docker container, as we'll see shortly, it's going to generate the protobuf code that we need and include it in our build. So to do this, we'll jump back to the browser and in the README again, we'll scroll down a bit until we see this code here that says replace the build section with the following. So in here, again, we have a bunch of well-known plugins that are used to integrate protobuf generation with Maven and Spring Boot so that we don't have to connect all these things ourselves. So these code snippets are all taken from the official GitHub repositories. So we're not doing anything too special or wild here. We're just following the documentation for these plugins. So go ahead and choose the little copy button at the top right again for this, and then we'll jump back to your ID. And what we're going to do this time is scroll down and you should have a snippet of code for the build section that looks like this. So what we're going to do is we're going to highlight all of this and then just delete it. And then we're going to paste in the code that we just copied from the GitHub repo, just like this. So all we've done is just add some new extensions and add some plugins for Proto that we need along with the Spring Boot Maven plugin that existed already. So again, on the top left, what you want to do here is choose Load Maven Changes, and that should get rid of the error that appears inside these configuration tags here. And if that doesn't work, what you can do is go into the project, right click on pom.xml, scroll to the bottom under Maven, and then just reload the project from there. And sometimes that works a bit better. But at this point, you should be seeing no errors in your pom.xml file. And that means that we have all the dependencies that we need in order to get this to run. So if you're having any errors, just double check that you've copied all the stuff from the README into the right place in your pod.xml file. And also make sure to reload the Maven project so that it indexes the latest changes. Okay, so now we've got all our dependencies in place. What we can do is create our first proto file. So again, the proto file is used to describe our gRPC service, as well as the requests, any responses that our service is going to return. So it's kind of like a blueprint that we will use to generate code. So on the left, under the billing service project, we're going to go into source, into main, and in the main folder, what we're going to do is right click. We're going to add a new directory, so this option here, and we're going to call this proto, just like this, and then hit enter. And then inside of the proto folder, we're going to right click again, we're going to choose new, and then we're going to choose file, and then we'll say billing_service.proto, just like this. And if you hit enter, you can see it creates an empty file on the right here, and over here we have a .proto file. So you'll know that it worked because there's a little P to the left with a square icon in it. So IntelliJ does recognize proto files, which is good. And then in here is where we start defining the gRPC service for our billing service. So the first thing we need to do in here is specify the syntax. We'll say syntax, and then this is going to be equal to a string, and then we'll say proto3, and then we'll add a semicolon at the end. So this just describes the version of proto that we are using. And then in here, we're going to add an option, and then we'll say Java_multiple_files, and then this will be equal to true. So what this means is that it's going to split our service, request, and response files all into different files. By default, the code generation will put everything in the same file, and that gets a bit messy. So by splitting it out, it just makes it easier to manage our code. And then on the next line, we'll say option, and then we'll say Java_package, and then we'll say equal to, add a string, and we'll say billing. So this just ensures that the code generation puts all of our code in a package called billing. And then this is what we can use from the code that we write ourselves to reference the service and response and so on. So now on the next line, what we can do is specify the name of the service and any methods that are part of the service and the things that it returns. So say service, and it's going to be called billing service. and then we'll add some braces. And then this is all we do to specify a service. And now we can specify the methods that exist on the service. So we'll say RPC. So this is the protocol that we're using. And we'll call this method create billing account. And then we're going to add some braces. And then we'll add billing request. So we haven't created this yet, so don't worry about the error. But what this means is that in our billing service, we're going to have an RPC method called create billing account. And this create billing account method is going to accept a billing request that it will receive from a given client. So the patient service is going to call the billing service, and it's going to pass a billing request to the create billing account method in that service. And then at the end, we'll specify what this method returns. We'll just say returns, add some braces, and then we'll say billing response. So again, all we're doing here is saying that the billing method is going to return the billing response. That's essentially it to define a service. So now we need to define the types for the billing request and the billing response. So at the end of the brace here, we're just going to take a new line, and then we'll say message, and we'll say billing request. And then we'll just open some braces here. And by using the message keyword, we are describing what the billing request is going to look like. So you can kind of think about this like a DTO or a Java object. It's going to have a bunch of properties in it that we will receive in the request. So the first thing we're going to send in the request is going to be a string, and it's just going to be a patient ID. And then we're going to set this equal to 1. The syntax is kind of strange because you might think that we are setting the patient ID to be 1, but this is actually used in gRPC and protobuf code to help with the serialization and the deserialization of this variable. Don't worry too much about this. If that doesn't make too much sense, all you need to know is that this number has to be unique. So to see an example of this, we'll add a new property, and we'll say string name this time, and then we'll set this one equal to 2. And the last property that we're going to send in the billing request is going to be an email. We'll say string email, and this is going to be equal to 3. So these numbers just need to be unique, and it's just to help gRPC and protobuf send to determine the different properties when the request is received and when the request is sent, and so on. So we can do similar now to define the billing response up here. So we'll just add a new message. We'll say message, and I will say billing response, open some braces. And what this is going to return is going to be a string, and then we'll just say the account ID. So this is going to be the billing account ID, and then we can set this equal to 1. And we'll just send back a status as well, just so we have some business-like properties to look at. We'll say string, and I'll say status, and then this will be equal to 2. And that's it. So we have completed our first proto file, and as you can see, it wasn't very much code in terms of the proto file itself, but we have added quite a bit to it. So we've defined our billing service and the methods within it. We've also defined the properties that need to be present in the request and the properties that will be present in the response. What we can do is we can use the dependencies that we added to our pom.xml file to generate our server, as well as objects for the request and for the response in our code, so that we can use these things in our code. So even though we have created our first proto file that describes the different parts of our gRPC service, this doesn't actually run. It's just a blueprint that describes each thing.
Okay, so to generate the gRPC code that we need for our patient service to interact with our billing service, we can run a few Maven commands that will generate the stubs that we can then implement in our code. So to see how this works, we're going to go into the Maven panel on the left here. So just choose this, and in here, as you can see, we have 2 options, one for the billing service and one for the patient service. So go ahead and open up the billing service, and then in the lifecycle methods, what we're going to do is choose the compile option. So what this does is it will compile all of our code, including the manual code that we add, and also any generated code that needs to be added as well. So go ahead and double click on compile, and on the right hand side you should see the process happening. So we can see that we have a green tick here, and then in the build window you can see all the steps that Maven is doing. So you should see this build success message appear, and that means that Maven has successfully completed the job. So if we have a look now in the project tree, you should see in here we have this target folder, and it's marked as orange. So this target folder is what gets output anytime we do a Maven compile. And if we have a look at this, so open it up, and you can see there's a whole bunch of stuff. If we have a look at generated sources folder, and if we go into protobuf folder, you can see we have gRPC Java in here, and we also have a Java folder as well. So if we look at the gRPC Java, you can see we have a billing folder, and then we have a Java file here that's called billing service gRPC. So this is the gRPC server stub that gets generated by Maven based on our proto file. So if we double click this and have a look, you can see on the right that there's a bunch of code and it's pretty verbose and confusing, but we don't need to worry too much about how the actual implementation of this code works. All we need to know is that it's there and we can use it. And if we look in the Java folder on the left here, you can see we have different objects that represents the billing request and the billing response. So again, these were generated based on our proto file. So if we have a look at the billing request, for example, and you can see in here that, again, there's a bunch of code, but you can see that it's generated based on our proto file. And this is pretty much the same as a DTO that we created in the earlier parts of our course to transport the data in REST request and also the REST response. So for example, in here, you can see we have a get patient by ID method, which allows us to get the patient ID from the billing request that gets sent to our gRPC server from the patient service. And we'll just have a look at the billing response as well. So again, this is the same thing. This is essentially a DTO that lets us return any data back to the patient service from the billing service. And you can think of it as a DTO, just the same as what we did in the earlier parts of the course. So for example, down here, there's a get account ID method that can be used to get the account ID that was generated back from the billing response object. Okay, so this looks good. We have the three things that we need to implement our gRPC server on the billing service, and we can go ahead and start implementing this code in our own logic. So if you're not seeing these things, double check your POM XML file. And again, you can compare that to the README in the finished repo, just to make sure you have all the things that you need. And also just double check that your proto file is in the right place. So it needs to go in a proto folder that's inside the source folder inside the billing service. So this proto folder is a convention that's used by our plugins to look for proto files. So if you haven't got this, then it might not find your file. So now that we have the generated code based on our proto file, we can go ahead and start implementing this code. So in the billing service, the first thing we need to do is set up a gRPC server that starts anytime our Spring Boot app starts. This means that whenever we start up the billing service in our IDE, the gRPC service starts as well and is ready to accept connections and messages from any of the gRPC clients, such as the patient service. So the first thing we're going to do is we're going to go into our billing service project, and we're going to go down to the com.pm.billing service package. And then we're going to right click and we're going to add a new package in here. And we're going to call this package gRPC. And this is where all of our server logic is going to go to start the server and receive messages. So on the gRPC package that was just created, right click and go up to new and go down to Java class. And then we'll call this billing gRPC service, just like this. And this is going to be a Java class. So go ahead and hit enter and it will create it on the right here for us. In the class that appears on the right, what we're going to do is tell Spring that this is a gRPC service and that we want to have it managed by the Spring Boot lifecycle. So to do this, all we need to do is add an annotation just above our class definition. So up here, we will take a new line and then we'll say at, and then we'll say gRPC service. And this should come from the net.devhitch.boot.grpc.server.service gRPC service package. So if you're not seeing this, make sure that you have this dependency in your POM and you can get it from the README. But the next thing we need to do is we need to implement the generated gRPC server stub, and we can do that by extending this class. So to do this, we'll add our cursor to the end here, and then we'll use the extends keyword to say that our billing gRPC service class is going to extend another class, and then we'll say billing service impl, and then we'll say base. And you should see an option to import this. So go ahead and import this class. So this comes from the billing.billing service gRPC.billing service impl base class, and this comes from the billing package. So the billing package is the package that gets generated whenever we ran the compile step in Maven. If we quickly jump back to our project and go into the target folder and into generated sources, into protobuf, and into the gRPC Java folder and into the billing package. This file, billing service gRPC, is where we pull the billing service impl base from. So if you're having problems with this import, make sure that you have the target folder generated and that you have this file in it. And also in IntelliJ, sometimes it doesn't pick up the generated sources correctly. So what you can do is right click on these two folders, the gRPC-Java and the Java folder, and right click and scroll down. And then you'll see an option that says mark as sources root, and just click this and you will know it's working if your folders in here turn blue. So this tells Maven and IntelliJ that we want to compile this code in our IDE directly as we're developing. So typically stuff in the target folder gets ignored as it's essentially the compiled version of the code you already have. But sometimes we want to include any generated code, such as our gRPC stuff, into our IDE and IntelliSense and things like that. So those are some things to try if you're seeing any errors. The next thing we want to do is we want to implement the create billing account method. So inside the method we just created here, we're going to say at, and then we'll say override, and then we'll take a new line, and then we'll say public void create billing account, and then we'll open some braces, and then we'll say billing dot, and if you do control space, the IntelliSense should open here, and it's given us all the options that we have inside the generated billing package that has all our gRPC stuff. So we're going to accept a billing request. So go ahead and double click this, and then we'll call this billing request. Then we'll add a comma, and we scroll over, and in here we're going to say stream observer, open some angle braces, and then in the angle braces we'll say billing dot, and then we'll say billing response this time, and outside of the final angle brace we'll say response observer, and just outside the last brace here we're going to open and close some braces just like this. Now the next thing we need to do is import the stream observer class. So go ahead and import this from the io.grpc stub, and it should appear up here just like this, and this should fix any errors. So all we're doing here is we are overriding the create billing account method that gets generated in our billing service impl base class. So if we jump back for a second into our project and into our proto file, in here we have specified the method that our gRP service provides called create billing account. So this gets generated automatically as part of our code generation. So if we jump back to the billing gRPC service again, what we can do is override this method and add our own logic. So this method exists up here in billing service impl base. So before we implement our create billing account method, I just want to explain a bit about this line here, which is the stream observer class. So whenever we receive a gRPC request to create a billing account, it's going to get handled here. So we receive the request and convert it to a billing request class so that we can interact with the request. And once we have completed any business logic and ready to return a response, we use what's called this stream observer. So a stream observer is a pretty powerful concept in gRPC, as with a stream observer, it lets us do things like earn multiple responses to the client at the same time, and also accept back and forth communication to that client. So by that, what I mean is once the client makes a connection to our server, we can send and receive data back and forward in real time from the client to the server. For example, in a chat application, you would send messages back and forth. And another example is with live dashboards. So as we create more billing accounts, we can return the real-time billing data back to the client, and they will get updates in real time, and they can do what they want with those updates. So this is different from standard REST HTTP requests, as REST typically uses a single request, single response model. So in the case of REST, if the client wanted to get some real-time updates on the billing analytics, for example, then they would have to continuously make GET requests every few seconds to our endpoint. So stream observers are more powerful in that regards, as it gives us a lot of flexibility into how we open connections and handle different types of back and forth communication with our clients. So that's just a bit of an overview on what the stream observer is and how we handle responses. But in this example, we're just going to return a single response back to the client with some information in it, which we'll see now. So at this point, we can implement our create billing account method. The first thing we're going to do is we're going to say log, and then we'll import the org.slf4j.logger package, and it should appear up here in your code. Then we'll say dot, and then we'll say info, and then we're just going to add a string in here, and then we'll say create billing account, request received, just like this, and then we'll open and close some curly braces, and outside of the string we'll say comma, and then we'll say billing request dot, and then we'll say toString. So all we're doing here is we're just going to log a message to our console that says we received a billing request, and just to display the properties in that request as a string. So this is helpful, as it will help us as developers to see that our server is accepting requests as we test out this functionality once we're finished implementing it. So all being well, we should see info message with the billing request appear in our console. So the next thing we're going to do is we're going to take a new line, and this is the point where the billing service would implement any business logic that it needs to do. So we'll just add a comment in here. We'll say business logic, e.g. save to database, perform calculations, etc., and so on. So for example, you might call a billing service method like we did in the patient service to perform any business logic, do database saving and things like that. So we're not going to implement any business logic right now, as we're focusing on the gRPC parts of the course, but this is where you would do it. And then after the business logic has completed and successfully run, what we will do is create a billing response object. So up here, as part of our stream observer, we say that the type of data that we return as part of the response observer object is going to be of a billing response class. So we have to create this. So we'll say billing response, and then we'll just call this response, and this will be equal to billing response, and then we can say dot new builder and open and close some braces, and then we'll take a new line, and then we'll say dot, then we'll say set account ID, and then we're just going to add in a random string here, and on a new line say dot set status, then we'll just say active, and then at the end we'll say dot build. So your code should look like this. All we're doing here is that we're pretending that we created a billing account for this patient, and we're returning the ID of that account, which is just a pretend ID that we have made up, and then we're just returning a status as well of active. So again, this is just some dummy data that we are going to return just to simulate what would happen with the billing account. And then at the end, we use the dot build method to complete the builder chain of calls, and at the end we will get a billing response object that's assigned to the response variable. And now all we have to do is return this response. So we'll say response observer. So this is the thing that we get as part of the arguments up here. And then we say dot on next, and then we'll pass in the response. And on a new line, we'll say response observer dot on completed. So there's two things that happen here. This first line is used to send a response from our gRPC service, in other words, the billing service, back to the client, which in this case is going to be the patient service. And on the next line, we say that the response is completed and that we are ready to end the cycle in this response. So the reason we need two lines for this is because we can send many responses back to the client if we wanted to. So say, for example, if we wanted to return another response before we completed the stream, what we would do is just use the on next method again and pass in another billing response. So in gRPC, we can return as many responses as we want before we decide to complete the request, which is quite powerful compared to REST, as it lets us do some of the things we discussed earlier, such as send real-time analytics or handle chat applications and things like that. So that should be it for our create billing account method. And hopefully you're seeing that it's not too different to how we handled REST requests in our patient service. So we set up a gRPC service and we implement the different methods that we specified in our proto file to handle requests and then send responses. Now at this point, we can start our billing service and we can test this endpoint to see if it works. So now the next step is to start this billing service app in IntelliJ and test if we can handle gRPC messages that we receive. So at the top, if you choose the drop down for the run configurations, and towards the bottom, you should see one for billing service application. So this is what IntelliJ creates for us anytime we create a new Spring Boot app, and it runs the Spring Boot server on our local machine. So before we Dockerize our billing service and do all that stuff, just going to make sure that the gRPC service works outside of Docker, as it's easier to track down any issues, as it rules out any Docker related problems that could be causing an issue with our application. So once we know that gRPC service is running properly and handling requests and responses as we expect, we can then go and Dockerize the application like we did with the patient service. So just go ahead and select the billing service application option then. And as you can see up here now, our ID is set up and configured to run this application. So So before we start this, we need to go and specify some ports. So in the project window, we're going to go into the billing service, and then we're going to go down to the resources folder and open this up. And this is where we have our application.properties file. So there's not very much in here at the minute. We just have the name of our application. But what we want to do is we want to specify the ports that our billing service exposes. So on a new line, we'll say server.port, and then we'll set this equal to 4001. So this can be whatever you want really, but because we're going to have a ton of microservices in this course, we want to try and keep things as organized as possible. So our patient service is running on port 4000. So it makes sense that the next service that we create, billing service, is going to run on port 4001. So again, this doesn't matter, but we're just following the specification that any of the microservices are going to expose REST endpoints on the 4000 range. And we can do similar for our gRPC server port. So we'll say grpc.server.port is equal to, and then we'll just say 9000, and then we'll say 1 as well. So all we're doing here is we're specifying the port that our gRPC server runs on. So our billing microservice is set up to receive REST requests on port 4001, and it's set up to receive gRPC requests on port 9001. So this is the good thing about using Spring Boot and these different technologies, is that we can have a microservice setup that uses REST requests and also gRPC requests and other things such as Kafka, which we'll see later, all in the same service. So these don't have to be unique. A single service can use many things provided they are set up correctly. So at this point, we have our port set up and we've got our code ready to go. So all we have to do is start the application. So up here, just make sure billing service application is selected and then choose the run button. And this will start the billing service inside IntelliJ. And if we scroll over, there are some messages that we want to look for. So you can see it says Tomcat started on port 4001. So this is our standard REST Spring Boot stuff that started successfully. So this is good. And then we'll see some log messages around the gRPC stuff on how it's registered the gRPC service called billing service, and it's using the billing gRPC service class that we just created. So this is good. And there's some other stuff around here around the protobuf setup. And the most important line down here is that the gRPC server has started on port 9001. So this means Spring has successfully started all the different things that we need, and the app has started as well. So if you're seeing any problems in here, have a look at the error messages and then double check that you have a target folder and that you have added the different pieces of code to the right packages and so on. So you can have a look at the GitHub completed repository for that. But now that this has started, the next thing we can do is make a gRPC request to create a patient's billing account to our new service. So we'll keep this running and we'll just hit the minimize option up here. And just like the REST request we made earlier to test our patient service REST endpoint, we can use the same approach to test our create billing account gRPC endpoint on our billing service. So to do this, we're going to go into the project tree and we'll scroll to the top and then we'll just close everything down so we can see. And we're going to right click on the top level project folder, so patient management, and choose new. And then we're going to choose directory, and then we'll call this grpc-requests. So just like we created the API requests earlier to test the different REST services that we have, in other words, the patient service, we're going to store our gRPC requests in the same way. So right click on grpc-requests, and then we'll just add a new directory in here. And then this will be called billing-service. And in here, we're going to right click again on the billing service folder, choose new, and then we're going to go down to the HTTP request option. And in here, we're going to call this create billing account, just like this, and then we'll hit enter. So remember, gRPC uses HTTP 2 under the hood, which is similar to REST, which uses HTTP 1, which is why we can use HTTP requests to test our gRPC server. So on the right, you should see an example request. What we're going to do is just delete all this. And the first thing we need to do is specify the protocol of the request that we're making. So in this case, we're using gRPC. So the nice thing about IntelliJ IDEA Ultimate is that it has good support for these types of requests. So we'll say gRPC, and then we'll say localhost, and then we'll specify the port, which is 9001. So again, this is the port where our billing service gRPC server is running. And then we'll say /, and in here, we will add the name of the service that we are trying to interact with as we specified it in the proto file. So we'll say billing service, just like this. And we have a look at our proto file again. After we specified the service, we'll add a slash, and then we want to specify the RPC method that we want to call. So in this case, it's create billing account, just like this. So the way this endpoint works is that the first bit is going to be the address of the server. The second bit is the name of the service. And then the last bit is the name of the RPC method. So this maps to the definitions in our proto file. So if we have a quick look at the proto file again, so just double tab if you want to follow along, and then we'll go to files, and then we'll say billing service.proto, and this will bring us to our proto file. And this is the bit that we are looking at. So we are calling the billing service, and then we're calling the create billing account method inside it, which is what this endpoint means. So the next thing we need to do is specify the protobuf message that we want to send along with this request. So again, if we have a look at our proto file, we have defined the billing request protobuf message as having these properties. So we need to send a patient ID, a name, and an email, and all of these things need to be sent as a string. So we'll jump back to our request file, and we'll add an object in here, and then we'll just add these things in. So we'll just say patient ID, and then we'll just say a random number, and then we'll add a comma, and then we'll say that the name is going to be John Doe, and then we'll add a comma again, and then we'll say email, and then in here we'll just say John Doe at example.com, just like this. So this is what our message is going to look like, and this will get converted to the billing request object in our billing service code. So as you can see, this request is very similar to the REST request we made earlier, in that we just specify the endpoint that we want to send some stuff to, and then we specify that stuff down in here. So now on the left, what we can do is hit the run button, and this should bring up the services window. And then if we have a look at the output here on the right, you can see that we get a response back from our gRPC endpoint. We get a fake account ID back, and then we get a fake status account back as well. So these things we hard coded into the response of our create billing account method in our service. So this means our gRPC service is working. So if you are not seeing this response in your services window, have a look at the run window and have a look for any errors. You should also see in the run window the log message that appears whenever we implemented the create billing account method. So we added the log message that said that we received a request, and it should display the different properties of that request as well. If you're not seeing this, then there's likely an issue with your code. So have a look at the finished example on GitHub to compare yours to mine and double check that you have imported all the dependencies and things from the right places. So at this point, we have our gRPC server that's running in the billing service. The next thing we're going to do is we're going to Dockerize our billing service application and deploy a container to our internal network. This allows us to test that the gRPC stuff is working when it is deployed to a Docker container, and that will give us confidence that when we deploy that container to production, that everything is going to work as it does in our local dev. Okay, so to Dockerize our billing service, what we're going to do is we're going to jump into the project window, and we're going to go to add the billing service, and on the billing service folder, we're going to right click, choose new, and then we're going to go down to Docker file. And on the right, you can see that a new Docker file has been created for us. So we'll just delete the code that was added. And since we have already created a Docker file that Dockerizes a Spring Boot application in the form of our patient service Docker file, it makes sense just to copy the code from that and reuse it here. We will jump into the project window, and we will go to the patient service this time, and then we'll open this window, scroll down until we see the Docker file, and then we'll open this, and then we'll just Control A to copy everything, and we're going to jump back to the billing service Docker file, which should be empty, and then we'll just paste it in here just like this. So a quick reminder on what happens here is that we use a base image that comes from Maven as a builder step to build the app. So it's going to install all the dependencies using our pom.xml file, and then it's going to copy all the source code over, and then it's going to package everything up. After it's been packaged, on the next step, we're going to copy the jar that comes from the target folder, and this target folder jar is going to have all the auto-generated code that we need for our gRPC service to work as well. And then we expose a port, and then we define an entry point on how to start a container based on this image. So there's a few things that we want to change in here. So the build step is the same, so that's fine. But on this step down here on line 17, we want to change patient service, so this here, to be billing service. And this is going to be the name of the jar. And then we also want to specify the port that the app runs on, which in this case is going to be port 4001. And then we also need to state the port for the gRPC server that's running. We'll say expose, and then we'll say 9001, just like this. And that should be it. So now we have a Docker file for our billing service. We can create a run configuration for this so that anytime we make changes to our billing service code, we can run the code through IntelliJ, which will build a new image for us and start a new container all within the ID. So up here, we're going to choose the three dots, and then we're going to go to edit. And on the left, under Docker, we're going to add a new configuration. So just choose the little plus icon above here, and then we're going to choose Docker file. And on the right, we're going to call this billing service. And under Docker file, it should have pre-populated the name of the Docker file, but if not, just make sure that it's the Docker file in the billing service that we're using. And then the image tag, we'll just call it the same as the service. So we'll say billing-service, add a colon, and I will say latest. So we're just telling Docker that we want to tag the billing service with the latest tag. And the next thing we need to do is expose some ports. So on the right hand side, choose modify options, and then we'll go down to bind ports. This will appear down here under the run options. And the next thing we need to do is specify a container name. So we'll just call it the same as the service, just so it's easy to track these things. So say billing service, just like this. And the next thing we need to do is we need to go into the modify tab here, and then we'll choose bind ports down here. And here we need to expose some ports on our container, which is helpful for testing and for development. So on the right, we'll choose the little folder icon, and we're going to just add some port bindings in here. So go ahead and choose the little plus icon here. And the first thing we will do is we will expose a port for the Spring Boot REST endpoints. So we'll say 4001, and then we'll add a container port that says 4001 as well. And then the next port binding we need to add is one for the gRPC server. And this runs on port 9001, and it's going to run on a container port of 9001 as well. We'll go ahead and hit OK. And the last thing to do is under the modify tab, we're going to add a run option. So choose run options down here. And in this input, we're going to add this container to the internal network so that other containers, such as the patient service, are able to communicate with the billing service when everything is Dockerized and running inside of our Docker networks. So we'll say -- and I'll say network, and I will say internal. So I think that should be it. So go ahead and hit apply down here. And what you can do now is choose this run button, and hopefully this starts, and then see a message here that says cannot access the Docker daemon. So that means I haven't started my Docker desktop app. So go ahead and start Docker desktop, which will also start the Docker context behind the scenes. And after this is running, you can choose this little green button again that will start Docker, and then it will say it's connected. So all we have to do now is try to run our Docker config again. So at the top here, we'll just hit the run button, and hopefully in here you should see some better logs, and it looks like some Docker things are happening. So it's building the image for us, and it's just installing all the dependencies. So again, the first time this runs, it's going to take a while because it's the first time that we are creating this image. So it has to download everything from scratch, but the subsequent Docker builds should be faster because Maven will cache the dependencies. So all being well, by the time it finishes, you should see in the output log window here, the Spring Boot startup logs that we see when we start the app normally outside IntelliJ. And we'll just have a look at some of these logs just to check for the correct logs. So Tomcat started on port 4001. This is good. And gRPC server started on port 9001. And we know our container is good because it's gone green and we have the little dot icon above it as well. So this is good. It looks like we now have a Dockerized billing service. Our gRPC service has started, as well as our Spring Boot app. So all looks good so far. So now we'll keep this running, and then we'll just minimize this window. And if we go back to our project tree, and we're going to go to the billing service again, and we're going to choose the create billing account.http file. So this is the request we made earlier to test our gRPC server. So in theory, everything should work the same because all we've done is Dockerized our application, but the endpoints and the ports and all that stuff are exactly the same. So if we hit the run button on the left here, we should see a response, and we do. So we get the dummy account ID that we hard coded in our code, and also the status as well. And we will just have a quick look at the container. So the services window, if you scroll down to the Docker section under containers, and if you click on the billing service one, you should see the output logs, and scroll to the very bottom, and you should see a message that says create billing account request received with patient ID, and then whatever you sent in the request, and you should see a name and email as well. So this is good. It shows now that we are able to start our gRPC server as part of the billing service inside a Dockerized container. If you're having any problems at this point, have a look at the Docker file again, just to make sure that all the code is good there. And again, just compare your code to the final code on the GitHub repository for any mistakes that might have popped up along the way. So now that we've created our first gRPC server, it's ready to accept requests from clients. We're going to jump back into the patient service and see how we can send a request to create a billing account for a patient to our new service once a patient is created. Okay, so at this point we have our billing service created, and we've also created our gRPC server, and we tested a gRPC request which sends a protobuf content to our gRPC server, and we're able to read the protobuf message and so on. So the next step is that we want to implement the gRPC client in our patient service so that we automatically create a billing account for a patient when a patient gets created. So the first thing we will do is we will set up the gRPC client and the protobuf files that we need in order for this to work. We'll jump into our code, and what we're going to do in here is go into the patient service, and in the patient service we're going to go into our pom.xml file, and we need to add the same dependencies in here that we added to our billing service so that we can generate our gRPC client based on our proto file. So just like before, what we're going to do is scroll down to the dependency section, and we're going to add our dependencies in here. So again, the best way to get this is to go to the GitHub repository and scroll down to the gRPC setup section under billing service. So again, this link is available in the description, or just go to my GitHub repo and find it there. So once you're here in the README, go ahead and copy the gRPC dependencies that we need. So it's all this stuff here, and we'll jump back to our code, and then we are going to paste it in just above the closing dependencies tag here, just like this. And you should have all these dependencies in your Maven repository, because all of our microservices use your local Maven repository that's stored on your machine. So it should be there, but if not, just go and reload the project by going to the project tree over here, and then right click on pom.xml, and then just scroll to the bottom, and under Maven, choose the reload project option, and this should hopefully fix any errors. So again, we'll jump back to the README in the browser, and we'll scroll down just a bit until we see this section for the build tags that we need. So again, go ahead and grab this and jump back to the code, and in pom.xml, towards the bottom of the file, you will see this section that has some build tags in it. So go ahead and select this and just delete everything, and we'll do Control V to paste in the code that we just copied. So again, we will probably see some errors here around some of these unresolved variables. So we'll just reload the project from our pom.xml using the Maven option, and if we have a look, this will resolve everything. Okay, so now we have our dependencies. The next thing to do is we need to get a proto file. So the proto file is important as it's used to describe our services, as well as the shape of the request and the shape of the responses. So go ahead and open up the project tree, and we're going to go into the billing service here, and we're going to go into the source folder, and we're going to right click on this proto folder, and then we're just going to copy this. So we'll copy this, and we'll jump back into the patient service, and then we'll just paste this inside of the source folder. So this window will appear, and just go ahead and click OK. And now you open up the new proto folder. There will be a billing service.proto file in here, and this is going to be exactly the same as the one that's used in the billing service. And we're going to keep the name as billing service because that service owns this file, or in other words, this file describes on how to interact with the gRPC server that runs in the billing service. So again, just as a reminder, this proto file in a real enterprise environment would live in a central location, and each of our microservices, so the billing service and the patient service, would both consume that file from wherever it's located. This way, all of the services are working from the same file, so if anything changes, all the services will get those changes as well. But for learning purposes, we're just going to copy the file across to our two services, because it takes quite a while to set up a central repository to store our proto files. So now that we have our proto files in place in our patient service, what we can do now is use Maven to generate the code that we need to interact with the billing service gRPC server. So what we'll do is open up the Maven tab on the left here, and
We're going to go into patient service, and in the lifecycle methods, we're going to choose clean, and this will run. And we will jump back into the Maven tab again, and under the lifecycle folder for the patient service, we're going to choose compile. So all being well, this will go and create a target folder that has our generated code in it. So let's have a look and see. If we close this down, and on the patient service folder, we should have this orange target folder. And if we open this up and have a look at generated sources, it hasn't appeared. Okay, so let's have a look and see why. So sometimes if you open up the logs, it might give some information as to what happened. So if we just scroll up, and we'll see that the protobuf stuff is trying to run. So let's have a look at this message, and it says the source/main/proto folder does not exist. And then it says review configuration or consider disabling the plugin. So what this means is that by default, the plugins are going to look in the source main proto folder and look for any proto files. And it's saying here that it couldn't find any. So that means we probably put our folder in the wrong place. So if we go back to the patient service and have a look at this, so we actually put the proto folder in the source folder, but it needs to go inside the main folder. So all we have to do is drag this into main, and then just choose the refactor button here and have a look inside main. Now we have the proto folder, so we can try this again and see if it worked. So we'll open up the Maven stuff on the left again, and what we'll do is choose the clean option. So what clean option does is it effectively deletes the target folder and clears the cache and things like that, so that we are starting from fresh. And then we'll jump back to the Maven tab again, and this time we'll choose compile, and this will compile all our code, and it'll try to do the protobuf stuff again. So if we have a look this time, it says compiling one proto file, so this is good, it's found it this time. So just to double check, we'll go into the patient service again, and in our target folder under generated sources, you can see we now have a protobuf option, and in here we have our gRPC Java and our Java folder. So what we want to do is highlight both of these folders, so the gRPC-Java and the Java folder, and then right click, scroll down till we see an option to mark directory as, and then we'll choose this, and then we'll choose generated sources root. So what you want to see is that the two folders turn blue and have this little icon in front of them. So this means that IntelliJ will pick up these folders as being code, so that it gets included in IntelliSense and things like that. Okay, so now we finally got the code generation working. We are going to set up the gRPC client that we need to interact with the billing service gRPC server. So we're going to scroll up, and inside of the patient service, we're going to go into the source folder and into main, into Java, and in our main package here, we're going to right click and choose new, and we're going to add a new package, and then we'll just call this gRPC. So this is where we're going to put all our gRPC code, and we've called it gRPC just for clarity, so it's easy to find things. As you can see, our patient service is starting to grow quite a bit in terms of all the different packages that we have. So inside of gRPC package, we'll right click, choose new, and we're just going to add a new Java class in here, and this is going to be called service gRPC client, and this is going to be a class, and we'll just hit enter, and this will create it on the right hand side for us. So the first thing we need to do in here is we need to add an annotation to this Java class so that Spring knows to manage it. So we'll say at, and we'll say service, and this will come from the Spring framework package. Inside of our method, the first thing we need to do is we need to create a variable to hold the gRPC client. So we'll say private final, and then we'll say billing service gRPC dot billing service blocking stub, and we'll call this blocking stub. What this is that it's a nested class within the billing service gRPC class that provides blocking, or in other words, synchronous client calls to the gRPC server that's running in the billing service. What that essentially means is that anytime we make calls to the billing service using this blocking stub, that the execution is going to wait for a response to come back from the billing service before it continues. So this is similar to how RESTful calls would traditionally work. So we make a REST call to a server, and then we wait for the response, and this blocking stub is going to work the same way. The only difference is that it's using the gRPC request as opposed to a REST request. So now we have a variable to hold our client. What we need to do is initialize this variable in the constructor. So we'll take a few new lines, and I will say public, and then we'll say billing service gRPC client, and then we'll open and close some curly braces, and this will give us our constructor. So inside of the braces here, we're going to pass in some arguments that get injected by Spring, and these are going to be environment variables that point to where our billing service address is. So we'll take a new line in here, and I will say at, and I will say value, open some braces, and in here we'll pass a string, add a $sign, open some braces again, and then we'll say billing dot service dot address, and then we'll add a colon, and I will say localhost. And outside of this brace, we're going to define a variable and a type. So we'll say string, and this is going to be the server address. Then we'll add a comma, and don't forget to import the value from the Spring Framework class to fix the error. And back over here, after the comma, we'll take a new line, and then we're going to say at again, and we'll say value, and we're going to open some braces, add a string, add a $sign, and open some braces again. And in here we'll say billing.service.grpc.port, and then we'll add a colon, and then we'll say 9001. And outside the last brace, we'll say int, and then this is going to be the server port. So what we're doing here is that we are going to add environment variables to our Docker container whenever it starts, and we're going to pass in the address of our billing service gRPC server so that we can connect to it. So just to remind ourselves, when we tested our gRPC endpoint in the billing service, we used localhost colon 9001, and then we called the billing service, and then we called the create patient account method on that service. So this address over here is okay for local development because everything is pointing to localhost. But when we deploy to a production environment, so for example on AWS, this address will change to be something like aws.grpc colon, and then the port might be different, but the actual endpoint itself will be the same. So it will look something like this. So by using environment variables for the address, which is going to be this first bit, and a separate environment variable for the port, which is the bit that follows on after the colon up here, it means we can configure easily where we want to point our patient service container to in order to connect to a given gRPC service. So this is the same approach we took with the databases in order to make our code modular, point our code to different services depending on the environment that we are in. So now that we have these variables, what we'll do is log out some messages to help with debugging in case we hit problems. So just inside of this curly brace here, we'll take a new line, and I will say log, and the option for SLF4J should come up. So just select this, and then we'll do .info, open some braces, and then we'll add a string in here that says connecting to billing service at, and then we'll add a space, add some curly braces, add a colon, and then add some more curly braces. And just after the last string, we'll add a comma, and then we'll say server address and server port. So this will help us debug any errors, because if the server address and server port are being picked up wrong, then we will be able to see this in our logs. So on the next line, what we can do is actually initialize our blocking stub, or in other words, our client, so that we can use it in other parts of our code. We'll say managed channel, and then we'll call this channel equal to managed channel builder, and then we'll do dot, and then we'll say for address. And then the first argument here is going to be our server address. So we are going to get that up here as an argument to our constructor that gets passed in by Spring. So we'll say server address, comma, and then the second argument we need is going to be the port, which we get from up here as well, and it gets passed in by Spring for us too. We'll say server port, and outside of the last brace, we'll say dot, and then we'll say use plain text, open some braces here, and then we'll say dot build. So what this does is it takes in the server address and the server port, and it creates what's called a managed channel. So all this stuff comes from the io.grcp package that we installed. So we don't have to write any connections ourselves. This is all being managed for us through the managed channel. And what the use plain text method means is that it disables encryption, which makes it a bit easier for local development and local testing. So now all we need to do is assign this to our blocking stub. So we'll take a new line just after the managed channel here, and then we'll say blocking stub is going to be equal to, and then we'll say billing service gRPC dot, and then we'll say new blocking stub to create a new blocking stub, and then we'll pass in our channel, and this will get assigned to our class level variable up here, and that's our client created. So now whenever we start our app, Spring is going to register our gRPC client as a service, and it's going to run all this code and start the client for us behind the scenes. And we should see this whenever the log message gets printed to the logs. So now that we have a gRPC client, what we can do is create different methods that use this gRPC client to interact with the billing service in different ways. So down here, just after the constructor code, we'll take a new line and we're going to say public and we'll say billing response, and then we'll import this from the generated code. So it comes from the billing package. And if we scroll up to the top, you can see that this is being imported from the target folder, which has the billing package in it. And all that was generated by Maven whenever we compiled the code, thanks to the help from our plugins. So down in here, we'll call this method create billing account. And in here, we will pass in the different arguments that the billing request is going to expect. So it's going to be a string of patient ID. We'll say string patient ID, add a comma, and I will say string name, and I will add a comma again, and I will say string email. So these are all the properties that the gRPC billing request expects. And at the end of this, we'll add some braces. What we can do is build out our request. So first thing is to create the request object. So we'll say billing request, and then we'll say space, and then we'll call this request. And this is going to be equal to billing request dot, and then we can do new builder, and then we'll do dot, and then we'll do set patient ID, and then we'll pass in the patient ID. And just to say this, we'll do dot, and then we'll do set name, and then we'll pass in the name, and then we'll do dot, and then we'll do set email, and then we'll do dot build at the end, just like this. And this will create a new billing request for us. So again, the billing request class was generated based on our proto file, and we get a builder that's also generated for us that we can use to easily set the properties on the request that we need. This is why we use the proto file, because anytime the billing request changes and we import the new file, our code will throw an error here and it says that we're missing a property or whatever. And to set the new property, all we have to do is call the setter that gets generated for us by the builder. So it's all quite nice in terms of code generation. So at this point, we now have a request object. All we have to do is send the request and capture the response. We'll take a new line down here and we're going to say billing response, and then we'll call this response is equal to, and then we're going to call our blocking stub. So again, our blocking stub is essentially our gRPC client that's going to wait for a response from the gRP server. And we'll do dot in here, and then we'll call the create billing account method, and we'll pass in our request just like this. So behind the scenes, this is going to do the exact same thing that we did whenever we ran the gRPC request manually. So what I mean by that is, in our project, we have the gRPC requests here, and inside of this, we have the create billing account.http file. And if we have a look at this, you can see we've got this request. So behind the scenes in our gRPC client, this code down here is doing the exact same thing as our HTTP request that we just seen. The only difference is a lot of it is generated for us, so we don't have to manage too much ourselves. So at this point, all we really want to do is log the response and then just return the response as well. So on a new line, we'll say log.info, add some braces, add a string, and then we'll say received response from, and then we'll say billing service via gRPC, and then we'll add a colon, add a space, and then we'll add some braces, and then we'll just add to complete this, and we're just going to add the response to the end. So again, this is going to help with debugging, as if there was any issues around the response, we should see it in here. And if the response was successful, we should also see the fake account ID and the fake status that we hard coded in the gRPC server on the billing service side. And the last thing to do is take a new line, and we'll just return the response back to the calling class so that it can do what it wants with it. And that's all we need to do for our gRPC client. So now we want to add a call to this method from our patient service whenever we create a patient. So we can close down some of these files, and just going to tap double shift again, and we're going to go into patient service.java. So in here we have our patient service class where we form all the business logic for handling patients. So what we'll do is scroll to the top, and what we want to do is we want to use dependency injection to inject our billing service client. So first thing is we will take a new line just below the patient repository variable here, and we're going to define another one for the billing service client. We'll say private final, say billing service gRPC client, and then we'll call this billing service gRPC client as well. And in our constructor that's just below this, in the arguments at the very end, just before the closing brace, we'll add a comma, and then we're going to just tab to autocomplete the code, and it's going to look something like this. So It's going to accept a billing service gRPC client class and assign it to a variable of the same name. So the last thing we need to do is just instantiate this variable up here with the one that gets dependency injected by Spring. We'll just take a new line over here and we'll say this dot billing service gRPC client is equal to the billing service gRPC client that gets injected by Spring. So now we've injected our client. We can use it anywhere we want in our code. So we'll scroll down until we see the create patient method over here. And this is where we want to add the call to the billing service to create the patient's billing account, provided the patient was completed successfully. So with that business logic in mind, it makes sense to do this after we try and save the new patient to the patient repository. So if this goes well, we can then call the billing service and try and create an account for them. So we'll say billing service gRPC client dot create billing account. And then what we'll do in here is we'll pass in the patient ID, the patient name, and the patient's email. And we will take this from the new patient that was just created. So the first argument is going to be the ID. We'll say new patient dot get ID, and then we'll do dot to string to convert the Jude type to a string type, and then we'll add a comma, and then we'll say new patient dot get name, add a comma again, and then we'll say new patient dot get email, and we'll add a semicolon at the end, and then we'll format this so it's easier to see. So your code should look like this, and that's it. So at this point, after the patient is created, we will create a billing account for them, which uses our gRPC client to call the billing service, and we get a response back that has a account ID and a status for that account, which should be created or whatever we hard coded it to be in the billing service. And then at this point, REST request to create the patient will complete, and the new patient will be returned back to the front end or the calling client. So the last thing we need to do before we start everything up is edit the environment variables in our patient service. So if we jump back into our gRPC client, remember we are passing in the server address and the server port for the gRPC server that runs in the billing service. So we need to make sure we pass these to our container through IntelliJ. So up here, we're going to choose the three dots and then go to edit the patient service configuration. And we'll scroll down until we see the environments variable section under the run section. And we'll just choose the folder on the right. What we'll do is we'll add a new environment variable. We'll go ahead and click the add button. And the first one we need to do is add the address for the billing service. We'll say billing underscore service underscore address. And then in the value, we are going to use the name of the Docker container that the billing service is running in. So all we have to do in here is say billing-service. And because the billing service container is on the internal Docker network, Docker is going to resolve the DNS for us and send a request to that container. So this is the same approach we took up here with the patient service database. We used a container name and then we just let Docker resolve this DNS to point things to the right containers. So the next one we need to add is we need to add the port. We'll add a new environment variable and then we'll say billing underscore service underscore gRPC underscore port. And this port is running on port 9001. And we know this is always going to be the correct port as this is what we set it to be in our billing service gRPC server. So go ahead and hit OK. And what you can do now is hit apply and then we'll just choose OK. Okay, so now we have added some new code to our patient service. We've updated the environment variables. We can go ahead and start all the containers that we need for our app to work. So what you can do up here is we'll start the billing service first. So just choose the billing service option and then you can click the run button to the right. This will start the billing service container. And the next thing we'll do is we'll start the patient service DB. So go ahead and start this one from the configuration options up here. And the last thing we'll do is we'll start the patient service microservice. So go ahead and hit run on this. So hopefully you're also seeing at this point how straightforward it is to stop and start containers and images all through IntelliJ, which is one of the really nice features about it. We will wait for our containers to start and it looks like everything has started. So this is good. And now what we can do is we can hide this window. We can close some of these down as we don't need them anymore. And then we'll just double tap shift and we'll go over to files and then we'll type create and we'll just open up our create patient HTTP request. So this is the REST request that we use to create a new patient in our patient service. So since the gRPC request to create a billing account happens behind the scenes on the back end, There's nothing extra we need to do in here when we create a patient, as it's all going to happen automatically for us, and the front end does not know about any of the implementation details. So all we need to do here is just change some of these properties so that the patient is unique. So I'll just change the name to be John Doe with billing account or something like that. It doesn't matter too much because this gets saved as a string in the database. And the next thing we'll do is update the email just so that it's unique. Otherwise, our Spring validation will throw an error. So we'll just say test_billing account as the email address. And if we hit the run button on the left, all being well, we should trigger the flow. We should get a successful response back, just like we did before with the patient's details. So go ahead and hit run. If we open up the services window, you can see we get a 200 response back. So this is good. And we also get the patient who was just created back. So this is good, as it shows we haven't broken anything in our patient service. So the next thing we can check, make sure things are working, is we can check the logs in our billing service and our patient service. And this is the patient ID of the patient who was just created. And then we should also have an email address and a name of the patient who was created as well. And then if we have a look in the patient service logs, we just double click on patient service over here. You can see we should have a log message here from our client, and it says received response from billing service via gRPC. And it's got an account ID, and this is just the fake account ID that we hard coded. And also we get a status back. So if you're having any problems at this point, it would be best to check the patient service code that we just added and also the billing service code that we just added. And also make sure that you have all the dependencies from the README and have reloaded your Maven projects and things like that. And otherwise, if you're seeing all these log messages and getting a successful 200 response back from your create patient request, then congratulations, you have just created your first service-to-service communication functionality that uses gRPC and protobuf. So at this point, feel free to stop and have a look at some of the code that we just wrote. Try and understand it, maybe change a few things, such as add your own property to the protobuf request and see what happens. And when you're happy, we're going to move on to the next section. Until this point, we have been using synchronous technologies like REST and gRPC to interact with our different microservices. So just to recap what this means, one service sends a request to another service, and then it waits for a response before it can continue execution. So this is fine for any one-to-one interactions, but what happens when a service needs to communicate with multiple microservices at the same time? So let's imagine that we have added 2 new microservices into our setup that need to be notified when a patient is created. In the synchronous setup, we would need to make multiple requests from our patient service, one for each new service, and then we would have to wait for a response to come back from each of these services. This not only slows things down, but also blocks other operations while we wait for a response. This can also cause problems if our traffic grows, because each time a patient is created, there are going to be 3 internal gRPC requests to the different microservices. So if you imagine in an enterprise environment where there could be hundreds or even thousands of patients being created in short succession, this would increase the load on our internal servers due to the amount of internal requests that are being made. Now, in a different scenario, let's imagine where one of the services is slow or even temporarily unavailable. That single bottleneck can disrupt the entire system. This is where asynchronous communication comes in. So by leveraging tools like Kafka, we can completely transform how our services communicate. So instead of waiting on responses, a service can publish an event to a Kafka topic. Other services that then need that information can consume it independently on their own timeline. And our patient service does not need to wait for a response. It simply sends the events and carries on with its current execution path. So in our microservices setup, we are going to send a patient created event using Kafka, and all the services that are interested in this event, in this case, the analytics service and the notification service, can consume these events and perform any logic it needs to perform using the data inside of the event. So this method of asynchronous communication opens the door to building a more efficient and reliable system. If any of our services go down in this case, it doesn't affect the other services, as they will continue to consume events from the topic, and the patient service can still send events to the topic. Likewise, if we need to add more microservices that perform logic when a patient is created, that microservice can subscribe to the topic and consume patient-created messages. The patient service does not need to be updated to make requests to the new microservice. So these are the new things that we are going to build and add to our current microservices setup to understand how Kafka works in enterprise systems to communicate between the different microservices. But before we get into the code, let's have a look at what some of these terms mean so that we understand better what all these different bits and pieces are doing. So there's a few key parts that we need to know in order to understand Kafka and how it works. So here in this green box, we have what's called the Kafka broker. So a Kafka broker is essentially a server that stores and delivers messages to consumers. So this is a standalone thing that will be hosted within the microservices setup, depending on the setup and the architecture. Inside of the Kafka broker, we have what's called the topic. So a topic is a categorized channel where messages are stored and exchanged. So basically a Kafka topic is used to hold different events that match a certain category. So for example, we might have a Kafka topic called patient events, and this topic would hold all of the events that are related to a patient, such as patient created events or patient updated events. So an event is a single piece of data or a message that is stored on a topic and is sent from a producer. So these events can have anything we want within them and are usually stored in a specific format such as JSON or protobuf. So for example, a patient created event might contain things such as the ID of the patient that was just created, the name of the patient and the email address of the patient and so on. So in order for events to make their way onto the Kafka topic, we need what's called a Kafka producer. So a producer is some code that lives inside of our microservice that is used to send events or messages onto a specific Kafka topic, and it contains any data that any of the consumers need in order to perform the different bits of business logic that they need to do. So a consumer then are also code that lives inside of individual microservices that is used to read any messages from a Kafka topic. So in this case, we have two consumers, and these would typically be two different microservices. So as new microservices join, they can easily subscribe to existing Kafka topics as consumers or produce messages to relevant topics. So any producer can send a message to any topic that it wants to, and any consumer can consume a message from any topic that it wants to as well. And we also see here an example of a consumer that is consuming from many topics. So this architecture is really scalable, as it means that any consumer can read any topic that it needs to read in order to get the data that it needs to work, and any producer can send any message to any topic depending on how the system grows or the business requirements. So this is the basics of Kafka that we need to understand in order to get things to work. There are quite a few additional features of Kafka that make it really scalable and powerful. For this course, we're going to focus on setting up our own Kafka broker and sending messages and consuming messages from our different microservices. So when do we use gRPC versus Kafka? gRPC is perfect for one-to-one communication when we need an immediate response from the other service. So for example, we used gRPC to interact with our billing service, ensuring that a patient's billing account was created immediately when the patient was registered. So Kafka is ideal for one-to-many microservice communication when immediate responses are not required. In the next section, we will see this in action as we build a notification service to send a simulated notification to the newly created patient, and we will also log an audit entry in our analytics service for that patient as well. So now that we have an idea on how Kafka works and how it's going to fit into our microservices setup, the first thing that we're going to do is we're going to set up our Kafka broker. So again, the Kafka broker is just a server that runs Kafka and manages all the topics and all the events. And the easiest way to start a Kafka broker is to use a Docker image. So similar to how we used Postgres to start a database for our patient service in our development setup using Docker, we're going to take the same approach here. This just means that the Kafka version and the setup that we use across our different environments, such as development and production, are going to be the same regardless of where it runs. So to do this, the first thing we need to do is we need to get a Kafka Docker image. So since Kafka is quite popular, there are a number of open source images that we can use. So if we quickly jump to the browser, and if you go to dockerhub.com and just search for Kafka, one of the first ones you'll see is this bitnami/Kafka image. So this is one of the most popular ones that is used quite a bit in enterprise environments. And as you can see down here, it's got over 100 million downloads and it's pretty flexible. So if we have a look at the overview, there's a whole bunch of stuff that we can do and settings that we can apply and so on. So feel free to have a look at this page if you want and explore all the different things you can do with this image. When you're ready, what we will do is we will just copy this name and we'll jump back to IntelliJ IDE. And in here, what we're going to do is we're going to go to the top here and we're going to add a new configuration that will let us start a Kafka Docker container based on an image, similar to what we have done so far with our different services and our different database containers. So go ahead and choose the three dots on the right, and then we'll choose edit. And on the left, we're going to choose the add new configuration button. So this little cross here, and then we're going to choose Docker image down here from the options that appear. So in here, there's a few things we need to specify. And the first thing we'll do is we'll change the name up here. So we'll just call this Kafka. And in the image ID or name, what we want to do is paste in the bitnami/Kafka image, and then we'll add a colon and it will say latest. So all we're doing here is we're telling IntelliJ to go and get the bitnami Kafka image from Docker Hub and download it to our local repository. And this is what we're going to use to start containers. So the next thing we need to do is specify a container name. So we'll just call this Kafka, just like this. And next we need to specify some ports. So go to modify options, and then we are going to go to bind ports down here, and we'll select this. And in the input that appears, we're going to choose the little folder icon. And in the window that pops up, we'll choose the add button on the left. So the first port that we need to expose is the internal ports that Kafka exposes in order for producers and consumers to connect to it. So this is specified by the Kafka image. So it's the default that we need to use. And then this port is 9092. So we'll set that as the host port. And again, in the container port, we'll just set this to the same port. So Kafka runs on port 9092. So we're just exposing this so that the other containers in our Docker network can connect to this port. And we'll add another port, and then we'll say 9094. And in the container port, we'll say 9094 as well. So this port that we're opening isn't required, but it's helpful for development, as it means we can access the Kafka instance from outside of a Docker network, such as from a terminal in our IDE or a Kafka client that's running separately. So go ahead and click OK. And the next thing we need to do now is add a bunch of environment variables. So in the modify options tab again, we'll scroll down until we see environment variables here, and then we'll choose this. And in the input that appears on the right, we'll choose the folder icon and open this up. And in here is where we can specify the environment variables that we want to set when our container is going to run. So there's a number of different environment variables that we have to set in order for Kafka to run. It would be quite tedious and error prone to type all of these individual environment variables out. So what we're going to do is copy them and paste them in here from the README in the GitHub repository. So again, you can grab the link to the finished GitHub repository in the video description. And once you're here, just scroll down until you see the README, and there will be a section called Kafka Container. And in here, there's a code snippet that has a lot of stuff in it. So we'll copy this in to IntelliJ and we'll explain briefly about what some of these things do. So on the right hand side, just choose the copy button and then jump back to IntelliJ. And what you want to do in here is choose this little paste button, and hopefully all the environment variables get pasted in properly based on the string that was just copied. So there's a bunch of stuff here, and it might be a bit confusing if you're looking at it for the first time, but essentially all this does is that it passes some important option to our Kafka container. So for example, this advertised listeners up here specifies the internal addresses and the external addresses that this Kafka instance is going to run on. And this bottom one here, the process roles, specifies what we want this Kafka container to do. So we've said we want it to be a controller and we want it to be a broker. What the controller role is here is that it's essentially a setting that we pass to this Kafka container to tell it that it is the main Kafka broker in the cluster of Kafka brokers. So what I mean by that is that we can scale our Kafka servers depending on how much load our enterprise app currently has in terms of traffic. So for example, we could have 3 Kafka containers that are running in different servers. And what the controller role does is it tells this container that it is in charge of orchestrating all of the other Kafka containers in our microservices setup. This includes things like ensuring the topics are partitioned correctly across the different container nodes and that the messages are sent efficiently to a given Kafka container without any duplication. So that's a brief overview of, so that's just a quick overview of the controller role and how Kafka can scale, but that's a bit out of scope for this course as it's a bit of an advanced topic. So for now, all we need to know is that we are specifying the environment variables that we need in order to get our container to run, and that other containers can access our Kafka broker. Okay, so now that we have this, we can click OK on the bottom right. And the next thing we need to do is we need to specify that we want our Kafka container to run in our internal Docker network. So if we go to modify options and we'll go to run options, and in the input that appears, we'll say -- network, and we'll say internal, just like this. And that should be it. So now we have everything in place that we need to start a Kafka container in our local microservices setup. What we can do is choose the run button down here, and this will pull the Kafka image from Docker Hub, and it will start a new container based on that image using all the properties that we specified, and it will add it to the internal network so that other containers can communicate with this container. So go ahead and hit the run button. You should see the services window open, and all being well, you should see a whole bunch of logs appear. And at the very bottom, the last log message you should see is Kafka server started. And you should also see on the left that we have a healthy container because everything is green. You should also see somewhere along the lines that we have this line that says awaiting socket connections, and it specifies localhost and the port 9094 as well as 9092. So this means that our container ports are open. So these are the internal and external ports that Kafka are configured to use out of the box. And this is why we needed to expose those ports whenever we started this container in our options. So that's essentially it. We now have a Kafka broker started. So if you're having any issues, the main thing to check is just to check the different options in your run configuration, specifically the environment variables, because that is where things are likely to go wrong. So if you're seeing any error messages or you are not seeing this Kafka server started message, go and double check the configuration. And once you're happy, we will move on to the next section. Okay, so now that our Kafka server has started and we have a running broker in terms of a Docker container, what we can do now is use some of IntelliJ IDEA Ultimate's built-in Kafka tools to test our broker to ensure that it can handle events successfully. So what you want to do is go into the IntelliJ settings tab, which you can find from the file option at the top, and under the plugin section, what you want to do in the search bar is search for Kafka. So it should be enabled already, but just double check that it is. So just tick the box and then choose apply and OK down at the bottom, and this will enable the Kafka plugin in your IDE. So on the left, you'll see this little icon here, which is the Kafka tools window. So if we go ahead and click this, it will bring up this window with a Kafka tab and a message that says there are no connections are set, add a new connection. So what this will let us do is it will let us connect to our Kafka broker and simulate the producing and consuming of different events. So in here, what you want to do is click add new, and this will bring up this window. And the only thing we need to change in here is we need to change the Bootstrap servers option. So because we're running inside a Docker container, our external Kafka port that we can access is on port 9094. So just go ahead and change this, and that's all we need to change. So what you want to do now is click the test connection button, and all being well, it should say connected with a green tick. So if you're not seeing this, make sure that your Kafka Docker container is running and that you've changed the port up here. And once this is working, go ahead and click OK. And as you can see now, there's some more options have appeared in our window. So on the left, we have topics and consumer groups, and then we have some options on the left-hand side as well. So the first thing we need to do is we need to create our patient topic. So go ahead and expand the topics option here, and you'll see that there's nothing there. So if you right click and choose create topic, it will bring up this window, and all we have to do is call this patient, just like this. And there's some other options here that we can ignore and go ahead and hit OK. And as you can see here, we now have a patient topic, and if we click it, you can see that there's some information here around the topic itself. So everything is set to 0 because we haven't produced or consumed any messages yet. But the next thing we can do is we can create a producer. So on the left, there's a little green arrow that's pointing up. So if you click this, and in the window that appears, there's going to be a few things. So on the left, we can specify the properties of an event or a message that we want to send. And then on the right, it will show all the data that is currently on that topic. So before we actually produce a message, we will create a consumer that will consume the message. So if we go back to the Kafka tool window down here, and in this tool window on the left, there's a little blue arrow pointing down, and this will let us create a Kafka consumer. So go ahead and click this, and at the top you should now have two tabs, a Kafka producer and a Kafka consumer. So what we'll do is we will start the consumer. So we have to fill out a few options on the left hand side here. So keep the topic as being the patient topic, as that's what we are going to produce events to and consume events from. And under the key section, we will keep this as being a string, and under the value section, we will change this to be bytes base 64. So this option down here, and everything else will stay the same. So now if you click the button down here that says start consuming, you can see that there's a little spinny icon here with a timer and a button that says stop consuming. So what's happening here is we have created a Kafka consumer that is listening to the patient topic inside of our Kafka broker. And over here, as you can see, there's an awaiting data placeholder text, which will display any messages as they are consumed. So we'll keep this running, and what we'll do is keep this tab open, and we'll jump back to the Kafka producer tab up here. So we'll click this one, and what we're going to do now is produce a message. So again, on the left hand side, we will keep the topic as being the patient topic, and the key we will keep as type string, and then we'll just add some text in here. We'll say test. In the value of our event, we are going to change the type as bytes base 64. We'll go ahead and choose this option, and then in the input we'll just add a string as well, and we'll say test. So that's all we need to do. And if we click produce at the bottom here, you can see on the right hand side we have an example of the message that was just sent. So it has a key of test and a value of test, as we can see over here. So now if we look at our consumer by jumping back to the Kafka consumer tab, you can see that the message has been consumed in our consumer. So over here, the key is test and the value is set to test. So this is good, as it shows our Kafka broker is working and we're able to produce events and consume those events from the patient topic. So it's good to get familiar with the Kafka IntelliJ plugin, as it's a good way to test Kafka things in isolation outside of any of the individual microservices. Okay, so now we have a Kafka broker that's running in its own Docker container. What we can do is we can add the Kafka producer in our patient service. So the Kafka producer is going to send a patient created event to a Kafka topic anytime we create a patient using a REST request. So this is going to tie into all the existing logic that we have so far. We're just going to add a new step to the flow. So as part of this, we will also create our Kafka topic, which we'll call patients, in order to send events to it. So by the end of the next section, we should have our Kafka producer and our Kafka topic up and running, and we will be able to see all the messages that are moving through the Kafka topic. So we'll jump into the code again, jump into the patient service so we can start creating our first Kafka producer. So on the left, we'll jump into the project tree and we'll go into the patient service, and we're going to jump into the pom.xml file. So the nice thing about using Spring Boot is that there is a Spring framework dependency that we can use that lets us connect to a Kafka broker from our code and easily produce and consume events. So to install this dependency, we will scroll up or down until we are in our dependency section. And what you can do is just above the closing dependencies tag, we'll add a few lines in here to give ourselves some space, and we'll add an angle brace, and then we'll add a new dependency group just like this. So the group ID, which we will add between the group ID tags, is going to be org dot, and we'll say Spring Framework, and we'll say dot, and then we'll say Kafka. So this is what your group ID is going to look like, and the artifact ID that we need is Spring-Kafka. Then the last thing we need is a version. So just add the version tags in, and the version that we're going to use at the moment is 3.3.0, and that's it. So this will give us some out-of-the-box code that lets us interact with our Kafka broker. So if you're seeing any errors in here, what you can do is just update your Maven repository by going into the project into the patient service and right click on pom.xml and scroll down to the very bottom of this list, choose the Maven option and choose the reload project option. And then this will reindex all the dependencies in your local Maven repository, and that should hopefully clear any errors that you're seeing in here. Our dependency in place, what we can do now is create the actual Kafka producer itself. So in the project tree, we're going to go into the patient service, and in the source folder, we're going to jump into main, and in the Java folder, inside of our main package here, we're going to right click and we're going to choose new, and we're going to add a new package, and we're going to call this Kafka. So this is where our Kafka producer code is going to go. So inside of this package, we'll just add a new file, and this will be a Java class, and we're going to name this Kafka producer, just like this, and the file should open on the right here. So this is where all the code is going to go that creates a Kafka producer. So this class will be responsible for sending events to a given Kafka topic. The first thing we need in here is we need what's called a Kafka template. So take a new line inside of our Kafka producer class, and we'll say private final, and we'll say Kafka template, and then we'll open some angle braces. And this is going to take two options. The first option is going to be a string, and then the next option is going to be a byte array. And then we'll call this Kafka template, and we'll add a semicolon at the end. And then we're going to import the Kafka template from the Spring Framework.kafka package that we just added to our pom.xml file. So go ahead and hit import, and it should appear at the top. Now it's going to give an error that says that this variable has not been initialized yet, but that's okay because we're going to come to that in a second. Firstly, I want to explain what this is going to do. This is essentially how we define our message types, and we use the Kafka template to actually send those messages as well. So by that, what I mean is in here, we are specifying that our messages that we send to a Kafka topic from this producer are going to be of key value pairs. So this is essentially telling Kafka that we are going to be sending a Kafka event that has a key of type string and it has a value of a byte array. So anytime we produce and send a message, we're going to convert all the data we want to send into a byte array, and we're going to add that to the event. And then we'll also add a key to the event as well, and we will send that event using the Kafka template. So we'll see how this works shortly. So don't worry if this doesn't make too much sense right now. The next thing we need to do is we need to initialize this variable. So what we'll do is we will auto-wire this dependency in the constructor of our Kafka producer class. So just below the variable, we'll take a new line, and then we'll say public, and we'll say Kafka producer, and then we'll just hit tab to autocomplete, and the code should look something like this. And inside of the constructor, we'll say this dot Kafka template is equal to the Kafka template that gets passed in. So all we're doing here is we're telling Spring to auto wire in the Kafka template implementation and assign it to our instance variable up here. And to make sure that Spring manages all the dependency injection for us, what we can do is add a tag up here just above the public class definition, and we'll just say at, and then we'll say service. So now this means that Spring will manage this class for us and inject all the dependencies that it needs. So now that we have a Kafka producer in place, or we can actually use the producer to send events to a topic, we need to define the properties and the type of data that we are going to send in an event. So just like with a REST request, we send JSON, and with a gRPC request, we send a protobuf format. We need to do the same with Kafka events. So there are different options you have here in order to define the format of your Kafka events. So you can use JSON if you want. You can use a map object to define key value pairs. But what we're going to do is we're going to use the protobuf format. So again, the protobuf format works well because it lets us define properties and generate code based on a proto file. It also works really well with Kafka, and it is something we have used before, our PC requests. So it will give us some extra practice working with protobuf files as well. So with that in mind, the first thing we need to do is we need to define a proto file that describes the event that we're going to send from our producer. So we will jump back into the code, and in here, we're going to go into the project tree, and we're going to go into the patient service, open up the file tree. In the patient service, we're going to go into source main folder, and we're going to go into the proto folder. So just a quick reminder about the proto folder. This is where we defined the proto file that describes our requests and response for the billing service when we did the gRPC section of the course. So it makes sense that we add in our proto file for the Kafka events in here as well. So we're going to right click on this proto folder, and then we'll go to new, and then we'll go to file, and then we'll call this patient_event.proto, just like this. And in this file, what we're going to do is we're going to describe all the properties that are going to be sent in any given patient event to the topic from our Kafka producer. So this will be similar to the other proto files we created. So we need to define a syntax, and this is just going to be equal to string, and then we'll use proto3, add a semicolon, and we'll add a package as well. So we'll say package, and we'll call this patient.events, just like this. So this means that all the generated code that we will get based on our proto file will go into a patient.events package, and it should make it easier for us to manage this. So now at this point, we have to define the message itself. So in this case, event and message are interchangeable. So just keep that in mind if the two terms are getting confusing. So we'll say message, and then we'll say patient event, and then we'll open some braces. And then in here, we'll say string patient ID going to be equal to 1. We'll take a new line, and then we'll say string name is going to be equal to 2, and then string email will be equal to 3, and then we'll say string event_type is going to be equal to 4. So all we're doing here is defining all the properties that are going into any given patient event that gets sent from our producer. So this can be whatever properties you like. We've just added some things here that make sense to send as a message that other consumers will probably need. So this is very much dependent on the business logic of any given application or how the application is architected. So we can send as much or as little as we want in these events, and they can be of any values we want. And that's all we need to do. And since we are in the patient service, we already have all the infrastructure code we need to generate our classes based on the different proto files. So all we have to do now is run the Maven commands to generate a patient event class that we can use in our Java code to actually build the event and send it from our Kafka producer. So before we generate our classes, what we will do is we will add an option to our patient event profile to tell the Maven plugin that we want to generate individual files for each of the different classes that it can create. So just below the package option, we'll say option, and then we'll say Java_multiple_files, and then we'll say equals true, and then add a semicolon. So this just tells the Maven plugin that we want to generate separate files instead of having all of the classes generated under a single parent class, which can sometimes make it harder to work with. So now that we have this, all we have to do is generate our code from our proto files again. And to do this, we'll jump into the Maven section on the left-hand side. So just choose Maven, and in here, under patient service, we're going to go into the lifecycle methods, and then we're just going to choose clean. So this will delete any of the old generated code that we previously had and gives us a fresh slate to work with. And then back in the Maven section again, we're going to go into compile, which is going to compile all our Java code and generate the new code based on our new proto files as well. So to see if this works, we'll go into the project tree again, and under the patient service, we'll go down to target, and we'll go to generated sources, and under the protobuf section in the Java section, you should see that we have this package called patient.events. And if we open this up, you can see we have a few new classes that were generated for us. And if we look at the patient event class, you can see it's generated a whole bunch of stuff. But if we have a look, and you can see that there were some methods created like get patient ID and get name and so on. So it generated a class that will act as a DTO class for us to set and get different properties on our patient event that is going to get sent from the producer. So this is the exact same approach that we took whenever we generated the requests and the response to interact with the billing service. So if you're having any issues at this point, double check that you put the new patient event.proto file in the correct proto folder. So it should be in source main proto, and also double check that you've named the file correctly, as well as check the syntax inside of your file just to make sure it matches this. And if all else fails, have a look at the finished code on GitHub. So now at this point, we have a patient event class that we can use to add properties to before we send a message. So we can use this in our producer. So what we will do is we will jump back into our Kafka producer. So if you've closed the file, just double tap shift and go to classes, and then type Kafka producer, and it should appear here, and it will bring you to the producer that we created in the previous section. So just below the constructor of our Kafka producer, we'll take a new line and we'll say public void, and then we'll say send event, open some braces, and then we're going to say patient, and we will name this patient as well, and then we'll open and close some braces. And don't forget to import the patient from the patient service.model.patient package, just like this. So anytime we want to send an event to a Kafka topic, we need to know some information about the patient. So this will come from the patient object, and we will see how this method gets called from the create patient flow. But for now, we're going to finish implementing this method. So the first thing we need to do is we need to create an event that has all the properties in it. So we'll say patient event, and then we'll just call this event is equal to patient event dot new builder. So this patient event is going to come from the generated code that we just created based on the new patient event proto file that we made in the previous section. So the import should look something like this. So go ahead and add your import if it didn't already. So back in our send event method, all we're doing now is we're going to build a new object using the builder that was also generated for us. So after the new builder method call, we'll take a new line and I will say dot, and I will say set, and I will say patient ID, and we'll say patient dot get ID dot to string. And we'll take a new line and I will say dot set name, and then this is going to be patient dot name, and we'll take a new line again and we'll say dot, and we'll say set email, and then we'll say patient dot get email, and then we'll say dot build. So all we're doing here is we are creating a new object that has all the stuff that we want to send in our patient event. The patient event is based on our proto file. So we forgot to add one in here. So just after set email, take a new line and we'll do dot set event type. And what the event type is that it's used to describe a particular event inside of a topic. So all we have to do is add a string in here. We'll say patient underscore created. So this is an approach we can use to further add subcategories to a message within a topic. So even though this event is going to go on to the patient topic, we can have subcategories within that topic that are useful for different types of events. So for example, this one we're about to send is patient created, and it's going to go on to the patient topic, but we could equally have a patient underscore updated event type that would go on to the patient topic as well. So all we're doing is we're using some sensible groupings to help make our lives easier for any consumers so that they can only consume the events that they're interested in from a given topic. So at this point, we have created our event and we have created our Kafka producer and our Kafka template. All that's left now is to send the event using our Kafka template. So just after the code that we just added here, we'll take a new line and we're going to add a try catch. We'll say try, add some braces, and outside of the last brace, we'll add a catch, and then we'll just catch all exceptions. And inside the catch block, we're going to say log, and it should bring up the option to import the slf4j.logger class. So go ahead and import this, and then we'll say error. Inside the braces, we're going to add a string, and then we'll say error sending patient created event, add a colon, and then we'll just add some placeholder braces. And outside of the string, we'll add a comma, and then we'll just say event, just like this. So inside of this try block, we are going to write the code to send a message. But if it doesn't work, we're just going to log an error using this catch block that says something went wrong trying to send the patient created event. So this will help us identify any issues that occur. And because it's in a try catch block, it means that the app won't crash as the error is going to be handled in this catch block. So even if the sending of the event fails, all the previous steps should still work. So inside of the try block then, all we have to do is say Kafka template, and then we'll say .send, and we'll open some braces. So the .send method will take two arguments, the first one being a string, and this string is going to be the topic that we want to send this event to. So we'll say patient, and then we'll add a comma. So as you can see here, it's populated the argument name, so sending us to the patient topic. After the comma, we're going to say event, and then we'll say .2byte array, and then we'll add a comma at the end. So all we're doing in the second argument is we're converting the event that we just created up here, and it has all of the stuff we want to send in it. So the patient ID, the name, and the email, and we're converting it to a byte array. So the reason we convert it into a byte array is just to keep the size of the message down, and it also makes it easier to convert this message or convert this event to an object in the consumer code, which we'll see in the next section. So this is all we need to do to send an event to the patient topic from our Kafka producer in our patient microservice. So the last thing we need to do before we can test this is we need to actually call this method. As you can see up here, it's not being used yet. So since we want to send this event when a patient is created, it makes sense to do this in our patient service layer. So this is all we need to do in here for our producer to work. So the next step is that we want to send this event anytime a patient is created. So we can hook this into the existing flow by calling the send event method from the patient service layer in our patient service microservice. So we'll double tap shift and then we'll go to classes by selecting tab and we'll type patient service and we'll choose the patient service class and it should bring us here. And then if we scroll down until we see the create patient method, it should be here in and around line 34. This is where we have all of the business logic and external calls that we need to fulfill the business logic of creating a patient. So just to remind ourselves how this works, we make a REST request from a HTTP client, such as the IntelliJ API request files that we have been using so far, and the request will get converted into patient request DTO. We then check if the email exists. If not, we handle that error. The next thing we do is we try and create the patient and save it to the patient service database. And at that point, we get a new patient back. After we get the new patient back, we make a gRPC request to the billing service in order to create a billing account for the patient. And we're sending some of the patient properties as part of the gRPC request. And lastly, all being well, we return the new patient back to the client that made the REST request in JSON format using a DTO. So it makes sense in here that we send the Kafka event to the topic at this point as well. So after the billing service call has completed, so this line, we'll add a few new lines in here, and then we'll say Kafka producer dot, and then we'll do send message, and then we'll open some braces, and we'll pass in the patient by saying new patient. So in order to send a message, we need to know some of the patient details. So we will pass in the new patient that was just created up here to our method, and then we will get the properties that we need from this object. So we have an error here because we need to pass in our Kafka producer. We'll scroll to the top and we're going to inject this dependency, just like we did with the patient repository and the billing service gRPC client. So we'll take a new line up here just after the variables and we'll say private final Kafka producer, and then we'll just call this Kafka producer as well. And inside the constructor, we will add in a new argument. So we'll add a comma just before the closing brace, and we can take a new line in here and then we'll say Kafka producer, and then we'll call it Kafka producer as well. So what Spring will do is it will go and find a bean or a class that's called Kafka producer, which will be the one that we just created, and it will inject it into our patient service. And at this point, all we need to do is assign the injected Kafka producer to the Kafka producer of this class. So we'll say this.Kafka producer is equal to Kafka producer. So we'll scroll down and see if our error is fixed, and it says that send message doesn't exist, and that's because we called it send event. So we'll delete this and we'll say Kafka producer dot, and it will say send event, just like this, and that's it, the error's gone. And that's it for our first producer. So as part of the create patient flow now, we are doing all the stuff we did previously, and we just added a new step that will send an event with the new patient data in it. So this method will get called and we'll pass in the patient to the send event method. We will create a new event class and add the properties to it. And then we will send that event as a byte array to the patient topic using the send method on the Kafka template. And we define the Kafka template up here in the class of our Kafka producer. So now that the code is in place, there are a few configuration things we need to add to our patient service in order for it to interact with the Kafka broker from the Kafka producer code that we have just written. So we'll jump into the project, and in the patient service project, we're going to go into the resources folder and we're going to go into the application.properties. So in here, we need to tell the Spring Framework Kafka dependency how the producer should serialize our message. So in here, we'll add a few new lines towards the bottom of the file, and then we'll say spring.kafka.producer. And then we'll say key-serializer is going to be equal to, and then we'll say org.apache.kafka.common.serialization.string serializer. And then on the next line, we'll say spring.kafka.producer.value serializer is equal to, and then we'll say org.apache.kafka.common Serialization.byteArraySerializer. Okay, so that was a bit wordy, but essentially all we're doing here is we're telling the Spring Kafka code that our messages are going to have a key of string and we're going to have a value of a byte array. So this is helpful for the Kafka template class to tell it what type of our message is instead of it trying to figure out itself, as sometimes it can get it wrong. So we'll add this to application properties because it's not going to change very often, but if it does change, then it's easy enough to find out where to change it because it's a configuration option that we've added to our properties file. And the next thing we need to do is we need to tell the patient service the address of our Kafka broker server so that the Kafka producer can connect to it. So to do this, we'll use an environment variable, as this is likely to change between environments. So we'll go up to the top here and then we'll choose the patient service configuration and then we'll choose to edit this configuration. And we'll scroll down until we see the environment variables option here. And then we'll just choose the folder icon to add a new one. And here we'll choose the add icon and we'll add a new property, and this will be called Spring_Kafka_bootstrap_servers. And as a value, we're going to set this as Kafka:9092. So this is a default environment variable that the Spring Framework Kafka package is going to use to configure the Kafka address. And the value here we're stating is at Kafka and it's on port 9092. So because we are running everything in Docker, the Docker context will find a service that's named Kafka and handle the service discovery for us based on the name and based on the port that we provided here. So this will essentially point to the Kafka container that's running inside our Docker setup. So go ahead and click OK. At this point, we can choose OK. Okay, so now what we want to do is we want to start up all of the relevant Docker containers that we need in order for our setup to work. And then we can test the full flow to make sure that the patient created event gets sent to the patient topic when a new patient is created. So down in the services window, what we're going to do is go into the Docker tab, and in containers, we are going to start up all of the containers that we need. So we should have the Kafka container started already. And what we want to do is start the patient service DB container. So just right click on this and choose start container. And then we'll do the same with the billing service. Just choose right click and choose start container. And what we want to do with the patient service is we want to build a new image because we have added our Kafka producer and a bunch of new code. So we want to make sure that all this gets added to the image before the container starts. So the best way to do this is to go to the top, and under configurations, we'll just choose the patient service one, and then we'll just choose the run button that's to the right of that. So anytime we run this configuration, it will create a new image with the latest code and start a container, which may take a few minutes, but when it's finished, you should see that the patient service application started and that we have a healthy container because of the green icon. Okay, so now we have all the containers that we need started. What we can do is we can hide this window, and we're going to go into the project tree, and this time we're going to go into API requests, and inside API requests we're going to go to patient service, and then we'll choose create patient. So this is the REST request we have been using so far to create a patient, and this is what is going to trigger the event to be sent to the Kafka topic. So just go ahead and change some of the properties in here so that the email address is valid and so on. And before we hit run on this, what we're going to do is we're going to start a Kafka consumer so that we can see the message as it appears on the topic. So on the left, we're going to click Kafka, and we want to choose create Kafka consumer this time. And then in this window, we're going to subscribe to the patient topic. So if you're not seeing patient in the dropdown, make sure that you have the patient topic created under the Kafka tool window. And for the key, we're going to say string. And then for a value, it's going to be bytes base 64, as that is what we have configured our Kafka producer in our patient service code to send the event as. So that's all we need. And if we click start consuming down here, you can see it says awaiting data. So what should happen now is that the patient created event should appear in this little window on the right after we send the request. So let's jump back to our createpatient.http file. And on the left, we're going to choose run, and it should bring up the services window, and we get a 200 response back, which is good. And then if we jump back to our Kafka consumer, you can see we now have an entry in this data table on the right. So as you can see, the value here is a big long string, and that's because we sent a byte array in our Kafka event. So what you can do if you want is you can copy this and just go to a web browser, and if you go to base64decode.org, it gives us a nice little tool to decode a base64 byte array. So all you have to do is paste the string that you copied from the data table in here. And if you choose this decode button down here and scroll down, you can see in here that we have the content of the event. So it's not exactly formatted correctly because this is technically protobuf format and it doesn't decode cleanly, but it's decoded enough that we can make out some of the things that we're expecting. So anytime we send a patient created event, we send the patient ID, which looks to be this part of the string, and we send the patient name, which in my case was John Doe with billing account, as it appears in my request. That is the name I give this guy. And if we jump back, we also send the email address in our event as well as the event type. So even though this looks a bit funny, it shows that we are able to produce an event and consume it through our Kafka topics. And if we jump back to our code, we will just check some of the other logs here. So under the billing service container, if we click this and scroll to the bottom of the logs, you should hopefully see a message that says billing account request received. So this shows that we haven't broken any of the gRPC stuff. This is all working. And because we got a response back from our REST request with a valid ID, it shows that the patient is being created successfully in the database. Okay, so that brings off the Kafka producer code that we need. And hopefully you aren't seeing any issues at this point. If you are, feel free to have a look at the patient service container to see if there's any errors in the sending of the Kafka message. And you can also use the Kafka tool window to check that the message is appearing on the topic, and just make sure that you have a topic created so that the message has somewhere to go. And also check the Kafka container as well in case there's any errors being thrown in here. At this point, you can also feel free to take some time to understand the code and how the flow works so far. So the architecture diagram is part of the finished GitHub repository if you would like to reference that. And once you're happy, we will move on to the next bit, which is consuming the message in an actual microservice so that we can perform any business logic that we need to perform when a new patient is created. Okay, so at this point, what we have completed so far is that we have started a Kafka broker and added our first Kafka topic to it called patients. And we've also added a Kafka producer to the patient service that sends events to the topic. We've also tested that we can consume any events from the topic using the built-in Kafka tools in the IntelliJ IDE. And what we're going to do next is create the analytics service so that we can see how an individual microservice can consume events from a Kafka topic using a Kafka consumer. So with that in mind, we will jump into the code. And in here, we are going to create the analytics microservice as a new Spring Boot application. So what we'll do is right click on patient management, and then we'll choose new, and then go into the module option over here. And this will bring up the window that we need to create a new Spring Boot module. So on the left, what we're going to do is we're going to choose the Spring Boot generator. And in the window, we will fill out the form that we need to complete to create our new analytics microservice. So for the name, we're going to call this analytics-service. And for the location, just make sure that it's inside of the parent patient management folder that we created at the very start of the course. And then the language, we're going to keep as Java. And then the type here, we're going to choose Maven. So just keeping things consistent with the other microservices that we have. And for the group ID, it should be com.py. And for the artifact, it should be the name of this microservice, which is analytics service. And for the JDK version down here, we want to choose JDK version 21. And then for Java as well, we also want to choose version 21. So when you're happy with this, go ahead and click next down here. And in here on the next window, we can choose our dependencies. So there's a few things that we need to add in order to get the analytics service to work. So there's a few dependencies we can add from the Spring Framework options here, and we can add the rest manually in our pom.xml file in the next step. So in here, in the search box, we're going to search for web, and we'll just add Spring Web in here. So this will give us a basic Spring Boot app with an Apache Tomcat server and some built-in REST stuff as well. And what we want to search for next is Kafka. So go ahead and choose Spring for Apache Kafka option. And that should be it for the Spring Framework dependencies that we need. So we'll have to add protobuf and things like that but we will do that manually. So go ahead and click on create. And in here, you can see now on the left, we have a new analytics service. So at this point, what we want to do is the dependencies that we need to handle our protobuf functionality. So remember, anytime we send a Kafka event, this event is going to be in protobuf format, and it's going to contain information about the patient who was just created. So in our analytics service, we're going to open this up and go into the pom.xml file. And in here, we're going to scroll down until we see the dependencies. And the first thing to check before we add our new dependencies is that we have a version for the Kafka dependency that we added whenever we created this Spring Boot application. So usually if you do not specify a version, it will take the latest version, which in most cases is fine, but sometimes we want to make sure that we specify a version so that we know that this version of Kafka is going to work well with the other versions of the dependencies that we have specified elsewhere. So inside of this dependency tag, we're going to add a new line, and we'll add an angle brace and we'll say version. And the version that we're using at time of recording is 3.3.0. So the next dependency we want to add is we want to add in the protobuf dependency, which helps us work with protobuf files and formats. So outside of the closing dependency tag for the Kafka package, we'll just add a new dependency tag, and the group ID is going to be com.google.protobuf. Then the artifact ID is going to be protobuf-java, just like this. And then the version is going to be 4.29.1. So this is the same version that we're using as part of the patient service as well, along with the same version of Kafka. So this should rule out any issues we have between the different versions that aren't playing nicely with each other. So after we've added the dependencies, we need to scroll down until we see the build section. And just like before, we need to add in some steps in here to tell Maven to compile our proto files into code so that we can use it in our own implementations. So again, the best way to do this is to go to the GitHub repository and grab this code from the description and grab this code from the README. So again, the link to the GitHub repository is in the description of the video. So just go ahead and go to that URL. And what you want to do is scroll down in the README until you see the notification service section. And then in here, you can also find the dependencies if you prefer to copy and paste those in. And after that, we'll scroll down until we see this build section here. So it starts with the build tag up here. And I'm just going to copy this whole thing and we'll jump back to the code, and then we will delete the current build section. And then we'll just paste this one in that we got from the README. So at this point, we'll probably see that we have some errors. So all we need to do is reload our Maven project. So in the project window, right click on XML inside of Analytics Service, and then we'll scroll to the bottom and then just reload the Maven project like we have been doing so far. And if we have a look at this, we can now see that the error is gone. Okay, so that should be it for our dependencies. If you're still seeing errors here, make sure that you copied the code correctly from the README, and also that you reloaded the project using the correct pom.xml file. So that should be all the dependencies that we need. And the next thing we need to do is we need to add in our proto file to the analytics service that will describe the event and the data that that event contains for a given event that is consumed from the Kafka topic. So easiest thing to do here is to go into the patient service where we have defined our proto file for the patient event. So go into patient service, into source, into main, and then we'll go into proto. And if we double click on patient event.proto, as a quick reminder, this is the proto file that we use to determine the format of a patient event that gets sent from a Kafka producer to the Kafka topic. So this is the exact same thing that will be consumed in our analytics service, Kafka consumer. So what we will do is right click on patient event.proto and then just copy this. And then we're going to go into analytics service again, and we're going to go into source, into main, and right click on the main folder, and then we'll choose new, and then we'll just add a new directory, and then we'll call this proto. And in here, we're just going to right click and paste in our file, and then this little window is going to appear. Just go ahead and hit OK, and then this will add in the patient event proto file that we need into our analytics service so that Maven will generate the patient event class that we can then use in our consumer. So again, just as a reminder on why we're doing this, so the proto files are used so that all of the microservices that produce and consume patient event messages have a single source of truth that they can read the properties from. So ideally, this proto file would be in a central location, and there would only be one file that all of the microservices would consume into their code bases in order to generate actual Java classes. That way, if the profile changes, it gets changed in one place and all the microservices will get those updates for free. But for learning purposes, we're just copying and pasting the profiles into each of our microservices. So at this point, what we can do is we can use Maven to compile our code, and that should trigger the generation of our profiles into a patient event Java class. So you see this happening, we will go into the Maven tool window on the left down here, and we're going to go into Analytics Service, into Lifecycle, and then we'll choose Clean. And after this completes, we will go back into the Maven tool window again, into Analytics Service, into Lifecycle, and then we're going to choose Compile this time. And hopefully this has picked up that we have a profile that needs to be compiled into code, and it looks like it has here. So if we minimize this window and if we go into the target folder, into generated sources, and we'll just have a look at the protobuf folder and the Java folder just to make sure that we've got the right stuff in here, and it looks like we do. So we now have this patient event class that we can use to convert the message that we consume from a byte array into a Java object so that it's easier to work with and manage. Okay, so now we have our infrastructure and protobuf file in place. The next thing to do is actually create the Kafka consumer. Okay, so at this point, we are in a position where we can create our Kafka consumer and handle the message that we consume from the patient topic. So to do this, we are going to go into the Analytics Service, and we're going to go into the main folder, into Java, and then we're going to go into our main package folder, right click on this, we will go up to new, and then we're going to add a new package. And then we'll just call this Kafka, just like this. And then we will hit enter. And then inside of this package, we're going to create a new Java class this time, which is a Java option. And then we will call this Kafka consumer. So the first thing we'll do in here is we will annotate this class with a service annotation so that it gets managed by Spring. Inside of this class, we are going to create a method. So we'll say public void, and we're going to call this consume event. And then we'll open some braces. And in here, we are going to specify the type of the message that we are going to consume. So when we send a message from our Kafka producer, we send it as a byte array. So if we quickly look at this by double tapping shift, and then if you type Kafka producer, it should be the file that's in the patient service. So just click this and it will bring us to our Kafka producer. And if we scroll down to around line 29, where we actually send the event, we convert the event to a byte array. So this is how it's going to be received in the consumer. So if we jump back to our Kafka consumer.java file, in the arguments of our method, we'll say byte and then add an array, and we will call this event. And then we will open some braces in here so that our method looks like this. So before we get into the implementation details of this method, what we need to do is we need to specify the topic that we want to listen to, or in other words, the topic that we want to consume events from. So to do this, we will use the Spring Framework Kafka annotations. So just above the consume event method we just created, we'll add a new line, and then we'll say at, and then we'll say Kafka listener, just like this, and we'll open some braces, and then we will say topics, and this will be equal to a string, and then we'll say patient, and outside of the string we'll add a comma, and then we'll say group ID, and then this is going to be equal to analytics service, and that's all we have to do to connect our Kafka consumer to the Kafka topic. So all the hard work is done behind the scenes by this annotation. And what we're essentially doing here is we're saying that any events that are sent to the patient topic are going to be consumed or going to be read by this method. And what the group ID does is that it essentially tells the Kafka broker who this consumer is. So since we could have a large number of consumers, it's good practice to specify an ID so that the Kafka broker can easily manage different things like partitioning and identifying different consumers and so on. But you don't need to know too much about this, apart from that it's good practice to do it. It's more of an advanced topic, which is out of scope for right now. Okay, so at this point, we have a consumer that is going to listen for events that are sent to the patient topic by any of the Kafka producers. And Kafka is going to do all the hard work to convert that event into this event variable here, which we know is going to be of type byte array, because that is how the event was sent from the producer. So the next thing we need to do now is we need to convert this byte array into a patient event Java object so that we can easily interact with it and get the properties that we need to get and so on. So to do this, inside of the method, we'll say patient event, say patient event in lowercase this time is equal to, and then we'll say patient event dot parse from, and then we will just pass in the event. So what we want to do now is import the patient event from the target folder, as this is the stuff that gets generated from our proto file. So go ahead and use the little helper icon here, and it should say import from the correct module, and it doesn't seem to. So that means that IntelliJ can't find our generated code. So to fix this, if you're seeing the same problem, is go to project and scroll down until you see the target folder in here that lives inside the analytics service. Open this up and open up generated sources, open up the protobuf folder, and right click on the Java folder. And what we're going to do is scroll down, and we're going to choose the mark directory as option, and then we're going to choose generated sources root. So this tells IntelliJ that we want to use code from the target folder in our own code that we handcraft. So just make sure that all this stuff has turned blue, and hopefully this works now. So we'll try again. If you hover over patient event, and this time we are seeing the correct import option, so just go ahead and import this class, and that should fix the import. So at the top, you should see something that looks like this, and that will import the patient event type, which we can use down here. So that seems to have worked, but now we have another error that says parse from is going to produce an unhandled exception, invalid protocol buffer exception. So what this basically means is that the protobuf code that we have added as dependencies is going to try and convert this event into a patient event class. But there's a chance that this might not work, and it's going to throw an exception. So to fix this, if we hover over at the error here, and it will bring up the light bulb on the left hand side. So if we click this, and there should be an option to surround with a try catch. And as you can see, it's quickly added a try catch to us. So we will handle the catch here, and then we'll just explain a bit more about what this code does. So what we'll do is delete the throw new line, and then we'll say log, and then we'll import the slf4j logger, and then we'll say .error, and then we'll add a string in here, and then we'll say error deserializing event, and we'll add some placeholder braces at the end here. Add a comma just after the last string over here, and then we'll say e.getMessage. So all we're doing in this catch block is we're just going to log the error that says we tried to consume a message, but it didn't work, instead of throwing an exception. If we throw an exception, it might cause the entire analytics service to go down, and that's not necessarily what we want. But we do want to be made aware that there was a problem trying to consume the patient event. So back to this line up here that we added to our try block, what's going to happen is that we are going to try and create a patient event object from the byte array that we received from the Kafka event. And this will get assigned to the patient event variable over here, and it will have the type of patient event. So the reason we need to surround this in a try catch is because there is a chance that this event that we receive may not be compatible with the patient event Java class. So even though we are using the proto files to specify the event type, there's always a chance that something could go wrong along the lines, such as a bug in the producer code that adds an extra property or has left out a property, or it could even just be user error from one of the developers who have accidentally forgot to update the proto file, for example, which means all the consumers would be unaware of a change that was made and things like that. So these things can happen. And even though we mitigate these things by using proto files, it's still good to add defensive code in here to handle any potential errors that could arise. So now at this point, the analytics service has access to the patient event for any given created patient, and it can do anything it wants with it. So in here, we could say perform any business logic related to analytics here. So we're not going to do anything too specific around analytics in this part of the course, because we are focusing on Kafka and how to consume messages and how to work with Kafka. Just be aware that at this point, this is where you would perform any business logic by calling a service layer or by calling a database, using a repository, and so on. So what we're going to do instead is just log an info message that will appear in our analytics service logs to tell us that the analytics service was able to receive a patient created event from the Kafka topic, and that it was able to parse the event and pick out the different properties from the event itself. So on the next line here, we'll just say log.info, and in here, we'll add a string, and then we'll say received patient event, and then we'll add a colon, and we'll just add some braces, and then we'll say patient ID is equal to, and then we'll just add a placeholder in here. Then we'll add a comma, and then we'll say patient name equal to a placeholder, and then we'll add a comma, and then we'll say patient email is equal to, and then we'll add a placeholder again. Outside of the last speech mark, we'll add a comma here, and then we can just start filling out some of these placeholders. So the first one is going to be the patient ID. So what we can do now is say patient event. So this is this one up here that we just parsed. Then we can say dot get patient ID. And we'll do comma, and then we'll say patient event dot get name, add a comma again, and then the last one we'll do is patient event dot get email. This is what your code should look like so far. And all we're doing here is we're just logging an info message to the analytics service logs. And we're just displaying some of the properties that we received in the patient event after we've parsed it up here. And that's it. So we don't have to do anything else in order to start our consumer, because whenever our Spring Boot application starts, it's going to register this Kafka consumer as a Spring Bean, and it will automatically start the Kafka listener for us, which is all handled by the Kafka listener tag. And all we need to do is specify our topic, which we have done, and provide a method to handle the message, which we have done as well. So before we can test our new Kafka listener, what we need to do is Dockerize our analytics service that we just created and add it to our Docker microservices setup. So to do this, we will go into the project, and the first thing we need to do is get a Docker file in order to create the image. So the easiest thing to do here is to go into the patient service, and we're just going to copy this Docker file. So the one down in here from the patient service folder, and we'll go back into our analytics service, and we're going to right click on analytics service, and it will just choose paste. And this is going to add the Docker file to the top level of our analytics service. So again, since we're working with Spring Boot microservices, it's easy to copy the Docker files across from one service to another, and it just saves us a bit of time. So what we'll do now is open up this Docker service that we just pasted in, and there's a few things we need to change. So if we scroll down, change the name of the jar that we need to copy. So instead of patient service, we'll say analytics service. And again, this is what gets created whenever we run the Maven build step from the builder step above. And we also want to change the port that we're exposing, and it's going to be 4002. So again, this doesn't matter too much what the port is, just as long as it's unique, so there's no clashes whenever we start the actual container. So the next thing to do is we'll go up into our configuration section at the top here, and we're going to go to edit, and in here we are going to create a new run configuration that will build a Docker image for our analytics service, and then it will also start a Docker container based on that image as well. So at the top left, we will choose add new configuration, and in here we're going to choose a Docker file. So under Docker, there's the option for Docker file, and we'll change the name to be analytics-service. And for the Docker file, we want to make sure that we're choosing the Docker file from the analytics service in our code. So what you can do is choose the little browse symbol here, go into the analytics service folder, and then choose the Docker file and click OK. And then this will update the input for us. And the next thing we need is the image tag. So we'll say analytics-service : latest. So this will create an image with this tag of analytics service, and it will tag it with the latest as well. The next thing we have to do is add some run options here. So we'll add the container name, and we'll just call this analytics-service as well. And then we will choose the modify option on the right. And then we're going to choose bind ports, and this will add a new input to the run options. And then we'll choose the browse option here, and then we'll just add a new port binding. So we will just expose the port that our Docker container, that our application is running on inside of the container, and that's port 4002. And then we'll set the container port to be in 4002 as well. And the next thing we need to do is add an environment variable to our analytics service so that our Kafka consumer is able to connect to the Kafka broker. So to do this, we will choose the modify button again, and we'll go down to environment variables, and then under environment variables, we'll add a new environment variable by clicking the browse button, and then we'll choose the add button here. And the name here is going to be spring _ Kafka _ bootstrap _ servers, and the value is going to be Kafka : 9092. So again, this environment variable is what the Spring Framework Kafka dependency is going to use to connect to the Kafka broker for us behind the scenes anytime we start our Spring Boot application. And this value is going to be the address of the Kafka broker server. And Docker is going to resolve the name Kafka to the IP address of the Kafka container because we are using the name here. And then the port is going to be 9092, as that's what Kafka is configured to expose. So we'll go ahead and click OK here. And the last option we need to do is add our analytics service container to our internal Docker network. we'll go to modify again, and this time we'll choose run options. And if we scroll down in the run options input, what we can do is say -- network and then say internal, just like this. And that should be it for the configuration. So our analytics service doesn't have very much to it apart from some Spring Boot stuff and a Kafka consumer. So what we can do now is click apply, and then we can click the run button, and let's see what happens. So it should open up the services window, and it should attempt to build and deploy a Docker image and container to our Docker setup. It looks like the image built and it tried to start, but we got an error here. So let's have a look and see what it says. So there's an error, and it says that no resolvable Bootstrap URLs giving in bootstrap.servers. So what this means is that it couldn't connect to the Kafka broker, and that's because we haven't started it. So the analytics service isn't going to work if it can't connect to Kafka. So what we need to do to resolve this is we need to make sure the Kafka is running. So under containers on the left, what you can do is right click on Kafka and then just choose start container, and this should start up the Kafka container. If you haven't got a Kafka container, or if you have deleted it, what you can do is go to the run configurations at the top and then just choose the Kafka option again over here. And this will download the image if it needs to from Docker Hub and start a new Kafka server for you. And all being well, the Kafka broker should start and the container should be green. So what we can do at this point is try and run our analytics service again. So at the top, just choose analytics service and choose the run button. And this time, let's see what happens. Okay, so we have a green container this time. And if we look at the logs, we can see that there's a whole bunch of stuff in the logs that you might notice. Some key messages to look at are things like discovered the group coordinator, Kafka:9092. So this essentially means that it's connected to our Kafka broker. And down here it says successfully joined group. That's good as well. And everything looks to have started. Okay, so before we can test this, we need to add some configuration to our analytics service. So this is going to be similar to the configuration we added to the patient service. So if we have a look at that, if we go to project and go into the patient service, and we'll go down to the source folder, into main and into resources, and then into application properties. So in here, we have these two lines that look like this. And what this does is it tells the Spring Kafka dependency how to serialize our Kafka messages. So our key is going to be a string, and then our value is going to be a byte array. So what we have to do is we need to add similar properties to our Kafka consumer, or in other words, the analytics service, to tell the Spring Kafka dependency in there how to deserialize our Kafka messages. So the quickest way to do this is to copy these two lines, and we will go into the project tree again. And this time we're going to go back into analytics service, into the source folder, into main, into resources, and into application.properties. And in here, we'll just paste this in, and we have to make a few changes. To do in here is, instead of saying spring.kafka.producer, we want to say spring.kafka.consumer, and then instead of key.serializer, we'll say key-deserializer, just like this. And we just need to change this last part as well. So instead of .string serializer, we'll say .string deserializer, just like this. And then we'll do the same for the value. So over here, we'll change this to spring.kafka.consumer, and then we'll say value.deserializer. And at the very end, we'll say byte array, and then we'll say deserializer, just like this. So again, all we're doing is telling Spring Kafka how to deserialize our event messages. So now at this point, all we need to do is start up our Docker containers and test this functionality out. So because we made changes to our analytics service, we have to build a new image and deploy the container to our Docker setup. And to do this, all we have to do is press the run button to run the analytics service configuration. After the analytics service container has started, you should see some log messages, most important ones being subscribed to topic, and it's subscribed to the patient topic, which is good. And it's also discovered the group coordinator, which is our Kafka broker. So all we need to do now is start the rest of our containers. So go ahead and start the billing service by right-clicking on the container and choosing Start Container, and do the same for Patient Service DB, as well as the Patient Service container as well. So if you aren't seeing the containers here, you can trigger the deployments from the configurations up here, from the configuration dropdown. And it's also worth noting that you will need to build a new image if you have made any code changes to any of your services. Otherwise, the container is going to have older code if you simply stop and start them. So each time you make a code change, you need to build a new image. So at this point, all our containers are green and healthy. So what we can do is minimize this, and we will go into the project tree and go into API requests, into patient service folder, and we'll choose the create patient REST request. So in here, all we have to do is change the email and make sure it's unique. So I'm just going to change this to Kafka_test, and we're going to change the name as well, just so it's clear in the log message that this is a Kafka related test. So when you're happy, go ahead and run the request. So hit the run button over here, and in the services window you will hopefully get a 200 back, and also the response object with the new patient in it as well as the ID. This just proves that we haven't broken anything in the patient service itself. And then if we look at the analytics service and scroll to the very bottom, we should see that we have a log message from our Kafka consumer, and it says received patient event, and it's got this little string that we created. So it's got the patient ID and it's got the patient name, which is going to be the same name as it's the one that you sent in the create patient request, and it'll have the email address as well. Okay, so this is good. It shows our analytics service is working as we were able to receive the patient created event from the Kafka topic. So that about rounds it off for the Kafka sections in this part of the course. So feel free to go back over some of the stuff that we have done so that you understand how producers, consumers, topics, and Kafka brokers work. And you can also have a look at the finished repository or the architecture diagram as well. So that's an additional thing to help you understand how all these bits and pieces fit together. So at this point, if you're having any problems, make sure that you have added the correct dependencies to the analytics service as well as the application properties that you need, and have a look at the finished repository to look at the finished code to see where you might have gone wrong. And don't forget to use the Kafka tool window as well to ensure that your Kafka broker is able to produce and consume messages. Okay, so far we have been interacting with our patient microservice directly from our REST client. This is okay for one service, but if our client needs to interact with multiple microservices, it becomes a bit more complicated. This is where API gateways come in. So what are API gateways? An API gateway acts as a single entry point for all the clients to interact with the multiple microservices. The way this works is that the API gateway will route the request to a given microservice, and the benefit of this is that it hides the internal addresses from the clients. An API gateway also means that we can handle cross-cutting concerns like authentication, authorization, logging, and monitoring, rate limiting, and things like caching that are common to all of the microservices. So to explain a bit more about what all this means, we will look at our current setup to see some of these problems, and then we will see how API gateways can help us solve some of these problems. So in our current setup, the front-end clients or the HTTP REST clients will communicate directly with the patient service using REST requests. This requires the client to know the exact address of the service, which isn't ideal, as if the address of the patient service changes, so for example, if the port changes or if we decide to rename this service to something else, for example, then all of the clients must update their configurations in order to make REST request to the patient service at its new address. So this leads to potential maintenance challenges depending on how many clients are consuming our patient service API. So the other drawback to this approach is that in our patient service, we have to expose a port, so in this case it's port 4000, to the internet. This introduces potential security risks as the service becomes directly accessible to any and all external traffic from the internet. This approach also causes scalability challenges with multiple microservices, as if we add more microservices, such as the analytics service, the client will also have to update its configuration to know the exact address of the analytics service as well, in order to perform any REST request that it needs to perform. As we add more services, we have to update the configuration again, and this problem continues to compound as we grow our microservices application. So to solve some of these problems, we can use what's called an API gateway. So in the middle of our screen here, you can see we have a new box which represents the API gateway, and you will notice that the flow has changed slightly. So now instead of our front-end client having to make REST requests to each of the individual microservices, all the requests, in this case the request for the analytics service and a request for the patient service, all go through the API gateway, and then the API gateway will redirect a given request to the appropriate microservice. So the first benefit of this is that it acts as a central entry point for all our clients. So all our clients simply need to know the address of the gateway, And each time the client makes a REST request, the gateway will redirect the traffic, which means that the front-end client only needs to know the address of the API gateway, and the API gateway will handle the routing to the appropriate service. Another benefit is that it means we can hide the internal addresses of our microservices, eliminating the need for the clients to change the configuration of the endpoint should the address of each of these microservices change. It also means that we no longer have to expose our patient service and our analytics service to the internet by opening a port, as the gateway will handle all the external traffic. This makes our microservices more secure, as it's a lot harder for hackers or any bad actors to interact with our services directly. This approach also simplifies the scaling of our architecture, as if and when we decide to add more microservices, we only need to update the API gateway instead of updating all of our front-end clients. Having an API gateway also means we can handle authentication and authorization in a single place. So an API gateway can work with an auth service. So an auth service would typically be a separate microservice which handles authentication and authorization, which you will see in the later parts of the course. And it means that the API gateway can pass all requests to the authorization service to make sure that the user who is making the request has access to the resource that they are trying to access. So for example, if the user tries to make a request to add a patient, the request will get intercepted at the API gateway point. It will get passed to the authorization service. The authorization service will check if the user has access to create patients, and if it does, it will return a success message to the API gateway, and the API gateway will forward the request on to the patient microservice. So again, we will see how this works a bit later in the off section of the course, but this is just to give you an idea of some of the benefits of an API gateway. And the last feature to mention about API gateways is that it lets us handle other cross-cutting concerns. So a cross-cutting concern is a feature or a piece of functionality that will affect all of the microservices regardless of what that microservice is intended to do. So this includes things like logging, caching, and bit limiting, as well as authorization and authentication like we have just talked about. So hopefully this gives you an idea of the benefits of an API gateway and why we use them. So in the next parts of the course, we are going to use Spring Cloud Gateway, which lets us easily configure a new service, which will act as an API gateway in our microservices setup and lets us define the rules to route requests and things like that. Okay, so at this point, what we can do is we can create our API gateway project. So even though this is an API gateway and it might sound a bit different to the other services we have created so far, our API gateway is going to be essentially another microservice. So it's going to run on Spring Boot and Docker. The only difference is that we're going to use the Spring Cloud Gateway dependency that comes from the Spring framework. So with that in mind, what we'll do is jump into our IDE and we will right click on patient management, and then we'll go to new, and from here we'll select module. Just like before, we will choose the Spring Boot generator on the left, and for the name, we're going to call this API Gateway. And for the location, just make sure that it's inside of the patient management folder. For the language, we will select Java. For the type, we're going to select Maven. And for the group, artifact, and package name, these should all be populated based on the name that we selected at the top. So for JDK, what you want to do is select Java version 21. And for Java, we'll select version 21 as well. So go ahead and click next once you're happy. And this will bring us to the dependencies window. So in here, what we want to do is search for gateway. And there will be two options that appear under the Spring Cloud routing package. One is gateway and the other is reactive gateway. So we're going to choose reactive gateway here. And the main reason for that is that it lets us define our routing endpoints in an application.yaml file. So there's a few other differences between these two dependencies, but under the hood, they both do essentially the same thing. So go ahead and select the reactive gateway. And when you're ready, go ahead and click create. So on the left in the project tree, we now have a new service, which is our API gateway. So now what we can do is we can define how we want our API gateway to behave. So in other words, we can define what requests get routed to which microservices depending on the URL that the client uses. So we will open up the API gateway, and then we're going to go to source, into main, and into resources. And this is where we have our application.properties file. So the first thing we're going to do is change this to a YAML file. So we'll just right click on this and then choose refactor and then choose rename. And then we will say application.yml for YAML. So the reason we're using a YAML file is because it makes it a bit easier to see our configuration at a glance and to work with it in general. So go ahead and click refactor and go ahead and open up the application.yml file. So in here, we don't have very much, but we can delete the stuff that's in here. So we're starting from a clean slate. So in here, we'll say server, add a colon, and then we'll hit enter, and then we'll say port on a new line, and then we'll say that our API gateway is going to run on port 4004. So again, this doesn't matter too much what port you want to use, just as long as it's unique. And we'll take a few new lines here, and then we're going to say spring, colon, add a space, add a new line, and then we'll add a space and say cloud. And then on the next line, we'll say gateway. And finally on a next line, we'll say roots. So in here, we'll add a dash, and then we'll say ID. So what we're going to do now is under this roots option is we're going to add all the rules that specify how to route to our patient service microservice. So we'll give it an ID and we'll say patient-service-route, and then we'll take a new line and then we'll say URI. So the URI is the internal address of our patient service that's running inside of our Docker setup. So we'll say http:// and then we'll say patient-service, and then we'll say the port that it's running on, which is port 4000. So this is the internal address, which we use inside of a Docker context, where Docker is going to resolve this name and send a request to a given container that has a name of patient service. And port 4000 is what we specify. The internal address is being anytime we run a Docker container. So all we're doing here is saying where this request is going to end up for this rule. So we'll take a new line here, and then we'll say predicates, and then we'll take a new line, and then we'll add a dash. So a predicate is what we use to determine what requests get sent to our patient service. So in here, we'll say path, and we'll say equals, and then we'll say /API/patients/ and then we'll add a double asterisk, just like this. So on the next line, we're going to say filters, and then we'll take a new line, and then we'll add a dash again. And a filter is a way for us to rewrite the predicate before it forwards the request to the actual patient service URI. So we'll say strip-prefix is going to be equal to 1. So what this does is it says strip out all the text after the first slash of the predicate and then assign it to the URI. So what that means is that it's going to strip out API from the path and then pass this along with the request to the URI up here. So let's have a look at an example to see how this works. So let's say we have a front-end client that is making a request to our patient service to get all the patients. So the REST client is going to send a request that looks something like http:// and we'll say localhost 4004, and then we'll say / and then we'll say API/patients, just like this. So when the front end or the REST client makes a request to this URL, the first thing that happens is that the request is going to land in our API gateway, which is at address localhost 4004, as this is what we specified the port as being up here. So once it arrives in the API gateway is going to use a bunch of these rules to determine what to do with this request. So since this request has a path of API/patients, that means that this path is going to match this predicate up here, which means that this route or this set of rules is going to get applied. So now that the API gateway has determined that this path matches this set of rules, the next thing that's going to happen is the API gateway is going to rewrite the request in such a way that it can call the internal address of the patient service in a way that the patient service microservice expects. So the API gateway will take this request and rewrite it in such a way that it looks like this. So we'll say http:// patient-service 4000, as this is the URI of this set of rules, or in other words, the microservice that we want to send this request to. And then the next thing it's going to do is apply the filters. So since this filter specifies that we want to strip the prefix, which is equal to 1, it's just going to take out /API and it becomes /patients. Then at this point, the request gets sent to the patient service, which is our Spring Boot app. And then the controller is going to handle the /patient route and then return patients array. So hopefully this makes sense. As previously, we would have called the patient service directly, but now instead what we do is we call the API gateway, and the API gateway calls the patient service on our behalf based on the different rules that we've defined up here. So this would work the same way for any of the microservices that we want to expose to the internet through our API gateway, such as the analytics service that we just created in the previous sections. So we would have another set of rules just below this one that might be called analytics service root, and the URI for that root would be analytics service, and then we can define the predicates and the filters and so on. So to see another example of this, what we're going to do is we're going to add a root to our API gateway that lets us view the API Swagger documentation that we created for the patient service. So what we'll do is we'll take a new line just beneath the previous set of rules for the root that we added, and we'll add a dash again, and we'll say ID, and then we'll say API dash docs dash patient dash root, and then we'll take a new line, and then we'll say that the URI is also at http://patient-service, and then we can say port 4000, and then on a new line we'll define our predicates. So for this one we want to say if the path is equal to /API-docs/patients, then we want to forward this request to the patient service as well. So this time we can specify a filter just like we did previously, but in this example we are going to completely rewrite the path so that it matches what the patient service expects. So in here we'll say rewrite -path is equal to API-docs/patients, then we'll add a comma, and then we'll add a slash, and then we'll say v3/API-docs. So in this example, what happens is the REST client will make a request to our API gateway, so http://localhost:4004, and then we'll say API-docs/patients, and then the API gateway is going to see that this request path matches this predicate. It's then going to rewrite the path into this format here and forward the request to the patient microservice. So what it's going to look like is http://patient-service:4000/v3/API-docs. So this is the endpoint where the documentation lives on the patient service microservice itself. So all we're doing is forwarding a request to that URL and rewriting it in a way that the patient service understands. So that's essentially it for our API gateway. So we have a rule that satisfies all the CRUD operation endpoints, and then we have a rule that satisfies the API docs endpoint. So in order to test this, what we can do is Dockerize our API gateway and deploy it to our Docker setup. So this is done exactly the same way as we have deployed the other microservices so far. So if we go into the project and we'll jump into the patient service, and what we'll do here is look for the Docker file, and we're just going to copy this Docker file and we'll paste it inside of our API gateway, just like this. And if we jump into the Docker file, what we can do is change the name to match the name of our API gateway. So we'll scroll down, and down in here where we specify the name of the jar, all we have to do is change this to be API-gateway, just like this. And down in the ports, we will expose the port to be 4004, as that's what our API gateway code runs on. So the next thing that we need to do is we need to create a run configuration for our API gateway. So at the top, what we're going to do is select all the configurations, and at the very bottom, we will choose edit configurations. And then on the left, under the Docker section, we will add a new configuration, and we will select Docker file. So in here, the name we will give will be API-gateway. And what we want to do is change the Docker file from the default billing service to be the API gateway one. So just go ahead and change this to API-gateway. And for the image tag, we're just going to call it API-gateway as well. And we'll add a colon, and then we'll add a tag that says latest. So down in the run options, the container name is going to be API-gateway. And the next thing we need to do is specify the ports that we want to expose on this container so that we can access it from the internet. So if we go to modify, down to bind ports, and we will add a new port in here. So just use the add button, and then we'll do 4004, and then the container port will be 4004 as well. And the last thing we need to do is add this API gateway container to the same network as the rest of the containers. Otherwise, it won't be able to forward the requests to the appropriate routes. So what we can do now is go into modify, into run options, and under the run options input here, we'll say -- network, and then we'll say internal, just like this. So at this point, we can run this, and it should hopefully create a new image for our API gateway, and it should also deploy a new container based on that image. Okay, so before we can run this, we need to make sure that our patient service is started. Otherwise, the gateway will fail to start because it will try to connect to the patient service and see that the patient service isn't running, and it will throw an error. So what we will do is update some of our properties for the patient service before we decide to run it. So on the left in our configurations, we're going to choose patient service. And what we want to do in here is under bind ports is we want to close the external port 4000 so that it is no longer accessible publicly through the internet. So go ahead and choose the browse icon on the right, and we'll just select the port. And what we're going to do is we're going to choose remove and choose OK. So now all we've done is just removed the open port 4000 from the patient service. It's still running internally on port 4000, but it just means that we cannot access this microservice on port 4000 from outside of a Docker context. In other words, from our IDE or from the internet or from the browser or whatever. So the only way to access this patient service now is through our API gateway. So we'll see this working when we start everything up. So go ahead and click apply on our new configuration and then click OK. So the first thing we need to do is we need to start our patient service database. Otherwise the patient service itself won't start. So on the left under services, what you want to do is right click on the patient service database. So this is under the Docker containers tab, and then we'll just start this container. And after the database is started, what we want to do is create a new patient service container that has the new configuration in it. So the new configuration is just us removing the exposed port from the container. So up here, just go ahead and click the run button beside patient service, and this will start a fresh container that has the latest changes on it. And after the patient service has started along with its database, what we can do now is start our API gateway. So at the top under the configurations, from the drop down, go ahead and choose API gateway, and then we'll just click run. And then this should build an image for us with the API gateway code and then deploy a container to our setup as well. Okay, so if you're seeing this error or if you had a problem with the image being built, then you'll see quite a large stack trace. If we dig through it, there's a few messages such as unable to find the root predicate, factory name with path, things like that. So what this means is that we have made a small mistake in our YAML and we just need to change the casing. So what we'll do is we'll close this, and under the API gateway project, under the resources folder in the application.yaml file, what we're going to do is we're just going to change the casing of some of our options here. So under the first root, we're going to change the path in here to be uppercase P, and under filters in here, we're going to change prefix to be camel case. So we'll change the S to be uppercase S, and then we'll change the P to be uppercase P, and we'll just remove the dash. So your path should look like this, and then your filter should look like this. And down in the second root for the docs, we'll do the same thing. We'll just change path to be uppercase, and then we'll change rewrite path to be camel case. We'll change the R, change the P, and then just remove the dash so that your code looks like this. But at this point, we can run this again. So up in the configuration options, just choose the run button, and then this will attempt to create a new image and deploy a Docker container, and hopefully everything works this time. Okay, so we got some better results this time. If we scroll over, we should see that our application, API gateway application, is started on port 4004, and we also have a green healthy container. So the easiest way to test this is to use the HTTP REST requests in IntelliJ like we have been using so far throughout the course. So go ahead and minimize this, and under the project tree, we're going to go into API requests, and what we will do to test our API gateway is go to get patients. So this is a GET request that we have been using so far to interact with the patient microservice directly. So up until this point, we have been using this URL and port 4000 to interact with the patient service directly inside of our microservices setup. But now since we've closed port 4000, so whenever we created our new patient service container, we removed the port bindings from the configuration. That means we can no longer make a request directly to the patient service itself. So let's see what happens when we try to run this request now. If we click run in the services window, you can see that we get an error and it says connection refused to localhost 4000. So that's because we no longer opened the port. So now the only way to access our patient service is through our new API gateway. So all we have to do is update this URL. So instead of port 4000, we will point our request to the API gateway, which is on port 4004. And the path for the patient service is what we defined in the application YAML file. So we'll say slash, and then we'll say API slash, and then we'll say patients. So the API gateway is open to the internet on port 4004, and it will take this request and it will forward it on behind the scenes to the internal address of the patient service. So this time, if we click run, you can see that we're getting an array of patients back. So this means that our API gateway is working as we're able to the API/patients request to our patient microservice. And the reason this works is if we have a quick look at our application.yaml file, which is in the resources folder of the API gateway project, we have specified in the predicates that this is the path that the API gateway is going to check in order to apply this rule. So since in our get patient request, we have API/patients, this matches this predicate, API/patients, and that's why it gets forwarded to the patient service behind the scenes. So another thing to note is that this is going to work with all of our requests to the patient service because we use this double asterisk. So this is almost like a wildcard path that says anything that starts with API/patients is going to get forwarded to the patient service. So for example, if we want to get a patient by a specific ID, or if we want to create a patient, then all these requests will get forwarded to the patient service as well. And if you want, you can also check that the docs route is working as well. So all you have to do is go to a web browser and go to localhost colon 4004, which is our API gateway address. Then we'll go to /API docs/patients. So this is the address that we specified in the predicate for this rule down in here. So /API docs/patients, and then this will rewrite the request down here into /v3 API docs and append it to the URI up here and then return the docs. So if we look at this in the browser, you can see that we have the open API definition here, and it's got our paths and patient endpoints and all that good open API stuff. So that's essentially it for the first step of our API gateway. So at this point, feel free to go back over some of the stuff that we have wrote in terms of the code and in terms of the different rules and predicates and so on, as it can take a bit of time just to understand how these things actually interact with each other to determine which request goes to which microservice and so on. If you're having any issues with this, make sure that you have double checked this application.yaml file against the completed one on GitHub, and that you have added the right config to the API gateway run configuration, and also double check the dependencies in the pom.xml as well. Okay, so now that we have an API gateway in place that we added to our microservices setup in the previous section, what we are going to look at now is how to integrate an authentication service into our microservices setup. So authentication and authorization is quite a large topic in itself. So for this portion of the course, we are going to focus on how to use JSON Web Tokens, or JWTs, in order to protect the endpoints in our patient service microservice. Up until now, we have been able to access our patient service openly from the internet, regardless of who we are. So when we introduce authentication, what's going to happen is we are going to have to log in by making a REST request to our auth service with a username and password. The auth service will then take our username and password that it retrieves in the request, and it will validate that those credentials are correct. So it will do this by comparing the username and password combination to that is stored in the database of the auth service. Once the auth service has verified that our credentials are correct, it will then return a JSON Web Token back to the client, and this token is going to be used in the subsequent requests to prove who we are. So by that, what I mean is after the client or front end has logged in and retrieved a token, it will then pass this token along with any subsequent requests to our microservices setup. So for example, we will do a GET request to our patient service, which will go through the gateway, and we will include this D token along with that request. The API gateway is going to take the token, and it's going to validate the token by making a call to the auth service. If the token is valid, it will then forward the request on to the patient service, and then the patient service will respond as normal. If the token is invalid, it will then return this result back to the API gateway, and the API gateway will respond to the client with a 401 unauthorized status code. If that happens, the request does not get forwarded to the patient service. It returns early and is handled by the API gateway. So there's a few steps to this. So the first thing we're going to do is we're going to create a new microservice called the auth service, and we will also create a database for the auth service in order to store the users along with any user's username and password. And then we will add the login endpoint that allows us to log in, given our credentials, and receive a JWT token. So that's the first step, and this is what we're going to do in the next section. Okay, so the first step that we're going to do is we are going to create a database for our auth service, which is going to hold all the credentials for all of our users in our patient management app. And just like we did with the patient service, we are going to use a Postgres database as this is a good relational database to use for our given use case. So in enterprise production environments, it wouldn't matter too much what database we use here because we are using Docker and microservices. So it is not uncommon to have different technologies such as MongoDB or similar for different microservices. It really depends on the use case for that microservice and how the data needs to be stored and so on. But since we've used a Postgres database before and a Postgres database is well suited to storing users, we're going to use a Postgres database for our auth service as well. So with that in mind, what we will do is jump into IntelliJ IDEA, and at the top under our configurations, we're going to scroll to the bottom and choose Edit Configurations. And under Docker on the left, what we're going to do is select the Patient Service DB. So our auth service DB is going to have a very similar setup to our patient service database in terms of the environment variables and the image and so on. So what we're going to do is choose this icon at the top that says Copy Configuration. So you should see down here that it created a duplicate of the patient service database. So we'll select this, and all we're going to do now is adjust some of the settings that we will need for our auth service DB to start. So the first thing we'll do is we'll change the name up here. So instead of patient service DB, we'll call this auth service DB, and then we can delete the one at the end as well. So in the main settings then, we're going to use a Postgres database, but as I specified previously, if you wanted to have a different database technology for this microservice, you could specify a different image in here, such as MongoDB, and it would fit nicely into our microservices setup as we are running Docker containers. But for this course, we're going to stick with Postgres. So just make sure that you have the image in here. For the container name, we will keep it the same as our service. So we'll call it auth service DB, just like this. And under bind ports, we are going to expose a port so that we can easily connect to this database from our IntelliJ IDE, which is useful for development as we can see the data easily in the database and add data and so on. So we have to change this port 5000 so that it doesn't clash with the patient service DB. So on the right here, go ahead and select the folder, and we're just going to change the host port to 5001. So the container port will stay as 5432, as this is what Postgres is going to run on by default inside of the container. So we can leave this as it is, and then we'll click OK. And under the bind mounts, we're just going to change a few settings in here as well. So go ahead and click on the little icon again, and it should bring up this window that specifies any mounts that we can bind. So as a quick reminder here, the host path is the directory on your local machine, so your computer or your laptop, where Postgres is going to store its data. And the container path is the path inside of the Docker container that is going to mount the data inside of the container anytime it starts. So anytime we start a container, the data from the host path on the left here is going to get mounted into the container, and this is what Postgres is going to use. So in other words, we are saving a backup to your local machine, and anytime a container is destroyed and recreated, it's going to use this data, and it just means that we don't lose the data anytime we create fresh containers. So go ahead and change the host path here to whatever you want on your machine. It doesn't really matter too much. So mine's is just at a DB volumes folder under my username, and I'm going to change patient service here to be auth service. So we'll have a different volume for each of our different services on our host path, and this gets mounted onto the container. And when you're happy with this, click OK. And next we'll open up the environment variables. I don't think there's anything we need to change in here, but we're just going to remind ourselves what these values are. So when Postgres starts inside of a container, there are a few values that we need to pass to the container so that Postgres can initialize a database successfully. So the first thing is the database, and this is going to be the actual name of the database that Postgres creates inside the container. And then we need to specify a user, and we need to specify a password. But this username and password can be whatever you want for development. And all we're doing here is keeping our database credentials the same for all our database so that it's easy to remember and manage as our system grows. So go ahead and click OK here. And the last thing we have down here is that we're specifying that the auth service database is going to run on the internal network. So this means that all of our other containers can interact with this database as it needs to. So go ahead and click apply, and then go ahead and click run. And this will open the services window, and you should see that it's starting to create a new container called auth service DB. Don't forget to start Docker desktop as well, as this starts your Docker context. And we will give this a moment to start, and you should see that it's working when this message appears. So database system is ready to accept connections, and we have a healthy container because it's on the left, we have a green icon. Okay, so once our database is started, what we can do now is create a connection to it from IntelliJ, just so we can work with the actual data inside of the database nice and easily during development. So we can minimize the services window, and on the right hand side, you should have a icon called database. So if you click this, it should open this little tab, and inside here, you will see we have our patient service DB. So this is the connection that we created in the earlier parts of the course in order to connect to our patient service DB. So what we're going to do now is connect to the off service DB. So go ahead and click this new button here. So it's the little cross icon, and hover over data source down here, and under the list, we will choose PostgreSQL. So as you can see down here, there's a whole bunch of other connections as well that's worth mentioning. So it's not just local databases like Postgres. We can also use MongoDB, MySQL, and also connect to cloud services such as Azure, so on. So this is why we use IntelliJ IDEA Ultimate, because it's pretty powerful for things like these. So with that said, let's select PostgreSQL, and it's going to bring up this window. So the first thing we'll do is at the very top, we're going to change this to auth-service-db. And in our options down below here, we're going to leave localhost as being localhost, and we're going to change the port to be 5001, as that is the port we exposed on our auth-service-db container in order to access it from outside of the Docker context or outside of the Docker network. So the next thing we need to do is specify our credentials. So our user is admin_user, and our password is going to be set to password, and our database is just going to be called DB. So again, these three properties are what we specified in the environment variables whenever we started up our off-service DB container. And if we scroll down, you should see we have a URL here that looks something like this. So these get auto-populated based on the previous settings, and what we can do now is test a connection. So just click test connection, and you should hopefully see a succeeded message. So if you're not seeing this, just double check these things up here, the port, the host, and the credentials and so on, and just make sure that these match the environment variables whenever you started your database container. And all being well, you should see the green tick, and that means that we are now able to connect to your off-service DB from our ID in order to interact with it, which is nice for development purposes and viewing the data. So go ahead and click OK, and click OK again. And now if we expand out our off-service DB, that we can see our database, which we call DB. And if we open it up and open up the public dropdown, you can see that there's nothing actually here because we haven't added any tables yet. So we have an empty database, which is good. So in the next section, we will create a new off-service microservice and add some data to our database and build out the login functionality that we need to retrieve a token. So now we have an off-service database running as part of our Docker microservices setup. What we're going to do now is create the off-service. The off-service is going to have two main responsibilities. The first one being that it's going to store all the users and all of the credentials of those users who are able to access our patient management system. And the off service is also going to be responsible for creating JSON web tokens and validating those JSON web tokens in any of the requests. So these things are all off related, which is why we're putting them in the off service, which is good for separation of concerns and so on. So the first thing we're going to do is in our IDE, we're going to add a new microservice for the off service. So in the project tree, we're going to right click on patient management, and in here, we're going to add a new module. And again, this is going to be a Spring Boot microservice. And on the right, we will see the form that we are familiar with. And we're just going to fill this out in the same way as we've done before. So the name for this is going to be auth service, and we're going to make sure that it's in the patient management folder, and it's going to be a Java project, and the type of this is going to be a Maven project as well. So go ahead and choose Maven, and then the group ID, the artifact, and the package name should all be populated for you, and it should look something like this. So go ahead and update these if it didn't. And for the JDK, we're going to choose Java 21, and for the version of Java, we're also going to choose Java 21 as well. So if these options selected, go ahead and click next. So there's a bunch of dependencies that we're going to need for this one in order for our authentication service to work in the way that it's intended. So instead of adding some here and some manually, it will be easier to follow along if we just add everything manually. So go ahead and click on the create button down here on the right, and this will create a new microservice for us called off service. So it should appear here in the list. And the next thing we're going to do is manually add the dependencies that we need. So go ahead and open up the off service folder, and we're going to open up pom.xml. So in here, we'll scroll down and you should see somewhere in the list that we have the dependencies, and it's automatically added the Spring Boot Starter one. That's okay because we're using a Spring Boot app, and then also a dependency for Spring Boot Starter test, which doesn't come into play right now. So what we're going to do now is jump into the README of the finished repository and grab the dependencies that we need in order for everything to work. So go ahead and open up the link, which you can get from the video description, and you want to scroll down to the section where it says off service. So just below this, there will be a list of dependencies. So there's a whole bunch of them. So just go ahead and select the little copy button on the right, and then we'll jump back into our ID and we'll take a few new lines just above the closing dependency tag, and then we'll just paste in our new dependencies, just like this. So let's talk through what these are so that we know exactly what we're doing. If we scroll up towards the top of the list, the first one we added is Spring Boot Security. So there's a whole bunch of stuff you can do with Spring Boot Security, but the main thing we want to use this for is to encrypt the passwords before we save them to the database. So we'll see how this looks later. The next dependency we added are some Spring Boot related ones. So these aren't anything special. These are ones we have worked with before. Spring Data JPA and Spring Starter Web that lets us build REST endpoints and interact with the database using repositories and models and so on. And down here, we've also added some dependencies for JSON Web Token. So again, the JSON Web Token is going to be the thing that the front-end clients receive when they have successfully logged in. So these packages are some industry standard ones that let us easily create, validate, and work with JSON Web Tokens in general. And down here, we have added a dependency for Postgres. So we are using the Postgres database, and this just tells our Spring app how to interact with Postgres database, and this will all happen behind the scenes using this dependency. And then the very last one we added is a dependency for Spring Doc. So this will generate the Swagger Open API spec that we need to create documentation on how to use our API. So this is good practice because we are going to be exposing endpoints such as the login endpoint. So it's good to document this so that other developers and third-party systems that are integrating with our system know how to use the auth endpoints as well. So if you're seeing any errors here, just reload your Maven project. And to do that, you can go into the project tree under off service, right click on pom.xml, scroll to the bottom until you see the Maven option, and then just choose the reload project option. And that should clear any of the errors. So if you're still seeing errors at this point, have a look at the README again to make sure that you've copied the dependencies in the right way and pasted them in the right place. Okay, good. So now we've got an off service and all the dependencies that we need. The first thing we're going to do is create the user model. So since we're going to have a users table in our database, it makes sense to have a model to represent this user as a Java object. So we can close our pom.xml and jump into the project tree. And in here, we're going to go into the off service, into the source folder, and then we'll go into main, into Java, and then on the main package here, we're going to right click, go up to new, and then we'll choose new package. And from here, we're going to call this model, just like this. So go ahead and hit enter. And then inside the model folder, we're going to add a new Java class. And this Java class is going to be called user. So this is going to be a class that represents all the properties that can belong to a user in our system. So go ahead and hit enter, and this will create the class on the right. So because this is a domain model, we want to tell Spring JPA that we want to link this class to the users table in the database. So to do this, we will take a new line just above the class definition, then we'll say at, and then we'll say entity. And on a new line, we're going to add another annotation. We'll say at, and then we'll say table, and open some braces, and then we're going to add in a value here called name, and then we'll say equals, and then we'll say string, and then we'll say users. So all we're doing here is we're saying that we want to map this user entity to a table called users. So the reason we have to do this is because a user table in Postgres already exists. It's handled by Postgres itself. So we're just avoiding any clashes here. Okay, so now we have our entity set up. We can start adding some properties to it. So inside of the class, we're going to add an ID. So we'll say at, and we'll say ID, and this will come from the persistence package. And on a new line, we're going to say at, and then we'll say generated value, open some braces, and then we'll say strategy is going to be equal to generation type, then we'll say dot, and then we'll say auto. And on a new line, we're going to say private UID, and we'll say ID, and then go ahead and import the UID class from java.util, and the code should look like this. So all this does is anytime we create a new user or try and insert a user record into the database, it's going to auto-generate the ID for us, and it's going to auto-generate a UUID or a UID, in other words. Okay, so the next thing we're going to do is we're going to store the user's email address, and this is going to be essentially their username. So first thing we'll do is we'll say @ and then we'll say column, and then we're going to open some braces. In here, we're going to say that the unique property is going to be equal to true, add a comma, and then we'll say that the nullable property is going to be equal to false. And then on a new line, say private string, and then we'll say email. So all we've done here is we've added a new property called email to our user, and this is essentially going to be the email column in the users table in the database. And then we're just specing some properties about the column here. So we're saying that this email has to be unique. So we don't want to have duplicate email addresses in our users table, and that the email for any given record has to have a value. This is what the nullable equals false means. So on the next line, we also want to store their password. So again, we'll say column, and we'll add some properties in here, and we're just going to say that nullable is equal to false. So this essentially means that a password is required. And then on the next line, we'll say private string password, just like this. And we're going to add one more, and this is for the user's role. So we'll say @column, and then we'll also say that nullable is equal to false. And on the next line, we'll say private string, and then we'll say role. So what the role is it's going to be the level of privileges that they have when they log in. So for example, we could have an admin who essentially oversees the entire system. We could have a viewer role who can only log in and view things without being allowed to create new patients, for example, and so on. So for this part of the course, we are going to create a user with admin role and see how they can log in and perform all the available actions. And we'll see how this works in the next sections of the course. But for now, we're going to finish creating our user entity by generating some getters and setters for our different properties. So we're going to have 4 columns in our database. Each column is going to represent one of these properties, and in order to get and set these properties, we need getters and setters. So go ahead and take a few new lines at the very bottom of the properties that we just added, and right click, and then go to generate, and then choose getter and setter, and then just select all these options and choose OK. And then this will generate the getters and setters that we need in order to interact with the data in this user record. Okay, so now we have our user, and we have linked it to a users table and told JPA that we want to persist the data from this class to our database table. The next thing we're going to do is we're going to add a script to seed our database with an admin user that we can use to test the login functionality when we have built out the login API and so on. So to do this, we're going to go into the project, and we're going to go into the resources folder in the off service. So it's down here, and we're going to right click on this, go up to new, and then we're going to select file, and then we're going to say data.sql in here, just like this. So go ahead and hit enter, and on the right it should open up an empty SQL file. What we're going to do now is jump back to the finished repository and grab some seed scripts which will insert an admin user for us. So again, just jump back to the finished repository, and under the off service in the readme, if you scroll down again until you see this data.sql line, and you can see that there's a few lines of SQL in here. So what you want to do again is just copy this code snippet, then we'll jump back to the ID, and inside the data.sql file that we just created, we're just going to paste this in just like this. So what's going to happen here is that it's going to try and insert a user into our database called testuser@test.com, and it's going to give it a default password which is encrypted, and then it's also going to give the role of admin, and if the user exists already, then it's not going to do anything. And we've also got a fallback just to check that the users table exists, and if not, just go ahead and create it. This should get created by Spring JPA anytime we start the app, because JPA is going to synchronize all the model entities for us automatically. So this is just to be safe, and that should be it. So this data file is going to run anytime we start the app. So at this point, we have all the basics we need in place in our off service in order to start our app. So we have our model, and we've also added a data SQL script. So the next step is to Dockerize our off service and start it as part of our microservices setup. So to do this, we do the same as usual. We will go and copy a Docker file from a different service, update the name, and then add a run configuration. So if you want to try this yourself before we continue, feel free to pause here and see if you can get the service started. Otherwise, what we will do is jump into the project tree, and we're going to go into the patient service and we'll just grab the Docker file from here. So it's at the top level here and it's just called Docker file. So we'll copy this and then we'll jump into off service and we'll paste this at the root of the off service folder as well. So it should appear in here and then we'll just open this up. And inside our Docker file, we'll scroll to the bottom and we'll change the name of the jar file that gets generated to off-service, just like this. And then the port we're going to expose now is port 4005, which I think is the next available port. So it doesn't matter too much if it turns out that this one's taken, but we can just come back and change it. So now we have our Docker file. We need to create a run configuration for the off service that's going to build the image and deploy a Docker container to our Docker setup. So at the top, under the configurations, we'll jump into the edit configurations window, Docker section. We're going to add a new configuration and we're going to choose Docker file from the Docker option in the list. So in here, we'll call this auth-service. Make sure that you choose the off-service Docker file that we just created. For the image tag, this is just going to be off-service, and then we'll tag this with the latest tag as well. And now we need to add a few of the run commands to the container name. Going to be off-service, and then we're going to go to the modify option on the right and we're going to find some ports. So what we're going to do for testing purposes and development purposes is we're going to expose a port on the service so that we can access it easily from our IntelliJ HTTP clients and from the internet and so on. And when we're sure that the off service is working, in other words, that we can log in and get a token, we will then integrate it to the API gateway, and then we will close this port so that the only way to access the service is going to be through the API gateway. So that's why we're opening a port now. So go ahead and choose the browse option on the right, and then we're going to add a new port binding. The host is going to be 4005. The container port is going to be 4005, as this is what we will configure our app to run on. So go ahead and click OK. And the next thing we'll do is we will go to the modify tab again, and we're going to add some environment variables. So go ahead and open up the environment variables window, and there's a few environment variables that we need to add. So again, instead of typing each one out individually and possibly introducing a bug by spelling mistakes, we'll just copy the environment variables from the README. So again, jump back to the GitHub repository, and under the off service section, under environment variables, we're going to copy this code snippet. So just go ahead and choose the copy button, and then we'll jump back to our code. And in here, we're just going to paste in the environment variables by using the paste button. And hopefully all the environment variables get added in a nice way that's easy to read. So all these environment variables are doing are telling our off-service microservice how to connect to the off-service DB. So we have a JDBC URL that points to the off-service database that's running in Docker. And then we've also specified the same username and the same password that we used to start the off-service database whenever that container starts. And then we have some JPA settings down here that tell Spring JPA that we want to sync our entities from our code with the Postgres database anytime we start the app, which is good for development purposes. So go ahead and click OK. And then the last thing we need to add in here is the run configuration. So we'll choose the modify button on the right, and then we'll choose run options, and we'll say -- network, and then we'll say internal. This is going to add our off service container to the internal network so that it can communicate with the API gateway and also the off service database and any other service that it needs to communicate with. So after this, we'll choose apply, and then we'll choose OK. And the last thing we need to do before we start up our off service is we need to add the port to the application properties. So in the project, we'll go into our off service folder, and then we're going to go down to source, into main, into resources, and then we're going to choose application properties. So because we've specified in our Docker setups that this application, our off service application, is running on port 4005, we just need to make sure that we specify this in here as well, so that when Spring Boot starts, it will start it on port 4005. So in here, we'll just take a new line, and I will say server.port is equal to, and I will say 4005, just like this. Okay, so I think that should be it for the service. So we are ready to start our configuration, which will build the image and start a container. So what we will do is open the services window, just check that we have Docker running and also that our off service database is running. And at the very top, what we will do is choose run off service option to start the process and deployment. So in the window, it will take a few minutes to build the image, as this is the first time, and then it should start an off-service container, which we should see on the left, and it should also add our test user to the database as well. And all being well, at the end of the deployment, you should see that we have the application started message. So started off service application on port 4005. And we should also see that the container on the left has turned green to show that it's successfully running. So this is good. It shows that our auth service has started successfully and deployed to our Docker setup. The next thing to check is to check that the database is successfully seeded with our data.sql script. So to do this, we will hide the services window and we will open up the database tab on the right. And what we're going to do is choose the auth service DB connection, and then we will expand this out. And if you had this open already, it might be worth choosing the refresh button here, as this will trigger the connection to update with the latest status of the database. Then we will expand the DB section, and then we'll go into public. And all being well, there should be a tables folder here, and it should say 1. And if we expand this out, you can see that it's the users table that was created. And if we right click on this, and if we select the edit data section, then in here, you can see that we have a row in the database that looks like this. So we have an ID, we have an email address, and then we also have a password, and then the role of admin. So this is the dummy user that we have seeded our database with, and allows us to make it easier to develop the auth service, as now we can build out the login functionality, such as the endpoints and so on, and we can use this user to ensure that we are able to validate the credentials and so on. So if you're not seeing this, and if you're having any issues with the deployment of the container to your setup, the two things to check are check that you have added the environment variables to your run configuration as they are in the README, and also double check in the POM, and just to make sure you've added all the dependencies as they are in README as well. And then the last thing to check is the data.sql script, just to make sure that it matches the syntax as it is in the README as well. Now that we have our auth service set up and we're able to connect to the database and add some data to it, the next thing we're going to do is create the login endpoint in the auth service that checks the user's credentials that we receive in the request and returns a JWT access token. So when it comes to creating new endpoints, it doesn't really matter too much which order you do things. But the first thing we're going to do here is we're going to create some new DTOs that represent the login request and the login response as Java objects. So just like we did when we created the REST endpoints in the patient service, we're going to have different DTOs that represent the data that comes in with the request, and we're going to have a DTO that represents the data that gets returned in the response to that request. So in the project tree, in the auth service, what we'll do is we'll go into the source folder, into main, and into Java, and then we will go into our main package here, and right click on this, and we'll go to new, and we'll go to package, and then we'll call this DTO, just like this. So go ahead and hit enter, and this will create the new package for us. And this is where we will put all of our DTO objects that we need for the auth service. So right click on DTO, we'll go up to new Java class, and then we'll call this one login request DTO, just like this. And this will be a Java class, so go ahead and hit enter, and it will create it for us on the right. So in here, we're going to specify all of the properties that we expect to receive for any given login request that we receive from the front-end client. So the first one is going to be the email. So we'll say private, and it's going to be a string, and then we'll say email, just like this. And while we're building these things out, we will also add validation that we want to trigger to ensure that the properties that we receive in a login request are valid. So the first one we'll say up here is not blank, and this is going to come from the Jakarta validation package. We'll go ahead and add this, and then we'll add some braces, and then we'll just add the message that we want to return in the response if this field is invalid. So we'll say message is equal to, and then it'll be a string, and I'll say email is required. And on the next line, we'll say email, and we'll add some braces again, and then we'll say message is equal to email should be a valid email address. So these two tags are going to check the email property that is received in the body of the login request. It's going to ensure that it's not blank. So if it is blank or doesn't exist in the request, then this message will get returned. And the second one is going to check that the email that's provided in the email of the request is a valid email address. So that's all we need for this one. The next thing we expect in a login request is the password. We'll take a new line, and then we'll say @not blank, and we'll add some braces, and we'll say that the message is going to be equal to password is required, just like this. And on a new line, we're going to say @ and then we'll say size, and we'll add some braces again, and then we'll say that the minimum length of a password should be 8, and add a comma, and we'll add a message again. And this time we'll say password must be at least 8 characters long. And on the next line, we'll just say private string password, just like this. So all we've done here is add a property to our DTO that stores the password as we receive it in the request. And again, just checking that the password is not blank. And we're just adding some new validation here to check the size of the password. So if the password is less than 8 characters, then it's going to return this error response message in the response body along with a 401 response code. So that's all we need for this DTO. So we'll go ahead and create our getters and setters. So add a few new lines, right click on the empty space and then click generate, and then just choose getters and setters. And in the window that appears, just choose email and password and then click OK. And this will generate the getters and setters for us. Okay, so this is all we need for the login request. So the next DTO we need is going to be the login response DTO. So back in our project tree, we will go down to the off service folder, and then we will go into our DTO folder again and right click on this and we'll select new, go to Java class, and then we'll say login response DTO, and this will be a Java class just like this. We'll go ahead and hit enter. And then in the class on the right that opens up, we will add the properties that we're going to send in the response to a given login request. So at this moment in time, we're only going to add one property, and that's going to be the JWT access token. So we'll say private string, and then we'll say token, just like this. And on the next line, what we're going to do is we're going to right click and we're going to go down to generate. And this time we're going to choose constructor. And in the constructor initialization window, go ahead and select token and choose OK. And what this will do is it will create a constructor that accepts a string token and then assigns it to the token variable above. So since we only have one property, instead of using a setter, it's a bit of a cleaner approach just to use a constructor, as it means we can initialize the object and pass in the thing that we want to initialize it with in using less code. And this just makes our code a bit easier to maintain. So we'll see how this works when we build out the login endpoint and when we actually use this response. So we still need a getter in here in order to be able to retrieve the token from the DTO, and packages like Jackson and things like that will use the getters to serialize an object into JSON. So this is important because when we return a response from our controllers, this object gets serialized into JSON. So we need to make sure that the libraries are able to do this properly. So all we have to do is right click and go down to generate this time. And this time we're just going to select getter. And from the getter window, just select the token and select OK. So now we have our login response DTO. We have a way to create the object and pass a token to it. And then we also have a way to retrieve the token out of the object as well. And there's a little warning up here that says that field token may be final. We just go ahead and select the make token final option. So what this does is it means that once this token has been initialized, it cannot be re-initialized again. So this is a nice feature to have, as it means we cannot accidentally override the token in the response by mistake or if a bug occurred in the code. And that's all we need for our login response DTO. So the next step we can do is we can build out the controller method. Okay, so now that we have our DTOs in place, what we can do is start writing the code for the controller method that's going to handle the request for a login. So in our project tree on the left, we will go into the off service and then we'll go into main and into Java. And what we're going to do is create a new package under the main package that we have here. So just right click this, go to new, go to package, and then we'll call this controller. And on the package that gets created, we're going to right click and we're going to add a new Java class. And this Java class is going to be called auth controller. So this will be a Java class that has all the request handler methods that will handle all the auth related requests. So go ahead and hit enter, and this will create the class on the right hand side for us. First thing we'll do here is we will annotate our class over here with the REST controller tag. So we'll say @ and then we'll say REST controller, just like this. And this will come from the Spring Framework package and basically says that we want to register this auth controller as a Spring Bean so that the Spring Framework will manage it for us in terms of dependencies and so on. The next thing to do is we want to create a method that handles the post to the login endpoint. So we'll take a new line and then we'll say @ and then we'll say operation and we'll open some braces and then we'll say summary is going to be equal to a string and then we'll say generate token on user login. So this is for our Swagger docs, and we'll take a new line again, and we'll say at, and then we'll say post mapping, open some braces, and then we'll add a string, and then we'll say /login. And on the next line, we'll say public response entity, and we'll add some angle braces this time. And inside the angle braces, we're going to say login response DTO, and we'll call the method login. And then we'll add some braces here, and we'll add an annotation in here. So we'll say at, and we'll say request body. And over here, we will hit tab to autocomplete, and the code should look like this. So whenever we receive a request to the login endpoint, Spring will convert the request body into our DTO object and pass it as an argument to our method here. So this is what our code looks like so far. So the first thing that is going to happen inside of our login method is that the controller method is going to call the service layer of our auth service in order to perform all the business logic that is needed to authenticate the user and return a token. So inside of our method, we'll say optional and add some angle braces, and then we'll say string, and then we'll say token optional. It's going to be equal to, and we'll say auth service dot authenticate, and we'll open some braces again, and then we'll pass in login request DTO. So what this is going to do is that when a login request happens, we're going to call a service layer method, which we will call authenticate, and this will accept the login request DTO. Then the authenticate method is going to do all the business logic that it needs to do to determine if the credentials in the request are valid and generate a token and so on, and handle any cases where the token is not invalid. And then it's simply going to return to us an optional. So again, an optional object in Java means that this is going to be either empty or it's going to contain a string. So in other words, the authenticate method is going to do all the logic, and if the request is valid, it will return a token as a string and assign it to token optional. If the token is not valid or expired or whatever, then the authenticate method is going to return empty to our token optional. So based on this, we will know if the email and password that the user has given us is correct or not, and we can handle the different scenarios based on that. So we haven't created the auth service method yet, but we will do that in the next step. For now, we're going to complete our controller method. So based on the things that we just mentioned, what we can do is handle the different scenarios based on if the token optional object has a string or if it's empty. So on a new line, we will say if, then we'll say token optional dot is empty, add some braces, and in here we'll say return response entity, then we'll say dot status and open some braces, and then in here we can say HTTP status and dot unauthorized, and then we'll just say dot build at the end. So if the authenticate method up here returns empty, that means that the login request that we received has invalid credentials, and therefore we are going to return early from this method, and we are going to return with an unauthorized status. So on the next line outside of this if statement, we can handle the case where the token is valid and we want to return it to the user. So we'll say string token is equal to, and then we'll say token optional dot get. So what the dot get method means is that it converts the token optional object up here from an optional into an actual string. And then we just assign this to the token variable here. And on a new line, we'll say return response entity, and we'll say dot okay, which means return a 200 status code. And then we'll open some braces. And then in here, going to return new login response DTO. And then we're going to open some braces and pass in the token to it. This means that the authenticate method has returned an actual token. And all we're doing here is we are getting the token string out of the optional, and we are creating a new login response DTO and passing the token to the constructor. And then we are returning this entire object as part of the HTTP response at the very end of the method. And this is why we used a constructor to construct our login DTO, as it just makes the code a bit cleaner on this line instead of having to initialize a new object, assign it to a variable called the setter, and so on. So this is a nice approach when you have a few properties only in your DTOs and Java objects. So at this point, we have more or less completed the login controller method that will handle the request and handle the different responses based on the result of the authenticate method. So we haven't created the auth service layer yet, so this is the next thing that makes sense to do. So in the project tree, we're going to go into our auth service, into the Java folder, and then into the auth service package, and then we'll go into new and create a new package this time, and we will call this package the service package. So again, we're just following the Spring Boot microservice architecture conventions that we started with in the patient service. So what we'll do is go into this service package and create a new Java class, and we will call this the off service like this, and then we'll hit enter, and this will create the class on the right for us. So the first thing we will do here is we will annotate this class as a service class. So just above the class definition, we'll say at, and then we'll say service, just like this. Inside of the off service class, we will create a authenticate method that will hold all the business logic that is needed to authenticate the user. So inside of our off service class, the next thing we're going to do is create the authenticate method, which will handle all the business logic for validating the user's credentials and returning a token. So in here, we'll say public, optional, and we'll open some braces, and then we'll say string, and then we'll say authenticate, and we'll press tab to complete the request. And inside of the braces, it should look like this. So the authenticate method will accept the login request DTO that gets passed in from the controller. The first thing we need to do in the authenticate method is we need to get the user from the database based on the email address we received in the login request DTO. So up here, we'll say optional, and then we'll add some braces, and we'll add some angle braces, and then we'll say user, and then we'll call this user, and this is going to be equal to user service dot, and then we'll say find by email, open some braces, and then we'll say login request DTO dot get email, and we'll import the user from the model folder or package, just like this. So what we're doing here is we're going to call the user service, which is going to be a different service layer class within our off service microservice, and this will return us a user if it can find one based on the email address. So we haven't created the user service, so let's do this next. We'll jump into the project, and in the service folder, we'll add a new file, and this will be a Java class, and then we'll just call this user service, just like this, and hit enter. And then this will open up on the right hand side. At the top in our class definition, we're going to say at, and we'll say service, as we want to register this class as a Spring service. Inside of the user service class, we will create the find by email method. We'll say public, and then we'll say optional, and in here we'll say user, and we'll call this find by email, open and close some braces, and then this is going to accept string email, and we'll open some braces to complete the method, just like this. And then we'll also import the user class from the model package, and we'll import the optional from the java.util package so that our imports look like this and our code looks like this. So in here is where we're going to have any business logic that we need in order to find a user by email, and also the call to the user repository to make a query to the database to find a user as well. So at the moment, we do not have any business logic that we need to implement in order to find a user by email. So all we can do here is we can call the user repository and return the result. So just say return user repository, and then we'll say dot find by email, open some braces, and then we'll pass in an email. Okay, so what this find by email method is going to do is it's going to ask the email address that gets asked to it as an argument from the calling class, and it's going to call the user repository to find a given user by their email address. And this simply gets returned back to the calling class. In this case, it's going to be the off service that we created previously. So we haven't created the user repository yet, so we can do this next. We'll jump back into the project, and in the off service, we're going to go into the main package and right click, go up to new, and we'll go into package, and then we will create the repository package, just like this, and we'll hit enter. And inside of this repository package over here, we're going to right click, go up to new, and we're going to create a new Java class, and we'll call this user repository. And this is going to be an interface this time. Since we are creating a JPA repository, we will extend the JPA repository so that we can add our own methods to it. So to do this, we need an interface. So go ahead and hit enter. And over here on the right, we now have our new interface. So the first thing we want to do, so just after the user repository declaration, we'll say extends, and then we'll say JPA repository, and we'll open some braces. And then in here, we're going to say user, add a comma, and then we'll say UUID. So we'll import these things. So the user comes from the model package, and UUID comes from the java.util package. So all we're saying here that our user repository that we want to use to access the database is going to extend the JPA repository based on the user model, which maps to the user table, and the unique identifier for this model is going to be of type UID, in other words, the ID. So in here, we can now add a method to use JPA to search the database for a user based on the email address. So we'll say optional, add some braces, and we'll say user, and then we'll say find by email, add some braces, and then we'll say string, and then we'll say email. And we'll import the optional from the java.util package as well. that our code looks like this. And this is all we need to do now to add a find by email method to our user repository, as JPA will handle the SQL query behind the scenes based on the property name email here and the keyword find by that we specified in the interface of our user repository. Okay, so now we can use this in our service. So we'll jump back to user service, and what we're going to do now is inject the user repository into our user service using dependency injection. So to do this, we will take a new line just at the start of our class definition, and we'll say public user service to create a constructor, and we'll open some braces, and then we'll say user repository, and then we'll call this user repository in lowercase as well. And then inside of the constructor, we'll say this dot user repository is equal to user repository, just like this. And then we will add our instance variable to the class. So just outside of the constructor, we'll say private final user repository, and we'll call this user repository as well. So all we're doing here is we're using dependency injection to tell Spring that we want to inject the user repository class that we just created into our user service. And then we want to assign it to the class variable up here that we've called user repository. And down in here under find by email, the error's gone now, as we have a user repository object that we can use to call the find by email interface method. Okay, so now we have created a service layer that calls the user repository. We can use this in our off service layer. So if we jump back to offservice.java, this is where we created the authenticate method a few moments ago, and we need to call the user service to find a user by their email as we receive it in the login request DTO. So to get the user service, we're going to take the same dependency injection approach, and we're going to inject it into this off service class using Spring like we did before. So we'll create our class variable first this time. We'll say private final, and then we'll say user service and call this user service. And on the next line, we will create our constructor to initialize this variable using dependency injection. So we'll say public off service, and then we'll pass in the user service. And inside of the braces, we'll say this dot user service is equal to user service, just like this. So now we've initialized the user service that we need to find a user by their ID and injected it into our off service. That means we can now use it in our authenticate method down here. Before we continue, you're probably wondering why we do not call the user repository in here directly instead of calling a user service, which then simply calls the user repository anyway. There's a few reasons we do this. One of the main reasons is that it makes our code more extensible. So by having a separate user service, it means that in future, if we need to add new endpoints, for example, that allow us to find a user by an email, then all we need to do is call the user service class from the new request handler in the controller. It also means that if we needed to add any additional business logic or any additional steps that we need in order to find a user by their email, all we have to do is add it to this one place, and all the consumers of the user service are going to get this for free. So that would mean less refactoring should we need to extend this code. And the final reason is that it simply follows good Spring Boot microservice architecture, as we follow the pattern of controller and service and repository, which is familiar for a lot of developers who could be coming in after us to change and maintain our code. So now that we have added the user service and we're able to get the user in the database based on an email address, and we assign this to an optional user variable. And again, it's set as optional as there's a chance that the user might not exist. In that case, then this optional is going to be an empty optional. Otherwise, it's going to have a user object in it. So the next steps we need to do are we need to check that the password's valid. And then if the passwords are valid, we will generate a token. So we can do this by chaining these operations together. So to see what that means, what we're going to do is we're going to add a new line just before the semicolon at the end, but after the brace. And then we'll say dot, and then we'll say filter, and add some braces just like this. And inside of this filter method, we can say U for user, and then we'll say dash, and then we'll add a right angle brace to create an arrow. And then we'll say password encoder dot matches, open some braces, and then we'll say login request DTO dot get password, and then we'll say comma, and then we'll say u dot get password. So what we're doing here is we're passing the user that we receive from the user service call to the filter method here using chaining. So this u variable is essentially the result of the call to the user service. So what happens in the filter method is that it's going to check if the password in the login request matches the one that is stored for the user. If the passwords do not match, then the optional up here is going to become empty, effectively ending the chain. And we're going to do this using a password encoder that we haven't created yet, which we will do next. But first, we're going to finish adding our chain methods here so we can see how this works first. So again, just before the semicolon, we're going to take a new line and then we're going to add a dot, and then we'll say map, open our braces, and then we'll say u. Again, for user, we'll add our arrow, and then we'll say JWT util dot generate token, open some braces, and we'll say u dot get email, comma, and then we'll say u dot get role. So what this last step does is it generates a token using the user's email and the user's role. So again, we haven't made the JWT util class yet, which we'll do in the next section as well. But what we want to understand at this point is that if the user's password matches, or in other words, the filter condition passes, it will then pass the user down the chain into the map function here and assign the user to this variable u as well. And what the map function will do is that it will transform this user object into a token that then gets assigned to the optional up here. So that means this variable no longer contains the user, but it now contains the token. So we'll change this to say token. And the optional is no longer going to be a user object, but it's either going to be a string or it's going to be empty. So at the very bottom of our method here, all we have to do at this point is say return token, and our code should look like this. So hopefully this makes sense. If it's your first time seeing this sort of code, it can be a bit confusing because of the way the chaining works, but when you understand how it works, it means we can write some very nice code using optionals. Okay, so before we go and create our password encoder and the method, we need to generate the token down here, just like this. So again, just to summarize, we are doing 3 steps as part of this code. The first step is we are going to get the user by the email that we receive in the request. We then pass the result of this call to the user service to our filter function. So because this is an optional, then the u variable in here is either going to be a user or it's going to be empty. If u is empty, then the chain ends and the token variable up here is going to be set as optional empty, and this gets returned back to the controller. If the user has a value, then we're going to check the passwords against the database to make sure they match. If the passwords do not match, again, the chain ends, the token gets set to optional, empty, and this gets returned back to the controller down here. If the passwords do match, then the user gets passed to the map variable down here, and the map variable is going to convert the user object and replace it with a token, and this is going to be a string, and this gets assigned to the optional up here as a string, and then this token gets returned back to the controller. So we'll see how this works when we come to run the code, but the first thing we need to do is create our password encoder. So to do this, we will jump into the project tree, and in our main off service package, we're going to right click, go into new, and we're going to add a new package, and this is going to be called config, just like this. And in this config package, we're going to create a new file, and this will be a Java class, and we will call this security config, just like this. We go ahead and hit enter, and this is where we're going to put all our Spring security config and beans and so on that we need in order for our off service to work. So in here, we're going to add our password encoder and also add some configuration for our Spring security setup. So the first thing we need to do is up here above the class definition, we have to annotate our class as being a configuration bean. So Spring will manage this and see that it's a configuration class. And the first thing we'll do inside our class is configure Spring security. So Spring security out of the box is pretty restrictive. So even though we want to use it for some things, we don't want to use it for everything. So to configure it as we want, what we'll do is say @bean, and then we'll take a new line, and then we'll say public security filter chain, and then we'll do tab to complete the function. And all we've added is that we have named the method security filter chain, and this accepts a HTTP security object that we've called HTTP, and it throws an exception. So inside this method, we're going to say HTTP dot authorize HTTP requests, and then open our braces. And in here, we'll say authorize, and then we'll add a dash and an angle brace. And then we'll say authorize dot any request dot permit all. So what this means is that it tells Spring Security to authorize all requests that it receives to the off service and let them through without adding any additional security checks. We don't need to block requests at the off service level, as the only requests that we are going to receive are going to be from the API gateway, which we control. And we also do not expose our off service to the internet, but that reduces the risks of receiving any bad requests from any bad actors. So at the very end here, after the closing brace, we'll take a new line, and then we'll say dot CSRF, open some braces, and I'll say abstract HTTP configurer, and then we'll add double colon, and then we'll say disable, and we'll add a semicolon at the end here. So what this does is disable the cross-site request forgery stuff. So again, this is something that we do not need, as our traffic is coming from the API gateway, which we control, and CSRF would typically be used to protect against any front-end client requests that have a hacked authentication token. So we don't need this because our off service is secured by the API gateway. So at the end, all we have to do is say return HTTP build, and that will complete this filter chain and configure Spring Security to be a bit less secure than we need it to be. So now that we've configured our filter chain for the security, the next thing we can do is create our password encoder. So we'll take a few new lines after the method we just created, and I will say at, and I will say bean, and I will take a new line, and I will say public password encoder, and then we'll set this to be a password encoder, and then we'll open our braces. And then in here, and inside of this method, we'll say return new bcrypt password encoder. So this bcrypt password encoder comes from the Spring Security framework up here. And this is what we're going to use to encode the passwords in our database. So we'll explain a bit more about how this works and how we use this to validate passwords shortly. But the next thing we're going to do is we're going to add our new password encoder bean to our off service so that Spring will inject it to the off service as a dependency. We'll jump back to our off service.java file and we'll scroll to the top, and we're going to add a new class variable here. So we'll say private final password encoder, and then we'll call this password encoder with a lowercase p here. And then we will initialize this using the injected password encoder that Spring will give us in the constructor using dependency injection down here. So after the user service variable, we'll add a comma, and then we'll say password encoder. And then in the body of our constructor, we'll say this dot password encoder is equal to password encoder. So now that we have this, if we scroll down, you can see now that the filter method in our chain doesn't have an error anymore as the password encoder is being passed in. So how do we use the password encoder to check the passwords? So if we have a quick look at our database, so open up the database tab and then go to the off service DB connection, and then we'll just open this up and view the data in the users table. So right click on users and go to edit data. You can see in here under the password section, we have this long string that doesn't make any sense. So whenever we save passwords to the database, we do not save them in plain text. We encode them so that it's hard to see what the actual value is. So if a hacker gets access to our database, they are able to see all the users, but they don't know what the exact passwords are. So this is encoded and then we save it to the database. So that means in our off-service logic where we want to check the password, what we do is we encode the password that we receive in the request, and then we compare it to the encoded password that's saved in the database. So once the encoded password is saved in the database, it's never decoded or anything like that. So this is the way we do it. So essentially what's happening here, so if the password in the request is equal to password, then this gets encoded as a string that doesn't make much sense. So something like this. And then this is what we use to compare the value in the database for the given record, which is what this code down here is doing. So the main reason we do this is purely for security reasons, as it means, one, if any bad actors get access to our database, they can't see the passwords, and two, the passwords are encoded, and once they're encoded, they cannot be decoded. Okay, so now that's all we need to do to verify the passwords for the user that we are checking. And the last step is going to be to generate a token, assuming the previous steps in the chain have all been successful. The last step for us to do in our authenticate method is we need to implement the generate token function that will create a token for the user, provided that the user exists and that their password is valid. So to do this, we'll jump into the project tree and we're going to go into the off service and into the main package again. And we're going to add a new package this time. And this is going to be called util, just like this. And inside of this utility package, we're going to add a new class called JWT util, just like this. So go ahead and hit enter. And this is where we will put the utility class that will help us generate a token. So what makes tokens secure is that they can only be verified using what's called a secret key. So a secret key is just a string of random characters that is stored securely on the server. So we use the secret key to generate a token and also to prove that the token has come from our servers and is valid anytime we receive this token in subsequent requests to our protected endpoints such as get patients. So the secret is important. In enterprise production environments, we would treat it as securely as a password. So it's important to keep that in mind. But to see how it works, we're going to implement our JWT util class. So the first thing we're going to do is we're going to initialize a variable for the secret key. We'll say private, and then we'll say final, then we'll say key with a capital K, and then we'll call this secret key, just like this. So this key is going to come from the Java security.key package. So go ahead and import this up here, and we are going to initialize this variable through the constructor. So we'll take a new line, and then we'll say public JWT util, add some braces, and then we're going to add an annotation in here. So say at, and we'll say value, open some braces, and then we'll add a string, add a $sign, add some braces, and then we'll say jwt.secret. And outside of the brace, but before the last brace, we're going to define the type of this value, which is a string, and we'll give it a variable name of secret. And then we'll import this class from the Spring Framework Beans package up here, just like this. And we'll add some braces to complete our method. So what we're doing here, we are injecting our secret key from the environment variables. So we do not want to store the secret key as text in the code, as this would pose a bit of a security risk, as our code gets checked into a GitHub repository, which is visible by many people. And if some bad actors get access to our GitHub repository, they will be able to go in and find the secret keys in the code. So that's not what we want. So we hide them away using environment variables. In our constructor, once we have secret key that we receive in the arguments as a string, we can convert it to a Java security key object. So to do this, we need to do a few steps. So the first one is we'll create a byte array. So we'll say byte, open some braces, and then we'll say key bytes is equal to, and then we'll say base 64.getDecoder.decode, and in the decode method call, we'll say secret.getBytes, and in the argument for getBytes, we'll say standard charsets.utf_8. So this is what your code should look like. And all we're doing is we're converting the secret that we received as a string into key bytes. And on the next line, we'll say this dot secret key is equal to keys dot mac, and then we'll do sha, and then we'll do key 4. And then we'll open some braces, and then we'll pass in our key bytes. And the keys variable over here comes from the JSON Web Token Security Keys package. So go ahead and import this, and your code should now look like this. So all we've done is we've taken our secret key, which is a string, and we have converted it into a format, which is a key object, and then we can use this to create tokens, as we'll see shortly. So now that we have the secret key variable that's initialized, we can take a few new lines below our constructor, and we'll say public string, and I will say generate token, and we'll open our braces, and I will say string email, add a comma, and I will say string role, and then we'll open some braces at the end. So this is the method that we're going to use to generate a token, as the name suggests. So what we're going to do now is say return, and I will say JWTS, and then we'll say dot, and then we'll say builder, and then we'll open some braces, and on a new line, we'll say dot subject, pass an argument in here, and then we'll say email. So the subject in JWT is a standard field, and it's mainly used to store an ID that relates to the person who is trying to log in. So in this case, it's going to be the email address of the user who's trying to log in. And on the next line, we'll add a claim. So we'll say dot claim, open our braces, and then we'll add a string, and we'll say role. Outside of the string, add a comma, and then we'll say role. So a claim is a custom property that we can add to JWTs. So JWTs have standard fields that they expect, such as the subject, but a claim is a custom one that we can add. On the next line, we'll say dot issued at, and this is going to be a date. So we'll just say new date like this, and we'll import the date package from Java. So this is just the issued date that gets stored in the token, and this is going to be used to determine if the token is valid or not. On the next line, we can say dot expiration, and what we'll do here is say new date and open some braces, and inside of the braces, we're going to say system dot current time millis. So this is the milliseconds, and then we'll say plus 1000, and then we'll say times 60, and we'll say times 60 again, and I will say times 10. So this is essentially 10 hours. So it depends on the requirements for how long to set an expiration time for, but having expired tokens can be a pain during development. So we're just going to set this for 10 hours so that we don't constantly have to log in again as we're building different microservices. So on the next line, we'll say dot again, and I will say sign with, and then this is where we pass in our secret key. So we'll say secret key, and then this is the secret key that we have created up here. And then the last thing we need to do is say dot and then compact, and that's it. So whenever we use dot compact, it's going to take all these properties that we have specified,
it's going to create a string and then it's going to sign that string using the secret key. So by sign, what we essentially mean is encode this token using the secret key. And then the compact method is going to squash everything down into a nice single string that will form our JWT token. So after we've built a token, it then gets returned back out of the generate token function as a string up here. So this is all we need to do in here. So now that we've created a generate token method, we can use it in our code. So we'll jump back to our offservice.java file and we'll scroll to the top and we will inject this to our service just like we did with the other dependencies that our off service needs. So up here, we'll say private final and then we'll say JWT util and then we'll call this JWT util as well. And down in our constructor at the very end here, we'll add a comma and then we'll say util, and in the body of the constructor we'll say this dot util is equal to JWT util. Notice an error here and it says cannot auto wire as there's no beans of JWT util type found. So this is an error that comes from Spring and it's saying that it's unable to automatically inject JWT util class as a dependency as it cannot find the JWT util class. So to fix this, we will jump back to JWT util and above the class definition, we are going to annotate this with the component tag. So every time we add a component tag to a class, it essentially registers this class as a Java bean and as a Spring bean, and then that means that Spring Boot knows which classes to autowire using dependency injection. So if we jump back to the offservice.java file, you can see now the compiler has found a bean that matches our class name and it knows to inject this whenever the code runs. And now we've passed in our JWT util class, we can scroll down and you can see now that the error is gone from the map function in our authenticate method. So this means the last step in our authenticate chain is that it's going to take the user, it's going to pass the email and the role that we get from that user object, which comes from the call to the user service, and it passes those things to the generate token call in our util class and returns a string. So that means that at this point, the chain completes and the result of this gets assigned to our variable token up here. And we know it's going to be a string and we know it's going to have a token. And if any of these other steps fail, then this token variable is going to be an empty optional. So at this stage, we have completed our authenticate method and all that's left to do is to wire up our off service to our off controller, and then we can test that we are able to log in and retrieve a token. So if we jump into offcontroller.java, which you can do by double tapping shift if you close the file and just searching for off controller. And here we will have an error because we haven't injected in our off service to the off controller. So we'll just scroll to the top of the off controller class and we will add a constructor to wire this in. So in here we'll say private final and we'll say off service, and then down below this we'll add our constructor. So we'll just say public off controller and then we'll pass in the off service, which will get wired in by Spring, and inside the body of the constructor we'll say this dot off service is equal to off service. And now if we scroll down, you should see that our code is now free from any errors. So in terms of code, that's all we need in order to log in and retrieve a token. So before we start this, what we'll do is we need to update our environment variables for our off service container. So at the top in our configuration drop-down list, we want to edit the off service configuration. We just choose the three dots and choose edit, and in here we'll scroll down until we see environment variable, and what we want to do in here is we want to add a new one. So we'll click add over here and then we'll add in JWT underscore secret. Now for the value for this, it really doesn't matter, but you just want to put in some random string, as this is what's going to be used to sign the tokens at the point when it gets generated, and also this is going to be used to validate that the token has come from our system when we build the validate endpoint later. So some tools you can use are available online. So if you just Google for secret key generator, it will give you a random string and then you can just paste it in here. Okay, so this should be it for the environment variables that we need. So go ahead and click OK. And down here, we will click apply and then we'll click OK. So before we try and run this, what we need to do is go into the off service folder and we'll go into the test folder. So by default, IntelliJ is going to add a default test to the code. And because we're doing very specific stuff with reading secrets and converting to bytes and so on, that will cause havoc with the tests, and that's not what we want. So since we're not adding unit tests as part of this course, and therefore we aren't using this test folder, the best thing to do to avoid a whole host of problems is to just delete this test folder. But
of the code base like this. So we will see how to write some integration tests, which are really powerful for testing this functionality in the later sections of the course. But for now, to make our lives easier, we'll just delete the boilerplate test that IntelliJ provides for us as part of the bootstrapping of our service. So at this point, we should have everything we need, and we can go ahead and run the off service build to create a new image of our off service and deploy it to our microservices setup. Okay, so hopefully at the end of the logs in the services window under the off service container, you will see that the application has started. So now what we can do is we can test our new login endpoint using the built-in IntelliJ REST client. So we'll minimize this and we will go into the project tree, and we're going to go into the API request folder, and we're going to create a new directory in here. So we will right click, go up to new and over to directory, and then we'll say auth-service. So just like we did with the patient service, we're going to put all of our off service requests in its own folder just to keep things organized. So go ahead and right click on this and we'll go to new, and then we'll go to HTTP request down here, and we'll call this one login. We'll go ahead and delete all the stuff that was added here, and we can add a comment if you want, just to remind ourselves what this does. We'll say login request, we retrieve a token, just like this. And on a new line, we will specify the verb. So we're saying post, and then we'll specify the endpoint. So it's going to be http://localhost : and then we'll say the port of our off service that we exposed for testing. That is 4005, and then we'll say /login. And as you can see, IntelliJ has picked up that it's testing the login request handler on our off controller. If we control and click this, it will take you to the method, which is quite nice. So while we're here, just to remind ourselves, the login request is going to expect a body, and in that body, it expects to be a login request DTO. And if we look at login request DTO, we have to provide two properties. That's the email and the password. So if we jump back to our requests, we will take a new line and specify the content type. We'll say content-type, add a colon, and then we'll say application/JSON. And then we'll take a few new lines in here, add some braces, and then in here is how we specify the properties we want to send in the request. We'll say email, and then this is going to be test user at test.com, and then we'll add a comma at the end of the string, take a new line, add a new string, and I will say password, and then the password is going to be password 123. So whenever we seeded the data in our database, we created a user that has this email and that has this password. So the encoded password that we see in the database for the seeded user is the encrypted version of password 123. So now all we have to do is run this, and we should receive a token in the response. So go ahead and click run, and in the services window, you can see that we have a 200 response back, which is good. And then we get a token back in the body of the response. So this is good. It shows that we're able to generate a token based on the username and password that we sent in the request. So let's see what happens when the credentials are invalid. So if we edit our password to be something that's wrong and we send this request, you can see that we get a 401 back, which means we have been denied access to get a token. So this is good. We'll just do the same with a user that doesn't exist, just to prove that it's working. We'll say wrong user at test.com and then hit send. Then if we look at the response, you can see we get a 401 response back as our credentials are invalid, which essentially means these credentials are wrong. So this is good. It shows that we are able to create login functionality now. And if we just revert this back to some valid credentials, and we will make a request, and then we will get a token back. So if you're having any problems at this point, have a look at the different bits of code that we added in the login request controller, as well as the different services and so on that we created, and also make sure you've added the right environment variables and so on. You can also have a look at the finished code for this section on GitHub to see if there's anywhere that you might have missed along the way. So before we move on to the next section, we are going to have a look at this token and talk a bit more about how it works. So if you want to follow this part, what you can do is copy the entire token. You just highlight everything inside the string and do Control-C. And what you want to do is go to the browser and go to jwt.io. If we have a look at this website, you can see that there's some text here about what JWTs are and how they are a standard. And if we scroll down, you can see that we have a debugger. So there's a warning here which basically says be careful where you paste them, because they're essentially passwords and so on. But since we're just learning and doing things for development purposes, there's no harm really. So what we're going to do is we're going to paste in our token in the encoded section on the left. And on the right, you can see that there's some information about the algorithm that's made public by the token. And more important bit is the payload. So as you can see in here, we have some information about the logged in user. So the sub is the email, and we've also got our custom attribute, which is the role, and it's been set as admin. And then there's also the expiry time and the created at. So this is the data that's inside of the token, and it's going to be used to prove who the user is after they log in and we verify the token on our backend systems. And if we scroll down, you can see that it says here that this signature is invalid, which means that even though you're able to see the contents of the token, that is not enough to prove that this token is valid. This is where our secret key comes in. And if you want, you can paste your secret key in here, and then you should see that this goes green. But essentially, the point that we're trying to learn here is that the secret key is going to be used to validate the token signature in order to prove that this stuff has actually come from our systems in the first place. So that's pretty much it for the login part of our authentication system. So before we move on to the validate endpoint and things like that, feel free to stop here and have a look at all the code that we wrote, because we added quite a bit in this section, and try and understand how the various bits and pieces fit together, as this is a pretty common workflow in enterprise environments. So it's a good thing to understand as much as you can. So in the next section, we are going to look at how we can validate a token that gets sent to our microservices setup for a given request from any front-end client. Okay, so in the next section, we are going to look at how to create a validation endpoint that we can use to check if a token is valid or not. So if we have a look at our architecture diagram for this section, we have created our auth service, and we've also tested the login endpoint that allows us to send our credentials and receive a key token in the response. So the next step is to create this validate endpoint. And once we have that, we can start integrating our auth service with our API gateway. So with that in mind, we will jump back into the code. So the first thing we will do is create the validate controller handler that will handle the validate request. So in our auth service, so we'll double tap shift in our code and we'll go to auth controller, and it will bring us to the auth controller in our auth service where we previously added the login endpoint in the last section. So we'll take a new line here at the very bottom of our class, and then we'll say at operation, open some braces, and then we'll pass in a summary. And this is just going to be a string that says validate token. So this again is for the Swagger docs. It doesn't really affect the code too much. And then on the next line, we'll say at, and I'll say get mapping, open some braces, add a string, and I'll say slash, and I will say validate. So this is the endpoint that the API gateway is going to call in order to see if a token is valid or not. So we'll take a new line on here. Then here we'll say public, and then we'll say response entity. Then we'll add some braces, and then we'll say void. And then we'll call this method validate token, just like this. And then we'll add an annotation in here. So we'll say at, and I'll say request header, open some braces, and then we'll add a string. And then we'll say authorization. And outside of the brace for this annotation, we will give this a type and a name. We'll say string, and then we'll call the variable auth header. And then we will import the request header from the Spring Framework package. And then we'll add some braces at the end to start the method. So what this does is that any requests that we get to the validate endpoint, Spring is going to get the authorization header from the request headers and pass that header to us as a variable called auth header, which is going to have a type string. So the RFC standard and the convention that is used for handling the access tokens is to send them in an authorization header and have it prefixed with the word bearer. So what I mean by that is, as part of the request, we are going to have a header, and one of those headers is going to be called authorization, and the value for that header is going to be bearer, and then there'll be a space, and then after that is going to be the access token. So this is the standard that we use so that all the different systems around the world can understand where the access token is coming from in a given request and how to access it. So this is what the header is going to look like. So the first thing we're going to do is check that the header exists and that it's valid. So on a new line, we'll say if, and then we'll say auth header is equal to null. And then we'll add this condition in here. So we're saying if the auth header does not start with bearer, and then we'll open some braces here, and then we'll just tab to complete the code. And all we're saying is if the auth header doesn't exist, auth header does not start with bearer, then we are going to return early, and we're going to return unauthorized, which essentially means that the token isn't valid, and then the API gateway will handle that scenario, as we will see later in the course. So the next thing we're going to do is take a new line after this, and then we'll say return, and then we'll say off service dot, and then we'll say validate token, open some braces, and then we'll say auth header dot substring, and then we'll say 7. And at the very end, we're going to take a new line, add a question mark, and then we'll say response entity dot okay, then we'll say dot build, and then we'll take a new line, we'll add a colon this time, and then we'll say response entity dot status, and we'll say http status dot unauthorized dot build, and we'll add a semicolon as well. And this is what your code should look like. So let's explain what we're doing here. So we are going to call a validate token method that lives in the off service business layer. So we haven't created this yet, but it's going to contain all the code and all the business logic that we need in order to validate a token. And we are going to pass our token to this method. So what we're doing is we're getting the substring that starts at index 7 from the auth header. So the reason we are getting a substring from the auth header is because the auth header is going to have the word bearer and a space in it. So we don't care about the word bearer. All we care about is getting the token. So if we count the number of characters on the word bearer, 1, 2, 3, 4, 5, 6, and then we have a space, which is 7. By using the substring method, we are essentially cutting out the word bearer and then passing only the token to the validate token method. So the validate token method will return a boolean, so either true or false. And based on this result, we are going to use a ternary, which is essentially an if-else statement in shorthand. And we are going to do two things. So if the validate token method returns true, then it'll enter the first part of the conditional, and that will return response entity OK, or in other words, status code 200. And this tells whoever made the request to the validate endpoint, such as the API gateway, that the token is valid. If the validate token method returns false, then it will jump into the second part of the statement and it's going to return an unauthorized status code instead back to the API gateway. So for this endpoint, we are not returning any explicit data as part of the response. We are simply returning a status code to indicate if the token is valid or not. So a 200 or an OK status code indicates that the token is valid, and a 401 unauthorized status code indicates that the token is not valid. Okay, so now what we need to do is implement the validate token method. So if we double tap shift and we'll go into auth service, and it should be part of the auth service microservice. And this is where we added the authenticate method in the previous section. So it makes sense that we keep all of our logic for authentication and validation in the same service file. So what we'll do is at the bottom of this file, we'll take a new line just beneath the authenticate method, and then we'll say public, and I'll say boolean, and then we'll say validate token, and then we'll just tab to complete the method, and this method will accept a token as a string, as you can see here. So the next step is we're going to add a try catch block. We'll say try, and then just outside of the try, we'll say catch, and then open some braces, and then in here, we'll say JWT exception, and then we'll call this E, and then we'll add our catch block. So in the try block, we're going to say JWT util dot validate token, open some braces, and then we'll pass the token to it. And just below, we'll say return true. And then in the catch block, we'll say return false, just like this. So what we're doing here is in the try block, we are going to use the JWT utility class to validate the token that gets passed to it. And if this passes, then we'll simply return true. And the way that the validate token function is going to work is that if the token is invalid, it's going to throw a JWT exception, and that is what we catch down here. So if the token is valid, then we just want to catch the error and return a boolean that is false instead of returning the exception. In our auth controller, the response will be determined depending on this boolean. So that's it for the service layer. The next step is to implement the validate token functionality itself in the JWT util class. So we'll double tap shift, and then we'll say JWT util.java, and we'll jump in here. And this is where we have all of our code and logic that interacts with the explicitly. So it makes sense to add our verification code in here as well. We'll scroll to the bottom and we'll take a few new lines down here, and then we'll say public void validate token, and this is going to accept string token as well as an argument, and then we'll open and close our braces. Here we'll say try, and we'll add a catch block again, and we're going to catch two exceptions this time. So we'll say signature exception, and this will come from the JSON Web Token security package. And just outside the closing tag of the catch block, we're going to add another catch block, add some braces, and then we'll say JWT exception, and we'll call this E as well, and we'll add some braces here. So inside of our try block, we're going to say JWT s.parser.verify with, and we're going to open some braces in here, and then we're going to cast the secret key that we're about to pass in as a secret key. So, and outside of the last brace, we'll say secret key, and I will add a semicolon at the end and import the secret key object from the Java from the crypto package. And your code should look like this so far, but instead of the semicolon at the end, we actually need to pick a new line, and then we'll say dot, and then we'll say build, and then on a new line again, we'll say dot, and then we'll say parse signed claims, and then we'll pass in the token, and then we can add our semicolon at the end of this. So this is what our code looks like, and this is how we verify if a token is valid or not. So the first line, we are using the JWT package to parse the token, and then it's going to verify the signature using the secret key that we have defined in our environment variables. So again, this secret key comes from up here when we use the constructor to pull in the environment variable and do all the base 64 stuff. And this is the same secret that we use down here to verify that the token has come from our servers and was signed previously using the exact same secret key. But this is why the secret key is so important, because if any bad actors get a hold of the secret key, then they will be able to create fake tokens and access our system. So that's not what we want. So this is why we keep this as secret as possible. So if anything goes wrong with this validation step, then the key package is going to throw a couple of errors that we want to handle down here. And those are the signature exception error and the JWT exception error. So if this happens, what we want to do is just throw a new error. We'll say throw new JWT exception invalid T signature. And in the catch block down below that, we will do the same. And we'll say throw new JWT exception invalid JWT. So we are just keeping the error that gets thrown consistent, so that in the off service, if we jump back to it, we only have to catch one error in here. So now that our JWT util class is in place and the validate token method is in place, it's going to validate the token. If nothing happens, then we'll just return true on the next line. If the validate token method does throw any of the exceptions that we've seen down in here, then they're going to get caught in the catch block, and then we just return false. And at that point, the validate token method will return true or false back to the off controller. So if we jump into off controller now, you can see down in here, the error in our code is gone. And depending on if the result of this validate token call to the off service is true or false, we're going to get a 200 response or a 400 response back, depending on the result. Okay, so now that our code is in place to validate a token, we can deploy it to our Docker setup, and then we can try and make a few requests to see if it works. So go ahead and run the off service deployment to create a fresh Docker image and deploy it to our container setup. And once everything's started, you can minimize the services window for now, and then we can close a few of these tabs down to give ourselves lots of space to work with. So we'll go into the project, and we're going to go into the API request folder, and we'll go into off service, and then we will open up the login.http file. So what we need to do now is we need to run the login request to get a token, and then we will take that token from the response, and then we will create and run a validate request, and we will pass that token along with it. So to make this process a bit easier, what we can do is programmatically get the token from the response and save it as part of IntelliJ's environment variables so that we can use it later on. So to do this, in the login.http file, we'll take a new line at the bottom, and then we'll add a right angle brace, and then we're going to open and close some braces. And inside of this, we're going to add 2 percentage signs, just like this. And this is where we can run some inline code. Inside of this, we'll say client.global.set, open some braces, and then we're going to add a string. And this string, we are going to call token. And outside of the string, we'll add a comma, and then we'll say response.body.token. So what this is going to do is it's going to make the request as usual, and then it's going to parse the response and the body, and then it's going to take the token value from that response and assign it to the global variable that we have called token. So that's all we need to do here, but we will keep this open as we need to come back to it. So the next thing we need to do is create a HTTP file for the validate request. So in the project tree on the left, under API requests and under off service, we will right click this and we'll go to new, and then we'll go to HTTP request, and then we'll just call this validate.http, just like this, and then hit enter. And what we want to do in here is we want to delete everything, and we'll add a comment if you want, and then we'll just say get request to validate token. And on the next line, we'll say get, and we'll say HTTP : and then we'll say localhost 4005, and then we'll say /validate. And IntelliJ should pick up the endpoint that we're trying to test. And on the next line, we will specify the header that we need to send. And in this case, it's the authorization header. So we'll say authorization, add a colon, add a space, and it will say bearer, add a space, and then we'll add a double left bracket, and that should add a double right bracket for us. And then in here, we'll say token. So your request should look like this. And what this is going to do is it's going to call the validate endpoint in our auth service. It's going to add the authorization header to it, and that authorization header is going to have a value of bearer, and it's going to have the token in it. So this code here is going to get replaced with the actual token that's stored in the IntelliJ environment variables. So don't worry about the error. IntelliJ doesn't pick up the global environment variables for some reason, but this will exist provided that we run the login request first. So what you want to do now is open up your Docker desktop to start up the Docker context, and under the containers, what you want to do is make sure that the auth service is running and that the auth service DB is running. And once you have done that, open up login.http. So the first thing we're going to do is log in and get a token. We just run this request, and you should see in the response that we get a token back. And this token value is what's going to get saved in the IntelliJ client, which is what this code does here. And now if we jump back to the validate.http file, the token down here is going to get placed in here. So this will pass the token along with the request, and hopefully we get a 200 response code back. So let's run this and see what happens. And as you can see here, we don't have any data in the response, but we do get a 200 response code back. So this is good, as it means that our auth service is now successfully validating our tokens. And to test what happens if the token is invalid, you can delete the placeholder and just put in some stuff in here. Doesn't make sense because this isn't a valid token. And then if you run the request, you can see this time we get a 401 back, which means unauthorized. Okay, so this is good. It shows our auth service can now validate the tokens we sent it, provided they are in the correct format in the auth header. And that's essentially it for the validate endpoint. So if you're seeing any issues at this point, have a look at the finished code on GitHub, and also double check that you have the JWT secret as an environment variable in your auth service, and have a look at the code that we have written so far.
Okay, so now that our auth service is running and we are able to make requests to it directly from our API client to ensure that it works, the next step that we're going to do is we are going to integrate the auth service into the API gateway. So again, this just means that all the requests to the auth service have to go through the API gateway, which is good for security and for maintenance. And it also means that whenever we want to make requests to our patient service using our API client or our front ends, that all the requests to the patient service are going to go through the gateway, and the gateway will automatically intercept the request and validate that the token is valid. So with that in mind, we will jump into the code, and in the project window, we're going to go into our API gateway project, and is we need to add a new rule that specifies how to route to the auth service. So we will go into the source folder over here, and we will go into main, and then we're going to go into resources, and we're going to go into application.yaml. So in here, that's where we have the configuration for our API gateway routes. So we have some routes for the patient service and the patient service docs, and this is where we will add the routes for the auth service. We'll take a new line, and in here, we will add a dash, and I will say ID, add a colon, and I will say auth dash service dash route, and on the next line, we'll say URI, add a colon, and this is going to be the internal address of our auth service when it's running in Docker. So this is the endpoint or the microservice that this set of rules is going to route to if the request satisfies the predicates. So we'll say http colon / and then we'll say auth dash service colon 4005. So again, this is where the auth service is running when it starts inside a Docker container, and Docker will handle resolving the DNS to the actual address of the container behind the scenes for us using the name of the container in here. So on the next line, we can define our predicate, and we'll say path with a capital P, and then we'll say equals, and then we'll say /auth / and then we'll do a double asterisk. So this predicate means that whenever we receive any requests to our API gateway that have a path of /auth / whatever, then this request will get forwarded to the auth service. And on the next line, after our predicate, we can define a filter, and we'll say strip prefix is going to be equal to 1. So again, all strip prefix does when it's defined under the filter is that it's going to remove everything after the first slash, and then it's going to attach the rest of the stuff to the URI up here. So let's look at an example. So our front end and our REST clients are going to send a request
to http://localhost:4004, which is the address of our API gateway. And the path that the client will send will be /auth/login, for example. So this will be a login request, and we will obviously have the username and password in the body of this request. So what's going to happen in our API gateway is that Spring API gateway is going to check the path against all of our predicates. So it's going to see that the path up here is going to match this predicate because it starts with /auth and has some stuff after it. It's then going to apply the filter. So what happens then is that the API gateway is going to apply the filter, and then it's going to forward the request on to the URI. So this will look like http://auth-service 4005/login. So based on these rules, this request gets transformed in the API gateway into this URI, and the request gets forwarded on to the auth service. Okay, so hopefully that makes sense. We're going to see it working shortly, but that's all we need to do to define the route to the auth service. And since we have everything else set up, we can redeploy our API gateway to our Docker setup and test that we can route a request to the auth service through our API gateway. So go ahead and open up Docker Desktop, and this will start the Docker context. And we're going to go into the services window. And over here under containers, we are going to start the different services that we need to test this bit of functionality. So the first thing we're going to do is start the auth service DB. So right click on this and just click start container up here, and do the same with auth service. And just make sure that if you have made any changes to the auth service, that you actually redeploy an image and a new container using the configurations at the top, because if you just stop and start a container, you may not have the latest code, as it will be using an older image. So just keep that in mind. And the next thing we will do, because we made code changes to our API gateway, is we will go to the run configurations at the top and select API gateway, and then we'll just click run to build a new image and run a new container. So this is the nice thing about microservices architecture, is that to test little bits of functionality, we do not necessarily have to have all of our containers running. We can run the different containers that we need depending on the thing we're trying to build or the functionality that we're trying to add. So this is a nice approach to microservices development. And now that our API gateway is running, we can jump back to our REST API clients and test that we can log in, but also validate a token using the different requests. Before we jump into this section, just make sure that the API gateway container, auth service container, and auth service DB container are all running. And if not, you can have a look at the logs to see why they didn't start. So with that in mind, we will minimize this window, and we're going to go into the project tree, and we're going to go into API requests, and we're going to go into auth service, and we're going to open up the login.http file. And this is the request that we're using to log in. So just a reminder of how it currently works, that we make a post request to the auth service directly by exposing the port that the auth service microservice is running on. Then we send an email and a password along with this request. The auth service will do its thing to check the credentials and return us a token, and we'll set the token in the context variables of our IntelliJ HTTP clients so that we can use it later. So what we want to do now is update the URL of the request so that it no longer goes directly to the auth service, but instead it goes through our API gateway. So to do this, we'll change the port to point to our API gateway. So our API gateway is running on localhost 4004. So we'll just change this in here. And we also have to change the path to match what the rules in the predicates in our application YAML of our API gateway are expecting. So instead of just /login, we're going to send all the auth requests to the auth service, and we determine this by adding the word auth to the path, and then we'll add a / just like this. So now all being well, this should work the exact same as before. It should log us in and return us a token and return a 200 response. The only difference this time is that we are passing through the API gateway. We're going to open up the services window again here, and we're going to run the push request over here. And if we have a look at the result, you should hopefully be seeing the same response as we did before. So we have a 200 OK response, and then we also get a token back. So this is good. The first step of logging in seems to be working. So we'll minimize this again, and we'll go back into the project tree, and we're going to go into validate.http file over here this time. And all we want to do in here is we want to do the same thing. So we want to call the validate token endpoint, which is going to pass through our API gateway and call the auth service behind the scenes, validate the token, and we should hopefully receive a 200 response back because we should have a valid token after we just logged in. So first thing we need to do here again is update our endpoint. So we'll change the address to be localhost 4004. Then we'll do /auth and then we'll say /validate. And this will route the request through the API gateway into our auth service, and it will pass the token in the header of the request. So again, we'll open up our services window, and what we'll do now is we will make a GET request to validate, and you should see in the response up here that we have a 200 response code and we have no errors. So this is good. It shows that our API gateway rules are working. If you're not seeing the same thing here, you can try and call the auth service directly by going straight to port 4005 and calling either login or validate just to make sure that the auth service pieces are working. And if they are, it's probably an issue with your API gateway. So double check the application YAML rules. And to help with that, you can look at the finished code on GitHub. So the last little bit that we want to do in this section is we want to close the port on the auth service so that we can no longer access it directly from our clients. What I mean by that is currently, up until now, we have been accessing the auth service directly from our REST client, but we have just added functionality which goes through the API gateway. So whenever we say close a port, it means that we remove the port binding on the container so that this container can only be accessed inside of the Docker network by all these other things that are also inside the Docker network. And it means our REST clients can no longer directly access it unless they go through the API gateway. So to do this, we will jump into our code and we're going to go to the run configuration at the top, and we're going to edit the configuration for the auth service. We just click on the three dots here and then click edit configuration. And in here, we're going to scroll down until we see the run section down here. And this is where we exposed the port on the auth service. Okay, so to do this, we will click on the browse button on the right, and we will just select the port binding that we added previously, and then we'll click remove. And since there are no port bindings now, that means that the container is now closed to traffic from the internet, such as our REST HTTP clients and so on. So go ahead and click OK and click apply down here, and then we'll click run to deploy a new container. After the container is deployed, we will close down this window and we'll go back to login, and then we'll click run here just to check that this is still working, and it is. So we get a token back, which is good. And the next thing we're going to do is check that we can no longer access the auth service directly from outside of a Docker context. So we will change the URL here to be 4005, and then we'll do /login. But this is the old request that we were using to test the auth service. And now if we click run, you can see this time we get a connection refused, as we are no longer able to access this microservice as it's running securely inside of the Docker context and it's protected by the API gateway. So now we have integrated the auth service login and validate requests to our API gateway, and we tested we are able to access the auth service through our API gateway using the IntelliJ REST HTTP client. Final step we need to do in order to get the functionality working for our API gateway is that we want to intercept all the requests to our protected microservices, such as the patient service, and we want to call the validate endpoint on the microservice from our API gateway to check that the token that the user is sending along with the request to get the patients is a valid token. And then depending on the result of the validate request, we will either return an unauthorized response back to the client, or we will allow the request to continue. So with this in mind, we will jump into the code and we're going to go into our project tree. And in our project tree, we're going to add new functionality to our API gateway. So get and open up the API gateway project, and we're going to open up our file tree until we see our main package down here. And on this package, we're going to right click, go up to new, and then we'll select package. And we're going to call this filter. And in the filter package, we're going to right click and we're going to go up to new and select Java class. And we're going to call this JWT validation gateway filter factory. So this is a bit wordy, but there's a specific reason why we need to name things this way, as we'll see shortly. So go ahead and hit enter, and this will open our class in the editor here. So in here, the first thing we're going to do is we're going to annotate our class with a Spring annotation. And the annotation we're going to use is going to be the component one. This tag tell Spring that this class is a Spring Bean and we want to manage it in the Spring lifecycle. So the next thing we're going to do is over here in the class definition, just before the opening curly brace, we're going to say extends, and then we're going to say abstract, gateway, filter, factory, and then we're going to open and close some angle braces, and then we'll say object. Inside of this class, we're going to say at, and then we'll say override, and on the next line, we're going to say public, gateway filter, and then we'll say apply, and then we'll open our braces, and then we'll say object, and then we'll say config, and then we'll open and close some braces again. Okay, so let's talk about some of this code because it can be pretty confusing, especially giving some of the names. So what we've created here is we've created what's called a filter class. So a filter class in Spring Boot is a custom class that allows us to intercept HTTP requests, apply custom logic, and then decide whether or not to continue processing the request or to cancel the request. So this fits into the architecture that we're trying to achieve nicely, as it means that we can use a filter to call the off-service validation endpoint to check if a token is valid or not. And depending on that, we can then handle the request in the appropriate way. So by extending from the abstract gateway filter factory, we are telling Spring Boot and the Spring Boot Cloud Gateway dependencies that we want to add this filter to the request lifecycle. So by extending the abstract gateway and implementing the apply method down here, which is what the override annotation is for, it means that Spring Cloud Gateway will automatically apply our filter to all the requests. And all we have to do is implement our business logic in the apply method here for how we want to process and handle the request. So the first thing we need to do is we need a request to the validate endpoint. And to do this, we need what's called a web client. So just above this override stuff at the top of our class definition, we're going to take a new line and then we'll say private final web client, and we'll call this web client. So this is the thing that we are going to use to make HTTP requests to our off service. So we will initialize this using dependency injection, and we'll see why we have to do this in a minute. So just below this, we'll say public JWT validation gateway filter factory, and then we'll open some braces. And then in here, we're going to say web client, and then we'll say dot builder, and we'll call this web client builder. And we're going to take a comma after this, and then we're going to say at, and then we'll say value, and then we'll open and close some braces. And we're going to add a string in here, and then we'll say $, open some braces, and then we'll say auth.service.url. And outside of the first brace here, we're going to say string, and then we're going to say off service URL, just like this. And inside of our braces, we're going to say this dot web client is equal to web client builder dot, and then we'll say base URL, open our braces, and then we'll say off service URL, and then we'll say dot build at the end, just like this. And then go ahead and import the value annotation from the Spring framework. And our code looks like this so far. So what we're doing here is we are creating a constructor for our validation gateway filter factory class, and we are passing in a web client builder, and this will be dependency injected using Spring Boot. As a second argument in our constructor down here, we are going to take the base URL of the off service from environment variables, and we are going to assign it to off service URL. And in the body of our constructor, we initialize the web client using the base URL that was passed in by Spring up here. So the reason we pass in the off service URL as environment variables is because depending on the environment that we're currently working in, the endpoint of the off service is going to be different. So for example, in our local Docker setup, it will probably look something like auth service :4005. But on AWS, it might look something like ECS.AWS. blah, 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 and then different port, for example. So this is why we use environment variables, so that we can easily change the properties and point our API gateway to different microservices depending on the environment that we're in. So we can delete that comment, and that should be it for our constructor. So at this point, whenever our app starts, Spring will go and create us a new filter, and it will initialize a web client using the base URL, which we will pass in as environment variables. And at this point, we can start implementing the logic that we want this filter to carry out. So inside the apply method, we're going to say return, and then open some braces, and then we'll say exchange, a comma, and then we'll say chain. Then we'll add a dash and a right angle brace to create an arrow, and then we'll open and close some braces. So the exchange variable here is an object that gets passed to us by Spring Gateway that holds all the properties for the current request. The chain variable is a variable that manages the chain of filters that currently exists in the filter chain. So what I mean by that is we have one filter here that we are using to validate our JWT tokens, but we could equally have as many filters as we want that each would do a different thing. So for example, in a different class in our API gateway, we could have a logging filter, which would do some advanced logging, and we will be able to get access to that filter using this chain variable. So both of these variables get passed in by the abstract gateway filter factory class that we are extending. So these things are essentially managed by Spring Boot and Spring Cloud Gateway. So we don't need to know too much about where they come from. We just need to know how to use them. So inside of our arrow function, the first thing we're going to do is we're going to check the request for an authorization token. So we'll say string token, and this will be equal to exchange.getRequest, and then we'll open and close some brackets, and then we'll say get headers, open and close some braces again, and then we'll say get first, and then we'll open some braces again, and in here we'll say http headers dot authorization, just like this, and then we'll add a semicolon at the end. So all we're doing on this line is we are getting the authorization header from the request, and we are going to assign it to the token variable up here. So remember, anytime a client sends a request to a protected endpoint, we are going to send an authorization header, and it's going to have a bearer token as part of that header. So the next thing we're going to do is we're going to check if the token exists and it's in the correct format before we try and call the auth service. So we'll take a new line in here, and I will say if, open some braces, and I will say token is equal to null or exclamation mark, and then we'll say token dot starts with, and then here we'll add a string, and then we'll say bearer, and then we'll add a space, and then we'll add our braces to open our if block conditional, and we'll take a new line, and then in here we'll say exchange dot get response, open and close some braces, and I will say dot set status code, and I will say http status dot unauthorized, and we'll add a semicolon at the end. So all we're doing here is we're doing some simple checks on the token to ensure it exists before we try and do more stuff with it. So if the token does not exist, or if the token does not start with bearer, it means it's in the wrong format, and we're going to use the exchange variable. So remember, the exchange variable is a Java object that represents the current request. We're going to get the response from this, and then we're going to set a status code of unauthorized. And once we have set these properties on the exchange, we can return or cancel the request at this point and return the response back to the front-end client. So to do this, we'll say return, and then we'll say exchange.getResponse.setComplete. So this returns early from our filter, and we're also saying here that the response is complete, so that Spring can go ahead and actually return that response back to the calling client. So the reason we do this is just to be more efficient, as there's no point trying to make an API call to the off service validation endpoint if we know that the token is going to be bad. So there's no point sending an empty token or a token that's in an invalid format. So we just handle this case early and also handle the request early as well. Okay, so at this point, we can assume that we have a token that is in a valid format. The next step is to actually call the validate endpoint on the off service to let the off service to do its validation steps. So in here, we'll say return, and then we'll say web client.get, and open and close some braces, and on a new line, we'll say dot, and then we'll say URI, open some braces again, and then we'll add a string, and then we'll say slash validate. And on the next line, we'll say dot, and then we'll say header, open some braces, and then we'll say http headers dot authorization, add a comma, and then we'll add in our token. And on the next line, we'll say dot again, and then we'll say retrieve, and then we'll take a new line again, and then we'll say to bodiless entity, and then we'll take a new line again, and then we'll say dot then, open some braces, and then we'll say chain dot filter, and then we'll open some braces, and in here we'll say exchange, and that should be it. So what we're doing here is we are using the web client that we created earlier. So up here, we initialized a web client using the off service URL that we get from the environment variables, and we are going to make a GET request using the web client to the URI that's at /validate. So the way the web client works is it's going to take the base URL that we set here, and it's going to add the URI that we defined here to it. in order to create a complete URI to call from this request. And in here, we are simply taking the authorization header from the initial request, and we are setting it on this request to the validation endpoint. And then we are going to retrieve the response. We are going to tell the web client that there's no body in the response, so don't do anything there. And if all goes well, the then method will get called. So if the response is 200 or some sort of success code, we then say continue the request. So this is what we're saying here. So what this chain.filter line does is it essentially tells Spring that our filter has finished processing the request, all was successful, and that we are happy for the request to continue down the chain. So the next thing in the chain could be another filter, or it could be you continue the request on to its destination, such as the patient service microservice. So we don't need to know explicitly what the next step is. All we have to do is say that this step is completed, and then Spring Boot and Spring API Gateway are going to manage the next steps. So this is all we need in terms of the code for our filter that will call the validate endpoint on the auth service and handle the response and process the request depending on the response. So it looks like we missed a semicolon down here. So we'll just go ahead and add one, and that should fix the errors. So now we have the processing logic in place for our custom filter. What we can do now is specify which routes or which rules this filter applies for. So if we jump into the project, and if we go into the API Gateway project down into the resources folder, and then we're going to go into application.yaml, and in here is where we specify the different rules. So currently all our requests to our different microservices go through our API Gateway. So things like the login route and the get patients route and so on are all handled by the API Gateway. So there are some of these routes that we do want to apply our filter to, and some we do not. So for example, when a user is trying to log in, they won't have a token yet. So we do not want to apply the token validation logic to any of the off-service routes, as this means they will never be able to log in as they don't have a token in the first place. But we do want to apply it to the patient service, as our patient service is going to be protected. So all of the routes on the patient service can only be accessed if the front-end client sends a authorization header in the request. So what we can do in here to specify this is that we can scroll down, and inside the patient service rules or the patient service route, we can add a new line under filters down here, and I will add a dash, and I will say JWT, and I will say validation, and that's it. So now the validation filter that we just added to the API Gateway is only going to affect any routes to the patient service because we've added it as a filter down here. So the way this works is that Spring is going to use the name that we applied here to look for a class that is prefixed with Gateway Filter Factory. So if we look again at our filter, we have named this class JWT Validation Gateway Filter Factory, and this was very much intentional as it's a convention in Spring. So the first half of this class can be anything you want. So we have called it JWT Validation because that's what makes sense to call this class. And by adding Gateway Filter Factory to the end of our class name, this tells Spring that this is a filter class and we can use it in a YAML file. So the first half of this class is going to match the filter that we specify here in application.yaml. So hopefully that makes sense. It can be pretty confusing because it's all convention based, but this is a nice way that Spring gives us in order to define custom filters that we have defined using Java classes and define them in here as simple strings. So this keeps our roots in a separate file from our code. Okay, so at this point we have everything in place that we need to ensure that the patient service cannot be accessed unless the request goes through the API Gateway and that the token validation proves that the token is valid and has come from our auth service. So before we start everything up, we have to make a few changes to the config of the API Gateway. So in our run configurations, we're going to go to API Gateway and then we'll just edit this configuration. So just choose the three dots and then choose edit. And what we need to do here, go into our environment variables. So choose the modify button on the right, and then we'll choose environment variables. And in here, we'll open up the browse panel by clicking the little icon, and this will open up the window. So in here, we have to specify where the auth service URL is going to be. So we'll click add, and then we'll say auth_. service underscore URL. And as a value for this, it's going to be http:// and then we'll say auth service, and then we'll say and then we'll say port 4005. So because we're using a local development and Docker for all of our microservices, the auth service URL is going to be at this address here and on this port. Then we'll click OK, and then we'll click apply, and then we'll click OK again. So now we've added the environment variable to the API gateway microservice so that the API gateway knows where the auth service is. The last thing we need to do, because we added a custom environment variable that will not exist in the test project, is just delete the test project to stop our build from failing. So in the project window, we'll go into API gateway, open the source folder, and then right click on the test folder, and then we'll just delete this to remove it from the API gateway project. So anytime we try and build a Docker image, it's going to run the tests. And in this case, the test would fail because we haven't defined the auth service URL environment variable that our code expects. So instead of trying to maintain tests that we're not using, we'll just delete them for now, and we will add some better tests later on in the course. So at this point, we should have everything we need in our API gateway. So we'll open up Docker desktop, and we'll open up our services window. And the first thing we'll do is we will start up all the containers we need in order to test this functionality. So what we're going to do to test this is we're going to log in as usual, and then we're going to make a request to get patients. So under the Docker section, we will go into the containers, and we'll start the different containers that we need to test this functionality. So we'll say auth service DB and the auth service. So we'll start these two as we need to be able to authenticate ourselves and also validate our tokens. We'll just make sure those have started, and that looks good. The next thing we need is we need to start the patient service DB. We'll go ahead and start this container, and we'll start the patient service as well, as we need to be able to retrieve a list of patients in order to test that our microservices setup is working so far. And the last thing we need is the API gateway. So instead of starting a container here, we've made code changes and changed configuration. So we need to create a new image and a new Docker container. And all we have to do this is run the API gateway configuration up here. So just click run, and we will let this build, and hopefully we've added all the things that we need to do in order to get it to work. So this has started, which is promising. If we have a look at some of the logs, don't see any errors. So this means that our filter has been integrated with the gateway on the face of things at least. So now what we're going to do is we're going to minimize our window, our services window, and we're going to open up API request folder from our project tree, and we're going to go into auth service, and then we'll select login.http. And from here, just make sure that the post request is going to the right endpoint. So we want to make sure that you are going to localhost 4004, as that's where our API gateway is, and then do auth login, and then the API gateway will pass the login request to the auth service behind the scenes. So just double check this before you start, and then click run on the left. And this means we have gotten a token, so this is good. And now we're going to go into the project tree on the left again. And this time we're going to go into patient service, and we're going to go down to get patients. Just a reminder on this endpoint is also going through the gateway, since we're specifying 4004. And then we use the path name API/patients. And this is going to call the gateway. The gateway will then pass this request on to the patient service, provided that the token is valid. So we have to make sure we're sending a token along with this request. So all we have to do in here is add a new header. So we'll say authorization, add a colon, and I'll say bearer. And then we're going to add some curly braces like this, and then we're going to say token. So just a quick reminder of what this does is if we look at the login.http file again, whenever we log in, we are taking the token from the body of the response using this line down here. And this sets the actual token value that we receive from the response as property in IntelliJ called token. And then that means we can use it in our different requests. So we'll jump back to get patients. And now what we can do is run this request and see what happens. So we'll click run, and we see that we get a list of patients back. So this is good. It shows that we're able to get a list of patients through the API gateway, and we're also passing a token. So the next thing we're going to try is we're going to remove the authorization header. So just comment it out if you want. And then we're going to run this request again. And this time, if we look at the services window, you can see we're getting a different response. And this is a 401 response. This is what we're expecting because we've tried to call get patients up here through our API gateway without passing in a valid token. So the API gateway has seen, oh, there's no token in this request, so I'm just going to reject it instead of letting it through. And we can also see this working if we try to pass in a token in the correct format, it doesn't actually make much sense. So if we click run this time, even though we are passing in an authorization header, and have a look this time, what happens? In the services window, you can see we actually get a 500 response. So this isn't quite what we're expecting. We were expecting to see a 401 because we sent an invalid bearer token along with the request. Let's dive into this to see what the problem is. So this error indicates that this response has come from the API gateway. So if we have a look at the logs, and to do this, we will look at the Docker container API gateway on the left, and you can see straight away we have some big error messages. And if we look at the error, it's saying 500 server error for HTTP GET to API/patients. And if we have a look at the error, we can see that Spring Cloud Gateway has logged all the different checkpoints, or in other words, all the filters that it ran when it tried to process our request. So if we look at the first one here, it says 401 unauthorized from GET, and then the off-service validation endpoint. So this is actually what we're expecting because our token was invalid. So this shows that the request from the API gateway to the validation endpoint on the off service actually returned the right thing. But what happened is that the API gateway itself did not handle the 401 unauthorized status code properly, and it returned a 500 error to the client. So in a way, our functionality is working because it did not let the patient request through and return any patient data because the token was bad. However, the response we get is quite confusing because a 500 error code typically indicates that something went wrong on the server. So what we want to do is ensure that the API gateway returns 401 anytime the off service returns a 401 to the API gateway. So the reason we do this is because we want to make sure that the responses are as clear and meaningful as possible to our front-end clients, because remember, there are going to be a team of front-end developers who have to consume our API, and if they are interacting with our API in the front-end code, for example, and they get a 500 response back, that indicates that something went wrong, and it makes it more difficult for them to consume our API. Whereas if we send the actual status code back, which informs them that the request was unauthorized, this makes it easier to manage the different UI elements on the front end. So to fix this, we're going to create a custom exception handler that will catch any of the 401 unauthorized errors that we receive back from our off service, and we will handle them appropriately in our API gateway. Okay, so we will minimize the services window and we'll close down some of our files for now, and we'll jump back to the API gateway folder, and we're going to go into our main package down here, and we're going to add a new package, and this package will be called exception. And in here we'll add a new file, and this will be a new Java class, and then we'll call this JWT validation exception. This will be a Java class, so we'll go ahead and hit enter. And then in here, we are going to annotate this with a Spring Boot tag, and this is going to be the REST controller advice tag. So this tag essentially tells Spring that this class is going to handle an exception. So inside of this class, we can define the exception that we want to handle. So we'll say at, and then we'll say exception handler, add some braces, and then we'll say web client response exception, and then we'll say dot, and then we'll say unauthorized, and then we'll say dot class, and we'll take a new line, and then we'll say public, and then we'll say mono, and then we'll say void, and we'll say handle unauthorized exception, open braces, and then we'll say server web exchange, and then we'll call this exchange, and then we're going to add some braces in here, and then we'll import the mono class from the Reactor core package, and the mono object is used by the filter chain to tell Spring that the current filter is finished. So this emits a signal to say that the current execution is finished. So don't worry too much about what that means, because we're not returning anything as part of the mono response here. But this is why we're using this return type, because of the way the filter chains work. So inside of this method, we're going to say exchange dot, and then we're going to say get response, and then we're going to say dot status code, and then we'll say HTTP status dot unauthorized, and on the next line we'll just say return exchange dot get response dot set complete, and that's it. So what we're doing here is that we're specifying a custom exception. So when our API gateway tries to call the validation endpoint on the off server, and if the off server returns a unauthorized response, instead of returning a 500 response code from the API gateway to the client, we're going to intercept this, and we're going to ensure that the response that gets sent back from API gateway to the front-end REST client is going to be unauthorized, as that's what the front-end client is going to expect to see, and it makes for a cleaner API. This is all we need to do. So we can go ahead and run the API gateway configuration again, and this will deploy our changes to our setup. Okay, so once everything's deployed, we can test this again. So we'll minimize our services window and we'll close down some of these tabs. We'll jump into the project, and then we're going to go into API requests, and we're going to go to patient service, and we're going to go to get patients.http. So this is the previous request we sent that resulted in a 500 error response. So we're sending the correct header in the correct format, but we're sending a weird token. So at this point, we're expecting to see a 401. So let's run this and see what happens. And this time you can see now we're getting a consistent error response back, which says 401 unauthorized. And that's because our controller device in our custom validation exception handled the 401 response from the validation endpoint on the auth server that told us that our token was invalid, and then we returned the correct response back to the client. So it's good to keep things like this in mind when you're designing APIs, because consistent and expected responses help the consumers, or in other words, the front-end clients, how to handle the different scenarios that they could encounter when interacting with our API. So we'll just do one final check here by adding our token back into the request up here so that our code looks like this. And if we hit run, and see this time, instead of getting a 401, we are getting a list of patients back from the patient service because we are authenticated and able to do this. So that about wraps it up for the API gateway portions of this course. At this point, you can feel free to experiment with some of the things that we've added, just so that you understand how it works, and have a look at the architecture diagram as well, just to understand the flow of the requests and specifically how the API gateway handles the requests using filters. And likewise, if you're having any problems at this point, you can have a look at the finished code on GitHub to have a look at the different services and see that your code matches that of the finished repository.
Okay, so now that we have the main functionality of our auth service working and we have integrated it into our API gateway, the next thing we're going to do is we're going to add the documentation to the auth service. So again, this is helpful as it makes it easy for any of the consumers of our API to understand how to work with our auth service. And it also means we can do some client code generation to generate the API requests later, to generate things such as API request clients, as we'll see later in the course. So if we open up the project, and if we go into the auth service, and if we go into the source folder, and then we'll go into main Java, into the main package, and into controller. And if we go into our auth controller, we have already added the Java doc annotations that we need to our controllers as we added these throughout the course. So if we look at each of our endpoints, we can see we specify an operation here. And this operation is what we use to generate the open API Swagger docs. So this is the same thing we did with the patient service in order to create documentation for it. So the documentation is going to be generated for us anytime we build and deploy the auth service to our Docker setup. So all we need to do is expose it in the API gateway so that we can access it from anywhere on the internet or from our front-end REST clients. So to do this, we will go into the project tree and we will go into API gateway, into source, and we will go into the resources folder, and we're going to open up application.yaml. And if we scroll to the bottom, you can see we have a root rule that looks like this. And this is what exposes the documentation for the patient service to the internet via the gateway. So all we have to do is add similar to this for the auth service. So we will take a new line just below this, and we want to indent so that we are in line with this tag here. And then we'll add a dash, and then we'll add a space, say ID, add a colon, and then we'll say API-docs-auth-root. And on the next line, we'll say URI, add a colon, and then we'll say HTTP : and then we'll say -service, and then we'll say colon, and we'll say 4005. And on the next line, we'll add the predicates. We'll take a new line, and then we'll say predicates, and then we'll add a colon. And then on the next line, we'll add a dash, and then you can say path equals /API-docs/auth. So any requests that we receive to our API gateway that has this path is going to be handled by this root rule. And on the next line, we can add the filters. So we'll say rewrite path is equal to, and then we'll say /, and then we'll say API-docs, and then we'll say /, and then we'll say auth, and then we'll add a comma, and then we'll add a /, and then we'll say v3 API/docs. So a quick reminder here, anytime we use Spring Doc to generate the documentation in any given microservice, it will automatically expose the documentation on this path here, which is v3/API-docs. So all we're doing here is we're going to make a more user-friendly route and route this request to the off service and to the location where the Spring docs are. So you will probably notice that this is very similar to how we expose the route for the patient service up here, and that's because it is similar. All we're doing is we're sending the auth docs to the off service, and we are sending the patient's docs to the patient service. So by approaching things this way, when the front-end clients come to consume it, they are unaware that each of these things are on different microservices because to them the URL looks the same. But this is one of the advantages of using API gateway routes, is that it hides the implementation of the actual route using these routing rules. So this is all we need because the API docs are already running as part of the off service. Then the API gateway will handle the request and return the API docs for us. So at this point, we can start our Docker desktop app. We start up Docker context and in IntelliJ IDEA, and we can go into the services window and we can go into our containers. So from here, we will start the off service DB container and we will start the off service as well. And once these two things have started, we will go and deploy a new API gateway with this new configuration that we just added to the routes. So go ahead and select API gateway from the configuration and then click run. And this will build a new image and deploy it to our Docker setup. So once the API gateway is deployed and we have an off service and an off service DB container started, we can go ahead and test the off service documentation route. So to do this, we will use a web browser. What we're going to do is go to the URL and then we're going to type localhost 4004/API-docs/auth. And then if you hit enter, you should see some JSON that looks like this. So this is the Open API documentation. And if you have a look under the paths, you can see that we have a post request to login. And under here, it describes the different things that are needed to interact with this API, such as the request body and things like that. So this is good. It shows that our documentation is working. So this JSON file that we see here is going to be used to generate API requests from a given front-end client. So we'll see how this works later on in the course when we come to build out a simple UI for our microservices API that we're building. At this point in the course, we've added quite a bit of functionality, and up until this point, we have been testing things manually using things like IntelliJ's HTTP request client, checking the logs, and so on. But as our system grows, it takes a lot longer and sometimes becomes harder to test things manually. And this is where automated testing comes in. So in enterprise environments, this is a pretty important concept as it helps us validate that our code is working before it gets shipped to production. So testing in itself is a pretty huge concept, and I could make an entire course just dedicated to testing. So as part of this course, what we're going to do is we are going to learn the theory behind some of the more widely used testing approaches, and we will look at automating the HTTP requests we have been using so far to test our application. So if we have a look at some of the testing approaches we can use, one of those is called unit testing. So unit testing is testing individual units, such as classes or methods, in isolation. And this could include testing specific business logic items that are important to the business needs. Then the next approach is called integration testing. Now, integration testing is a bit of a wide term, but it essentially means that we test multiple components working together, such as a controller, service, and repository. It can also mean that we can test multiple parts of a wider system. So the second part here basically means that we can test different microservices together with testing all of the microservices at once. So for example, this could be testing an API gateway, the off service, and also the patient service without worrying about the analytics service, the billing service, or the notification service. So this is the test we're going to write as it replicates the manual approach we have been using so far. So we'll see how this works in the next section. But there's a few more tests that I want to make you aware of that are important to know as well. So the first one is what's called end-to-end testing or E2E testing. So this is the most complete level of testing where we would set up tools that will perform various workflows starting from the UI, which would in the end call an API and also a database, as well as different microservices as and when needed. So this is essentially testing a system as the end user would use it. So this is the most complete workflow, but it also takes the most time to set up and can be the hardest to maintain. And before we move on, there's a few other tests that are worth mentioning as well. So there is security testing, which ensures that hackers can't access the internals of our system or the internals of our microservices. There's also performance testing, which tests how well our microservices setup performs under heavy loads and heavy traffic. And there's contract testing, which is testing the interfaces between microservices. And we have acceptance testing, which is testing that our functionality matches that of the business requirements that were specified for a given feature. So that's a bit of an overview of some of the main testing approaches. And as I mentioned, we're going to use integration testing in this version of the course to automate the tests that we have been running manually so far. So in here, we have been using IntelliJ REST clients to make a post request to login, and this will go through the API gateway to the off service, and we will get a token back. And then as a separate REST request from IntelliJ, we were taking the token and we were passing it along with the request to get patients, which also went through the API gateway to the patient service. And this also includes the middle step that validates the token and so on. So each time we want to test this, we have to do 2 steps manually, and it becomes a bit cumbersome. So this is what we are going to automate using a tool called Rest Assured. And this is what we will do in the next section.
Okay, so now that we have an idea on the different types of testing that we can do, we are going to jump in and write our very own integration tests that are going to test our off service, our API gateway, and our patient service. So to do this, we are going to use a tool that's called Rest Assured. But this is an open source tool that I've used quite a lot in enterprise level companies to test REST APIs. So if you go to restassured.io, you can have a look at the website and the documentation and so on to get a feel for how it works. But the main thing is that it's good for testing and validating REST services in Java. So this is good, as is what we want. And it gives us a little example here. So in this example, we make a HTTP REST request to this URL, for example, and the server at this address is going to return some JSON that looks like this. And then down below, you can see that we have an example of a test, and you can see that the test makes a GET request to this endpoint, and then it checks the status code and it checks the body of the response for various bits and pieces. So this is a nice tool as it makes for some clean and maintainable tests that are easy to follow in terms of understanding what the test does. So this is why we're using this tool. There's a whole bunch of different API test clients you can use, and they all more or less do the same thing, and that is validate and test that your REST APIs are working. So with this in mind, we will jump back into our code, and in here, we're going to right click on patient management, and we're going to go up to new, and we're going to go to module. And this time we're just going to select a new Java module over here on the left that will hold all our integration tests. So the reason we're putting these integration tests in their own projects are because they are testing a number of cross-cutting services. So by that, what I mean is because we are testing the API gateway, the off service, and the patient service, it does not make sense to put our integration tests into either of those projects. Also, by having our integration tests in their own project, it makes it easier to run them and also to integrate them into CI/CD pipelines and things like that. So we'll see how some of these examples play out as we build out our integration tests. So in here, we are going to call our new Java module integration-tests, and they are going to go into the patient management project, just like the rest of our microservices. So again, the reason for this is just to keep all our code organized under the same folder. And this is going to be a Maven project as well. And we're going to use Java JDK version 21. And this module isn't going to have a parent, so it's standalone. And the only other thing to check is under the advanced settings down here, is that the group ID is set as .pm. So after you've filled out this form, go ahead and click create. And you can see that we now have a new module on the left in the project tree called integration tests, and our pom.xml file has opened on the right. So this isn't a Spring Boot application because we don't need any of the Spring Boot stuff. It's just a simple Java module that is managed by Maven as well. So the next thing we're going to do is add our dependencies that we need to our pom.xml file. So in pom.xml, we are going to scroll to the bottom, and just after the closing properties tag here, going to add in our dependencies tags. We'll open an angle brace and then we'll just say dependencies. And in here, we're going to open another angle brace and then we'll say dependency. And this will add some group ID and the artifact ID and so on. So the group ID is going to be io.rest-assured. And then for the artifact ID, we're going to say rest-assured. And just after artifact ID, we'll add the version. So we'll add a version, and then we'll say 5.3.0. So this is the latest version at time of recording. So it's best to use the same version as I'm using here, just in case any of the newer versions have break-in changes. So after the version, we'll take a new line and we're going to say scope. And in here, we're just going to say test. So all this scope tag means is that this dependency only comes into play anytime we run our tests. So this is useful to know for Spring Boot projects as well, because you can define test specific packages in your pom.xml. You can add the scope tag, and it means that any dependency that has the scope tag will not be packaged in your production code. So this is good as it reduces the size of your Docker images and so on. So just something to bear in mind. And the next dependency we're going to add is JUnit. So just after the closing dependency tag that we added here, we're just going to add a new one, and then we'll say dependency. And the group ID for this one is going to be org.junit. And then we'll say Jupyter, and the artifact ID is going to be junit-Jupyter. So JUnit is a popular unit test library for Java, and even though we are not writing unit tests, it gives us nice utility methods that help us write our tests and do test setup and things like that. And it also ties nicely into rest assured and to our ID, so we can easily run tests and so on. So we'll see how this works after we write our first test. And then the version is what we'll add next. So we'll just add version tags in here, and then we'll say 5.11.4. So again, at time of recording, this is the latest version. So it's best to use this version in case there's any breaking changes in the newer versions that get released, or incompatibility issues with rest assured and so on. And again, we'll add the scope tag in here, just so we can scope this dependency as part of the test scope. And at this point, this is the only two dependencies that we need in order to run our rest assured integration tests. So you may have a few errors around the version. So all you have to do here is reload the Maven project, and it will go and download all the dependencies that you need to your local cache. So just go into the project tree, into the integration test project, right click on pom.xml, scroll to the bottom and select Maven, and then choose reload project. And if this doesn't work, go to the top here in the main menu, and under file, scroll down to invalidate caches and try invalidating and restarting your IntelliJ ID. And this is all we need to set up our integration test project. So now our integration test project is set up. What we're going to do is write our first batch of integration tests, and this is going to test the login functionality of our microservices system. So we will open up the project window, and under integration tests here, we're going to go into source, and we're going to go into the test folder. So this test folder has a Java folder in here already, but there's nothing in it. So we're going to right click on this folder. We're going to go up to new, and we're going to add a new class, and we're going to call this auth integration tests, just like this. So because we are going to put all our auth related integration tests in this class, it makes sense to name it in such a way that describes what these tests do. So this is going to be a class, and then we'll just go ahead and hit enter, and this will open up a normal class file on the right. So inside of this class is where we put all the code that we need to run our tests and to also do any setup work and things like that. So the first thing we're going to do is we're going to specify the base URL of all our requests so that all the tests know our API gateway is in order to make the auth related requests. So inside of our class, we'll say at, and then we'll say before all, and you will notice that this gets imported from the JUnit package. And after this, we'll add a new line, and then we'll say static void setup, open some braces, and then we'll open some curly braces in here, and then we'll say rest assured, then we'll say dot, and then we'll say base URI is going to be equal to a string, and then we'll say http://localhost:4004. So all we're doing here is we're setting up the base URL or URI that the rest assured tests that we haven't created yet are going to use. And this is going to happen before all of the tests run. And the reason we are using localhost 4004 is because that is the address of our API gateway when all the containers are running inside of Docker. So these tests do not run inside of the Docker network. They are going to run as if a user or a front-end client is trying to access our microservices architecture from the wider internet. And because of the way we have architected our different microservices, all the requests from external sources, such as any front-end clients or from the internet, have to go through the API gateway. But this is just something to keep in mind. These integration tests are going to be completely separate from the internals of our microservices architecture, and it does not run inside of a Docker context and things like that. Okay, so now we have set up the base URL. The next thing we can do is write an actual test. So on the next line after our setup method, we'll say @test, and then we'll take a new line, and then we'll say public void, and then we'll say should return okay with valid token. And we'll open some braces, and we'll open and close some curly braces as well. So the naming of tests is pretty important. Different companies in enterprise environments would typically have a standard when it comes to the test names, so that it's easy to see at a glance what this test is going to do. So the convention we are using here is should, and then we'll say an expected outcome, and then the last part says with this data. So we're essentially saying we should get a valid token and an OK status code, all as part of the same response. So inside of our test method then, there are typically 3 steps that you will do to create a good test. And this is regardless of if it's a unit test, an integration test, or whatever. Those 3 steps are 1, arrange, 2 is act, and 3 is assert. So the 3 A's, what arrange means is that you do any setup that this test needs in order to work 100% of the time. So this includes things like setting up any data that the test will need and things like that. Once we have arranged our test, the next step is to act on that test. And this is the code we write that actually triggers the thing that we are testing. So in this case, it's going to be actually calling the login endpoint and getting a response. And the third step is we assert the result from stage 2. So in this scenario, after we call the login endpoint, we are going to get a response. Step 3 is to assert that the response has a valid token and also has an OK status. So this is just to give an idea of how to structure a test. So in order to make a request to our off service, we need to pass in an email and we need to pass in a password. So this counts as something we will do in the arrange step. So to do this, we'll say string, and then we'll say login payload is equal to, and we're going to add 3 speech marks here, or double quotes, and this should add the closing set down here. So after the 3rd speech mark or quote over here, we're going to take a new line, and then we'll hit tab, and then we're going to open and close some braces. And then inside of these braces, we're going to hit enter, and then we'll hit enter again. And in beside these braces, we'll hit tab, and then we're just going to add some more double quotes or speech marks, and then we'll say email, and then we will close this speech mark, add a colon, and then we'll add another speech mark, and we're going to say test user at test.com. Close our speech marks and hit comma. On the next line, open some speech marks again, and then we'll say password, close the speech marks and hit colon. Then we'll add a space, and then we'll add some more speech marks, and we'll say password 1, 2, 3, and we'll close our speech marks just like this. And down in here, we're going to have a red squiggle that indicates we need to add a semicolon, so just go ahead and add this. So this is what your code should look like. And all we're doing here is we are defining the properties that we are going to send in the request that our test runs. So this is just JSON that's going to go in the body of the HTTP request. And the reason we are doing it in string format is purely for convenience, because we want to make sure that this test is easy to follow and easy to understand, as well as easy to maintain, which we can easily do just by editing the string. So once we have the payload, there is nothing else we need to do to arrange the test. So the next thing we're going to do is we're going to add the act actions. So just below the string here that we added, we'll take a few new lines to give ourselves some room, and we'll scroll down. And in here, we are going to write the code that actually runs the test. So what we'll do is say response, and this will be a rest assured response. So if you scroll up, you will see an import that looks like this. So it comes from the .rest assured package. And back down here, we'll say response, and this is going to be equal to, and I will say given. Just make sure you import this from the rest assured given option here, as there's a few other ones. And on the next line, we'll say dot, and then we'll say content type, and then we'll say application/JSON, and we'll take a new line, and then we'll say dot body. Then we'll pass in our login payload that we created up here. So rest assured abides by the 3 steps that we are doing up here. So this given step is essentially the arrange step. So the way to think about this is, given that the body has a payload of this data and this password, we are going to form something that triggers the thing that we are trying to test. So down here, we'll take a new line, and I'll say .when, and then we'll take a new line again, and then we'll say .post, add some braces, and then we'll say string, and then we'll say /auth/ log in, just like this. So this is essentially the act portion of our test as it triggers a post request to the login endpoint on the auth service. So after we have arranged using the given keyword and acted using the when keyword, the last thing that we can do is assert, which we do by using the then keyword. So we'll take a new line and I'll say dot and I'll say then, open some braces. And on the next line, we can start to do the things that we want to assert on. So the first thing we'll do is we'll say dot status code and then we'll say 200 because we want to assert that the response to our call to the auth service up here is going to return a 200 status code. And on the next line, we'll say dot body and we'll pass in a string and then we'll say token, add a comma, and then we'll say not null value, open and close our braces. And then we are going to import this from the hamcrest matchers package, just like this. And on the next line, we can say dot extract and then we'll say dot response. So the dot extract method is going to pull the response from the request that we made up here. And then the dot response method is going to get the actual response object from that and assign it up here to a response variable. And what we can do with the response to help us with debugging is we can print out the token that we received in the response of our test request. So we can say system.out.println and then open some braces, and then we can add a string, and then we'll say generated token, add a colon, and then after this we can just add a plus, and then we'll say response.json path.getString, and inside of this method we'll just pass in the token as that's the property that we want to get from the response object. And that's pretty much it for our first test. So if we just have a look at this again, the first thing we're doing is we are setting up our test. In this case, all we need to set up is the body that we want to send in the test. We are then acting. So in other words, we are performing the post request to the auth login endpoint, which is going to call our auth service. And we are then asserting that the response in our test contains a status code 200 and that the token in the body is not null. So this just means the token has to have a value along with the token property. And then if any of these assertions, so in other words, the status code or the not null check down here fail, then our test will go red and it will tell us why the test failed. Okay, so that should be it. And what we're going to do now is we're going to start up all the Docker containers that we need in order to test the auth service login endpoint, and we will run our test and see what happens. So go ahead and open up Docker Desktop if you haven't already, and back in IntelliJ, we will open up the services, and in the Docker window, we're going to go into containers and we're going to start up the auth service DB, the auth service, and the API gateway container. So we need these things because the only way we can access our auth service is through the API gateway. And we also want to ensure that our test is testing against the real auth service database, as that will catch any issues, if there are any, between the communication of the auth service and the auth service DB. Okay, so once we have these things started, the next thing we can do is hide the services window. And if you scroll up, you can see that in the left column over here, there are some options. So we have a double green arrow beside the class definition here. And then we also have a single green arrow beside our test. So these are things that let us run all of the tests in this class or an individual test. So often in large enterprise code bases, there could be a few hundred unit tests or integration tests or whatever. And sometimes you only want to run the ones that you actually care about. So this is just something to keep in mind, as you don't always have to run all the tests. You can run individual ones using these handy little buttons on the left. So what we'll do is click the double arrow beside our class definition and we'll see what happens. So go ahead and click Run Auth Integration Test, and you should see that the IDE starts to do some stuff, and you should also see that it opened up the run window and our test. So all being well, you should see that we have a green arrow here, and that means our test passed. And if we look at the output window, you can see that our test logged the token that we received back from the auth service request. So this looks good, and that's essentially it. So congratulations, you have just completed your first integration test. So the benefits of having this automation test is that it's doing the exact same thing that we did in our TTP REST request. So if we have a quick look at the project, and if we jump into API requests and in auth service, we'll go to login.http. You will notice that our test does essentially the exact same thing as this. The only difference is that it's automated, means we can run these tests whenever we make any changes to the login flow, for example, just to make sure that the generated token is still returned. So let's take an example to see how this test will help us catch issues. Let's pretend we have made a change to our auth service and the auth service has failed to deploy. So to simulate this, we will go into the services and we're going to right click on auth service and we're going to just stop this container. So our auth service is offline, but we will keep the other two services running. And then we'll minimize the services window and we will go back to our auth integration test and we will run this test and we will see what happens. We just click the little green arrow and then click run auth integration test. And you should see that it's trying to run the test. And eventually we get this cross and it says one test failed. And if we look, we can see that we expected to get a HTTP status code response of 200, but we only got a status code of 500. So that means something went wrong in one of our services. So this is the sort of scenario that you might see during a CI/CD pipeline run, as if you have made some code changes that have triggered a deployment to AWS, for example, the test would run as part of that CI/CD pipeline run, and then you would get an email to say that some of the tests failed. And then at that point, depending on the setup of the environment, some rollbacks might happen and things like that to undo the changes that caused the service to go down, for example, but that's a bit out of scope for this. The main thing to take away is that anytime you make some code changes now to the auth service login flow, you can simply run these integration tests, and if the tests are green, that means you haven't caused any unintended changes to the code. And if the tests do not pass, it means something has gone wrong at some point and it's time to go and investigate if the change was expected, and if not, a bug might have been introduced. So these are the benefits of automated integration tests. So the next test we're going to look at is how to write a negative integration test. So the first test we have created is what is called the happy path. So a happy path is when all the inputs are good and the response codes are good and the data in the response is also good and everything is well in the world. But that's not always the case. And we have added code to our auth service that ensures that the credentials that are sent to the login endpoint are invalid, then the correct status code is returned and the correct responses are returned and so on. So we can also write a test to test the scenario. So the good thing about having written one test is that we can essentially copy and paste it and adjust depending on what we want to do next. So what we're going to do is we're going to copy the previous test that we wrote. So copy everything from the closing brace all the way to the top of the test tag. And we'll take a few new lines at the bottom of our class here, and then we'll paste this in like this. And we're going to change the name of the second test. So we'll say should return unauthorized on invalid login. As the name suggests, and in this test, we are going to send an invalid username and password in the payload, and then we will assert that we get the unauthorized response back. So to simulate this, in the login payload, we're going to change some of the data that we're going to send. So for the email, we're going to say invalid_user@test.com. And then for the password, we'll just put in wrong password. So because these tests are integration tests, they are testing against the real auth service DB. And when we created the auth service DB, we seeded the data with a test user. And in our previous test, we used the correct credentials of a user that we know exists in the database. So in this test, we are going to use credentials that we know do not exist in our database. And in our rest assured setup, there's a few things we need to change. So down here, under the status code, we are expecting to see a 401. And since we are not expecting any data in the body, we can delete these 3 lines down here. So we are just deleting the code that checks that a token exists because it's not going to exist. And we can also delete this log message because there's not going to be a token to log out. And since we're not acting on the response variable up here, we can just remove this and our test looks like this. So this test uses the same approach that we did previously. So we have the given, when, then syntax. And all we're doing this time is we're just asserting that the status code is 401. And that is enough to give us confidence that if the wrong credentials are passed to the auth service login endpoint, that this functionality is working correctly. So what we can do now is open up the services window again and just make sure that you start the auth service again and the API gateway is running and the auth service DB is running. And back in our auth integration test file, we will scroll to the top and we will run all the tests again. So just click this run test button to the left of the class definition. And if you click run auth integration test, this will open a test window and you can see it's run both our tests this time and both have passed. So if we click the unauthorized on invalid login test, you can see there's nothing really in the logs. But if you did want to add some debug messages, they would appear in here. And as you can see, our tests are quite quick considering what they're actually doing. So we're calling the gateway will call the off service will call the off service database, and so on. And all this happens quite quick, and our tests are running quite fast. So that's about it for the auth integration tests that we are going to write as part of this version of the course. In the next section, we will have a look at how to write some integration tests that call our patient service. We will see how to do some advanced things in there, such as passing the token along in the header and so on. But at this point, you can feel free to stop, have a look at some of the tests that we wrote, or the 2 tests that we've wrote, and you can feel free to either add some more of your own tests or adjust the current test that we have added, just to add to your understanding of how it all works and the value of integration tests. And if you're having any problems at this point, check that you have the containers running and that you've added the dependencies to pom.xml and so on. You can also look at the finished code on GitHub to compare your code to mine. So in this section, we are going to write an integration test, the test that we can retrieve a list of patients from the patient service provided we are logged in. So this is an interesting one to look at because there are a few steps involved. So the first step is we need to be logged in. So in other words, we need to have the access token, and then we also need to pass this to the request to the patient service. So this is quite a common scenario in enterprise environments, and it's a good way to also test that the authentication stuff is working for a given microservice. So in our integration test project in here, we're going to go into the test Java folder, and then we're going to add a new Java class, and then we'll call this patient integration test. So again, this is testing the patient service, and it's an integration test. So this is why we name things like this. It's to help us identify where our tests are. So we'll go and we'll hit enter here, and this will create a new class on the right for us. And just like before, the first thing we're going to do is do a before all, and we're going to do some setup to tell our test where the API gateway URL is. So we'll say at, and I'll say before all, add a new line, and I'll say static void, and I'll say setup, open some braces, and then open some curly braces, and then in here we'll say rest assured dot base URI is equal to, and then we'll add a string, and we'll just say http : and I will say localhost : 4004. So this is the same as before all in the auth integration test that we wrote, and we have to add it here because the before all only applies to the test class that is currently in. So even though it says before all, it really means before all the tests in this class. It's worth pointing that out. And it also helps us keep our tests self-contained. So what I mean by that is that we do not want our patient integration test to have a dependency on the auth integration tests or any other tests. One of the other criteria that makes a good test is that it can be set up and run independently of anything else, which makes our test robust. So after our setup method, we'll take a new line, and then we'll say at test, and then we'll take a new line again, and then we'll say public, and then we'll say void, and then we'll say should return patients with valid token. And then we'll open some braces, and then we'll open some curly braces. So as part of the setup for the test that calls the patient service, we need a valid token. Otherwise, our test is going to return a 401 because that's what the service is going to return if the token does not exist in a request or is invalid. So the easiest way to do this is to copy the functionality from the auth service. So if you remember back to when we added the test for the auth service, we actually had a test that created a token. So if we look at should return OK with valid token, it actually returns a valid token from the auth service. And this is the exact same token that we would use to log in. So we've essentially done this step. So all we have to do is copy the code over. We'll go into the project and we'll go into our auth integration test. And we're going to scroll down until we see the should return OK with valid token test. And we're going to copy the payload. And we'll also copy the rest assured stuff down here, all the way down to the bottom of the response. So we'll copy this, and then we'll jump into patient integration test, and we'll just paste it in here, just like this. And under the code that we just copied, we can change this a bit to be more specific to what we need it for. So at the very bottom, we can delete the 3 lines after body, and after the status code line, we'll say dot, and then we'll say extract, and on the next line, we'll say dot, and then we'll say JSON path, and on the next line, we'll say dot get string, and we'll just add in a string here, and then we'll say token, just like this. So we are just extracting the response, and then we are using a JSON path method to pick out the token from the response. And this will change the type up here. So instead of response, it's just going to be a string, and then we'll call this token. Okay, so let's look at what we've done so far. So we've just copied the payload and we copied some logic from the auth integration test to call the login endpoint and return us a token. And this token gets assigned to this variable token up here. And that means we can use it to call the patient service in order to get a list of patients. So if you're wondering about this copy and paste approach between the tests, what you can do is you can create a helper class that lives in a different package in the integration test project that has this code in it. You would then reference that utility class in both the patient integration test and also the auth integration test. That means you don't have to copy and paste between the tests if you don't want to. And it's usually the approach that we would take in enterprise environments when we have a ton of integration test suites to maintain. But for learning purposes and to keep things a bit simpler, we are going to write our tests in this manner so that it's easier to follow. Okay, so now at this point in our test, we have used rest assured to go and get a token. We can then call the patient service using this token. So at the very bottom of the stuff we just added, we'll take a few new lines and then we'll say given, add some braces. And on the next line, say dot, and then we'll say header and open some braces. And then we'll add a string and then we'll say authorization. And just outside of the string, we'll add a comma and then we'll add a string again. And then we'll say bearer, add a space, and then we'll add a space outside of the string, add a plus, and then we'll say token, just like this. So at this point, all we're doing is we're setting up our test and we're passing in the authorization header along with the token in the format that the auth service expects, which is the bearer token format. And on the next line after header, we'll say dot when, and then we'll take a new line and I will say dot get, open our braces, and we'll add a string in here, and I will say slash API, and we'll add slash, and then we'll say patients. And on the next line, we'll say then, and on the next line, we'll say dot then, and on the next line, we'll say dot status code, and we'll say 200, which indicates a success status code. And on the next line, we'll say body, and in here, we'll say patients, add a comma, and then we'll say not null value. And this is it for our test. So the first step is to do the test setup, which we've done up here. So we have gotten a token and we're passing it along with the authorization header. Then we are acting on the thing that we're trying to test, which in this case is the patient service, by doing a get request to API/patients. And once we get a response, we then assert this response by using the then keyword. We check the status code and we assert that the body has a patient's property in it, which has a not null value. And that's it for this test. So as you can see, it didn't take very much code to write a test, which we were previously having to do manually in 2 steps. So what we want to do now is open up our services window. We want to start the auth service DB, and the API gateway. And we also now want to start the patient service DB and start the patient service itself, because after we get a token from the auth service, we're going to then call the patient service, and we want to assert that we get a real list of patients back from our patient service database. So after all these things have started, what you can do is close the services window, and we're going to scroll to the top of our patient integration test project, and we're going to click run on the left, and then we'll click run patient integration test, and this will open up the window, and you can see that we have a test that passed, and there's nothing in the window because we didn't add any log messages, and there's nothing to display. But this test is green, which means all these steps down here have successfully passed, and we have a list of patients. If you really wanted to, you could add a log message in here to display the list of patients in the test output window if you wanted to. So again, just to check that our test is properly working, we will open up the services window and we'll stop the patient service container up here. And this is essentially taking our patient service offline. So now watch what happens when we run this test. So if you go back to the run window on the left, and you can rerun this test just by clicking the little arrow here. And it's going to take a bit longer because it's running in the test and the different services behind the scenes are trying to communicate with the patient service. And it's going to take a few seconds before that try actually times out. And it looks to have about a 30-second timeout here. So after 30 seconds, you'll see that this test expected a 200 status code, but we actually got a 500 response error back, which means something is broke. And if we look at our services window, and if we click on the API gateway, for example, you will actually see an error. So in here, it says the connection timed out after 30 milliseconds, and it tried to reach the patient service. And that's because the patient service is offline. Again, this is why integration tests are very helpful. And if we look at the amount of code it takes to write these things, there isn't that much code involved at all. So what we'll do is we'll just open up the services again. We'll start our patient service, and this time we'll go into the project, and under integration tests, if we right click this, we have an option to run all the tests. So this will run all the tests in our project, and since we've pretended to apply a fix to the patient service, let's run all our tests to make sure that our system is back up and everything is green again. So this will go and run all the tests, and there we go. All our tests are green, and after just under 2 seconds, we have tested that the off service is working, and also our patient service is working as well. And by design, our API gateway is also working as it's directing traffic to the off service and the patient service. So that about wraps it up for this section on testing in this version of the course. Hopefully you can see how helpful having integration tests are and how they can quickly help you catch bugs instead of having to manually remember to go and test each of the different endpoints individually. So at this point, you can jump into the code and try to write some more tests for the patient service, or just have a look back at some of the tests that we wrote and understand what each line is doing. If you're having any problems at this point, have a look at the finished code on GitHub, just to make sure you compare your code to mine and catch any mistakes that could have popped up along the way.
Okay, so far we have been running our containers locally using Docker. This is fine for development. However, in enterprise production environments, we need a solution that is more scalable, secure, and reliable. So this is where AWS or Amazon Web Services comes into play. So AWS is a cloud provider that offers various tools and services to run our microservices in the cloud. However, AWS incurs costs for running these services, which isn't ideal for us when we are trying to learn how production environments work and for developing locally. So even though AWS has free tiers, this is not equivalent to being free. So just keep this in mind, as it can sometimes catch people out when they come to trying to use AWS's free tier, and then they see that there's a few dollars have been charged to their account. So in order to get around this, we're going to use a tool called LocalStack. So LocalStack is a tool that allows us to run simulated AWS environment locally on our development machines using Docker. So this allows us to develop and test AWS-based applications in a safe way without incurring any of the costs that are associated with the real AWS. So even though the LocalStack environment is a simulated environment, the code that we write to deploy our application to LocalStack is going to be fully compatible with the real AWS. So you're still getting the real hands-on experience that translates directly to production enterprise environments that use Amazon Web Services. So before we actually try and deploy our code and our microservices to the simulated AWS environment on LocalStack, there's a few things that we need to learn about how AWS works in order to host containers and run containers and all that stuff. So there are a ton of services and concepts to learn when it comes to AWS, and that would take a whole course in itself. So for this course, we are going to focus on the bare essentials that we need as enterprise developers to create and run containers in the cloud. So the first thing we need is what's called a VPC. So a VPC stands for a virtual private cloud, and this is an AWS provided resource that isolates other resources on a private network and is secured from the outside world. So a VPC also defines how the other services that we are going to use can communicate with each other. So for example, we are going to start a bunch of containers and start up databases and things like that, and we need a way for these things to communicate to each other, and this is what the VPC does. So the VPC essentially creates a network and allows all the other services that we use to communicate with each other securely and protected from the outside world. So the next thing that we need to know about is ECS. So ECS stands for Elastic Container Service, and this is a container orchestration tool that runs and manages Docker containers on AWS. So ECS is the Amazon service that we are going to be working with the most, as this is what starts and runs all of our microservice containers. So if you are familiar with Kubernetes, which is another tool that orchestrates microservices, this is very similar. It's just AWS version of that. So inside ECS then, there's a number of things that we need to understand in order for us to implement ECS correctly. So the first thing that we will need to create is an ECS cluster. So a cluster is a logical group of ECS services and tasks that run within a VPC. So once we've created our VPC, we will create an ECS cluster, and all of our ECS services and tasks will go inside this ECS cluster. So an ECS service then is in charge of managing an ECS task
and also integrates with load balancers. So for each of our microservices, we're going to have an ECS service that manages the ECS task. So an ECS task then is the actual running instance of a container, which is created from a task definition. So for each of our microservice, we are going to have an ECS task, and this task will run the container itself. So the task and the service can be a bit confusing to understand, but the main thing to know is that the service is going to manage the task and the task manages the container. And the last thing we need to know about is the task definition. So this is a blueprint that defines how a container should run, including its image, its CPU, its memory, and any environment variables and any other settings that we need to do. So the best way to think about a task definition is it's the same as the run configurations that we created in IntelliJ, where we defined the container, environment and variables and so on. And this is what is used to create an actual container. So we will see a diagram at the end of this section on how these bits and pieces fit together. So don't worry if it doesn't make too much sense right now, because there's a lot of different pieces to understand. So the next thing that we need to know about is ALBs. So an ALB stands for Application Load Balancer. And this is pretty important because since all of our infrastructure is secured inside a VPC, we need a way for internet traffic, such as requests from the front-end clients to reach our microservices. And this is where the ALBs come in. So ALBs are an AWS service that lets us easily configure a load balancer so that traffic can access our VPC and access any of our ECS services, depending on how we set it up. So the ALB sits on the public subnet, or in other words, it's accessible by the internet, and it forwards requests to the different ECS services. And since our ECS services are inside of a VPC, they are on the private subnet. So a private subnet means that it can only be accessed specifically from the VPC itself. So it cannot be accessed from the internet. So in other words, an ALB provides a secure entry point for all internet traffic, such as our front-end clients. So before we jump into the diagrams of our infrastructure, as a quick reminder, we are going to use AWS Local Stack. So this allows us to run all the things that we have just talked about on our local dev machines without incurring any costs that are associated with those services on AWS. So Local Stack uses Docker. So even though there's a few additional things to set up, it's all going to run very similarly to how we have been running things so far using different Docker containers. So there's a hobby tier that we can use that gives us access to all of the AWS services that we need without having to pay for subscriptions, which is very nice. And it fits in to our current development workflow nicely, as we will be using the same containers that we have been using in development. So we'll see how this all works when we come to the coding bits of the section. And unfortunately, there are some features that are not supported or have limited support. So these tend to be things around the security groups and the IAM roles and things like that. So there are some features that are not supported or have limited support, such as security groups, IAM roles, and cloud discovery and service discovery, due to the limitations of trying to run AWS services on a single machine. But don't worry, this won't affect the course or any of the services we need. It's just something to be aware of if you are experimenting on your own with some of the various AWS services. So just a quick look at LocalStack. As you can see here, we have a whole bunch of different AWS services that we can access and use to develop locally. And if you happen to have access to an AWS account, which you can sign up for yourself, but you will need a credit or debit card, you will see that these are the exact services that exist on the real AWS. So we are going to be using a bunch of these to deploy our stack to AWS Local Stack environment. Okay, so let's look and see how our microservices stack is going to fit into an AWS infrastructure. Okay, so the first thing that we have is we have the virtual private cloud. So this is the dark blue background here, and this is our VPC. So this is going to set up all the networking infrastructure that is needed for the different AWS services to communicate with each other and to make sure that each of these services are individually secure. Over here, we have RDS, which is our database setup. And just below this, we have MSK, which is our Kafka setup. So these are the names of the managed services that AWS provides to give us managed databases and to give us managed Kafka. So what I mean by managed is that AWS handles the maintenance of our databases and our Kafka cluster for us. So this means that we don't have to worry about database backups, dependency upgrades, or any of the infrastructure maintenance, as AWS and MSK will schedule and handle these things automatically for us. So this is nice as it means we don't have to worry about doing those things ourselves, as they can be time consuming and often tedious to perform, especially in enterprise environments. So the downside of these services are that they incur a cost. So since AWS is managing these services for us, they're going to charge us in order to do that. So even though these services are managed under the hood, they are essentially the same things that we have been using on our local development setup using Docker. So for development, we have been using a Postgres database for each of our services, and we also started a local Kafka instance using Docker as well. And this is the exact same thing, only managed by AWS. And over here, we have our ECS cluster. So ECS is the container orchestration service that's going to run and manage all of our Docker containers. And it provides a much more powerful, flexible, and scalable solution for production environments compared to the Docker internal network, which we use locally during development. So inside of our ECS cluster, we have a bunch of ECS services. So the ECS service is responsible for managing the ECS tasks, and the ECS tasks are what actually run the containers. So for example, over here, we have our off service, and this is a container that is started by the ECS task. And outside of the ECS task, we have the ECS service that manages that task. So the task runs the actual container. It defines how much memory, how much CPU, the environment variables, and so on that container needs to run. And this is managed by the service. And the service is going to manage the access to our task or our container, which it can do through a load balancer or through ECS service discovery. The ECS service will also manage the scaling of the tasks. So what I mean by that is that if our off service is receiving a lot of traffic, the ECS service will automatically create a new task that will run another container. So for example, it could start as many containers as we want or as we need, depending on the traffic. And in a similar fashion, the ECS service will also handle if the container fails. So if the ECS task stops because the container has stopped for some reason, then ECS service will see this and it will automatically start up a new container. So this is why we need two different things that ultimately run a container. So we can have as many services as we want inside of an ECS cluster, and each of our microservices is going to have its own ECS service, as we can see here. So we have our off service, we have our billing service, our patient service, our API gateway, and we also have our analytics service down here. And all these things are going to work the exact same way as they do in our local dev environment. So the API gateway is going to receive requests. That's going to check if those requests are valid. And the patient service is going to send Kafka messages to our Kafka instance, which is over here in MSK. And the patient service is also going to send gRPC requests to our billing service. And then down here, our analytics service is going to consume events from our Kafka topic. So the functionality and infrastructure of our patient management setup is going to act the exact same as it will on our local dev environment. The only difference is that we are making it work on AWS using all the AWS services that it provides us. So that's how ECS is going to work. And the last thing we need to look at here is our application load balancer, or our ALB. So as a quick reminder, in our local dev setup, we have set up a API gateway that handles requests from the outside world, and it validates the request and forwards the requests on to the respective microservice based on the rules that we define. So in our AWS setup, we are going to add a application load balancer to our infrastructure that will allow traffic to access the API gateway from the internet. So the reason we need this is because all of our infrastructure is inside a VPC, and this is secure from the internet. So an application load balancer provides a way for our front-end clients to make requests through our VPC. So we can then forward the requests onto any of our ECS services. So in order to keep the functionality the same as we have seen on local dev so far, all our load balancer is going to do is it's going to forward the request to our API gateway. And from there, our API gateway is going to take over and it's going to act as it normally would. So it would authenticate the request and it will forward the request on to the respective service depending on the route. So again, functionally, this is all the same. We're just adding an extra step in front here to provide an entry point to our AWS infrastructure for our front-end clients, and this is done in a secure way that we can completely control. Okay, so that was a bit of a crash course on AWS and some of the most common services that you will see in enterprise production environments, and this is what we are going to build using LocalStack. So hopefully you can see that this setup is very similar to how we run things locally. The only difference is that we have a few extra layers and configurations to take advantage of AWS's powerful container orchestration and infrastructure management. And we are going to build these things out piece by piece. So don't worry if it seems overwhelming at this point. We're going to build it out piece by piece, and we will check that each bit is working individually before we move on to the next bit. And by the end, you'll have a fully fledged AWS infrastructure that's running on your local machine that you can access to manage the patients. So just a quick note on why do we need all this complexity when there are simpler deployment tools that exist. So if you haven't worked in an enterprise environment before, you're probably asking, why do we need this level of complexity when there are simpler deployment tools and services that exist? So for example, there are tools that are great for deploying small full stack apps using a few clicks, but these tools have limitations for complex applications. So AWS gives us full control over the infrastructure, the scaling, and the security of our infrastructure, which makes it better for production environments. So for example, we have full control over ECS, which lets us run the multiple microservices in containers. We can decide how we want to scale those containers, how much memory that we want to allocate to each service and to each task. And we can also define things like recovery and disaster management. It also means that multiple teams can work on different areas without having to overlap. So we might have a DevOps team who manages the infrastructure, and we might have the feature teams who focus on building out patient management features. And each of those teams can handle their own area independently of the other team, and they have full control on how to do that. We also have full control over things like RDS for our databases and Kafka for our real-time messaging. And we can also control the access to our infrastructure using application load balancers and security rules and things like that. So while there are tools out there that let us easily deploy simple code bases, all of the infrastructure is hidden away from you. And if you come up against a scenario where you need specific scalability or where you need specific infrastructure changes, you will likely hit problems with these services. So this is why the largest enterprise companies are using things like AWS, as it gives them full control over their infrastructure. Okay, so now the first thing that we're going to do is we're going to install the LocalStack application onto our development machines so that we can interact with it locally. So if you go to localstack.cloud, you will see the landing page here, and it has some information about how LocalStack works and who uses it and so on. And the most important thing to note is this bit of text here that says develop AWS applications locally, and that LocalStack is a drop-in replacement for AWS in dev and testing environments. So this is why we are using it, as it means we do not need a real AWS account to test and develop locally. So what we're going to do is we're going to click this Get Started button here, and this will bring us to the sign up page. So in order to use LocalStack, we need to sign up for an account and get an API key that will give us access to the pro features. So go ahead and sign up using this form. The next screen, it's going to ask how are you using LocalStack, and what you want to do is click the hobbyist option down here and then click next. And on this screen, go ahead and fill out your details for your first name and last name. You can enter a GitHub username if you want, but it's not required. And we'll scroll down and there will be a box here that says get a hobby license. So what a hobby license is that it's a special plan for those of us who are using LocalStack non-commercially. So since you're following this course and you are not using LocalStack for commercial purposes, what you can do is check this box and accept the terms and agreements down here. And this means you will be able to get all of the pro features of LocalStack for free, which is really cool. So again, this license is only used for non-commercial purposes, so just bear that in mind. And if you scroll down, the last thing we need to do is accept the terms and agreements down here, and then you can click on the sign up button. And the last step is to go to your email and verify the link that you received in your account. After you have verified the link, go ahead and sign in. So
whenever you sign into LocalStack, you will see the dashboard. This is a place where you can see more information about getting started with LocalStack or having a look at your different instances of LocalStack. Feel free to stop and have a look around here if you want. And when you're ready, if you scroll down to the very bottom on the left here in this nav bar, and down here in the bottom set of links, there's going to be an option that says download desktop. So LocalStack also provides a desktop application that we can use to start LocalStack and view the resources that we're using and so on in a nice desktop UI. So this is one of the easiest ways to get started. There's a whole bunch of other ways to get started using the CLI and stuff if you prefer that. So it's up to you, but for this course, we're going to use the desktop UI. So go ahead and click this link, and on the right here, you will see an example of what LocalStack desktop UI looks like. And if we scroll down, you can see we have a bunch of options to install it depending on your operating system. So go ahead and click one of these depending on your operating system and follow the download instructions. After you've installed LocalStack, it should appear on your development machine. So go ahead and open the program. So it'll have an icon that looks like this and will be called LocalStack Desktop. So open this and you will see the desktop UI that looks something like this. So this is where we can start and manage our LocalStack containers. So how it works is that LocalStack is going to use Docker that's installed on our development machines in order to simulate the AWS services. So from our point of view, it looks like we are interacting with AWS, but we were actually interacting with LocalStack, and behind the scenes, it's using a bunch of different containers to run the different AWS services. So we'll see what this looks like whenever we come to creating our own stack. So the first thing we need to do now is we need to start a container. So go ahead and start Docker. So just open Docker Desktop and this will start up the Docker context. So once it's started, you can just minimize this. And what we're going to do now is click on the Launch New LocalStack Container button here. And in here, there's a form that we need to complete to specify some settings for our LocalStack container. So we will give it a name and we'll just call this LocalStack, but this can be whatever you want really. We'll scroll down and the next option that we're going to see is the image. So we can ignore this because we are going to add an auth token and this will automatically download the LocalStack image for us. So depending on if we're on the free version or the pro version of LocalStack, then there's a different image to use. But the LocalStack UI will figure this out for us depending on the API key that we provide. So we'll scroll down until we see the environments variables here. And then you'll see that the first one that's been pre-filled for us is the LocalStack auth token. So this is just to authenticate us against our LocalStack account to prove that we are a pro LocalStack user. So to get the auth token, what we're going to do is jump back to the browser and we'll go back to the dashboard for LocalStack. And on the left-hand nav, we're going to go down to auth tokens down here and we'll just select this. And in here, there will be a auth token that has been generated for us. And this is what we use to activate LocalStack as a pro license. So go ahead and copy this and jump back to the LocalStack desktop. And what you want to do is paste the value in here. So this value should be treated like a password. So make sure not to share it with anyone, as it means that people will be able to get access to your LocalStack account and start instances under your account and so on. And that's not what you want. So just keep that in mind. And after we've done this, we can scroll down and then you'll see some more of the default settings that LocalStack provides, like opening ports and doing some mounts and so on. So when you're happy, go ahead and click Create on the bottom right down here. And this will begin to start a LocalStack container. So if we jump back to Docker Desktop, we can actually see this happening. So this will take a minute to complete, but when it does, you will see that you are brought back to your LocalStack dashboard on the desktop app. You'll see now that we have a container that's running. So once your container started, the last thing we need to do is log in from the LocalStack desktop application itself so that we can get access to the full functionality of the desktop app too. So down here, there's a little sign in button and all we have to do is click sign in, and then this will open up a web browser that will ask for a code. So if you jump back to LocalStack desktop, you will see there's a code appear on your screen. So go ahead and copy this and then just paste this in to the code button here and then click confirm. And this will log us in to the desktop app, and that is our LocalStack setup ready to go. Okay, so now that we have LocalStack running, what we're going to do is install the AWS CLI. So this is the easiest way to interact with any AWS instance, and it also works the exact same with local stack. So a CLI is just a command line interface, and it allows us to run different terminal commands to do different things on our AWS instance, and this works the exact same way as it does with a real AWS instance as it does with local stack. So if you go to docs.aws.amazon.com, and you will see this documentation page for Amazon. And if you select developer tools at the top, and what you want to do is choose command line interface option from the dropdown. Here, it's going to bring you to the AWS command line interface docs. And from here, what you want to do is choose get started on the left, and underneath this, we will choose install/update link. And we scroll down on the main page here. You can see that there's a few different ways to install this depending on your operating system. So go ahead and install this depending on your operating system, following the instructions. Okay, so once you've installed it, what we're going to do is make sure that it's working. So what you can do is open up IntelliJ, and on the left, you will see an option for terminal. So go ahead and click this, and this will open up a terminal in your IntelliJ IDE. So this is nice as it keeps all of our focus in our IDE. It's easy to find things and run the AWS CLI commands, especially as we're building out our infrastructure as code in Java. So this terminal that I have open is called git bash. So I don't think it's going to matter too much which terminal that you use, because most of the commands that we will run in the remainder of the course are going to be the AWS CLI commands. So the terminal that I'm using here is called git bash. So this is a client that lets me run Linux-like commands on Windows. So this means if you're following along on Mac OS, that the commands should be the same. If you are on Windows, I highly recommend that you go and download this one by searching for git bash on Google and just following the download steps, as it makes it easier to follow along with the course. And if you're on Mac OS, the commands that we write here should work the exact same on your operating system, regardless of the terminal that you're using. Okay, so once you have the terminal open that you are happy to work with, go ahead and type AWS space -- and then say version. And if you installed the AWS CLI correctly, you will see an output that looks like this. So at the time of recording, we are on version 2.24.0. So I do recommend that we use AWS version CLI version 2 for this course. Okay, so now that we have the AWS CLI running, to configure it so that all the commands that we write are directed to the local stack instance. So to do this, we say AWS space, and then we say configure, and then hit enter. This will start a little wizard thing in the terminal. So the first thing that we need to add is the AWS access key. So local stack doesn't actually verify these things, but they need to exist. Otherwise, the CLI isn't going to work. So we'll just say test and then hit enter. And then for the access key, we'll say test again. And then for the region name, we'll say US-East-1. So for local stack, the region doesn't matter because we are working off our local machine. But again, the AWS CLI is going to expect it to be there. And go ahead and hit enter. And for the default output format, we're just going to say JSON. So what this does is anytime we make some CLI commands, such as to show us the state of our AWS cluster, then it's going to return the result of that command in JSON output. And go ahead and hit enter, and that should be it. So now we have configured the AWS CLI to work with local stack. We can test to see if this is working. So you can say AWS --endpoint--URL is equal to http:// and I will say localhost: 4566, and then we'll say lambda space, and then we'll say list-functions, and go ahead and hit enter. And as you can see, this returns an empty array with a key of functions, and it's inside a JSON object. So let's talk about this command a bit more. So the AWS at the start means that we are using the AWS CLI that we just installed from the Amazon website, and then we're specifying the endpoint URL. So this is important as this tells us where we want to send the CLI command to. So because we specified localhost: 4566, this is the address that local stack is running on. So we're saying that we want to list all the Lambda functions from the local stack instance and then display the result. So if we had a real AWS instance, then this endpoint URL would be different, as we would be sending this command to our real AWS. Okay, so now that our local stack is running, we have the AWS CLI set up, we have everything we need to start creating our infrastructure. Okay, so now that we have local stack set up, the next step that we're going to do is we're going to start building out the AWS infrastructure that we need to host our application in local stack.
So to do this, we're going to use a technique that is called IAC, or infrastructure as code. So what this means is that we write our infrastructure in Java code, which can be then put in source control, just like we do with our application code. So by this, what I mean is we're going to use Java code to create the different things we need, such as our VPC, our ECS cluster, and all the ECS services, as well as our database and our Kafka infrastructure using code. So one of the biggest benefits here is that it means our environments can be created and destroyed easily and consistently. So for example, in enterprise companies, we would have a whole bunch of different environments, such as a testing environment, a user acceptance testing environment, as well as a production environment. And it's important that all these environments are consistent, which we can easily do since the infrastructure is stored as code, and we just need to run a few AWS commands in order to create and destroy different environments. So we'll see what this looks like in the next section as we start building out our infrastructure as code application. So we can build out our infrastructure using the AWS UI or the local stack UI, but it's much easier to follow and debug problems from a learning perspective if we write it as code, because you're able to reference the GitHub repository for examples and so on. Okay, so to show at a higher level at how this actually works, let's have a look at this small diagram. So on the left, we are going to write our infrastructure using Java code. Once we have all the different bits and pieces of our infrastructure defined, we are going to generate what's called a CloudFormation template. So CloudFormation is an AWS service that lets us define and provide our infrastructure as a single configuration file. So this file is going to contain all the services and things that our infrastructure needs in a single JSON or a YAML template file. So once we have this CloudFormation template that describes our infrastructure, depending on our environment, we can then use this CloudFormation template to deploy a new environment. So for example, if we are using local stack, we can use this CloudFormation template to start up a new environment based on the infrastructure that we have defined. And we can use the exact same CloudFormation template to create a new environment on the real AWS, and this will work in the exact same way. So it doesn't matter if we are using local stack or the real AWS, provided we create a CloudFormation template that has all of our infrastructure defined in it, then it's going to work the exact same. So now that we have a bit of an idea on how infrastructure as code is going to work, we can jump into IntelliJ and start creating our infrastructure in Java. So now we're going to start creating our infrastructure for our microservices setup. So as mentioned in the previous section, we're going to use infrastructure as code to do this. And this is going to go in a separate project. So to keep everything nice and organized, we're going to put our infrastructure code underneath the patient management folder in the project that we have been working in so far. So it's going to go in the same place as all the rest of our stuff. And this just helps us keep everything nice and organized. So let's right click on patient management, and then we'll go to new, and then we'll go to module. And this is going to be a new Java module. And we're going to call this project infrastructure. And just make sure that the location is under patient management and that the build system is Maven. For the JDK, we will choose Java version 21, and that should be it. So go ahead and click create, and this will add our project to the project tree over here, and it will open up our POM XML file. So in here, we're going to add a few dependencies that we need in order to write infrastructure as code. So, and on the right, you will see our POM XML. So there are a number of dependencies that we need to add to make it a lot easier to build out our infrastructure in Java code. So there's two things we need. There is the AWS Cloud Development Kit that lets us create CloudFormation templates that we need to deploy our infrastructure onto AWS and to local stack. And we also need the AWS Java Software Development Kit that lets us interact with our infrastructure using Java code. So in our pom.xml, we will add these dependencies. So just underneath the closing properties tab down here, we'll take a few new lines. We'll add an angle brace, and then we'll add in our dependencies. So add the dependencies tag, and inside the dependencies tag, we'll add a dependency tag for a singular dependency. And the group ID is going to be software.amazon.aws.cdk. And inside of the artifact ID, we'll say aws-cdk-lib, just like this. On the next line, we'll add an angle brace, and then we'll just add our version. And the version that we're going to use is 2.178.1. So at time of recording, this is the latest version. If you do opt to use the most latest version, if you're following this course in the future, then just bear in mind that there could be some compatibility issues. And the next dependency we need is for the Java software development kit. We'll add a new dependency tag in here, and the group ID is going to be com.amazon AWS, and the artifact ID is going to be AWS Java SDK. And on the next line, we'll add the version, and we will use 1.12.708. So again, at point of recording, this is the most recent version that works with version 2. If you are using the latest version in the future, just bear in mind that the SDK version that you use has to be compatible with the CDK version that you are using up here. At this point, you might have a few errors here. So just open up the project and go into the infrastructure project, right click on pom.xml and scroll to the bottom and choose the reload project option from the Maven tab. And this will update the dependencies of your project. Okay, so now we have our dependencies in place. We can start creating our actual infrastructure. So in the project window, we are going to go into the infrastructure project over here, and we're going to go into the source folder, and we're going to go into main. And in Java, we're going to add a new package. So we'll right click, go up to new, and then we'll go to package, and then we'll just call this pom.pm.stack. So what a stack is it's essentially all the components that make up our infrastructure. So it's essentially another word for infrastructure, and it's a term that AWS use quite often in CloudFormation and things like that. So we're just using the same terminology. So go ahead and hit enter, and then this will add the package. And what we're going to do is right click on this package. So right click and go up to new, and then we're going to add a Java class, and we're going to call this local stack. This is where we will put all of the infrastructure for our local stack. So go ahead and hit enter here, and this will add a class to the window on the right. And the first thing we're going to do up here is we are going to extend the Amazon CDK stack class. So we'll say extends, and then we'll say stack, and we're going to import this from software.amazon.ws.cdk, just like this. Inside this class, we are going to create a constructor. So there are some things that we have to pass to the parent stack class that we're extending from, and this must come from the constructor of our local stack class. So say public, and we'll say local stack, and then we'll add some braces, and then we'll say final app, and we'll call this scope. We'll add a comma, and then we'll say final string ID, and then we'll say a comma again, and then we'll say final stack props, and then we'll just call this props, and go ahead and add all the imports from Amazon AWS CDK package. So this is what your import should look like after we have defined our constructor, and then we'll just add some braces in here. Inside of this constructor, we are going to call the stack constructor by using the super keyword. We'll say super, and then we'll just pass in the scope, the ID, and the props, just like this. So this is just the boilerplate code that we need to create a new stack. And all we're doing is we're passing in the scope of our app. So I'll explain more about what this does shortly. The ID, this is going to be the identifier for the stack that we're about to create. And then stack props is any additional properties that we want to define ourselves. So outside of our constructor, we are going to add the main class. So we'll say public static void, and then we'll say main, and then we'll say final string array, and we'll call this args, and we'll open and close our braces. So just like any Java app, this is the entry point for the code that is going to create our CloudFormation template for our infrastructure. So in here, we can create a new AWS CDK app. So we'll say app, and then we'll say app in lowercase, and this is going to be equal to a new app. And then we'll open some braces, and then we'll say app props, then we'll say dot builder, and then we'll open some braces, and outside of the closing brace, we'll say dot, and then we'll say out, dir, and then we'll add a string, and then we'll say dot slash, and then we'll say cdk.out, and then we'll say dot build. So all we're doing here is we're creating a new AWS CDK app, and we are defining where we want the output to be. So whenever our stack is created, it's going to create a CloudFormation template, and this template is going to go into the cdk.out folder. So the next thing we need to do is we need to define our stack props. So we'll say stack props, and then we'll say props is equal to stack props, and then we'll say dot builder, and then we'll say dot, and then we'll say synthesizer, and then we'll say new bootstrapless synthesizer, and open and close some braces. And at the very end, we'll say dot build. So what this does is we're just defining some additional properties that we want to apply to our stack. So all we're specifying here is the synthesizer. So the synthesizer is an AWS term that is used to convert our code into a CloudFormation template. And all we're doing here is we're passing in the type of synthesizer that we want to use. So we are using what's called a bootstrapless synthesizer. So I'll explain a bit about what a synthesizer actually is. So a synthesizer is an AWS term that is used to convert our Java code that defines our infrastructure into an actual CloudFormation template. And what a bootstrapless synthesizer is that we're telling the CDK code to skip the initial bootstrapping of the CDK environment, as we do not need it for local stack. And after we've created our props and our actual CDK app, the last step that we need to do is link our local stack class to this app so that CDK knows to build our stack anytime we run this Java app. So on the next line, we'll say new, and I will say local stack, open our braces, and then we'll pass in the app, which is essentially the scope as we've defined it up here. So the scope of our local stack app is this app down here, and we'll add a comma, and then we'll say string, and then we'll call this local stack, which is the ID of our stack, and then we'll comma again, and then we'll pass in our props. And the props again just comes from up here where we've defined our bootstrapless synthesizer. And after we have linked a new CDK app instance to our stack, all we have to do now is say app.synth. So app.synth is going to tell the CDK app that we created up here that we want to take our stack, add any props, convert that stack to a CloudFormation template, and put everything into the cdk.out folder. And we'll just add a log message at the bottom here so that we can see when stuff is happening. So we'll say system.out, and then we'll say print ln for new line, and then we'll add a string, and I will say app synthesizing in progress. So by default, the Amazon CDK doesn't print out too many logs, so we'll add our own just to see that things are actually happening. So even though we haven't added anything to our stack up here, we have added the initialization code that we need that actually starts the process. So what we can do now is create a run configuration for our stack, run the code, and we should see some stuff appear in this cdk.out folder. So we'll go to the top and we'll go to edit configurations. And if you don't have a configuration for local stack, what you can do is on the left under application, just choose add new configuration, and for the name, add local stack. It's going to run on our local machine. And for the build and run options, you want to choose Java and choose the infrastructure project. And the main class is going to be com.pa.stack.localstack. And for the working directory, we're going to choose the infrastructure folder in our patient management project. Down here, just make sure that you have the shortened command line option in here like this so that it runs correctly for our Java version. So go ahead and hit apply on this and go ahead and click run, and you should see that the window opens and it'll say app synthesizing in progress, and then it'll say process finished with exit code 0. So this is good as it means there's no errors. And if we close this down and open up the project window, and then if we go to infrastructure, you should hopefully see on the left now have the CDK out folder. And if we open this up, you can see that we've got a whole bunch of JSON that was generated by the AWS CDK package. And the most important one to look for is this local stack.template.json file, as this is our CloudFormation template that has all our infrastructure in it. So if we look at this, there's nothing here because we haven't defined any infrastructure yet. But as we build out the different components of our infrastructure, it will appear here as a CloudFormation code. So at this point, we have essentially set up a infrastructure as code project that creates CloudFormation templates, and we are in a good place to start adding different components to our infrastructure. If you're not seeing this folder, make sure that you have the correct dependencies in place, and also make sure that you've added the run configuration to the top. And you can also have a look at the finished code on GitHub to compare the main class to mine. Okay, so now that we have our infrastructure project in place and we have it set up so that we can generate CloudFormation templates based on our code, we can start to actually add the individual bits that we need that makes up our AWS infrastructure. So the way we're going to approach this is that we are going to create the VPC first. So again, the VPC is top level AWS component where all of our infrastructure is going to live. And the VPC also sets up the networking that is needed for all our different services and resources to communicate with each other. So this in mind, we will jump back into the code and we are going to go into our infrastructure project and we're going to go into source, into main, and then we will go into our local stack class. And this is where we will add all the code for our stack. So far we have synthesized a stack based on the things we add up here. So there's nothing in here yet, but the first thing we will do is create our VPC. So just above the constructor, we're going to take a new line and then we're going to say private final, and then we'll say VPC, and then we'll say VPC again. So we can import this from the AWS CDK package, and we're just going to call this variable VPC. So we need a class level variable because when it comes time to create the other parts of our infrastructure, we need to link those bits of infrastructure to our VPC, which we will do by using this variable. So we'll see how that works in the next sections. But for now, we want to actually create a VPC and initialize this variable with it. So just below the super keyword down here, we're going to say this.vpc is equal to create VPC, and then we'll add some braces. So there's going to be an error that says cannot resolve this method, and that's because we haven't created it yet. So we're still going to follow the coding best practices for creating our infrastructure, and that includes creating reusable methods. So just below the constructor, but above the main class, we're going to take a new line and we're going to say private VPC, and then we're going to say create VPC. Open our braces, and then we'll open some curly braces as well. And here is where we're going to put the logic to actually create a VPC. So we'll say VPC.builder, then we'll say .create, and then we'll open some braces. And this is going to take two arguments. It's going to take the scope and it's going to take an ID. So the scope is essentially the stack that we are currently in. So we can just say this. So in this case, this keyword is going to reference the local stack class, and this extends stack. So all we're doing is we're saying that this stack is the scope for this VPC, and we'll add a comma, add a string, and we will call this patient management VPC. So this is just a unique identifier that helps us and also helps the CloudFormation templates keep track of the different components. And just outside the last brace, we'll say dot, and then we'll say VPC name, and then we'll add a string, and then we'll just give this a name as the same as the ID, which we've called patient management VPC. So when we come to see our infrastructure in local stack, we will be able to easily identify the different components by their name. So on the next line, we'll say dot max, and then we'll say AZs, and then we'll say 2. So what this is that it stands for the max availability zones. So when we work with AWS, we can specify where in the world we want our infrastructure to be distributed to. So for example, by saying 2 availability zones, this means that this VPC is going to be available in 2 different zones throughout the world. So this is good for reliability and so on. And on the next line, we'll just say .build, and that's it. So the last thing to do is just return this. So up here, we'll say return, and that's essentially it to create a VPC. So when we call this method, the AWS CDK is going to take this code, it's going to take our properties, and it's going to convert it into CloudFormation code. This function gets called up here because we have added it to the constructor. Whenever this class runs, the constructor is going to run by default. It's going to do the setup that it needs to do to create a stack, and then it's going to create a VPC, and this VPC is going to get added to this stack as part of the build step. So we can see this working now. If we go to the local stack run configuration that we added in the previous section, and if you just click run, you will see in the output window that appears that it says app synthesizing in progress, and it finished with exit code 0, which means it was successful. And then if we have a look at the project, and if we go to the cdk.out folder in the infrastructure folder, and if we go into our local stack template.json, you can see we actually have some stuff in here now. And if you scroll down, there's quite a bit of different things that were added. And this is everything that's related to creating a VPC on AWS. So if we look at the very top, we can see that it's added the name that we wanted to add, so patient management VPC. If we keep scrolling down, you can see that it's created the subnets, it's created the root tables, and it's created a whole bunch of different IP addresses for each of these different things, and so on. So this is very low level configuration, as you can probably tell by looking at it. This is one of the benefits of using CDK, as it saves us having to go in and create all this ourselves. So you don't have to know what all of these different properties are, as it's pretty substantial and it's more at the DevOps level. But it is good to know and understand that this is why we use AWS as well, because it gives us such fine-grained level of control. So we can control everything from the different IPs, the DNS, the route tables, the NAT gateways, the public subnets, private subnets, and so on. So in enterprise environments, this is pretty important, as we could hit a bunch of different scenarios and use cases where we have to fine tune all of these properties. But again, for this course, you don't really need to know what all these things are doing at such a low level. All you need to understand is that we have used AWS CDK to create a VPC, and the VPC creates the routing and the networks that are needed for our internal services to work and communicate with each other. Okay, so now we have our first taste of how we can create our infrastructure using AWS CDK in Java code. And we have created our first VPC and also seen how this gets turned into a CloudFormation template. So the next thing we're going to do, now that we have a VPC, is we're going to create the two databases that we need for our auth service and our patient service. So again, for this, we are going to use AWS RDS, which is databases as a service that's provided by Amazon. And we are going to create two Postgres databases. So again, even though we are calling this RDS, under the hood, all it is the same Postgres database that we have been working with so far in the course in our development environments using Docker containers. So we will jump back into the code, and the first thing we will do is we will create the method that we can reuse to create the different databases that we need. So just below the VPC method, we'll take a new line and then we'll say private database instance, and then we'll call this create database, and this is going to accept some arguments. So we'll say string ID, add a comma, and then we'll say string, and then we'll say DB name. And then we'll open and close some braces just like this. And we have to import the database instance from Amazon CDK RDS package. So go ahead and import this. And this is the construct or the class that will create an RDS database. So inside of this method, we'll say return, and then we can start to build up the properties that we want to specify for our new database instance. So we'll say database instance, and then we'll say .builder, and then we'll say .create, and then we'll say this, and then we'll say ID. So again, this keyword applies to the current class or stack that we are currently in and assigns that to the scope of our database instance. So on the next line, we'll say .engine, and in here we'll say database instance engine like this, and then we'll say .postgres because we want a Postgres database, and then inside of the properties we'll say Postgres instance engine props, then we'll say .builder, and then we'll take a new line and then we'll say dot, and then we'll say version, and inside the braces we'll say Postgres engine version, and then we'll say dot, and then we'll say BER _ 17 _ 2. So already here specifying the version of the engine, and just outside of the first brace here in our pile of braces at the end, we'll say dot, and then we'll say build. At the very end, we'll say dot build just to get rid of some of these errors, and we'll format our code just so it looks a bit nicer and easier to follow. So your code should look like this so far. So all we've done is we have started to build up our database instance, and we've specified an ID, and we've also specified the engine to use. So we used a database engine builder to specify that we want a Postgres database, and then we've just added this to the .engine prop. So this is going to be a similar sort of pattern when working with AWS CDK. We tend to use the builder pattern a lot to create the different things as well as the props to provide that thing. So it can be a bit tricky at first, but once you get a hang of the builder pattern, then it will come a bit easier, especially as we build out some more of these things. So we have our basic builder in place for the database instance, but we need to specify a few more properties before we continue on. So just above the closing build method call here, we're going to take a new line, and then we'll say .vpc, and then we're going to pass in VPC. So you'll notice that this has turned purple, and that is because it's referencing the VPC from the class level variable up here. So this is why we made the VPC a class level variable, so that we can access it in all of our private functions without having to pass too many arguments to things. And if we look in our database instance, this is all we have to do to connect our database to our VPC. So in terms of the code, it's quite straightforward. and AWS CDK will do all of the crazy networking stuff behind the scenes to create a CloudFormation template that allows our database to be connected to this VPC. So the next thing we need to do is we need to specify an instance type. So what an instance type is that it's essentially a combination of the CPU, the compute power, the storage, and so on that we want this database to run on. So in here, we'll say instance type, and then we'll say of, and then we'll say instance class, and then we'll say burstable to, and then we'll add a comma, and then we'll say instance size, and then we'll say .micro. So for local stack, this doesn't matter too much because local stack is running on our local machine. So it depends on that. But whenever we deploy this to AWS, we can specify that we want to have this database to be running on different compute levels depending on what we need this database to do. So for example, if we're storing a large amount of data, we can say instance size dot extra large or extra large 2, 3, 4, and so on. And we can also change the instance class to be that of a higher specification. So this allows us to configure the different compute power that we need for this database depending on our use case. So we'll just leave these as some defaults for now because local stack doesn't really care about that. And then again, and on the next line, we can say allocated storage. And then we'll just say 20. And this is the amount of storage that we want to allocate to this database. And on the next line, we can specify our credentials. So the credentials are going to be used to connect to the database from whatever Spring Boot application needs to connect to it. So we'll say credentials dot from generated secret, and then we'll say string inside of the braces, and we're going to pass in the username. So we'll say admin underscore user. So what this does is that it's going to take the username that we specify, and it's going to generate a secret from this username, and it's going to automatically apply it to the database. And then the next thing we want to do is specify the database name. So say .database, and then we'll just pass in the DB name. So we are taking this from the arguments up here because depending on the service that needs a database, then we're going to specify a different name. But the remainder of the settings are going to be the same for all of our databases. The only thing that changes is going to be the name. And then on the next line, we're going to say removal policy, and then we'll say removal policy.destroy. So what this means is every time we destroy the stack, which we will see in the next parts of the course, we also want to remove the database storage. So this is good for development purposes, really, as it means every time you destroy the stack, you're destroying the data as well, so that the next time you start up a stack, you will have fresh data to work with and there's no bad leftover data from the previous stack. You typically wouldn't do this in production unless you specify a backup policy as well. So there's a ton of different things we can add to this depending on the use case that we need, but for our purposes, this is plenty. So we have created a database and we have assigned it to the VPC. Now all that's left to do is to call this method from our stack constructor. So we'll scroll to the top, and just after we created the VPC, we'll say database instance, then we'll say auth service db is equal to, and then we'll say create database, and then we'll pass in an ID and we'll just call it auth service db, and then we'll add a comma after this, and then we'll say auth dash service dash db, just like this. And we can take a new line and then we can say database instance, and then we'll say patient service db, and this is going to be equal to the exact same. So we'll say create database, and then we'll do patient service db, add a comma, and then we'll call this patient service db. And that's it. So now we've created two databases, one for each of our different microservices. And the way this is going to work is that the constructor is going to run, it will create the VPC, and then it will go and create these two databases. So we can see this in the CloudFormation template. So to generate a new CloudFormation template based on the fact that we have two databases, all we have to do is click run up here and it will generate it for us. So after you see exit code 0, if you jump into the project and if you go down to the local stack template.json, and if you scroll to the very bottom, you should see a whole bunch of stuff that is related to RDS. So you can see that it's created the patient service DB, and it's used the T2 and it's used the db.t2.micro class as the compute power to run on. And it's also set up the storage. And down here, you can see the database engine is what we specified. And you'll also see that it's done some clever stuff to securely save our password using AWS Secrets Manager. So Secrets Manager is a service provided by AWS, and I think it will be up here somewhere. Yeah, so up here, you can see that it's created this off service DB secret attachment, and it's of type secret manager. and it references the off service DB. So this all looks good. Whenever we come to actually deploy our stack to local stack later in the course, we will see how all this works together. Okay, so now that we have the code that will create the databases in our CloudFormation template, the next thing that we will do is we will create a health check for each of our databases. So what a health check is that it's a way for other services to know when the database is running and ready to accept connections, but also it will tell other services if the databases are in a bad state. So we are going to take the same approach here and create a method that will handle the database health checks. So we'll scroll down, and just below the database method that we created in the previous section, we will add a new method, and we'll say private, and then we'll say CFN, and then we'll say health check, and we'll call this create DB health check, and we'll add a database instance as an argument, and then we'll add a comma, and then we'll add an ID as a string as a second argument. So in here, we'll say return, and then we'll say CFN health check dot, and then we'll say builder, and then we'll say dot create, and we'll pass in the scope, which is going to be the current stack. So we'll just say this, add a comma, and we'll say ID, and then at the end we'll just say dot build to get rid of the error, and we will format our code so it's a bit easier to see. So this is going to create a health check construct or class that will give us the health status of the database that we pass into the method. So just above the build method, we'll take a new line, and then we'll say dot, and then we'll say health check config, and inside the braces we'll say CFN, and then we'll say health check, and then we'll say dot, and then we'll say health check config property, and dot builder, and then we'll say dot build, just like this. So in here we are going to use the builder pattern again to define all the properties that we need to pass to our actual health check. So just after the builder over here, we're going to take a new line just like this, and above this we'll take a new line again. And the first thing we'll do is we'll specify the type of the health check. So this is going to be string, and then we'll say TCP, which is essentially which says that we want to use a TCP endpoint to check if our database is online. Then we'll say port, open some braces, and then we'll say token dot as number, and then we'll say db dot get db instance endpoint port. So this is going to get the port that our database is running on, and it's going to convert this string to a number, and then this gets passed to port that our health check is going to check in its request. And on the next line we'll say IP address, and in here we'll say db dot get db instance endpoint address, and again this is very similar to the port. We are just telling the health check what address to look for, and because we are using the methods on the DB instance object, we don't have to configure these things manually, as AWS CDK will automatically resolve all these things for us, which is nice. So on the next line we'll do dot request interval, open some braces, and then we'll say 30. So this just says check the health endpoint every 30 seconds, and then we'll say dot failure threshold, and then we'll just say 3. So this just means that this health check will try 3 times, and it will try once every 30 seconds before it reports a failure. So this just gives our database a chance to actually start up in case there's delays that take a bit longer than 30 seconds. But if it takes too long, then we do want to report back a failure. And that's it. So now we've configured our health check. We can call this health check from our constructor. So if we scroll to the top, and after the databases that we created, we'll take a new line, and then we'll say CFN health check, and then we'll say auth DB health check is equal to create DB health check, and then we'll pass in our off service DB, and then we'll pass in an ID, and we'll just call this off service DB health check, just like this. And then we can do the same for the patient service DB. We'll say CFN health check, and we'll say patient DB health check is equal to, and then we'll say create DB health check, and then we'll pass in the patient service DB as a first argument, and then we'll just give an ID as patient service DB health check as a second argument. And that's it for our health check. So now we can pass these health checks to any dependent services, and we can configure it so that the health check must pass before the service starts up. So we'll see how these health checks are actually used in the later sections. But for now, we'll just run the app to make sure that our CloudFormation template gets updated correctly and there's no errors. So at the very top, just click Run Local Stack, and this will regenerate a new CloudFormation template in the cdk.out folder. So feel free to have a look in here now if you want, just to check that things are appearing. and all the new stuff that we add will get added to the bottom. So as you can see here, it has added different health checks for our two databases. Okay, so at this point, we now have a CloudFormation template and infrastructure setup that will create a VPC, and it will create two RDS databases that our services will use, including health checks. So the next piece we are going to set up is we're going to set up our Kafka brokers. So just like before, we are going to use Amazon AWS's MSK managed Kafka service. This just means that we don't have to do too much of the low-level maintenance of a Kafka broker in terms of backups and upgrades and things like that, as it will be managed by AWS for us. But under the hood, it's the same old Kafka instance that we use during development in our Docker containers. So with this in mind, we will jump into the code and we will go into our local stack. We will create the method that will create an MSK Kafka cluster for us. So scroll to the bottom or towards the bottom, and just after we added the method for create a database health check, we will create the method to create an MSK cluster. So we'll say CFN, and then we'll say cluster. So we'll say private CFN, and then we'll say cluster, and then we'll call this create MSK cluster. And then we'll add some braces, and then we'll add some curly braces to complete our method. And then we will import the CFN cluster construct. So just click on this and then choose import class. And there's going to be a ton of options here, but the one we want to choose is the one that is .msk at the very end, as this is a Kafka cluster. So go ahead and import this. Inside of our method, we'll say return, and then we'll say CFN cluster, and we'll say .builder, and then we'll do .create. We'll pass in our scope, and then we'll pass in our ID, and then we'll just call this MSK cluster. And on the next line, we will say dot, and then we'll say cluster name, and then we'll just pass in a string, and I will say Kafka-cluster. This just gives our cluster a name so that we're able to easily identify it in local stack when we come to deploy everything. And on the next line, we'll say Kafka version, and then we'll pass a string in as well, and then we'll say 2.8.0. So at time of recording, this has the best support for local stack. So it's the one I recommend to use as part of this course. And on the next line, we'll say number of broker nodes. And in this case, we're just going to say 1. So as part of a Kafka cluster, Kafka, or the MSK managed Kafka, can create a bunch of broker nodes to control all the different topics and handle the events and so on. And this allows us to create a high availability Kafka instance, as if any of the broker nodes go down, there are going to be a number of different broker nodes to take over control. So we can have any number of broker nodes in here, but since we're using local stack, it only has support for 1, so we'll just keep this as 1. But on a production environment, in enterprise companies, you would typically have a higher number of broker nodes for resiliency reasons. So on the next line, we'll say .broker node group info, and in here, we'll say CFN cluster, and I'll say .broker node group info property, and then we'll say .builder, and on the next line, we'll say instance type, and we'll add a string in here. So again, all we're doing is specifying the compute power and things that this Kafka cluster is going to use. So we'll just say Kafka.m5.extra large. So again, for local stack, this doesn't matter too much, but for AWS production environments, this specifies the size of the machine to run on, and higher values tend to have higher compute power, but also cost a lot more. And just after the brace here, we will take a new line, and then we'll say dot, and then we'll say client subnets. And in here, we'll say VPC.get private subnets, and then we'll say .stream, and then we'll open some braces, and then we'll say .map. And in here, we'll say I subnet, add a double colon, and then we'll say get subnet ID, just like this. And outside of the first brace over here, we're going to say dot, and then we'll say collect, open some braces, and then we'll say collectors.toList. So this is how we connect our Kafka cluster to our VPC. So what we're doing here is we're getting all of the private subnets from the VPC as a list. So this is all this is doing. And then it's going to pass that list to the client subnets argument of our broker node group info. So that might seem a bit complicated, but because we can have a number of broker nodes, we have to make sure that each of those nodes is able to access all of the other nodes on the VPC. So this just connects our VPC to all of our broker nodes using the private subnet on the VPC. Okay, so at the very end of the code we just added, we have this closing brace. So what we're going to do is just before this closing brace, we're going to take a new line, and then we'll say dot, and then we'll say broker AZ distribution, and then we're going to pass in a string here, and then we're going to say default. So what this does is that we want to specify how our brokers get distributed across our different availability zones. So remember, our VPC has 2 availability zones. So we can specify in here what brokers belong to what availability zones. So for example, if we have 4 Kafka broker nodes, what we can do is specify that 2 of those nodes will go in the first VPC availability zone, and the last 2 will go in the second VPC availability zone. But since local stack doesn't care too much about how this works, we're just going to pass in default, and then we will let the CDK handle how to do the distribution. And just before the last closing brace down in here, we are going to complete the builder for the Kafka broker node group info. So we'll just say dot, and I will say build. And outside the last brace, we will complete the actual builder for the cluster. We'll say dot build, and your code should now look like this. Okay, so some complicated stuff in here, so don't matter too much about some of the intricate details here. All you really need to know is that we are creating a Kafka cluster using MSK. That is the managed Kafka service. We are specifying the number of brokers that we want to add to our cluster. We are specifying that we want all of our brokers to be available on the VPC that we created earlier. And then we're just specifying a distribution for the number of brokers against the number of availability zones that we have in our VPC. Okay, so now that we have this, the last thing that we have to do is call this method. So we'll scroll up to the top, and we can go to the bottom of our list of infrastructure pieces. So the last one that we created was a health check for the patient DB, and we'll just take a new line, and then we'll say CFN cluster, and we'll call it MSK cluster is equal to create MSK cluster, just like this. So even though we're not using this variable at the minute, it will come in handy later, as we'll see in the later parts of the course. So now if we hit run at the top here, this will create our new CDK CloudFormation template. If you want, you can have a look at this in the template.json file, just to make sure that the MSK cluster is added to the bottom. And as you can see here, it is, and it's got all the settings that we have specified. So it's got the instance type, and it's got the number of brokers, and so on. Okay, so at this point, we now have a CloudFormation template that has a VPC and RDS database, as well as the health checks for off-service DB, patient service DB, and we also have a MSK Kafka cluster. So we pretty much have all the infrastructure parts in place. So the last piece of infrastructure that we need in place before we can start deploying our containers is we need an ECS cluster. So the ECS cluster runs inside the VPC, and it controls all of the ECS services. So this is what we will create next. So we will jump into the code, and in our local stack class, we are going to create a new class level variable up here, and we'll say private final, and then we'll say cluster, and we'll call this ECS cluster. And then we will import the cluster class from the ECS package in the Amazon Web Services package. And the reason we are doing this is because we are going to need the details of the ECS cluster when it comes time to create the individual services as well as the application load balancer. So we are going to make it a class level variable for easy access. And once we have this, we can scroll down into our constructor, and just after we created the MSK cluster, we'll take a few new lines, and then we'll say this dot ECS cluster is equal to create ECS cluster, and then we'll add some braces. And just like we have been doing so far, we will create a method that has the responsibility of creating an ECS cluster and returning the details of that cluster to our class level ECS cluster variable. So we will scroll down, and just above the main class, we will add a new class in here, and we'll say private, then we'll say cluster, and then we'll say create ECS cluster, and we'll open our braces. And here we'll say return, and then we'll say cluster, and then we'll say dot, and then we'll say builder, and then we'll say dot create. So again, just double check that the cluster you imported comes from this ECS package, as there are many clusters available, so it can be easy to get mixed up. So just double check this, and inside the create, we're going to pass in the scope, which is this, and then we're going to give it an ID. Then we'll say patient management cluster, and outside of the last brace, we'll take a new line, and then we'll say dot, and then we'll say VPC, and then we'll just pass in our VPC to connect our ECS cluster to our VPC. And on the next line, we are going to say default cloud map namespace, and then open some braces. And then inside of these braces, we're going to say cloud map namespace options, and I will say .builder, and I will say .name. And inside here, we'll pass a string, and then we'll say patient-management.local. And outside of the last brace, we'll do .build, and outside of the very last brace, we'll do .build again. So at this point, your code should look like this. And let's talk a bit about this default cloud map namespace. So what this does is this sets up a cloud map namespace called patient-management.local for service discovery in AWS ECS, allowing microservices to find and communicate with each other using this domain. So for example, when we create an off service, other microservices will be able to find the off service by saying off-service and then dot, and then we'll use the cloud map namespace, which is patient-management.local. So this is a convenient method, as it means we do not need to know the IPs and internal addresses of our ECS services, as it's all managed by the cloud map service discovery. And all we need to do is know the namespace and the name of the actual service. So this is similar to how Docker works on our local dev whenever we add all the services to the internal network. All the containers are able to find each other using the container name. So this concept is very similar. It's just at a higher level. So this is important to note for when you are deploying to the real AWS in production environments. However, this functionality is not supported very well in local stack because all of the services essentially run on localhost on our dev machines. But it's good to add it here, as it just means whenever we deploy this to the real AWS to simulate a production environment, that the cloud service discovery functionality is already in place. So this is essentially it for the method we need to create an ECS cluster. So what we will do now is just double check that the error has gone up here in our constructor of our local stack class, and it looks like it is. Okay, so now we can test this out to make sure that it's getting added to our CloudFormation template. So go ahead and run the local stack project and just wait until it completes, and we'll jump into the project. And we'll just have a quick look at the template, and we'll scroll to the bottom, and now we can see that we have a patient management cluster that is of type ECS cluster. And as you can see here, it's added some details as well about the service discovery. So the CloudFormation template is going to automatically create the service discovery things that it needs, and it's going to attach all our services to this domain. Okay, so now we have an ECS cluster in place, as well as our VPC, RDS, and MSK. So this is most of the infrastructure things that we need in order to get our containers up and running. So the next thing that we need to do is we are going to create our first ECS service. So as a quick reminder, an ECS service is used to manage an ECS task in terms of the load balancers, managing the scaling, the number of resources that a task needs, and it will also handle a failed task by starting a new one and things like that. So an ECS service is going to run the task, and a task is a thing that actually runs our container. So with this in mind, we'll jump back into our code, and we're going to create a new method that will create a service depending on the properties. So we'll scroll down, and just above the main method again, we'll add a few new lines, and then we'll say private, and then we'll say Fargate service, and then we'll call this create Fargate service. And then we'll open some braces, and then we will make sure to import the Fargate service from the services.ecs.fargate service. So what a Fargate service is it's a type of ECS service. So there's a number of different ECS services that we can use, but Fargate is the most common one that is used in enterprises, as it makes it really easy to start, stop, and scale ECS tasks that run the different containers. So there's a few arguments that we're going to pass to this method to make it reusable. The first one is going to be an ID. So we'll say string, and we'll say ID. And the next argument is going to be the image name. So we'll say string image name. So the ECS task is going to take an image name, and it's going to build a container from that image name and start a container for us. So this is similar to what we did in IntelliJ. So we'll see how this works shortly. Next, we're going to accept a list of ports that we want our containers to expose. We'll say list, and then we'll say integer, and then we'll just call this ports, and then we'll import the list from the Java util class, just like this. And then we'll add a comma, and we're also going to accept a database instance here, so that if the service that we're about to create needs to connect to a database, then we will handle that in here as well. So say database instance, and we'll just call this DB. And the last one we need is environment variables. So remember that each of our services needs a bunch of environment variables in order to run. These environment variables get passed in at the point when the container is run. And since the Fargate service is going to handle this when it creates a task, and since the ECS task is going to handle this when it creates container, then we need to tell the ECS task what environment variables to use. So in our method, we will define some of the defaults that we know all our services are going to need, but we're also going to add the option to pass in any additional environment variables that the services might need whenever they are created. So we'll say map, and then this will just be a string of key value pairs, and we'll import the map from the Java util package, and then we'll just call this additional env vars. So just additional environment variables. So we'll format this, and this is what your code should look like so far. So now that we've got a method that accepts a bunch of arguments, we can start to create the different bits and pieces that we need in order to run a container. So as previously mentioned, an ECS task is the thing that actually runs a container. So in order to create an ECS task, we need to create an ECS task definition. So a task definition is essentially a blueprint for a container, and it's used to specify things like the amount of CPU, the amount of memory, the image that we want to use, the environment variables, and so on. So let's start coding this up to get a better idea of what it looks like. So just inside our method, we'll say Fargate task definition, which is the construct that we are creating, and we'll call this task definition. And this is going to be equal to Fargate task definition dot, and then we'll say builder, and we'll say dot, and we'll say create, and we will say this as a scope, and then we'll say comma, and then we'll say ID plus, and then we'll add a string, and then we'll say task. And then at the very end, we'll say dot build just to get rid of the error. And this is what we have so far. So just above the final dot build, we can add some properties in here. So we can specify a whole bunch of stuff. So the first thing we're going to specify in here is the CPU. And then we'll just give us a low value of 256, specifies 256 CPU units. And on the next line, we're going to specify the memory. So we will give this a value of 512, which is in megabytes. We specified the memory and some of the resources that we need for this task to run. The next thing we can do is specify the actual container that we want this task to start. So on a new line, we will say container definition options, and we will import this from the ECS package. So it's this one that comes from AWS cdk.services.ecs, and we'll call this container options. And this is going to be equal to container definition options.builder.build. So this is going to be the builder that we use to add a bunch of options that we want to specify for the actual container. So just before the dot build, we will take a new line, and we'll take a new line again, and then we will move just above this, and then we'll say dot, and then we'll say image. So this is the image that we want this container to be created from, and we're going to say container image dot from registry, and we'll open some braces, and then we'll say image name. And then we will import the container image from the SCDK ECS container image package, just like this. So we are getting the image name from the arguments up here in the arguments of our method. So anytime create Fargate service gets called, we are going to pass in the image name to specify the to use. And this gets added down in here. So the way this works is very similar to what we've seen during local development when we were using Docker. The task will pull an image from a repository, and then it will use that image to create a container. So we can specify where an image comes from, such as ECR, which is Amazon's own container registry that you would typically use in production environments. But because we are using local stack, then local stack will know to pull the image from the local image repository on our machine. So as a quick reminder, during the course, whenever we were building out our microservices, each time we built and deployed an image to our Docker setup, we created a new image that was stored on our local development machines. So for local stack, this is where it's going to get the image from. So we will see more how this works when we come to deploy everything to local stack. And the next thing we're going to do is we're going to take a new line after the image and say .port mappings, and then we'll say ports.stream, and then we'll take a new line and then we'll say .map, open braces again, and then we'll say port, then we'll do dash and then a right angled brace to create an arrow, and then we'll do port mapping, and the port mapping comes from the ECS services package, and then we'll do .builder. We'll do .build just to get rid of this error. And just before the last brace, we'll do .toList, and this will just get rid of all the errors here. And we will format this a bit so that the code now looks like this. So all we're doing here is we're going to specify the ports that this container is going to use. And these ports come from the method arguments up here. So depending on the service that we're trying to create, it's going to have a different set of ports. We just need to expose those. And this is all we're going to do down here in our code. So just after the .builder line that we added, after the braces, we'll take a new line and it will say dot and it will say container port, and then we'll just say port. And on the next line, we'll say dot and it will say host port, and then we'll say port as well. On the next line, we'll do dot and then we'll say protocol, and then we'll do protocol dot TCP. So this is what your port code should look like. And all we're doing is we're just taking each of the ports that we received in the method arguments, and we are assigning it to the container port and to the host port down in here. So again, the container port is the port that the application is running on inside of the container, and the host port is the port that we want this container to expose so that other services can access it. So in this case, we need to do this so that the task definition are able to forward requests to the application that's running inside of our container. Okay, so now the next thing we're going to do is just before the final .build line, we're going to add a new line and say .logging. And in here is how we specify how we want our logs to be displayed and where they go to. So during development, when we were using Docker, we were able to see inside the container logs, and this is helpful for development and debugging. And it's also helpful for catching any errors and things like that. So we need to configure where the logs inside our container are going to go. So inside of the logging tags here, we'll say log driver .ws logs, and then we'll say AWS log driver props .builder .build, just like this. And just before this build call, we will take a new line and we'll say .log group. We'll say log group .builder, and then we'll say .create. So this is going to create a log group, and this is good because we want to group all of the logs for a given container or service into their own group of the same name, so it's easy to find where these things are. So inside of the create, we'll do this, pass in our scope, add a comma, and I will say ID, and I'll do plus, and then we'll add a string, and we'll just say log group. And just before the closing brace here, we'll take a new line, and I will say .log group name, and I will add a string, and I will say /ECS /, and just outside of the quotes, we'll do plus, and I will say image name. And just before the final brace, we'll do .build again, and this will build the log group. Okay, so for the logging stuff we just added, your code should look like this. So there's a bunch of nested builders and stuff here. So just take your time and make sure that everything's in the right place. And all we're doing here is essentially creating a log group name that's prefixed with ECS and then the image name. This makes it easy to find all the logs for our image. And then there's a few additional options we can add in here. So just after the log group name property here, we'll take a new line, and then we'll say dot, and then we'll say removal policy, and then we'll say removal policy dot destroy. This just means whenever the stack is destroyed, it's going to destroy all the logs as well. Just so the next time you start this stack, you're starting from a clean slate, which is always nice. And then if we do dot retention, and then we can say retention days, and we'll say dot, and then we'll say 1 day. So this doesn't matter too much for local stack, but for enterprise environments, all the logs and keeping logs can be pretty expensive. So it's good to set a retention that doesn't cost too much money, but still has enough history to be helpful. And this is pretty much it for our container options. So what we have now is we have the image, we have the ports that we need to expose on the container so that the task and the service can communicate with it properly. And then we've just created a log group down here to store our container logs. So the next thing we can do is we can define our environment variables for this service that we're trying to create. So what we will do is we will take a few new lines after the container options that we just created. So we're still inside the create Fargate service function. And in here, we will say map. And this is going to be some key value pairs of string and string. And we'll just call this vars. And then this will be equal to a new hash map. So a hash map lets us store key value pairs, which is what we want for our environment variables. So on the next line, what we will do is say mvars.put, and then we'll add a string. And then we're going to say spring underscore Kafka underscore bootstrap underscore servers. And then we'll close our string, and then we'll add a comma. And after the comma, we're going to say string, and then we're just going to say localhost.localstack.client. cloud, and then we'll add a colon, and then we'll say 5410. So all we're doing here is we are passing in the Spring Kafka Bootstrap server environment variable to whatever service this is, and it's going to have a value of localhost.localstack.cloud and a port of 5410. So this is one of the endpoints where LocalStack sets up the Kafka Bootstrap servers. So there's two more that we need to add as well. So we'll just copy this, and at the very end, inside of the same string, we'll add a comma, and then we'll just paste this again, and then we'll change the value at the end to be 11, and then we'll add a comma again, and then we'll paste it in again, and we'll change the value at the end to be 12. So these are the three addresses that LocalStack could set up Kafka to be hosted on. So we have to pass them all in as a single environment variable to the Spring Kafka Bootstrap servers. So this means any of our microservices that require access to Kafka, such as the patient service and the analytics service, they will be able to do so because we have specified where the Kafka Bootstrap brokers are. And we're putting this in regardless of the service, as it means if we add any new services in future, they will all automatically be configured to use these Kafka brokers. So on the next line, what we're going to do is say if, and then we'll say additional n bars, then we'll say not equals by doing exclamation mark and then equals, and then we'll say null, and then we'll open some braces. So if the additional environment variables, which we receive as part of our function arguments up here, is not equal to null, then all we're going to do is say nvars.putAll, and we will pass in the additional environment variables to this new environment variables map that we've created up here. So all we're doing is just merging all the environment variables together. And after this if statement, we'll say if, add some braces, and then we'll say db, and then we'll say not equals, then we'll say null, and then we'll open some braces again. And in here, what we're going to do is if this service requires a database, we are going to configure the environment variables for that database. So we'll say nvars.put, and then we'll add a string, and then we'll say spring underscore data source underscore URL, and outside of the string we'll add a comma, and then we'll add a string again, and then we'll say jdbc, add a colon, and then we'll say Postgres SQL, add a colon, and add a // and we'll add a %sign, and then we'll say s, add a colon, and then we'll say a %sign s again, and then we're going to add a slash, and then we'll say %sign s dash db. So these are placeholders for our jdbc connection string. At the very end of the string, we'll say .formatted, and inside of the braces, we'll just take a new line, and then we'll say db.get db instance endpoint address, add a comma, and then we'll take a new line again, and then we'll say db.get db instance endpoint port, add a comma, and then we'll just pass in our image name as well. And at the very end, that's a semicolon just to fix the error. So all we've done here is we're specifying our connection string in order for the service to connect to whatever database has been passed in. So for example, if we are creating a patient service, then the database that we pass in is going to be the patient service database. And from that, we get the instance endpoint address, and that gets added to this first little s up here. And then we get the port, and this gets added to the second %s up here. And then we get the image name, which is going to be the exact same as the service name. And this gets added to this last %s up here, and then we just append db to the end. So on the next line, we will define some more environment variables. So we'll say nvars, and then we'll say .put, and then we'll say spring underscore data source underscore username, comma, and then we'll say admin underscore user. This is just the user that we set up whenever we created a database, and because we hard-coded this user in the create db method up here, then it's going to be the same for all of our databases. So we scroll back down to our function. The next one we need is the password. So we'll say nvars.put, and then we'll say spring underscore data source underscore password. And the password for this is going to come from the database variable here. So whenever we created a database, the CDK code will create a password behind the scenes and add that to the secrets manager. So to get the password, all we have to do is say db.getSecret, and then we'll do secret value from JSON, and then we'll pass in a string, and then we'll say password, and at the very end we'll say string, just like this, and this will get the password and pass it in as an environment variable. And the next one we need is nvars.put, and then we'll say spring jpa underscore hibernate underscore ddl underscore auto, and then we'll add a comma after this, add a string, and then we'll say update, add a semicolon at the end, and then we'll say nvars.put and then we'll say string, and then we'll say Spring underscore SQL underscore init underscore mode, and then add a comma, and then in the value, it'll be a string, and we'll say always. So these two values just mean that the database that the service connects to is going to run the JPA Hibernate stuff and run the data.sql script as well. So for development purposes, this is good because it means we will have the same list of patients and the same login and the same users that we have been developing with so far. But for production environments, you would usually leave this out and do some manual inserts or use some database migrations to set up the data. But for learning purposes, this is fine. And the last one we want to add is envars.put, and then inside the braces, we'll say spring underscore data source underscore Hikari underscore initialization underscore fail underscore timeout. And we'll add a comma. And for this, we will put 6 and then we'll put 5 zeros. So this is going to set a timeout just to make sure that if the database isn't ready at the point when this service is trying to spin up, that it retries a few times before it fails instead of failing straight away. So that's it for the environment variables that we need. And you will probably notice that it's very similar to the environment variables that we added to our run configuration whenever we created an image and a container for a given service during development in our IDE. So if we look at one of our services here, so for example, the patient service in IntelliJ, and if we have a look at the configuration, you can see that we are passing in more or less the same environment variables if this service needs a database. And the patient service is going to pass in additional environment variables that it needs. But the point here is that regardless of how we try to run a container, whether it's in Docker on our local desktop or in AWS ECS or through local stack, to start a container, we pass in any environment variables that it needs, what image we want to use, and then the thing that we are using is going to handle the starting of a container. So hopefully you're beginning to see some of the advantages of Docker starting to materialize. Whenever we start up and deploy our local stack and see things running, hopefully it will become a bit more clear. So with that in mind, we will jump back to our code. And after the last closing brace down here, we're going to take a new line. And what we need to do now is we have created a hash map with all our environment variables in it, but we haven't done anything with this yet. So as you can see, it's never queried. So what we have to do now is just after the database if statement, and here we'll do container options, and then we'll do dot environment. Oh, and it's not finding it. So it looks like we have an issue with our container options. And if we scroll up, what we actually want to do up here is we want to actually add the environment variables to our container definition options before we build the options. So because we want to do this later on in the code after we have run some logic, what we can do is adjust our container definitions object to be of the builder instance, and then we can add our environments variables later and then build it later as well. So you see what I mean? I'm going to change this type up here by saying container definition options, and then we'll do dot, and then we'll say builder. And then at the very bottom, we will delete this line here. So instead of actually building our class instance, we will keep it as being of a builder instance so that our code now looks like this. So that fixes the error. And then we can scroll down here, and if we do container options dot environment now, you can see this has fixed the problem. And what we can do at this stage now is pass in our envars hash map that will have all the environment variables that we need in it. So again, this environment variables object or hash map comes from up here. And after all this logic is run, all we're doing is adding the environment variables to our container options that we defined previously. We have added all the container options that we need. The next thing we can do is we can add our container options to our task definition that we created up here. So at the moment, we have separate objects for a task definition and a container definition. So we just need to link these two together. And we do that by taking a new line down here. And then we'll say task definition dot add container. And here we'll say image name plus, and then we'll add a string, and then we'll just say container. But this is the ID, and then we'll add a comma. And then we'll say container options, and then we'll say dot build. But this is what our code looks like so far. And what this does is it essentially adds a new container to our task definition with these container options. And at this point, we build the container options to actually create an object that we can pass to the task definition. And as part of the container options, we also have specified a image. So this is how an image gets linked to a container and how we link a container to a task definition. So there's lots of different bits and pieces that we need to do, but the good news is that this is a very common pattern for creating a Fargate service. So once we've done it for one of our services, the rest should follow suit. And as you practice building out more features using this technique, it will become a bit clearer. Now that we've defined our task definition, which has our container and all of the options in it as well, we can actually create a Fargate service now that will run the ECS task. So down here, we can say return, and then we'll say Fargate service dot builder, and we'll do dot create, and then say this, comma, and then we will pass in the ID as being the ID. So this comes from the arguments. And on a new line, we'll say dot cluster. So in here, we'll specify ECS cluster. And this is the ECS cluster that we created in the previous section. And this is using the class level environment variable to determine this. And on the next line, we will say dot, and then we'll say task definition. And this is going to be the task definition that we created. So we'll say task definition. This task definition comes from up here in the same method, which is the first thing we did. So we created a task definition with all the memory and such. This is what we're passing in to this service. So this service is going to use this task definition to start a container, and the service will also do all the management for that task, such as handle if the task needs to scale and so on. So after this, we can say dot, and then we'll do assign public IP, and then we'll say false. So a Fargate service also controls the external access to the task which is running a given container. So if we wanted to, we could open up this service to the internet by assigning a public IP address. But since this service is internal, we're going to say public IP address is false. And then the next thing we'll do is say dot service name, and then we'll just call this the same as the image name. And on the next line, we'll say dot build, and that's it. So now we have created a Fargate service. We have linked this service to the task definition, and the task definition will have a container based on the image defined in our container options. And we've also added all the environment variables and all that sort of stuff that we needed. So now anytime we call our create Fargate service method, we are going to get a new ECS service created. So let's see how this works by going up to our constructor. And at the very bottom, after we've created the ECS cluster, what we can do is start creating services. So the first one we will do is the off service. So we'll say Fargate service, and we'll just call this off service. And this is going to be equal to, and then we'll say create Fargate service, and we'll pass in a string, and then we'll call this off service as an ID, add a comma, and then the image name is going to be auth service, as this is the name of the image that we have been working with in development up until now, and this is the exact same image that we are going to deploy to our local stack environment. So the next thing we need to do is specify the list of ports. So we'll add a comma here, and then we'll take a new line, and then we'll say list of, and in here we'll pass in a number, and this is just going to be the port that our off service is running on. So it's going to be port 4005, and you can double check this in the environment variables in the application properties of the off service. At the end, we'll take a new line again, and then we can pass the name of the database that we want to link to the service. We'll call off service DB, and then we will add a comma again, and then we'll say map of, and then we'll open our braces, and then we'll say string, and then we'll say JWT underscore secret, and we'll add a comma, and then we'll add a string again. So this string is going to be the JWT secret that the off service is going to use to create and validate tokens. So the easiest way to get a value for this is if we go up to the run configurations at the top. If we go into off service, we'll just edit the environment variables. And if we scroll down on the right to the environment variable section, browse, and in here, you should have a JWT secret that looks something like this. So just go ahead and copy this one. We just double click on the value, do Control A, just to make sure you have everything. Do Control C to copy it, and then we'll just close these down, and then we'll just paste the value in here, just like this. So all we're doing here is passing in the different properties that we need in order to create a new Fargate service. So the first thing is an ID, the second thing is an image name, and then we specify the ports that this runs on. We then specify the database to link to, and lastly, we specify any additional environment variables that we want to add to this container when the service starts. So now that we've added the off service, we can also configure the health checks. So to do this, we will take a new line, and then we'll say off service dot get node dot add dependency. And then in here, we will say off DB health check, and then we'll just duplicate this line again. And the argument this time is just going to be off service DB. So this tells the CDK logic and the CloudFormation template that our off service has a dependency on the DB and also the database health check. So this just makes sure that the database starts before we try to start the off service. So on the next line, we can do similar for the billing service. So we'll say Fargate service, billing service is equal to, and I'll say create Fargate service, and then we'll pass a string in and we'll call it billing service, add a comma, and then we'll pass in an image name. So we'll take a new line and we'll add a string and we'll call this billing dash service, and then we'll add a comma, add a new line again, and this time we need to specify the ports that we want to expose here. And then here we'll say list of, and for the billing service, we need to expose the port that the application runs on, which is 4001. And we also need to expose the gRPC port, because remember, the patient service is going to make gRPC requests to the billing service. So we need to open the gRPC port as well. And this is on 9001. And after that, we'll add a comma and we'll specify a database. So the billing service doesn't need a database, so we'll say null. Then we'll add a comma, and then we can specify any additional environment variables that we need. So there are none. We can just say null again, and that's it. So now we have another service, and this time it's the billing service. So the billing service doesn't really have any dependencies at this point. It's pretty much standalone. So we can move on and create the next one. So the next one we can do is the analytics service. We can say Fargate service, and then we'll call this analytics service. And then this is going to be equal to create Fargate service. We'll add our ID, which we'll call analytics service. And then we'll add a comma, and then we'll say string, and then the image name. So it's analytics dash service. And we'll add a comma again, and I'll say list dot of, and this is going to be the ports that our analytics service runs on, and in this case it's 4002. Outside of this we can add a comma and we'll specify a DB, which again the analytics service doesn't have a DB at this point, so we'll just say null and we'll add a comma, and then for additional environment variables there are none, so we can just say null as well. And then we can save this, and the analytics service is going to have a dependency on Kafka. So remember, the analytics service consumes Kafka events. So we need to make sure that Kafka is running before the analytics service tries to connect to the broker. So on the next line, we'll just say analytics service. Oh, and we will call the name of our Fargate service analytics service as well, just for consistency with the rest of our services. So just make sure that you've named this Fargate service analytics service. And then down in here, we'll do analytics service dot get node dot add dependency. And then we'll do MSK cluster. So all we're doing here is saying the analytics service has a dependency on the Kafka cluster. And that should be it. So the last service we need is going to be our patient service. On the next line, we will do Fargate service, and we'll call this patient service, and this will be equal to create Fargate service. We'll add our string for the ID, which we'll call patient service, add a comma, and then we'll add the image name, which will be patient dash service, add a comma again, and we'll pass in our list of ports. We'll say list of, and this port is going to be port 4000, and we'll add a comma again, and we'll specify a database, which is going to be patient service DB, and we'll add a comma, and the last thing we need to do is specify the additional environment variables that the patient service needs. We'll say map, and then we'll say of, add some braces, and then we'll take a new line in here, and then we'll add a string, and I'll say billing underscore service underscore address, add a comma, outside of the string, add a comma, and then we'll say host.docker.internal. So because LocalStack does not implement the ECS Cloud Discovery functionality, we can just define the billing service address as being on the docker.internal address. It will then use the port that we define to send the request to the right place. So on the next line, we'll add a comma, and I will say billing underscore service underscore gRPC underscore port string in here, and then we'll specify the port that the billing service gRPC server is running on, which is 9001. And at the very end, we'll add a semicolon just to fix the error. And then we will add all the dependencies that the patient service has. We'll say patient service dot get node dot add dependency, and then we'll say patient service DB, and then we'll just duplicate this line. And instead of patient service DB, say patient DB health check, and we'll duplicate this line again, and there's also a dependency on the billing service, because whenever we create a patient, it's going to make a gRPC request to the billing service. So in order for that to happen, we just want to make sure that the billing service is started before the patient service starts. And the last one that we're going to add, so we'll just duplicate this line again, and then we'll say MSK cluster. So because the patient service also sends patient created events, we need to make sure that the cluster is running before the patient service has started. Should be it for all of our services. So do now is run our local stack project and see what the updated CloudFormation template looks like. So go ahead and click run, and it looks like we have an error. So whenever the CDK code tries to create a CloudFormation template, it will tell you when it can't do that. So it looks like we have an error here, and it's around stream prefix is required somewhere. So it looks to be at local stack.java line 193, and this is the create Fargate service. So it's falling over trying to do something around the logs by the looks of things. So if we go into this line, so line 193, in our stack, let's see where this is. So it's down here. So it's failing trying to build the task options, and the stream prefix is usually related to the logging. So we've probably left out something here, and take a new line just above the build tag down here. And if we do dot, and if we do stream prefix, and then we'll just use the image name as a prefix. So this is used along with the log group name, just to keep all of our logs organized based on the image name which we are using depending on the service. So this looks like it's fixed, so let's try it and see. So if we just run the local stack project again, and we will see how far we get this time. And it completed with a code of 0, which is good. So let's have a look at the CDK stack. So we'll jump into the infrastructure project, into cdk.out, and let's look at this template. And as you can see, there's a whole bunch of stuff in here now. And you're basically just looking for things to give you a clue that the services are going to be created. So if we go to the very bottom, you can see some promising code in here. It's related to patient service task and also Fargate and so on. So patient service here with a type of ECS service. This is good. It looks like on the face of it that our CloudFormation template is coming along well. We won't know for sure until we actually deploy it to local stack, but getting the CD code to generate all this is pretty good because it will tell us if it can't do that. So now at this point, we have the majority of our infrastructure in place. So we have our VPC, RDS databases, our managed Kafka, as well as most of our ECS services. So you'll probably notice in the last section that we did not create the API gateway service, and that's because this is a bit of a special case. So as we previously mentioned, all of the services inside our ECS cluster are protected from the outside world by the VPC. So in order to get access to all our services from the front end must go through the application load balancer and our API gateway. So the way this will work is that we create the API gateway in a similar fashion to what we did with the previous services. So this will be an ECS Fargate service. The only difference is that we will tell the CDK that we also want to create an application load balancer to expose this service to the front-end clients. So in our code, we will define the API gateway as a service similar to the other services we created. The only difference is behind the scenes, CDK will create this additional step over here and create an application load balancer for us. So we do not have to do anything special over here. It's all configured as part of the Fargate service we create for the API gateway. So to understand how this works, we will jump into the code and we will jump into our stack and we'll scroll down towards the bottom where the main function is. So even though the API gateway is a Fargate service, it is a bit of a special case in that we want it to be a load balanced service as well. So with that in mind, we are not going to reuse the create Fargate service because we would have to add some logic in here to cater for a load balancer, and this method is already quite long. So it's perfectly fine to create a special case service. And by that, what I mean is we will create a method. So we'll say private create API gateway service, and this won't accept any arguments because there's only ever going to be one instance of this service. So the previous method that we created called create Fargate service is going to be for any internal services that we want to create, and this create API gateway service is going to be the special case that handles the API gateway service as well as creating the load balancer. So there are going to be some similarities, which means we can copy and paste. So the first thing we're going to do is jump up to the create Fargate service, and we're just going to copy the task definition. So just like the internal services, our API gateway is going to work the same way. in that we need to define our container options and task definitions and so on. So we will start by copying the task definition and we'll scroll down to our new method and we'll just paste it in here just like this. And we'll just update the ID over here in this section to be a string and we'll say API gateway task definition just like this. So this will create the task definition that we need in order to start a task and run our API gateway container. And the next thing we need to do is define the actual container and the image and the environment and so on. So if we scroll up again, we can copy some of this from the previous method. So what we are looking for is the container definition options builder. So what we're going to do is highlight this and scroll all the way down until the bottom of this block of code, and it should be just before the hash map code start. So just copy this and then we'll scroll down and we will paste it just after the task definition that we added. There's going to be a few errors here, but don't worry too much about that at the minute because we'll fix them as we go. So up here on the first error, we're going to change the type to be of type container definition options without the builder, as we're going to build it all in one go this time. And the image name is just going to be string, which we'll call API gateway. So this is the image that this task definition is going to use. And we can also hard code the ports because we know what they are. So delete the ports variable that doesn't exist, and I will say this.of, and then the port for this is going to be port 4004, as that's the endpoint that our API gateway is running on. So we'll scroll down to the next error, and in the log group, we can update the ID. So we don't need the dynamic variable anymore. All we have to do is say API gateway log group and same for the image name down in here. We can delete the variable and then we'll just say API gateway as part of the string in the log group name, just like this. And the last thing we can do in here is update the stream prefix to. We'll add a string and we'll say API gateway. And at the very end, we just want to delete the semicolon and I'll do dot and I'll say build. So this is just going to build the container options in one go this time, as opposed to previously when we built the options at a later stage in the flow because we needed to add environment variables and things like that. So this time we can add the environment variables in line. So we will scroll up and just after the image up here, we will say dot and I will say environment and I will say map.of and we'll take a new line and then we'll say spring underscore profiles underscore active, add a comma and I will add a string and I will say prod. So I'll explain a bit more about what this does when it comes time to actually deploy our stack, but essentially the API gateway is going to have a different set of routes for development and a different set of routes for production, because obviously the endpoints are different depending on the environment. So we will see how Spring profiles help us with this in the next section. And then we'll add a comma in here and we'll add a string and then we'll say auth underscore service underscore URL, add a comma again, and we'll add a string and we'll say http / and I'll say host.docker.internal and then we'll specify the port that the auth service is running on, which is 4005. So again, because local stack doesn't implement the service discovery very well, we're just going to use the Docker internal service discovery in combination with the port so that the services can find each other. And the auth service URL is used to verify the tokens in the given requests before they get passed on to our internal microservices. So this is functionality that we added earlier on in the course. Okay, so now we've created a task definition and container options that we need. And the last step is to create a service. So again, this is going to be quite similar to how we created the service in our create Fargate service method. The only difference is the type of service that we create. So to see what this looks like, back in our code, just before the closing brace of the method, we'll say return. And in here, we'll say application load balanced Fargate service. And we'll call this API gateway. On the next line, we'll say this is equal to application load balanced Fargate service dot builder dot create. And at the end, we'll just do dot build just like this. And this is what our code looks like so far. So before we add the actual properties, I just want to show you the actual difference here between what we're doing. So if we look at the previous method where we create an internal service, we use the Fargate service class. But this time we are using the application load balanced Fargate service class. So the only difference here is that this one is going to automatically create an application load balancer for us. So we don't have to create this manually. All we do is specify that this is what we want. And the CDK code in combination with the CloudFormation is going to automatically start one. So there's a lot of magic happens behind the scenes, but whenever we deploy it to local stack, we will see how it all works. So before we get to that, we need to specify some things in our service. So we'll say inside the create, we'll say this, which is the scope, and then the ID is going to be a string, and we'll just say API gateway, and then we'll say service. And on the next line, we'll say dot, and we'll say cluster, and then we will link this application load balanced Fargate service to ECS cluster. We'll say ECS cluster, and looks like we're getting an error that says might not be initialized. So we scroll up, it's probably because we have an error up here as well, and we haven't specified a return type. We just make this method return void, as the return type will not be used anywhere. And if we scroll down, the error should be gone at this point. After we've added a cluster, we'll take a new line, then we'll say service name, and this will be a string, and we'll call this API-gateway. It's like this. And on the next line, we'll do dot task definition, and then we'll just pass in task definition that we defined previously in this method, all the way up here. Then we'll say dot desired count, and then we'll set this to 1. So what we can do as part of creating the actual ECS Fargate service is define how many instances of a task that we want to run. So because we have an API gateway, we initially want this to be 1, and if the traffic increases a lot, then we can increase the desired count to match this as well. And on the next line, we'll say dot health check grace period, and then we'll say duration, and then we'll say dot seconds, and then we'll just put in 60. So this is how long the application load balancer will wait for the API gateway container to start before it throws an error. And then at the end, we do dot build. And that should be it for our Fargate service. And there's one thing we forgot to do. And if we scroll up, you can see we created a task definition, and we also created some container options, but we did not link our container options to our task definition. So we can do that down here, just above our API gateway service code. So we'll take a new line, and then we'll say task definition dot add container, and then we'll just call this API gateway container, and then we'll add a comma, and then we'll just pass in our container options just like this. So this will add our container options to our task definition, and then we add our task definition to our service down here in order to tie everything up. And this will create an API gateway service with a running container and also an application load balancer that provides an entry point into our protected infrastructure. So all it's left to do now is call our new create API gateway service method from our constructor so that it gets added to CloudFormation. We'll scroll all the way to the top, and we will find our constructor, and we'll just scroll to the bottom of the constructor. And just after all these patient service dependencies, we'll say create API gateway service. And we don't have to pass any arguments to this method because we have hard coded all the API gateway specific config that we needed, and we have access to our environment level variables up here that we need for the VPC and the ECS cluster. So the last thing we'll do is make sure that our CloudFormation template gets created. So let's go to the top of IntelliJ, and we'll click run, and this will run the CDK code to size our app, and all looks good. And we'll have a look at our project. We'll go into the infrastructure project, into the cdk.out folder, into the template, and let's scroll to the very bottom of this, and you can see we should have a whole bunch of stuff that's related to a load balancer. So again, just pick out the keywords to make sure that your things look right. So for example, here's the port that our API gateway is running on, and you can see here load balancer to target. So this looks like it's created a load balancer for us, which is good. So we now have a CloudFormation template that on the face of it looks like has everything we need to build our infrastructure. So the next step that we need to do is we need to prepare all our Docker images to make sure that they are using the latest version of the code, and then we can deploy our stack to the local stack instance that's running on our desktop. Okay, so now that we have a CloudFormation template that we can use to deploy local stack, the next thing that we're going to do is to prepare our Docker images so that they are ready to be deployed to the local stack environment. So the way this works is that since local stack runs on our development machines, it's going to use the Docker images for the services that we need to deploy to ECS that exist on our local machines. So during development, whenever we created our various microservices, we ran a configuration up here that did two things. The first thing was that it created a Docker image, and then the second thing was that it actually ran that image. So the images that we deploy to ECS are going to be the exact same ones that we used during our development. So this is one of the biggest advantages of Docker, is that we can be sure that the code is going to run the same in local stack as it does in our IDE, because we are using Docker containers for everything. So this is one of the prime reasons why we use containers. And since we have been building the images for each of our services as we go, we should already have the images
on our system. But just to be sure, what we're going to do is create new images for each of the things that we need, just to be sure that all of the images for our services are up to date with the latest code. So to do this, we're going to go into our ID and we're going to go into the terminal on the left-hand side. And this will open up your preferred terminal in the parent folder of our project. And what we're going to do in here is we're going to see how to build a Docker image using the terminal. This is the same as when we ran the run configurations at the top. Both approaches are going to create a Docker image. The only difference is how we do it. So if you prefer, you can just use the run configurations because the output is still going to be the same. Each service will be updated with the latest image. So in the command line, if you prefer to do this, what we're going to do is we're going to run a Docker command to build an image for each of our services. So we'll just start at the top of our list and we'll do the analytics service first. So in the terminal, we'll say cd and then we'll do analytics service. And this will bring us into the analytics service folder in our project. And in here, we'll say Docker and then we'll say build and then we'll say -t and then we'll say analytics -service and then we'll say space and then we'll add a dot at the end. So what this does is that it's using the Docker CLI, and you should have this because it comes as part of the Docker desktop installation. And then the build command is saying that we want to build a Docker image, and the -t means that we want to tag this image with this text here. We forgot to add the latest tag, so just use your cursor to go back a few steps, and after the E in service, we'll add a colon and then we'll add the word latest. So the -t tag here means that it's going to create an image called analytics service, and it's going to tag it with the latest. So anything after the colon is considered a version. So we use a well-known term called latest to say that this is the latest version of this image. And then we add a space and then we add the dot. And the dot means that we are telling Docker to use the Docker file that is in the top level of this directory. So as a quick reminder, if we look at the directory in the project window, inside each of our services, we have a Docker file. So we don't need to specify the name of the Docker file because the Docker build stuff is going to use a convention based on the file name. So just as long as the file is called a Docker file, then this command down here is going to work. So just before you hit enter, go and check that you have Docker desktop running. And when you're happy, go ahead and hit enter and you will see output that looks very similar to what we've seen before. So it goes and runs all the different Docker things, and the output is similar to what we've seen when we started a given service using the run configurations. So again, it doesn't matter if we use the terminal or if we use the run configurations to create a Docker image, they both give the exact same result at the very end. So hopefully at the end, you should see something like this that says that it's naming to blah, 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 and then /analytics : latest. Okay, so once this has completed, we can check that it worked by going into the services tab on the right. And in here, we can see under the Docker section, under images, that we now have an analytics service image, and it has the tag latest. So if you haven't deleted any of your local images at any point throughout the course, then you should see all the images for all the different services and things that we have been running in here. But it's still good practice to make sure that the image we're about to deploy is a new image, just to be sure that there's no issues when it comes time to running everything in local stack. So this is just a rinse and repeat process now for the rest of our services. So we'll jump back to our terminal, then we'll do cd, and then we'll do ... And this will bring us up a level into the patient management folder again. And in here, the next service that we need to build is going to be the auth service. So we'll skip the API gateway for now, as there's a few additional changes we need to make to the routes, which we'll do in the next section. But for now, we will build as much of these images as we can. So in our terminal, we will do cd and then we'll do auth service. And again, it's going to be the same command that we used previously to build a Docker image. So we'll just say Docker build, and then we'll say -t, and then we'll say auth-service : latest, and then we'll say space, and then we'll add a dot. And this will build a new auth service Docker image for us. And as you can see, the output is the exact same as if we ran it through IntelliJ run configurations up here. After it's completed, you can jump into the services and just check under the Docker images that an auth service page has appeared. And as you can see over here, it says it was created 9 seconds ago. So this is good. And it will jump back to the terminal again. And the next one we'll do in the list is the billing service. So we'll do cd and then we'll do ... and then we'll do cd billing service. And then we'll just use the same Docker command again. So we'll say Docker is build -t, and we'll say billing -service : and then we'll say latest space and then add a dot. And we will run this and let it build a fresh image for us. We'll have a quick check to make sure that the billing service image is created, and here it is. That's good. And then jump back to our terminal, and the next thing we need to build is going to be the patient service, and that's the last one before we go and have a look at the API gateway. So in the terminal, we'll do cd and then 2 dots, and then we'll do cd patient dash service, and then we'll do docker build -t patient dash service, and then we'll say latest, and then we'll do dot, and then hit enter. And after that's completed, we can do a quick check. So we'll jump into services and scroll down, and then we should have the patient service in here as well. So the next one we'll do is we'll do the API gateway. So this is a bit of a special case, and I'll explain why. So if we close this down, and if we look at the API gateway, if we go into source, into resources, and go into application.yaml, in here is where we have provided the routes. So example, for the off service route, we've defined a URI like this, and same for the patient service and the docs and so on. So the reason why we put all these routes in a application.yaml configuration file is that it means we can have a new one for our different environments. So for example, the URI for development, whenever we run all our containers in Docker through, and are going to simply use the container name. But whenever we deploy to local stack, it's going to be different. And whenever we deploy to a real production AWS, what happens is this URI is going to be different again. So for example, on the real AWS, it could be something like auth-ecs-service, and it could be a long string or whatever, and then it could be aws.com, something like this. So depending on the environment, we are going to have a different application.yaml file that will have all the routes configured for that environment. So to see how this works, what we'll do is we'll open up the project, and in API Gateway, under the source folder and in resources, we're going to right click on resources, and we'll go to new, and then we'll go to file, and then we'll call this application, and then we'll say dash, and then we're going to say prod, and then we'll say .yaml. So this is just a suffix in this case that indicates production. So we just call it prod for short. So by using this syntax, we can define a profile whenever we start the container that tells Spring which application.yaml file to use. So for example, for dev, it will stick to the default application.yaml. But if we provide a Spring profile environment variable with a value of prod, then Spring is going to know to use this one. So we'll see how this works when we deploy to ECS, but for now we'll hit enter, and we'll jump back to application.yaml, and then in here, we're just going to copy all of this, and then we'll go into the production one, and then we'll just paste. So the majority of the properties in here are going to be the same, such as the port, the route names, the predicates and stuff. The only thing that is likely to change is going to be the URI. So since we're using local stack, and as we mentioned before, the service discovery for all the service names isn't 100% supported in local stack. So what we'll do is we'll just use the Docker host name in combination with the port, and then we'll let Docker decide where to send the requests based on those two things. So what we'll do is jump to the top of the file, and we're just going to go to the routes section here, and under each of the URIs, just going to change the host. So instead of off-service, we're going to say host.docker internal, and then we'll keep the port the same. So behind the scenes, this is what local stack is going to use to start up all our ECS services in combination with this port. So all we're doing is telling our API gateway where to send the request depending on the path and the filter and so on. So by doing this, our API gateway is going to act the exact same. It just changes where it sends requests to. So this approach is good because we don't have to change any code. All we do is change these configuration files, which is a bit nicer. So we can do the same approach to the rest of our routes. So just go ahead and copy the host that we added to the top one here. And I will scroll down, and under patient service route, we can just replace the host in here. So we'll just paste this in like this. And then for the docs, we can do the same again. So under the URI, we'll paste in the new host. And for the URI, for the off-service docs, we'll just do the same thing as well. And that's it. So we've called this production because we're simulating a production environment, but we could equally have called this local stack and then had a third one that would be used in an actual production environment, but this is fine for now. So this is all we need to do. What we could do now is build an API gateway Docker image. So to do this, we'll open a terminal, and we'll just go back to the top level patient management. So we'll say cd, and I will say ... and then we'll do cd API-gateway. And in here, we'll do Docker build, and then we'll say API-gateway, latest. Oops. And in here, we'll say Docker, and then we'll say build, and we'll say -t, and then we'll do API-gateway, and then we'll do latest, and then we'll say dot. So this will build a new API gateway image, and it will copy all of our application YAML files across as well. So we've configured our Docker file to copy all of the files inside of the API gateway. So we don't need to do any additional steps in order to get our new application prod YAML configuration file into our image, because it's going to get copied over automatically. So go ahead and hit enter. And after that's done, we'll have a look at the services, and up towards the top of the images, we should have a new API gateway image. Okay, so that's it for all the images we need. I just want to jump back quickly to our infrastructure code and explain how our local stack setup is going to know to use this application.prod config file. So in the project, if you go to infrastructure and go to source, into main, into Java, and into the local stack class, and what you want to do is scroll towards the bottom where we have a create API gateway service method. And if you have a look in here, as part of the container definition options, we pass a bunch of environment variables to our container. And one of these environment variables is called Spring Profiles Active. So this is a built-in Spring environment variable, and it lets us specify a profile. A profile is essentially the application YAML file to use. So because we've called it prod here, Spring is going to look for the application.yaml file that has the word prod in the file name. So it's all based on file names and stuff like that. So that's how it works. And the last thing that's worth mentioning is that during development, we created containers for Kafka and our databases and things like that. We don't have to specify images for those things for our local stack setup, because we are using RDS and MSK to handle our Kafka and our databases. So those things, and they're built into AWS, which means they're built into the local stack as well. So all we have to do is specify those things in our CloudFormation template, which we have already done in here, and those things will get created whenever we run our actual template. So that's about it for our Docker images preparation. So just check that you have all the images for all the services that we created manually underneath your images sections here. If not, just go back into the folder for that service and create a new Docker image. We have everything in place that we need to deploy our stack to our local stack container. So check that you have Docker desktop that's up and running, and also check that you have the local stack desktop app as well that's running, and that you have a running container. And it's also a good idea to be signed in as well. So go ahead and do that if you haven't already. And at this point, local stack's running. We can just close the window or minimize. We can jump back into IntelliJ. So the way this works is that we write a command in the terminal that's going to take our CloudFormation template. So as a quick reminder, this is the JSON file in our infrastructure cdk.out folder that describes our entire infrastructure as JSON properties. And we use the AWS CLI to deploy this CloudFormation template to a CloudFormation instance on AWS, or in this case, onto local stack. So what we're going to do is we're going to create a file that will hold this command. And the reason for that is it's just to make it easy to follow along, and it gives you something to reference on the completed GitHub code just in case you're having any problems. So what we're going to do is go into the infrastructure folder on the left, and in the very top level, so we're going to right click on infrastructure, and we're going to go to new, and we're going to go up to file, and we're going to choose file, and we'll just call this local stack -deploy.sh. So this is just a shell script file that we're going to put all the different commands that we need instead of repeatedly typing them out in the terminal, but it's all going to work the exact same. So at the top here, we'll do hashtag, and then we'll do exclamation mark, and then we'll say slash, and then we'll say bin, and then we'll say slash, and then we'll say bash. We're going to use a bash script here, and then on the next line, we'll do set, and then do -e. So all this does is stops the script if any command fails. So you don't have to type these comments if you don't want to. This is just for your own reference. And then on the next line, we're going to say AWS, and then we're going to say --endpoint -URL is equal to http:// and then we'll say localhost : and then we'll say 4566, then we'll say CloudFormation, then we'll say deploy. We'll do a backslash, then we'll take a new line, tab a couple of times until we're in line with the stuff above here, and then we'll just add a double dash again. So all we're doing here is keeping our command nice and organized. You could run these on the same line if you want, but if you do drop things to a new line, you have to add the slash at the end as well. And in here, we'll say stack-name, and then we'll add a space, and then we'll say patient-management. And again, we'll add backslash, and then we'll take a new line again, and then we'll say -- again. And this time we'll say template-file, add a space, and then we'll add a string, and then we'll say // and then we'll say cdk.out/, and we'll do local stack dot and then we'll say template.json. Okay, so what this does is that it's going to use the AWS CLI to deploy our CloudFormation stack. So over here, we've specified the command that we want to use, which is CloudFormation deploy, and we've also specified the endpoint URL. So the endpoint URL is really important here, because if we do not specify this, then the AWS CLI command over here is going to try and execute this command against a real AWS instance. So that's not going to work because we haven't configured credentials for that. So it would fail. So it's important to add this endpoint URL. And the endpoint URL that we're pointing to is the local stack endpoint. This is where local stack runs as we configured it in the container. So if you have a look at local stack desktop, you can see there's a address here. So this localhost.localstack.cloud actually resolves to localhost on our own machines. And then it uses the port 4566 to expose this URL to the internet. So this is what we use to tell the AWS CLI to run this command against local stack. So the next thing we're doing then is we are giving our stack a name. So this can be whatever you want, really. It's good to give it a meaningful name so that you can identify stuff in the SUI. So we've just called this stack name patient management. And the last argument we have here is the template file. So since we are doing a CloudFormation deploy, we have to tell AWS CLI where our file is. So we are going to run this script from inside the infrastructure folder. So here's our script here. So we just use a relative path to tell it where our template file is. So it's in the cdk.out folder, and then we just reference the name as well, which is localstack.template.json. So this is important that these two match, otherwise the command's not going to work. Okay, so now that we understand what this is doing, this is the code or command that is going to deploy everything to localstack. And that's all we need to do in terms of the actual deployment. The CloudFormation stuff and the AWS CLI essentially does everything under the hood. So all we have to do is run the command and point to our template file, and then it should hopefully all deploy successfully to localstack. So before we see this running, we're going to add another small command in here that will get us the endpoint of our load balancer URL. So this is going to be essentially the URL that we use to make requests to our API gateway. So we'll add a few lines, and then we'll say AWS, and then we'll do --endpoint--URL. And then this is going to be equal to http:// and then we'll say localhost:4566. And then we'll take a space, and then we'll say EL, and then we'll say BB, and then we'll say 2. So this is just the Elastic Load Balancer version 2 command. And then we'll say describe-load-balancers. And we'll add a space, and then we'll add in our backslash, and then we'll take a new line, and then we'll add tab a few times. And in here, we'll say query, and then we'll add a string, and then we'll say load balancers, and then we'll add some square brackets, and then we'll say 0, and then we'll say dot, and then we'll say DNS, and then we'll say name. And outside of the string, we'll add a space, and then we'll say --, and then we'll say output, and then we'll say text. So this isn't required for a deployment, but it's a nice convenience thing to have, as it's going to print out the load balancer address that we use to access the API gateway in our stack, instead of us having to run this manually every time. So anytime we do describe load balancers, it's going to return all of the load balancers in our stack, including their addresses. And since we only have one, we are using the query tag here to say, give me the first load balancer, so at index 0, and then give me the DNS name, and give the output as text. So all being well, we should see a URL style piece of text at the end of our script that tells us where the address for our load balancer is. So this could change every time we deploy a fresh stack. So just bear that in mind as well. And this should be it. So now all we need to do is run this script, and we will see what happens. So go into the terminal, and in here, just make sure you're in the patient management folder to start with, and then we'll do CD, and then we'll go into our infrastructure folder, and then we'll do /, and then we'll say local stack -- and then we'll say deploy.sh. So we will run this and see what happens, and if we hit any errors, then we'll just fix them as we go. And then we'll hit enter here, and you should see this sort of message here that says waiting for change set to be created and waiting for stack create update to complete. So these are good messages, as it means that our AWS CLI is communicating with our local stack instance, and it's just running everything behind the scenes. So this will take a few minutes to create, because behind the scenes it's creating all our databases, the Kafka cluster, VPCs, the ECS cluster, all the ECS services, and all the ECS tasks. And all being well, at this point you should see a message that says successfully created updated stack patient management, and then you should see the address of our stack load balancer. So if you're not seeing these success messages, just make sure that you have local stack started, you have Docker desktop started, and double check that you have correctly added in the script here. So the finished example of this is on GitHub. You can copy and paste it as it is there in here. It will work the same, just in case there's some errors that you might have missed. And it's also worth noting that this is a bash script, so you will have to run it through a bash terminal, such as git bash, and it should just work on Mac OS. Okay, so before we start testing our endpoints to make sure that everything's working, what we're going to do is have a quick look into the services tab. And if we look at containers, you can see that the local stack instance has created a bunch of containers that are prefixed with ECS. So this is how or simulates the real AWS ECS container orchestration stuff by using Docker to create containers locally. And if we have a quick look at some of these containers, if we just pick one, it's kind of hard to know what each one is because it doesn't add the name. But if we click into one and have a look, this looks to be the billing service. So you can see in the logs here that it's very similar to what we've seen anytime we start a container through IntelliJ IDE, and everything looks to be good in here. So there's things like the gRPC service has started, the application has started, and so on. So this all looks good. And then it's the same for the rest of our services too. So feel free to stop and have a quick look at some of these containers just to have a look and see what's happening. And when you're ready, the next thing we're going to do is we're going to jump into the local stack UI, and we're actually going to look at some of the things that was created for us. So open up local stack, you should see that this container here is clickable. So if you click this, and the first thing you'll see is the container logs. So the container logs is for local stack, and it will also give you some information about your stack and why it failed and so on if you had any errors. So feel free to have a look at this too if you want. But what we're going to look at now is the resource browser. So over here, there's like 6 little boxes. If you hover over it, it's called resource browser. Okay, so on the face of it, it looks like everything worked. We have an endpoint here, and we've also had a look at the resource browser to see if all the different parts of our stack were deployed, and all looks like it did. So the next step is to test that our app behaves the same as it does when we worked on it during development. So if we go to the terminal again, and in the terminal, as part of the response to our script, we got this text here that looks like this. So this is essentially the endpoint that local stack created for us when it created our application load balancer as well. So this is the URL that is essentially the access point to our stack and also goes through our API gateway. So what we're going to do is copy this, and we're going to go into the project, and we're going to go into API request folder. And the first thing we'll do is we'll check that we can log in. So we'll go into the off service, we'll go into login.http. This is the request that we have been using to test our login endpoint so far. All we have to do in here is change the host name to match the host name of our ALB. So this is what we just seen in the terminal in here. So we'll just copy this and we'll just paste it up into the address up here so that it looks something like this. So your endpoint is obviously going to be different, but it should be very similar to this. The only difference should be this random character string in the middle, but everything else should be the same. You also want to keep the port the same, as this is what we configured our API gateway to be. And you also want to keep the path to be the same as well. So the only difference is that we are now pointing to local stack as opposed to our local host, which we used during development. So now all we need to do is run the post request, and all being well, we should see in the services window that we do a post request to our endpoint and that we get an OK status back. This is good, as it means we are able to log in. So as part of the deployment to the off service, as a quick reminder, what happens is in the resources folder, we have a data script, and this runs whenever the app is deployed for the first time. And this is going to seed the database with a test user that we just used to log in. So you wouldn't normally do this for production deployments, but for learning purposes and to ensure that local stack is up and running, this is perfectly fine. So this is good so far. We're able to get a token. So the next thing that we're going to try is we're going to try and get all our patients. So this is a good test because it'll test that the patient service is working correctly. So if we go into API requests again, and then go into patient service, and then go to get requests. And again, we have a request that looks like this. So we previously called localhost 4004, which is our API gateway. We append the path as being API/gateway. And then we also pass in the token that we got from the login step in the previous request. So in the get patients one, we're just going to update localhost here as well. We'll paste this in again, and everything else should stay the same. And if we do a get request now, we can see we have a list of patients. So this is good. And as a quick reminder, this list of patients comes from the patient service. So whenever the patient service gets deployed, after it connects up successfully to the database, which in this case is the RDS database, it runs this data.sql script, and this just has a random list of patients in it. So this is the list we are seeing in here. So this is good. And the last test we want to do is that we can actually create a patient. So this is where, if anything's going to go wrong, it will be this bit, because this does a whole bunch of stuff with gRPC requests and Kafka and all that stuff behind the scenes. So let's see what happens. So we'll jump into API requests, into patient service, and we're going to go into create patient. And this is the request that we use to create a patient. And it looks like we haven't created a patient in a while. So there's a few bits and pieces we'll have to do. So the first step is we'll paste in the address of our load balancer into localhost up here. And we'll change the port to be port 4004 over here. So again, this just points to our API gateway. And then we'll change the path to be / and then we'll say API, and then we'll do /patients. So it should look like this. And then the next thing we need to do is make sure we're sending our access token as well. So if we jump back to the get patients request, we'll just copy the authorization header into here. Then we'll jump back to create patient request, and we'll just paste it in the header section up here. And then we'll take a new line after this. So our request now looks like this. So once you're happy, go ahead and hit run. And it might take a while for the request to come back, but hopefully at some point you're seeing something that looks like this, essentially the result from the create patient request. So what's happening is that some of the services essentially needed to warm up because it was the first time we were accessing them. So for example, Kafka, it needed to check if the topic exists. If it didn't exist, then it looks to have created one, and the gRPC stuff as well just needed some time to spin up. So this is pretty common with first time deployments to infrastructure, and there's ways to mitigate this, but for testing and learning purposes, we just want to make sure that we're getting a 200 response back from our create patients. So the last thing we're going to take a quick look at is some of the logs, just to see that the get patient request actually posted a Kafka event and that the event was received as well. So what we're going to do is go into the services, into our containers under Docker. And the first service we're going to try and find is the billing service. The easiest way to do this is just to click each of the containers. And as you can see here in the logs, it'll give you the name of the service. Just click through these until you come to the right one. So billing service. And if we scroll to the bottom of the logs, you can see hopefully something that looks like this. And it says creating billing account request received, patient ID, and also the name and email of the patient. So as a quick reminder how this works, anytime we create a patient, we make a gRPC request straight away to the billing service as a point-to-point microservice communication option. And as part of that, we send some details about the patient. Once the billing service receives this gRPC request, it simply logs out some of the details. So if you're seeing this, this is good, as it means the patient service that's running inside of ECS is able to communicate with the billing service that's also running inside of ECS as well. And the next thing we're going to look for is the analytics service. So again, just click through these containers until you find the one that we're looking for. Once you have, we will scroll over and we should hopefully see a Kafka event. So here we see a Kafka consumer event, which is promising. And if we scroll over, we can see received patient event and the ID of the patient, as well as the patient name and email and so on. So this is good, as it shows that our infrastructure is working very similar to what it did in development, which is what we are trying to achieve. And that also shows that we're able to log in, get some patients, and create patients as well. And our databases are running and our Kafka instance is up and running as well. So if you're not seeing any errors at this point, congratulations, you've just deployed your first CloudFormation stack to AWS using local stack. So when it comes to creating a real production AWS environment, you would simply run the same CloudFormation stack and you would get an environment that is created, which is very identical to the one that we are looking at in local stack. So if you're having any problems at this point, you can have a look on GitHub for the finished scripts and things. Also check in your local stack desktop for any CloudFormation errors, and also check the container logs in local stack to see if there's any information in here as well about the stack deployment status. Okay, so the last thing I'm going to show you is how to deploy changes to your stack if you have made updates to the Java CDK code or to the CloudFormation template. So if you do want to make some changes to your stack, add new services, change some of the existing services and so on, what we need to do is delete the old stack before we deploy a new one. So typically, if you were updating infrastructure on the real AWS, we could just redeploy the new CloudFormation stack. But because local stack doesn't support that sort of functionality, the local stack docs suggests that we delete the old stack and then redeploy the new stack. So for learning and development purposes, this is a perfectly fine approach to take. So in the infrastructure folder, you're going to go into our local stack deploy script, and all we're going to do is just below the set E flag, we're going to take a few new lines, and then we'll say AWS, and then we'll do dash endpoint, and then we'll do dash URL is equal to HTTP // and then we'll say localhost and then we'll do 4566, and then we'll say cloud formation. Then we'll say delete dash stack, and then we'll add a backslash, and then we'll do a new line, add tabs a few times, and then we'll do dash, and then we'll say stack dash name, and we'll say patient dash management, and that's it. So now, as part of our deploy script, before it tries to deploy a new one, it will try and delete the old one. So if you do make changes to your stack, just run the script again. It will delete the old one and it will try and deploy the new one. Okay, and the last thing to talk about is just how to troubleshoot some of this stuff. So sometimes when you deploy some changes, the stack might get into a funny state where it won't delete and create either. So you have a few options here. You can go into the local stack desktop app, and you can go into the container and go to the resource browser and go into CloudFormation. And from here, you can choose the stack name. You just tick the box over here, and under actions at the very bottom here, you can choose remove selected. So this will try and delete the stack, and it will delete all the resources as well. So if that fails to work for whatever reason, the last thing you can try and do is on the containers is just try and delete this container and create a new one. So that's the last line of defense option, as it means you have to set up your API key and so on again, which is not the end of the world, but ideally you want to avoid that if you can. But as a last resort, it should work fine as well. That brings us to the end of this version of the course, and a big congratulations for making it through. I've designed this course so that you can build on your knowledge and practice adding your own features if you wish to do so. You can also visit codejackal.com to join the Discord community, where you can get help, share your progress, and suggest new features or topics you'd like to see in future course updates. We will also be expanding this course with more patient management features, such as additional APIs and UIs to enhance our enterprise app. We'll also dive deeper into AWS and DevOps, covering things like CI/CD, scaling, and other considerations we need to make when running microservices in production. All the links are in the description, so feel free to check them out. Finally, I would like to say thank you for watching. If you find this course helpful, please like, comment, and subscribe. It really helps more people discover this course and helps the channel grow. Thanks again for watching, and I'll see you in the next one.